the amount east or west your magnetic flux is compared to the true north and south.
Yep.
So you're already familiar with that concept. The
Yes.
inclination is the direction of flux relative to a horizontal reference at your location. So it can actually be pointing slightly downward from horizontal or slightly upward.
How would you get that reading?
3D compass.
3D compass.
Here, I'll post a thing.
Cool.
So
if I can type it in on my phone.
Did we get confirmation while you're looking at that for the planes being lighter? Did we get any? I missed a lot today.
All right, there's an example of what I'm talking about.
What up, SC?
What up, Isa? Did you catch the part, Isa, where planes get lighter as they fly a certain direction at the equator? Yeah, yeah.
I didn't see that one there.
Oh, that was an exciting conversation.
Yeah, the Otvos effect. It's greatest at the equator, and it tapers off as you go toward the poles.
Did you also hear Isa that
the scale on the airplane?
What?
I think Wolfie showed it on an airplane. He had a weight on a scale traveling east and west.
Oh, so we have proof of planes getting lighter?
Well, real quick.
Mass is getting lighter.
Weight,
Or
not necessarily planes, but just weight in general.
How much?
Yeah, you can't weigh an airplane in the air easily.
Real quick before we move on, how quick is like the inclination changing? Let's say like the declination changes over time. How quick is inclination?
If you're looking at a declination map over time, the inclination is a little more subtle, but it is changing its positions in much the same way as the north and south magnetic poles. The inclination is at its greatest there, obviously, because that's where the north and south magnetic poles actually are. So, I mean, pretty much the same.
Do you think you'd have a problem if people start using this for evidence of the dome?
As evidence of what?
The dome.
Oh, problems for using it as the dome?
Right,
yeah.
dude. You know, now it's
because it's moving around all the time.
Right. You know? Opened up a can of worms, haven't I? But that's fucking interesting, though. And that and that changes with the same pace as the declination. That's cool, man. Thank you.
Yeah, because the magnetic north and magnetic south is where the inclination is also at its greatest. So, that's you're going to see the same kind of changes over time.
Nice. That's wild. It makes me think of like a floating, like imagine like almost like a floating plastic bottle cap. You know what I mean? Like on top of like a glass, and it like fits it, but it changes. Like if you had a glass of water and like a cap that sat inside of that and kind of rode the waves or something. I don't know. Whatever.
Right. You want it to be freely suspended in multiple axes. So I mean, it's a little difficult to visualize, but there's a drawing of one. What I posted not too long ago.
Sweet. I mean, we can get to the more contentious subject of planes getting lighter, but I just was curious. That's cool. I never heard of the inclination part before. That's cool.
Well, we learned three things today, Isa. The plane, the inclination, and something else. There's no Coriolis at the equator. Were you aware of that?
Does it cancel itself out somehow?
The horizontal component of the deflection. The horizontal component of the deflection for north-south travel at the equator should be 0 right at the equator, because that's where you're experiencing the least amount of difference in tangential velocity.
I would like to try to explain to SC Montreal why Coriolis is a thing, and see if you can figure out why we say Coriolis is 0 at the equator.
Well, I gave him the vector cross product. Of course, that went over his head, though.
I was gonna not.
No way SC could understand a vector cross product. I mean, come on.
Well, you didn't respond with anything, so.
Uh-huh. We can't be that smart. I mean, a vector, we can't understand a vector, and cross. No way I could understand that. That's like way beyond my pay grade. Why don't you explain to us what it is?
Well, you have to know what vector multiplication is.
Mm-hmm. Okay,
So-
go on.
Yeah, I'm not going to go through all that right now.
I will explain it in my way. So we have a basketball. I'm not going to do it on the Earth because that's presupposing a sphere. So we'll go with a basketball. And of course, there's an equator, so to speak. There's a midline of the basketball where the basketball is the greatest radius. So this midpoint is about 4.5, 5 inches in radius. And the whole basketball around the middle is 30 inches in circumference. So this basketball, if it were spinning, could spin once per day, 30 inches in one day. Now, if you move up north or south of this equator, it spins less distance because the radius is no longer as big. So the radius is smaller, but it still spins once per day everywhere on the ball. Does that make sense so far?
Mm-hmm. How about in the center? Is it spinning at the center, at the equator?
The entire basketball is spinning once per day.
Got you. Tracking. Okay, go on.
Everywhere it's once per day. Now at the equator, it's moving 30 inches around. Okay?
Gotcha.
About, halfway up or down, it's moving 15 or whatever, half that number, inches per day. But both cases, so one is 15 inches per day speed, I guess you can call that linear speed, but still once per day. But the other one is 30 inches linear speed, distance. It's got to go 30 inches around, but still once per day. So there's a difference in the linear distance it travels, but not the angular distance or the angular time, whatever you want to say in that regard, okay? Does that make sense? So, if there is an object moving from the middle toward the north or south, it is moving in a direction where it moves from 30 inches per day that it has to travel to 15 inches per day if it moves north or south of that equator line. So if it's moving in that way, it actually slows down because it's moving fastest at the middle but slower toward the pole. Does that make sense? Everybody with me?
Careful with your use of the word down. You mean lesser of an effect.
Slower, whatever. The speed is the speed is less.
I think we follow, but there's some people who don't want to follow this.
Well, I'm just, that's why I'm kind of pausing to see if anybody's got questions. I mean, not only that, I'm hoping somebody else is double checking me, right, to make sure I'm right.
No, I'm pretty slow and I'm following. I'm 10.
Okay. So as you move north or south, you're still having to rotate once per day, but now you're only rotating 15 inches in that day instead of 30 inches in that day that you would have to do so at the equator. So now you're moving less distance. So now your speed has slowed down, or it's less, depending on which way you want to say it. And so that is what causes Coriolis. That slowdown as you move north or south. And by the way, that's also why we say that the Coriolis is 0 at the equator, because that's where you're moving fastest. And if you go north or south of the equator, you're having to slow down, but at the equator itself, you're moving at your fastest possible tangential speed.
Right, and it stands to logic that that's where the Coriolis should be its greatest. I mean, nothing you said made sense, bro. Absolutely nothing.
So
Sorry,
you got
man.
it backwards because Coriolis is 0 at the equator, and greatest at the pole.
Then you really do not understand the Coriolis effect. I'm sorry, bro, but
Do a Google
you
search
just
and
don't
see if
get
that's
it.
wrong. But did the other guy understand it? I mean, again, if your speed is greatest at the equator, and you don't have to, you're not, and you have to slow down going north or south, then something has to change. But if you're just sitting on the equator and you're rolling around, nothing changes. Coriolis doesn't happen because you're not having to change your speed as you move.
Yeah, just by you saying that you have to change your speed, you do not understand what the Coriolis is. I'm sorry, bro, but you just do not understand it.
Did you get the part where I said if you move north or south, you're still rotating once per day, but you're covering less distance?
Yeah, of
you
course.
understand that?
Uh-huh.
So how can your speed stay the same if you're still going once per day, but you're not going as far?
Nobody said that your speed changes the same. What you don't understand is
That's
if
what
you
I'm
have
saying.
a rotating body, right? Anywhere on that body, it doesn't matter where you are, at the center, at the top, it doesn't matter. Unless you're way like in the center, top, that might be an issue. But anywhere else, when you throw a ball, the ball travels straight. The reason why you see it turning is because you are turning. This is what you don't understand.
Forget about the ball. I'm just focus on that you're at the 45-degree latitude mark, right?
Well, hold on. Well, hold on one second. We can actually continue to look at the ball. If you're at the North Pole or you're at the South Pole, the Earth is rotating around the axis where you're at. So that's where you expect to see the greatest effect. In between those 2 points, where the equator is, you expect to see the least effect. That's
You got it backwards, man. It's unbelievable how you guys think. It's incredible. It's mind-boggling.
What I said earlier, SD, about your speed, your angular speed stays the same. No matter where you are on Earth, you're rotating, this ball, you're rotating once per day or once per whatever time. But as you go north or south, you're traveling a less distance in that once per day revolution. In order to stay the same once per day, but travel less distance, you have to slow your speed down.
That's understood, but that is not the Coriolis effect.
It absolutely is. That's exactly what it is.
The apparent.
Hold on. One sec. In regards to what do we have as a reference for measuring this Coriolis on the ball? I understand the theory of it, let's say. But what is our measure, let's say, to show, what are we trying to show Coriolis off of?
If you measure Mexico City to Dallas, Texas, or Mexico City to San Francisco, you'll get 2 distances, right?
Okay.
So if you also can go over to the east 500 miles and get the same distances to those 2 cities, and you'll find that they're closer together than the 500 miles that you went.
And this is in air travel or something to effect, right?
No, on the ground.
Okay, all right.
You go 500 miles one way, and then you go up north and do a 500 mile, or do a straight north. You'll find that they are now closer together. They won't be 500 miles. It'll be 200 miles or 300 miles or 400 miles, something less than 500 miles. Even though you've gone straight north from that position, both positions. I said it in kind of a cumbersome way at first, but this is what I meant. Two points at the equator, or toward the equator, going north, directly north. Those 2 points will be closer together.
So you want to hear a crazy thing now? How they're going to double, triple speak and make themselves look really silly?
Well, hold on.
Watch this example.
That would work on both things, though.
Oh, are you done, Isa? I
Yeah,
thought you were
go ahead,
done.
bro. No, go ahead, bro.
Okay, check this out, bro. You have an airstrip right on the equator, facing east-west, right?
Gotcha.
So now we have the Earth rotating, right? We have it from east to west, I think it is, or is it? I always mix that up.
Going east.
Going east. Okay,
West
so
east.
the Earth, right. So now your plane is facing east, right?
Mm-hmm.
When you take off, does the plane conserve momentum?
Planes always conserve momentum.
Perfect. So it's traveling at 500 miles an hour,
Mm-hmm.
but it's also conserving the 1,000-mile-an-hour speed of the rotating Earth, correct? Conserving momentum, correct?
Perfect. Yep.
Okay, now we turn the plane the other way
Mm-hmm.
and it takes off.
Okay.
Does it conserve the momentum of the Earth, and is it flying backwards now? What's going on here?
Always. Yes, of course. So you took off, you're on that runway, and you're taking off to the west. So you're going against the rotation of the Earth. So when you end up using this force to take off and fly eastward at 500 miles an hour, you're now going only 500 miles an hour net.
So you're going backwards 500 miles an hour.
No, you're not going back. You're still going forward.
That's what you said before. Why are you taking it? Why?
Hold on. You're still going in the west-east direction in space, but you're only going 500 miles an hour rather than 1,000 miles an hour.
And how are you making up for that lost speed?
What do you mean? How are you making up for the lost speed? You've used the jet engines to take off and fly that direction.
So you're taking off in a net negative speed.
Let's make it even more. Let's make it more apparent. If you took off, hold on.
You hear that?
Hold on. Listen to this. This will make it easier. Let's go even more extreme. Let's go 1,000. Let's say it's an SR-71 or some kind of fast jet, military jet, and you're going to go 1,000 miles an hour at the equator to the east. You would be in a relatively inertial state. I mean, you're kind of fixed. You're not going anywhere.
So you're not going anywhere.
You're not going anywhere.
You hear that? If you're flying 1,000 miles an hour on a plane going east, you're not going anywhere.
And that's where reference points are important, relative motion. So relative to the Earth's ground, you're going 1,000 miles east because you took off with Florida and you took off east or equator, someplace in Mexico or Nicaragua, whatever his equator is. You take off and you use that power to accelerate against the ground. You are going 1,000 miles an hour to the west, but in space you are not going anywhere. You are fixed in space. You are now inertial.
Okay, got it. So you guys heard it now. If you're flying 1,000 miles an hour east on a SR-71, you ain't going nowhere. Also, when you take off with a jet airliner going the other way, you're going backwards. You have negative speed.
No, same way when you're sitting inside an airplane, you're not moving in relation to the airplane, but you're moving in relation to the ground because motion is relative.
So when the SR-71 is cruising, is it flying downwards relative to the curve of the Earth, or is it flying level?
It's flying level.
It depends. If it's maintaining an altitude, then it's level. But if it's gaining altitude or losing, then it's not.
Yeah, assuming it's keeping the same altitude.
Yeah,
it flies level. That's how it keeps the same altitude, and it would have to need more power or would increase its speed for a given power if it was to change altitude. So we know it's going level because it doesn't change altitude above the surface, and it does rotate because gyros would detect this subtle rotation of the plane as you guys like to say, dips its nose around the Earth. But as far as the wings in the air concerned, it's flying perfectly level because the air is curved, the atmosphere is curved because it's around the Earth.
Why does the SR-71's fucking manual show its cruising angle of attack as a positive?
That only has to do with the angle of attack or how you effectively give lift. That's how you give lift to the wing.
While cruising and while fucking level.
Cruising. Yes, there is a slight inclination, the angle of attack.
Well, what is that slight? What is that degree?
Can I finish the sentence?
Fuck you. What is the degree?
I went to school for 4 years to understand aerodynamics.
What's the fucking angle of attack for SR-71?
I heard it 5 times. Even though the angle of attack is upward, that angle of incidence is what is key for this wing. To develop lift has to be slightly positive. Now, the angle of attack could actually be higher or lower, depending on the design and the weight distribution of the plane. That doesn't determine where the nose is going. It could be plowing. You could have the nose up, way up, 40 degrees, and fly a plane resting on his prop, as we say in the aerodynamic world.
We understand if a fucking nose is going to go up and down, it's going to go down.
Or a high left wing,
We're specifically
or a high left wing can actually have nose down and fly level. In fact, the more you accelerate,
specifically talking about
the
when
more
it's flying
it rises.
level.
The more
Where's
lift you
Rakia
get.
when we need
You're
him?
a fucking idiot. You are a
Where's-
moron. You
Where's
really are a
Rakia when we
moron.
need him? Rakia.
Alright, guys,
Why does it have a 4 to 7 degree angle of attack on cruise?
Glory, you're done.
Jeremy, this
Rakia,
temporary.
don't let him yell.
I'm just gonna have
Rakia,
to temporary
moderate.
mute. Anyone talking right now is just going to be temporarily muted. All right, we need to calm down. All right, no screaming. Let's not overtalk people, and definitely don't call names. This is literally the last time I'm telling you guys.
That was me yelling at first, so I apologize. But why is it having an angle of attack upwards? By a lot, 4 to 7 degrees is not a fucking little
You're
bit,
yelling again.
motherfucker.
Stop it.
4 to 7 degrees is
You're
not a
yelling
little
again.
bit.
Stop it.
Wow, why is Zanuck allowed to do that? Even though that guy's yelling, Zanuck's cutting
Because
in
he's
and
being
yelling.
unreasonable.
Yeah,
Nah,
and you
fuck you.
call
I
names.
apologize,
You just be out of here,
You
bro.
need,
I
you need an
apologize.
angle of attack. You need a angle
Nah,
of influence.
it's not your time to speak.
We're
I
talking
get
over.
to speak
Jeremy,
now.
would you please
I
mute
get
him,
to
please?
speak now.
Jeremy, would you
I get to
please
speak
mute him?
now.
How is
I get to
Zanuck
speak
asking
now.
for a
I
mute
get
when
to
he
You want
speak
to
now,
mute him
motherfucker.
because he's
I
out of
get to
control.
speak
I'm
now.
going to
I
explain
get
to him
to
why you
speak
have a
now.
4 to 7
I
degree
get
angle
to
of
speak
attack.
now. No one's gonna fucking hear you unless I get
You're
to
an
speak.
idiot. You're
4
an
to
idiot.
7
You're just an idiot.
degrees,
Period.
motherfucker.
Wow,
You're
more
triggered.
names.
You're fucking triggered, motherfucker. 4 to 7 degrees of an
The
angle of
guy
attack
yelling
upwards,
says somebody
mother
else is
cunt.
triggered.
Upwards is not downwards, cunt. It's one
And
thing if
nice,
it's
nice
one
All right,
thing.
what
job,
is this guy's
punk.
screen name? What is
Thank
this
you.
guy's screen name?
The
All
most high.
glory.
The most
He
high.
he doesn't understand how.
There you go.
Shut
He
the
doesn't
fuck
understand
up,
how to
man.
handle
Hold
Zanuck.
on. Hold on, man. Glory. What was it? Glory?
Glory.
All
What are you
glory.
All
doing? Yo,
glory.
you guys gotta relax, man. You gotta relax. No name calling.
Yeah,
Do
don't let
not call
Zanuck
names.
trigger you, man.
I don't think
Yeah, don't
Zanuck
let
was the one
Zanuck
trigger.
don't let Zanuck
like
call
it.
you an idiot and a moron, and then you call him names back and get in trouble, man. Don't let that happen.
No. Glory
I like
got
the
crazy
underhand
first.
of
Nobody jumped
attacks.
in to say anything to Glory. I
If you
didn't hear
guys
you.
are,
Didn't hear
if you
you
guys,
jump in to talk about Glory there, Rakia.
Yeah, I just
But
said
as soon
don't
as
call names. Didn't you hear me? Maybe
but
you're
you
hard of
but
hearing
but
too.
you but you
But what
mentioned
I
Zanuck
heard was
several
Zanuck
times, though.
interrupt him 3 times and call him
No,
names.
that's not what I
Yeah,
heard.
that's what happened. And then he started
No, it's
saying
not.
cunt.
It
Yeah,
it literally does not matter what anybody heard at this point.
right,
if you guys
exactly.
want to continue with the conversation, like I'll just quickly summarize what was being said. Is that the idea was, planes have to have an angle of attack, obviously, to maintain altitude. Otherwise, to resist the air and to keep them floating rather than sinking, you got to have an angle of attack. That's all really understandable. But the main thing that was being argued was, when planes take off and you've got the spin of the Earth, they've got to maintain altitude. Well, you know what the real argument to that is that when they come into land, guess what? The Earth is still spinning. So what? You've got to match the spin of the Earth. It doesn't fucking matter whether the Earth is spinning or isn't spinning. The fact is, you're on the runway, you take off, you land. There's no this spin of the Earth corridor. None of this fucking comes into it.
Right, we can follow that digression really easily. But just a moment to address the 4 to 7 degree angle of attack. If you have a 0 degree angle of attack, you will sink because objects do fall. So if the argument from All Glory is the 4 to 7 degree angle of attack is indicative of a concave Earth, you're out of your mind because it has to go upward. The angle of attack has to be upward, or else the airplane falls out of the sky. Now the matching the speed of the Earth while you're landing. The air, on average, is about the same speed as the rotation of the Earth. So since aircraft use the air to get where they're oh my goodness gracious. Since aircraft use the air to get where they're going, they care about where the air is, not whether free space around them is in a different reference frame or whatever.
So you're saying we have 800-mile-an-hour winds, 700-mile-an-hour winds, 1,000 respective of the. Are you kidding me?
Why?
No, it's not what I said, actually. That's totally and completely not what I said.
You
That's not
said
even
the
close to what
air.
he said.
It's exactly what you said. You said the air is relative the same as the Coriolis effect. Did you not say that?
No, I
he
didn't.
didn't
I didn't even
say
use the word
Coriolis.
Coriolis effect at all. The word Coriolis never even exited my mouth during that description, Essie.
You say
So,
irrespective of the
all
spin
right.
of the
So
Earth.
what are you saying then causes the drift from the Coriolis? Be specific, please. What causes the drift?
My entire response was specifically to aircraft landing. If we want to go to the other topic of the Coriolis effect, we can. But my response was specifically targeted at airplanes landing, not the Coriolis effect.
Okay, all right, fair enough. So we got a runway at the equator. It's going 1,000 miles an hour east to west. I'm coming at it from a northbound position. Okay? How do I see that runway?
How do you see it? You look at it.
Is it whizzing by me, or is it just magically matching my speed as I
You're in the air.
traverse?
Yeah, you're in the air. The air is on average, although in some places it differs, it is on average around the same rotation rate as the Earth.
So that is exactly what you said. You're saying that the air, as I'm coming in at 1,000 miles an hour, I got a side wind keeping me in line with the runway, miraculously.
Not miraculously. Didn't use the word miraculously. You inserted that because you're incredulous.
Scratch miraculously. Is that what you're stating?
I'm stating that the air, on average, has the same rotation rate as the surface of the Earth.
Unbelievable. Did you guys just hear what he said?
Yeah, I mean,
Nobody's going to contest that. No baller.
basic
Ballers, are
fluid
you agreeing
dynamics.
with this?
No, basically saying that the air doesn't, that there is no way to tell if the Earth is spinning, and that Coriolis effect has no effect on planes. So I don't know why we're talking about this topic. So really,
let's review what I actually said instead of your interpretation of what I said then.
Well,
what I actually said was that the air has, on average, the same rotation rate as the surface of the Earth. Nowhere in that statement does it say we cannot tell that the Earth is rotating or that the Coriolis effect cannot occur. Those are not words that I used. You inserted those words into my position without me actually saying them.
Let's very promptly dispel this fucking myth then. I just want you to quickly try to correct me here. If I'm wrong, correct me. We're talking about Coriolis effect, and you're trying to give an example of why Coriolis effect, how Coriolis effect is detected and seen in the real world, and you've brought up the fact that the air rotates at the same speed as the surface of the Earth, and so it has nothing to do with it, doesn't affect it, and yet that has something to do with Coriolis effect, the landing of planes. Come on.
The initial thing that you brought to me was how do aircraft land? That's not an example of the Coriolis effect. So when you tell me that my example that I gave to you about how it works has something to do with the Coriolis effect, you're wrong.
Okay, do planes have anything to do with the Coriolis effect? Or is there any way to detect, or is there any way to measure the Coriolis effect, or to show that the Coriolis effect has a differing amount of that it affects something in reality? That we can see.
If you want to stick with aircraft, you're going to have problems because aircraft have powered flight that they attempt to follow a ground track. So
the problems are yours.
Aircraft is not a good example because they will always be attempting to correct for any small corrections that they need to correct for.
No.
If you want another example that's actually a good example, you can do ballistics because ballistics don't have the ability to follow a ground track. Once they're let off, they go.
Nah, I'll stay with airplanes. And I'll ridicule you all day long because you just told me. I'm speaking now. I'm speaking now. You just told me. Hold on, Travis. You get your chance. He just told us in front of the whole world, all of YouTube and Discord, he just said that a plane coming in from south to north on the equator on a runway going 1,000 miles an hour east to west is compensated by wind, by 1,000-mile-an-hour wind. He just told us.
Did you hear the part where he said airplanes are not a good example for a demonstration of Coriolis because they are powered and correct for it? You have to go to something that is not powered.
Of course, after I destroyed your argument using a plane, like I said I would, you have to go now to a bullet. Of course you're going to do that. You have
Well,
no
Because
choice.
that's where the best
exactly right.
example of it is. If I'm
When you're
not going with
planning
the
to use
best
a plane-
example, who the hell am I, Essie?
You're
No,
right,
you just
SC.
got schooled with a plane, and now you're going to turn to a bullet without being man enough to admit that what you said is totally ridiculous. 1,000-mile-an-hour wind compensating for
Your
the
incredulity
Coriolis.
is not a valid argument, Essie.
That's the craziest thing I've ever heard in my life.
I can
Right,
demonstrate that.
like I said, your incredulity is not a valid argument.
Sure. Add on me. Why don't you?
I can
Well,
demonstrate
you
that
are
right now.
literally using incredulity as an argument.
I don't
No,
believe
it's not
It is
incredulity.
ridiculous, in quotes. That's you saying that it is something that you don't believe is possible, and that's your only argument against it.
No, you said it, Sunshine. You said 1,000-mile-an-hour winds compensating for the Coriolis for a plane to be landing.
I can
You got to
demonstrate
live
that.
with that now, not me. That's on you, bro.
Montreal, I think this is a really unproductive conversation because it's obviously something that is, to anybody, it's plain to see that a plane navigates the land, and whether it's spinning or not, they're not going to say that it's any different, and it obviously isn't any different.
I can demonstrate it. I'm demonstrating it right now in the chat. It's a GIF I
If you
made.
go to-
And if we're going to go ahead and assert what is plain to see, it is plain to see that an aircraft uses the air to get where it's going. So it might be important to know what that air is doing, because again, it's an aircraft and it's using the air to get where it's going.
Have you ever experienced 1,000-mile-an-hour winds? Have you ever been near a hurricane in, let's say, Louisiana or Florida? Why don't you ask Rakia what that's like? Or
Right,
somebody
so
in the south.
when we define wind speed, what we're having it defined in reference to is the ground. So wind speed is usually relative to the ground. If the air, on average, is spinning at the same speed as the ground, the wind speed would be, on average, 0, not 1,000.
Okay, SC, I don't know if you could hear me.
I don't know, man.
SC, can you hear me?
Yep.
I've been saying this a few times. I made this GIF a while ago to show exactly what a plane does when it flies north on Earth. What happens with the wind, how the wind helps to keep the plane from deviating. You can see as it flies into the wind, that's slowing down as well. The wind is going to help guide it to where it's going to stay from deviating.
You can't seriously believe this, bro.
I'm demonstrating it in real. This is the only thing I've put in this program was to throw the ball directly north at the speed that it was when it was at the bottom. The bottom and the top are going at different speeds. The wind is going at a different speed all throughout, and it's guided to exactly where it needs to go.
It's CGI.
The ground moving and wind speed relative to the ground speed has nothing to do with Coriolis and spin. You can't detect it. It's no different on either model. Let's move on. You said ballistics, right? Ballistics, you can prove Coriolis effect with ballistics. How so?
Yeah, planes don't account for Coriolis. Nothing accounts for Coriolis in any direction or anything like that.
That's just not true.
The planes don't account for temperature either, so temperature is fake.
No. I mean, if you think about it, like it says a gyro compass, that's its heading, and it goes straight, and it gets to where its destination was, but there was no accounting for anything else. Now, I'm just thinking and thinking about how I would logically want to get from here, pissed out of my face, to over there, and I've got something that's going to keep me in a straight line, like something.
They use GPS, they don't use gyro compasses.
No, I mean, no. Physically, you're in a plane and you're going in a straight line, any direction. There's no deviation from that.
You're following a ground path.
Yeah, they generally use a gyroscope to keep themselves on a straight path.
No, they use GPS to navigate. That's what they use nowadays.
Yeah, but if I'm trying to go from, let's say, Perth to let's say Cape Town or Durban, and I've got a straight line set up and stuff like that, I don't deviate from that straight line, do I? Or do I?
No, but the straight line is on the ground. You're following a
Yeah,
ground path.
No,
Yeah,
okay. I'm using a gyro compass to set me a set heading. So whether
But no one
forget
does that.
Yeah,
Of course they do.
you're no, because if you actually set a flight plan, you will
Yeah.
have various points along your flight path that you
Exactly.
will.
But
There will be very. Hold on, dude. As you
yeah.
set up a flight plan, there will be various points along that path that you establish your flight plan to pass through. These are all
Correct.
latitude and longitude and altitude. These
Correct.
all follow that path in that map that you've defined them on. So what you're going to do is any corrections that you need to apply while you're in flight to maintain that path along the ground is the corrections that you will apply.
Well, Kai, I do understand everything that you say, and we are just
That's
using
how
different.
aviation works.
Yeah, I know, but if everybody discovered a way to get from here to there, they'll do Hansel and Gretel and leave a trail. It's the most efficient way of getting there and stuff like that. But they go in straight lines. They go from here to there, then from there to there, then from there to there. They change their heading every time. If you track a flight, it doesn't do as you explain. It goes from a straight line from here to there, then another straight line from there to there, and that's how they do it. So
But they do it
there's
based on GPS now. They don't follow headings.
Right.
So
A
they
rum
don't.
line is not the shortest path. You will never follow a rum line to get where you're going.
Nobody mentioned shortest
And if
path
you're,
yet.
but hold on. If you're flying from, let's say you're flying from Australia to South Africa, for example. If you follow a heading, you wouldn't get there because your heading will change all the time when you fly.
Know that, do you?
You can plot a rum line if you really want to, but it's longer than a great circle route.
Yeah, it wouldn't be a straight line. It would be a curved line.
Yeah.
Yeah, no, I understand about rum lines and stuff like that. It also is a presupposition or a pre-assumption about one thing, but the straightforward thing is that before times and stuff like gyro compass or something, whatever. How long have we had the ability to set a straight course? 100, 200 years. But the ability to do that only now, but whatever we're talking about, the original thing we were talking about is the Coriolis effect and stuff like that. Do we experience it when we fly? We don't, because we would get that deviation. And if we're accounting for that deviation through our path through our different points that we cross through, I doubt it's got anything to do with Coriolis. It's just the way that it gets there, and it's the most efficient thing on the shape that we're on, whatever it is. But that doesn't prove anything either. Someone's giving you a set route, and you just follow the set routes. No one's out there trying to cut corners. And there have been people that has said that there was less distance between South America and Africa than what they say it is, because they independently tried it out.
No, but you can, if Jesus Christ, when you make a flight plan and you file it, you have it in your flight management computer, and you can see the distance between the waypoints, and then you fly it, and you have fuel predictions and time predictions between those points based on the distance and the weather. So you always know where you are, and you know the distances based on wind and the map.
If I've got an estimation going on, thank you for your time. I think it's Mole Man that's on. If you study flights when they go offline and are estimated, they are a good 3 degrees of latitude adrift.
Hold on. Quick thing. What do you mean they go offline?
Estimation. I've got to go now. I'll listen, man. Sorry, man. Estimating, yeah?
No, they're never offline. They always have a GPS signal. Well, maybe when they're directly over North Pole, they don't. But
yeah, there was a.
When you can't.
KRB or something. Sorry, mate. It was when you're talking about it knows the GPS and knows where it is. It's KRV. It's GNSS or GPS, and then there's another bit that's added onto it, and it's called.
Hold on, because you might be confusing it with ADSB signals getting back to ground station.
That is what it's doing. Yeah.
No, it's not kinetic. It's called it's not cinematic. There's a word for it. I wish I had it on my thing.
Do you mean that when you go to Flight Aware or Flight Radar 24 that you don't get the signal from the plane?
Yes, I would, and I'm trying to say this at the end. I know.
That has nothing to do with GPS.
But neither the pilot or any instrumentation knows where the pilot is. That's why we lost so many flights.
No, that's not true.
That's not correct.
That is not true. The pilots always know where they are.
Yeah, the GPS on the aircraft is always working. Whether or not a ground station has visibility of that data is dependent upon the ADS-B system, which within the past couple of decades was upgraded to allow for satellite communication, so that now we do have very complete tracking of aircraft over oceans.
Yeah, pilots really do know where they are.
But do they really know? Their instruments are telling them where they are, and they are recording where they are. And then when you match it against the estimated data, it's always 3 degrees of latitude out.
What? It isn't. What do you mean?
You should try it out. I mean, FlightAware is the example. You go to FlightAware, you check the actual track log of FlightAware and not the pilot's track log, and you compare them. There's nothing to verify what speed it was doing, so he's only assuming.
When have you done this? When have you done it? When have you seen a pilot's log and somehow referenced it to FlightAware where you don't even see the route properly?
Also,
you don't see the coordinates.
The cool thing about FlightAware 24 is that you can go on there and download all the data from each flight, and they literally I'm about to post a give me a second.
You got flight
spreadsheet. I'm gonna post a spreadsheet that shows all the data from it. They take it every few minutes. GPS coordinates, the flight, the speed, the time, everything.
Yeah, that's not true, mate.
Flight. It is true. I'm about to post it.
Yes, but is it aided estimation? Because when you go on FlightAware.com and you see the actual FlightAware synopsis or whatever like that, there is loads of periods where it can't tell what the speed is and it can't tell what the altitude is.
Not true.
Well, FlightAware is no good then, because everyone's using it gives better information. Interesting, but then why would FlightAware be recommended for people to use if it's bogus? No, I know this sounds stupid, but it's lacking what everything else is lacking. Everything else is bang on, but FlightAware's just got it wrong.
FlightAware's got it wrong. Okay.
I just posted a real flight going from LA to Sydney, and then I went to GC Map, and it'll just plot the path the plane should take based on the Great Circle and stuff like that.
Yeah.
And they match.
And then the screenshot I just showed is the download of the actual data, the CVC or some kind of, I don't know. You can download it for each flight.
Right, and there's always going to be small deviations for each flight off of the most optimal Great Circle course possible and where they actually end up. The differences can be for each individual flight from the most optimal Great Circle based on weather systems, because some of them do need to find the most advantageous winds to follow.
Yes, it's the same thing. Not many people actually rely or use a Great Circle in general because they've got other things going on. But every single time, maybe I'm just using the wrong website, but I couldn't find. I guess I haven't found these options available on Flight Radar. Maybe I should try a bit more on there, see if I can get a better story about what I'm talking about and actually replicate that.
If you go on FlightAware, right, and you click on any flight, like I always like to use a Sydney to Johannesburg. You go on a flight that already happened, and then if you click on it, there'll be a spot where it says downloads. You click downloads, and it has the KML and the CSV data, and you can download both of those.
But if you go to the blue button that says track log, flight log, it's a blue button that's separate to the pilot's log, then you'll see what they were estimating, what they were picking up when they were coming into range, and then you'll see the periods of estimation gaps. But obviously, surely they should be able to do that. That's why the website's there, but they can't get the data. They've got Cape Town to Singapore, 7 hours of data missing. You know, think about that. Same thing that always happens at Addis Ababa, north of Africa. There's an anomaly. There's an anomaly all around the world. There's a good 12 of them, 12 of old vortices, and they're all magnetic anomalies that are pretty much equidistant from each other, causing the same issues: Bermuda Triangle, Dragon's Triangle, South Atlantic anomaly.
True. Well,
but you have to look into it. You know, there's a pattern, surely.
well, regardless, we know that Sydney and Johannesburg are a specific distance away. So,
Did you see the flight that I posted, people?
yeah, I see it. Wait, I'm sorry.
Yeah. The
yeah.
London,
Today,
LA,
Auckland. Yeah, Auckland to where?
Santiago.
Yeah. I see. That's I've been tracking that one too.
Yeah, it's the other way around. Yeah, it's an interesting one.
Yeah, I'm sure the Great Circle is the first consideration, and then they adjust it based on the weather, things like that, and also the what's that thing that goes into it? The tops, E-tops, and then also places that they can't fly over.
Yeah, that
Yeah,
Auckland.
I think they have over. I think they have over 3-hour ETOPS nowadays.
That Auckland to Santiago is what is it? LA 800.
Yeah,
that's the
Yeah.
flight.
It's the
You've got Qantas, QF 28, 63, and 64. The other thing I noticed as well when I was studying this was that the flights from the USA were getting to altitude 20 minutes, cruising altitude, about 20 minutes, 30 minutes. When it left South Africa going to Australia, it took something like 2 hours to reach a higher altitude. So it gets 12,000 south and 10,000 in the north, roughly.
Don't they go like 20 miles, maybe 20,000 feet higher? 15, 20,000 feet higher?
Nah, 2.
2,000 feet higher?
Yeah.
It was like 30,000 feet, and then I thought overseas is like 45 to 50,000 feet.
Nah, apologies, mate. I'm talking about. I was talking about meters. Sorry, 10,000 meters, 35,000 feet, and that's in the north. And in the south, they do 12,000 meters, which is, like you said, about 5,000 feet more, roughly. Like you said. So sorry, you're right.
You said 10 and 12?
Yeah, 10,000 meters and 12,000 meters. Apologies. So it jumps from 10 to 12. So you're jumping 6,000 feet. But it seemed to me that the flights going from South Africa to Australia took way longer to get to cruising altitude and cruises at a high altitude for some reason.
Are you sure they don't go 14,000 feet? Or 14,000 meters?
I only on Flight Aware have I ever seen it never go past 13,000. So maybe that's a safe bet to explain. But somewhere between 12 and 13 was its maximum altitude, and it took a good 2 hours to get to that altitude. And it takes a collective of people to use these different websites or use the right data, whatever like that, to see what things are different. And then ask yourself, why are they different? And then you learn more. Insinuate anything, it's just things that I observe, and I might come across like I'm attacking or anything. But I studied them for ages because it was all this, flat earthers were saying that these flights don't exist and stuff like that. So I spent a long time trying to figure this out. And when you make a flat earth map, you've got your grid system, and then you've got your distances and widths and height lengths and all that, and boundaries of the lands. You put them all together, and the biggest gap that you're always going to get is going to be the Pacific Ocean. And then it's the question of, well, how do we verify these distances or things like that? And unfortunately, to get an equidistance map of flat Earth where everything is relative to each other, there'll be a massive gap, and that's about 18,000 kilometers, which is what 12 18,000 kilometers, 12,000 miles. Nah, I'm sure it's more than that. Yeah, it's definitely more than that. But I think my best bet was 18,000 kilometers. But still, yeah. I mean, this is the thing. And then you ask yourself, well, if the old days they possibly were using a type of map similar to that sort of projection, they really had to turn around and say that the Pacific was X amount wide. But if the logs of Magellan, whatever you want to call him, don't actually describe that he went across the Pacific in the way that we assume he does. It actually describes that he went up along the west coast of the Americas, and when you plot his route on grid paper, you'll see the shape exactly matches the left-hand side of the Americas. Then he loops up by the Bering Strait or Hawaii, and comes down again. Possibly while the fellow that came after him ended up in Hawaii and got killed. Most people there fucked him off. There's no way that he was told that Magellan went up to Hawaii, but he did, and then he ended up and then coming down to Guam. Just like, why would he come down to Guam if he was coming up from the equator? Things like that. But are those distances correct? If they're smaller, what does that mean? A whole lot of shit going on.
It's not that much shit going on. Hey, B-Baller, how long is that flight? Is B-Baller left? Did anybody know how long was that flight that he said from South America to Australia?
I think it's 13 to 14 hours for Australia to South Africa, and it's fucking hell.
Yeah, I think he gives 13 to 15 hours.
Yeah, and I think obviously it's working out at 900 kilometers.
Oh, it's much shorter.
550 miles an hour to do whatever divided by whatever. But they go out their way between Sydney and Santiago.
From Auckland to Santiago, from Auckland to Santiago, it's roughly 10 hours.
What about like from Sydney to Johannesburg, or from Perth to like did the flights ever cross Antarctica?
Not
They go close, but not over.
No, it's too dangerous. There's no airports to land at if they have an emergency.
You'd think that they should, right? Because
the straight path on a globe doesn't go over Antarctica.
Well, why not? Though, because it really should. Because
no, you can test it on Google Earth. You can go to Google Earth and do the straight path from Perth to South Africa.
I'm looking at it now.
I said Sydney to Johannesburg. Like I said,
I've done it many times on Google Earth, and it doesn't hit Antarctica.
Yeah, it does. It goes over Antarctica, Sydney to Johannesburg.
No, it doesn't. It does.
It does.
I've drawn myself. I can do it again.
I didn't say Perth to Johannesburg. I said Sydney to Johannesburg.
Yeah,
I'm sure there are direct flights. But
it doesn't hit Antarctica.
It goes quite close. It actually does go over part of it. But
quite close, so it doesn't go over it.
60 degrees south. I think it gets to about 60 degrees south. And then does a sort of like a right angle ish, gets in up towards the south of America to come up to Santiago. It doesn't go across, as we know down. But if we were adding,
the thing is that they don't go past 60, right? Why not?
How does it do that in 11 hours?
I think that it doesn't.
I'm gonna post the straight line from Sydney to Johannesburg, and it doesn't go even close to Antarctica on a globe.
There you go.
Yep, there you go. Posted it. It's 6,874 miles.
What program did you use for that?
Google Earth.
Okay, let me go again. I'm sure I've done this before, and didn't look like that.
That's Sydney to Johannesburg.
Surely the problem with using something like Google Earth to describe something that is not that shape, then surely Google Earth is only going to compensate with its coding for what description you give it.
What do you mean by that? I mean, we're just talking about the distances on the globe and where they go.
Yeah, like if I gave you the info and I said, look, mate, sort me out a ball, yeah, sort me out a program, it's going to do this, and here's your dimension. It's, you know, it won't be really hard to replicate if you know what you're doing. But if I didn't give you the dimensions, but I gave you the distances between stuff and this, that, and the other, yes. But the point is that you're naturally going to get the answers you're looking for because that's the whole purpose of the tool, isn't it? That those distances.
Nobody
Kosho
tried,
could do it in an hour.
Google Earth doesn't know what I'm trying to look for when I'm trying to figure out if a flight plan goes over Antarctica. Google doesn't know that.
Yeah, it's like trying to get a straight line from Galapagos to Indonesia. You're going to get a straight line, and it's going to tell you a distance of 16,000 or 10,000 miles. It's going to do exactly.
And that is what it would be on the globe.
Yes, but that is one question: is that has that distance been proven? And people would say yes.
But hold on, but we're not talking about has it been proven. We're talking about what would happen on the globe. That is what we say the globe is.
If the equator was a different length, then it means that everything else is different. And if you try to cover that up, then all you have to do is move the latitude lines so that they're matched to the math. And one half of the world, it's like saying when they're down the baseline for the India survey, they used 12-kilometer baseline when it should have been 11.11. So why would they use a baseline that had nothing to do with our distances per degree, etc., etc., etc.? Why did they use 12? How do you divide 111.11 by 12? It just didn't make sense. Why use 12 baseline?
No, but they can use the 12, and then the last one would be less than 12. I mean,
but they compensated. They compensated for the height of the Mount Everest, and they put that into their equation, and that's, I believe, the reason why they ended up getting 12, because they used the Everest as an excuse to raise that. And if you were to say half the world longer than the other half of the world, that would put your two celestial poles not at top and bottom, but just slightly to the left, both of them.
Do you think that they didn't account for the height of the Mount Everest when they did it?
Well, it's a case of just looking into these things and seeing what, and trying to think in ourselves. We're in the 1800s. How would we do some limit of variables, or as many as we could? We wouldn't go changing the baseline, would we? And considering like things like you just measure the circle or the base of the mountain or whatever like that. You can take that variable away, but they didn't, and then baseline is at 12. So then it means
how
that.
High is Mount Everest? Or how high is Mount Everest?
I don't know. I'm
higher, less high? What are you saying?
Well, no, you'd have to look up the India survey. I think it's called the Anglo.
Right, they got it at 29,000 feet and change.
No, I'm saying is they use a baseline of 12 kilometers or 12 meters or 12. It was definitely 12, and it should be 11.11, 111.
Why should it be 11.11? What's the reason why it should be that?
Because that is how many kilometers there are in a degree, and I know you're going to say on your latitude, but in simple terms, if anybody said at the equator it's 111, and if you're going from the equator to the north, those spacings are equal.
But what were they measuring? What were they measuring?
They were measuring the eastern hemisphere, the east of.
Did they use triangulation? Did they use triangulation?
They used iron grid.
A grid?
Yeah.
So not triangles. They used squares.
I wouldn't say squares because they didn't take the angles into consideration. So rhombus.
Oh, really?
Sounds weird.
How do you survey without taking the angles into consideration?
Yeah.
The square on the ground. To say it's a square, there's 4 by 90 angles. But if you're not using a square, but you're using the same length of sides, you're not using a square. You're just using a grid, aren't you? It's not perfectly
No, but how
aligned.
can you make sure that it's a how do you know that it's a grid if you don't have 90-degree angles?
Yeah, you know, rhombuses also have 4 equal sides. They're not squares. Yeah, I was looking at Xanax GIF of the moon guy. I'm not sure why he posted it, but at first it looks like funny, like, you know, like you guys say, like it's fake or something. But when you look at it long enough, you see it's impossible to have been faked. When you look at the space dust, for example, there's no way dust behaves like that anywhere on Earth. That's pretty crazy.
Why? It looks like it's blowing.
Yeah, that's. I was thinking that too. That's like, well, I wonder if they could put a fan behind him and just made it look like that. But then look at the second time, the dust, like the dust falls when he falls backwards. It doesn't fly that way.
Could you do it with a specific type of sort of sand underwater?
It's
no, because you have this material that's flying. You have material that's flying like 20 feet.
Right.
How do you make sand fly 20 feet?
Yeah, there would have to be no medium there for that to happen.
And fans actually make the material disperse.
Right. And also, like I said, the second time he falls, like the second pile that comes up behind him goes the other way.
Yep.
It's an animation.
Have you ever played in Bulldust?
Yeah, but
they use
it won't fly 20 feet when you kick it.
I'm not sure you've ever been to like North and Western Australia. You get this very fine red dust that does act like that. Bull dust.
Like this. I challenge you to do anything where you flick it up and it does this pattern. This is a no gravity pattern.
Yeah.
No, but they have wires for each individual grain of sand.
Yeah, not only low gravity. This is a no air resistance, no drag, zero drag pattern. And you won't have a zero drag pattern in any other situation unless you have zero drag.
Yeah, the drag is what's making me.
No, you just get you just get a consistent but particular size. So if you get something, you get a heavy material and classify it down to a certain particulate size, and it'll act like that.
No, it doesn't work that way.
It really will.
No, you're just making things up.
No, this is slow down.
If you have something microfine and you throw it out, it just becomes a cloud of dust. It doesn't go anywhere.
That's why I said something heavy, like iron, right?
Anything you're fighting. You're going uphill. You're going into the wind, and you're uphill battle right now mentally. Stop.
It's slowed down footage.
No, you're making stuff up.
No,
you're making things up. It's not slow motion. You can't have slow motion and particulate flying farther than it should at a rate faster than it should. Doesn't work, buddy. You just got to. You know what? It's up to you now to go find some simulation and try to simulate this. Go ahead.
Who's controlling the camera? The other guy?
Yeah, supposedly. He's lucky he didn't die. I mean, why is he jumping around like that?
Actually, that bouncing too, I was looking at. Like I said, at first it looks funny, but when you really think about it, he weighs like 500 pounds on Earth, and he clearly weighs about the same with all the suit and everything on. He weighs just about as he would normally weigh on Earth, maybe a little bit less. But
no, it's a sixth.
No, I know.
I mean, I know
but
if they sent me to the moon.
them.
I know if they sent me to the moon.
More weight. 500. Is it 500 pounds? Like
500 total plus his weight. Yeah.
I know if they sent me to the moon, I would definitely be hopping around like a bunny rabbit, falling all over the place with my glass shield and the rocks and all the moon's hard surfaces.
Yeah,
definitely, I would be I would definitely be risking that.
You don't fall the same way. You don't fall the same way. So it's like, you know, you think like, oh, I'm gonna fall down and break my glass shield, but I mean, look at him. He falls. It's a six. It's six slower. Six is heavy.
No, wait. You said he weighs about the same because
No, I was wrong. It's about half.
No, because he said he weighs 600. Well,
no, the suit is about 500.
Yeah, so you say he weighs about 200. Then
if it's 500, he weighs 200. Then that's 700 divided by 6 is like 116.
Yeah, so he weighs like 2/3 of his what he would usually weigh.
Maybe. Yeah.
But he also has terrible restrictions on motion.
Right. And also, like I said, that's not enough to really understand it because not only is he weigh 6 times as less, but the acceleration downward is going to be 6 times as slow. So I think that's why it looks so funky.
But he still has to move all that mass also.
Right.
He has to accelerate all that mass.
Which is
why it's in slow motion. The whole thing's in slow motion, right?
It doesn't look like it's in slow motion when the dust flies or when he falls or when he stands up.
If it's in slow motion, how would you explain the fast motion of his arm? That would be like, 60. His arm's waving at like 60 miles an hour type of thing when he falls.
He's falling moving much faster than it could on Earth.
And the dust is probably concrete mix.
Yeah, maybe.
And does it stay in the air like a concrete mix?
If it's really dry.
Yeah, but concrete mix will stay in the air. It'll waft up. It'll go up over your head.
And we have to decide if this is underwater or if this is somewhere dry, where the concrete mix would make sense.
Breaks all the laws of fluid dynamics. There's no way that this can happen in water for sure. And the slow motion objection doesn't comport with what we see here as far as the dust. Because if you had slow motion, think how much slower that dust would have to be going in reality. Or how much faster it would go.
Just think about it, guys. Of course. Just think about it, guys. Of course, if you went to the moon, the most dangerous environment man has ever been in, you would be hopping around like an idiot bunny rabbit, risking your whole life and the whole mission and everything. Come on, guys. Use your heads.
If you were one of the best, coolest dudes in the world who's already flown all the fucking test aircraft and been on the head of a rocket, then I don't think hopping around on the moon seems that scary, huh?
Well, I don't know. You can't. You said earlier they couldn't fall and break their shield.
No, I'm saying that I don't think that you're intuitively thinking about it correctly because it weighs a sixth as much, but also when you fall, you're accelerating downward 6 times as slowly. So it's like,
can you fall and break your glass shield on the or crack it at least on the surface of the moon if you hit a rock?
Yeah, you could. Yeah,
okay. So you're jeopardizing the whole mission by bouncing around like idiots.
Yeah, you could, but
That's
I don't
definitely
think...
what I would do if they sent me up there.
Are you saying you wouldn't do that?
No, that's what I would do, man. Look, that's what they did. You got to, those guys were the best, right?
No. I'm asking, what would you do? You're up there. You've got... I
don't think you say that's what he would do.
Your mission to do, but you also have this wonderful environment. What are you going to do?
I'd be hopping around like a bunny rabbit, risking my life, the whole mission,
I don't know
my
if you're
partner's mission.
or not, because you're a little cunt.
I would.
Come on.
Wow, now you're calling him a cunt. That's awesome.
There's no name calling, guys.
I know. I'm sorry.
Listen, I would do exactly what they did. I would risk the whole mission. My partner's life, my life, everyone.
Why are you cutting him off, dude?
Because he's saying the same thing over and over again and not answering the question.
That gives you the right.
You said,
who the fuck are you?
I'm asking you, are you being sarcastic? Because you're saying things like, I'd risk the whole mission. Now that sounds like
I would do exactly what they did.
And you're actually disagreeing with his decision. So I'm asking you, what would you do in that situation? Would you not do it, or would you do it? Because you are not being an honest person.
He's saying he's not being sarcastic.
Tell if you are.
To do what the professionals did, right? By bouncing around
Not
like
what
a
the
bunny
professionals
rabbit.
would do.
Wow, you cut him off again.
Well, what would you do, Moyoc? What would you do?
I almost
Moyoc.
certainly would,
Just
if
what
the
Moyoc
mission
would
parameters allowed for it, I would do it.
If what?
If the mission parameters allowed for it, I would do it.
What they do?
Yeah.
You say what they do?
I mean,
Mission parameters. Oh, you're saying this was written down. Go ahead and jump around, fall down, risk the mission. You're saying
No, you
that's
say,
written down. It's
would it be okay if I try and jump as high as I can? Yeah, we'll let you do that.
Yeah, news for you. The camera's tracking him, so it's clear he was, he was doing something that was meant to be recorded. So,
Yeah.
I mean, it makes it. I mean, he could have prepared to do that.
Center frame in focus, right, Kosha? Not easy to do.
Well, there they are astronauts.
I
Yeah,
still have
yeah.
no idea whether Jeremy would do it or not. This is like, it sounds like he's saying it with his tongue in cheek and saying, "Oh, this is so ridiculous. They never would have done it. I never would have done it." But yeah, they would have done it.
You
I mean,
dwell
come on,
on
guys,
it,
what would
act
you
like
do
you
camera?
are.
It's not rocket science.
we can't hear anything, guys. Total audio chaos. Relax.
Yeah, I'll go ahead and say what I was saying.
All he's doing is holding a camera. It's not rocket science.
It's not rocket science. I'll tell you what, you mount a camera on your chest and try and get somebody jumping around on the fucking moon, falling down under mission parameters, and keep it focused and center frame, you asshole.
Really focused?
Please, with the name calling. Guys,
Why is he
come on,
yelling?
name calling.
Why is he getting so loud?
Me?
Rakia.
I think it's funny that you think that's easy.
Well, they did train specially for that. They took intense classes on photography.
Oh, absolutely.
Yeah.
And there's no focusing, really, I don't think, at that range. That's going to be with the camera set at about infinity because there's no zoom on it.
Awesome.
So all you have to do is pan.
Yep.
It's not rocket science.
Yeah, oh yeah. Easy.
Was it in the mission parameters to jump around like a bunny rabbit and risk the mission, the astronauts' lives?
Okay, so you have been lying.
The whole world.
Cool.
It's okay, Jeremy. You'll get your sentence out here.
I never will be.
In a minute.
I'll never be able to.
I believe you, dude.
Back to the dust, though. Has anybody ever kicked bull dust?
Guy interrupting you every time you start to speak on this subject.
Every time, I know.
Well, I am hoping at some point get the answer. You won't answer.
Bro, if it's in the mission parameters, sure, I'll jump around like a bunny rabbit, risk the whole mission, risk my
is that
partner's
risking
life,
the mission?
my life.
Well, he cut you off again.
Would you risk your life?
I'll never be able to. As long as it's in the
You're
mission
saying
parameters,
it so cocksure of yourself, like you wouldn't do it. I know you're a dishonest person. It's very difficult to tell what you're saying because you're so dishonest.
Third time today. What is wrong with you guys? I am not.
Three different people, right? Isn't it three different people? Too?
Yeah. I am not a dishonest person. I don't know where you guys came up with this.
Well, what you've been saying this whole time. You're saying every time you say it, you would say things like, I would risk the whole mission, as if you're saying that you wouldn't risk the whole mission. So it's hard to tell what you're, and you are typically very dishonest in your, at least intellectually. So it's hard to tell whether you're being tongue-in-cheek. It's hard to tell whether you're being tongue-in-cheek with this or whether you're saying, yes, you would do it.
Yes, sir.
As long as it's in the mission parameters, okay, to bounce around like a bunny rabbit, risk my life, my partner's life, the whole mission in front of the whole stage of the whole world on the most dangerous environment man has ever been, sure, I'd do it.
Okay, so you are once again not answering.
I said yes.
That's his answer, man. Did you
no, because the way you're saying it is leaving it as saying that it's unacceptable risk.
Does it sound crazy?
The way you're saying it does.
Is that is that what happened?
They did it.
Is that what happened?
No, the way they actually did it. Is that crazy that they were jumping around and falling down on being kind of reckless, not being careful? Because when I go buddy diving, you know what I'm saying? When I go scuba diving around the rig and I have a buddy and he's being a fool, I'm pissed because he's risking my life.
I wonder if
you don't think astronauts are like that?
As long as it's in the mission
Just
parameters. As long as it's in the mission parameters, Rocky, that's all that matters.
See, look at that. You are so dishonest, man. You're disgusting. Fuck you. I'm leaving.
What's up?
Yeah, see you later, buddy.
Bye, Moyak.
He just
Guys,
had to
stop
get
picking-
that dishonest in there.
See you, mate.
Stop pissing off
No,
Moyak.
see you, Moyak.
It was good to see
you,
you.
buddy. Have a good day. Enjoy your time at Jim's.
Listen, man,
They'll really like him over there. He fits in
I
really
don't-
good over there.
as long as it's in the mission parameters to jump around like a maniac and fall, risk cracking your shield, risk your life, your partner's life, the whole mission in front of the whole world on the biggest mission humans have ever went on, the most dangerous environment ever, sure. Why not?
Yeah, that's true, man.
Dude, do you know how careful, like when we climb scaffolding just 12 feet up, right? You know how careful we are? Now, I know that's nowhere near the parameters of the moon, but why are we being so much more careful than these astronauts that are on the moon?
Mission parameters,
Which have way more to risk, right?
Mission parameters. That's all you need to worry about.
Yeah, I heard him say it. Hey, man.
I don't think I heard. Can you repeat it one more time? I didn't hear it at all.
Mission
They say it's
parameters.
okay, hop around.
Okay, got it.
Mission
Mission parameters. Now we're
Mission
caught up.
parameters.
The parameters of the mission.
Hey, if that's what they asked for, you got to give it to them.
Yeah, I mean, I don't know.
Joe Blow, astronaut number one's gonna film you hopping around and doing science. Maybe he was like trying to scratch the ground up with his knee, taking soil samples as he fell down or something. It does look strange, though. I have to give whoever's saying it looks strange.
I reckon if you opened a bag of cement up,
It does
rip the bag open, you
appear
kicked it.
like, I don't know. I guess I don't know what it would look like on the moon, but it does look weird. Yeah, if that's what the contractor set the parameters at, that's what I would do, I guess. Or I would like use a little common sense and say, maybe I need to be careful.
Rocky, you're roboting, or is it me?
No, I get like suits.
Oh, I definitely wouldn't do it. I'd be very careful.
What if
That's
the
because
mission
I'm a
parameter
pussy.
said it? What if the mission parameter said to do it though?
Oh, I don't. I'd get my buddy to do it, but I don't know. I'd be pretty scared.
Bro, your buddy's the one that takes off the rocket. If he dies, you're dead.
Oh, well, at least I won't be to blame.
In the blame game, that's what you like to do. I'm not even wearing the right outfit for that.
Does that outfit involve a red ball that you insert into your mouth?
Foolish, we were talking about the Atvos effect. We did all this before.
Oh, cool.
Don't make me repeat it.
I just asked if you heard of it, which I thought was a pretty simple question.
Yeah.
The other question I asked, which was a really simple question you could answer really shortly, because I assume you're on your phone. I try not to ask long questions when people are on their phone. Is, are you talking about a ballistic object in motion following the line of the equator?
No, they're talking about there is no Coriolis effect at the equator.
Yeah, no, I agree with that. So, but to have an effect, an object's got to be in motion, yeah?
You guys got to start being more specific about there's no Coriolis at the equator. That statement in and of itself is false.
Of course it is.
Well, actually, I mean, if you want to be really pedantic, I'm going to kind of steal man Jeremy here. You're kind of right, because it's two forces in equilibrium, so it's two forces cancelling each other out.
No, that's not why. That's not why, Druth. It's wrong because you could drop something at the equator and see the Coriolis effect.
You could drop something.
Yeah.
Yeah.
So if you travel horizontally across the surface anywhere on Earth except the equator, you'll experience Coriolis. If you travel east-west on the equator without changing elevation, you won't experience Coriolis.
Mm-hmm.
You won't experience Coriolis. But if you travel up or down, raising or lowering altitude, anywhere on the surface of the Earth, you will experience Coriolis. There's only one circumstance where you will not experience Coriolis, and that's if you don't change altitude, but you do travel across the Earth only east to west on the equator. You will not experience Coriolis.
How do you experience it?
You experience it, your path will deviate from its like a trajectory that it's supposed to be on.
Give me an example of that.
You shoot a bullet and it fires straight out of your gun, but it doesn't end up straight where the head of where the bullet is.
Well, if you aim on target, it will. Use a good scope.
Well, depends on
true
how
that.
accurate you're going to be.
So you're saying that if I
look, 25 miles, you'll be off by 100 yards if you're shooting north.
Yeah.
So you're saying that you're saying that if I true my scope shooting east to west at long distances, I really true my scope up really good, and I'm confident I can really shoot on target in west direction or something, and then I try to shoot north, it'll fire off to the
100 yards over 25 miles.
It'll end up missing to the right.
100 yards, yes, to the right.
Right, and then you say that it'll fire off to the right. And then
100 yards.
Hang on a second. And then are you also saying that if I then spin around and I shoot in the south, I'll hit 100 yards off to the left?
Yeah, pretty much. If you shoot
I don't agree with that. You would actually have to prove that. That's a wild claim.
I can help that with the claim. Do you do shooting, Crespo? Because it sounds like
25 miles.
No, not 25 miles. I'm going to use a different example. This will just take that. Have you had experience of treeing up a scope? Yeah.
Oh well, you know how it works, and I haven't shot a lot.
No. Have you zeroed a scope yourself?
No. Oh no.
No. That's fine. It's not a gotcha or anything. So normally, what you do when you're zeroing in a scope, you're zeroing in a scope for a certain distance. Yeah, 100 yards is general with both rifles, maybe 200 yards depending on what you're using it for. Now, when I shoot out to say, if I say I want to shoot out to say 600 yards, that scope is not going to be on target for that. Yeah, I have to account for that extra distance.
No, we're saying we're on a range east to west.
Yeah. All I'm doing here is just saying that when you zero in a scope, you zero in a scope for a particular distance, and then you have the accuracy of the gun itself. So pretty much, if you're shooting anything up to 1,000 yards, it's the square root of fuck all difference. One of my favorite phrases. Once you start, yeah, I know. When you start shooting out longer distance, it's an exponential error. Yeah. So that change in direction is getting more. It's like the 8 inches per mile squared thing that you guys love.
So it should be able to be demonstrated quite easily, right? You should be able to shoot east, shoot west, shoot north, shoot south, and then say, "Hey, look, on the north and south, it missed to the east both times."
Yeah, and there's a video on YouTube that shows that effect and also the Eotvos effect as well.
So, Jeremy, hold on. I want to know what you say, not whether it's right or wrong. What does the globe model say about Coriolis at the equator? Not whether you agree with it or not. What does it say?
It says that Coriolis could definitely happen at the equator. And it definitely will happen.
So if you Google, if you do a Google search and you look for a Google search, will it show those results?
Whoever's saying Coriolis, listen, this is a very specific phrase. Okay, Coriolis does not happen at the equator. That is wrong in and of itself.
So let's put it very simply. If we have an object traveling south, north of the equator, it deflects to the right. If we have an object traveling south, south of the equator, it deflects to the left. What happens between those 2 points? Does it deflect to the right, to the left, or nowhere?
So if you're asking me, that's a whole different question than Coriolis.
No, it's not. It's the same fucking question.
Then no.
That's exactly what I'm saying.
Kosho just agreed with me that Coriolis can't. Kosho literally just agreed with me. Coriolis can happen at the equator.
Yeah, Jeremy's talking about either Eotvos or dropping an object from a tower.
Oh, no, but Eotvos won't happen at the equator.
Eotvos does, absolutely.
Oh,
the
you said
greatest
because it
of the
goes,
equator.
yeah, but it doesn't deviate. Yeah, it doesn't deviate left or right,
Yeah.
but it deviates up or down. That's right.
Right. But dropping
Right.
something from a tower is a Coriolis effect as well, not the characteristic
It's the
or
Coriolis
vernacular that we.
effect.
So if you drop something
The
from a
Coriolis
1,000-foot tower, you will have a Coriolis effect when you drop that ball.
The
And it'll go
Coriolis
eastward.
effect. Are
Sorry,
you saying
what's
a Coriolis effect? It's called the Coriolis effect.
But they're
Because they
different
think there's
effects.
many of them, Jeremy.
there's a lot of effects that are part of this viewing an object's deviation from a rotating reference frame. Now, the one that they traditionally refer to is the one that Kosho is implying, and others were implying. Not dropping from a tower and not Diodbos. Everything but those two.
Okay, is dropping something from a tower, does that have a different name than the Coriolis effect?
Now, see, that's where the confusion starts. Is there's a Coriolis effect overarching
Don't answer my
term.
question. Go on
And
to something else.
I'm going to answer your question. If you don't like the fact that I'm answering your question, you can just shut up for a second. Okay. Now, the overarching Coriolis effect term is used for components in different directions. The one that's in the horizontal component for north-south travel is also called a Coriolis effect. That's where the confusion is.
Nobody's confused. Xanix's confused. He's saying it's a different type. I asked if they're... Dude, I can't stand when you don't answer my questions,
You just
but you
got done
think you're
explaining
answering
what
them.
we talk about when we say Coriolis.
Hold on, man. I wasn't done, dude. Is there a different... Xanix said this is a different type. I'm wondering, does this type have a different name, or is it just called the Coriolis effect when we drop something?
No, I gave the
Obfuscate
example.
again. Maybe
It doesn't have a
Zendukas
different
and
name.
obfuscate again.
It doesn't have a different name. But do
Maybe
you hear the thing I said?
Zendukas and obfuscate again, like he's been doing all day with the Coriolis effect. And all the questions he gets asked ever. Can't stand talking to this guy. Worthless. It's worthless talking to you guys. Some of you guys.
Yeah, did you hear the thing I said earlier about the Q-tips? Because it's a lot like that, dude. There's the specific brand called Q-tips, but it doesn't matter if it's a store-bought brand or whatever brand. They're all called Q-tips, right? So the general called Q-tips, but the specific item is actually called Q-tips also. So it's the same sort of confusion. It's like the entire in any movement any deviation as seen from a rotating frame, from an object moving in reference to that frame, is you're going to experience a Coriolis effect. But the one we normally talk about is a specific one of those Coriolis effects, and it's also called Coriolis effect.
Okay, let me phrase it in a different way. If I put in a Coriolis calculator that I am moving a certain distance, speed, and I put the latitude as 0, what will the results be?
Never seen a Coriolis calculator.
There's
Are you going to change your tangential? Are you going to change your tangential? Can you change your tangential?
Doesn't matter.
Hold on, man. Hold on.
Excuse me. Can you change your tangential speed at the equator?
No.
That's wrong. That's wrong.
How do you change it at the equator?
You go up or down.
But I'm going to walk, okay? Let me say I'm walking. I'm staying on the surface.
So this is a whole different thing then. That's what I said. This is a whole nother state. This is a whole nother thing than saying Coriolis doesn't happen at the equator. That statement is wrong. If you want to phrase it some other way, you might make a correct statement. But that one in and of itself is not correct. What do you guys not understand?
When we're talking about...
Osho already told you I'm right.
There's something that I don't
Xanix
understand,
knows I'm
right?
right.
I want these guys to sort of clarify something I'm thinking about, right? You're saying that Coriolis effect with ballistics doesn't happen at the equator. So am I right in saying...
Sorry if you hear me.
This is what I'm trying to think, right? So if I'm standing on the equator, I shoot a bullet north and I shoot a bullet south, there will be no deviation.
No, that's not true.
Is that what you're saying?
No. It's very... The quote that he was reading is very specific, and even in that case, you're going to experience Coriolis. If you're standing at the equator and you fire it north or south, yeah, you're going to experience Coriolis.
But the deviation will be up and down instead.
No. It'll be left and right.
Okay, but that's because that's the question that I first posed. I said, right, I'm standing on the equator. I drew the gun up to firing west and east. It's firing just fine. And then I try to shoot it north and then shoot it south, well, the deviation will be east in both cases, right?
Yeah, I think no. Yes.
The Earth is moving west. Yeah.
Yes.
So
No, the Earth is moving east. Yeah.
No, the sun rises in the east and sets in the west.
Yeah, because that's where the sun's moving. It goes towards the east. That's why the sun rises in the east, because it's.
Okay, it moves from west to east. Okay, so the bullet will deviate towards the west, right?
Towards the east is right. Because think about it, if the bullet's going, if you're shooting north though, did you say south or north?
North and south.
Well, if you're at the equator and you shoot it north, the bullet is going fastest eastward at the equator. So when it gets north, it's going to be deviating eastward. Then it's then its target, because it's moving faster eastward than its target is.
Righto. Okay, and then in south, it's also going to be eastward, right?
Yeah, I believe so. Yeah.
Did you guys catch that, or?
I'm wrapping my head around it. So you're saying that the effect is negligible at the equator, though, because it's not the amount of rotation is minimal.
No. So for things like the Foucault's pendulum, which is another example of Coriolis effect, Foucault's pendulum is not going to precess at the equator. That's also true. But
so there's no Coriolis at the equator. But you just said there is now with the bullet. Which one is it, Coach?
The bullet's traveling away from the equator, right? So we're giving him that. But like because you're talking about like something minuscule. Okay, let's just make a good example, an easy math example. Let's say we're at 45 degrees latitude, so we're expecting just half the rotation, right? So that's easy to understand. So what's the rotation at the equator? Anyone got that?
I think it's half at 60 degrees north. I think you got to go to 60 degrees before it's half.
Yeah, okay, you might be right.
No, it's not right. Nothing, absolutely nothing he said is right.
No, it's got to be 45. 45. No, it would have to be half at 45.
No, it's just half.
That's
at
half
60.
the radius.
It's half at 60.
Nothing you said is right.
How would you be?
Nothing is right. You know why? Because the Earth ain't spinning. There ain't no Coriolis effect on the Earth. Do you understand that?
I'm trying to lay this out.
That's why Foucault pendulums work perfectly, because
you're playing in their game.
Can we please stay on topic for just a minute? Like goldfish stuff. I just want to quickly flesh this out. So let's say we're at 60 degrees. No one's at 60 degrees latitude. Let's say 40. Why would you say half at 60?
St. Petersburg is.
Okay, hold on, Coach.
So 45 degrees.
I have a chart, and you can plug in the latitude of 60 degrees, and it'll multiply a factor, and that factor is at 60 degrees 0.7. Sorry, 0.7 of the value than it would be at the equator. And as you go higher and higher,
assume the Earth is turning.
Hey,
does your calculator assume the Earth is turning? Yes or no?
Yes, absolutely.
There you go.
Because
Game over.
It knows. That's why it uses that information of the spinning Earth to make its calculation. And the calculation
it knows it's spinning. Right. Got it.
Yes, because they tested it and they measure it and they understand it. That's how they make the chart.
Side chat, because
60 degrees would be a 0.9 effect on the output of that calculator I've just posted.
There's zero effect. You can show 1 inch of deviation, not show 1 centimeter of deviation.
The Foucault pendulum shows deviation.
That doesn't work.
And the deviation you want to shoot north is 100 yards to the right.
Recreate the football that was made due to the Coriolis. Show me that.
I've said this over 1,000 times to you. You shoot the artillery north, it misses the target by 100 yards. You hit it south, you miss it 100 yards to the opposite side. So it's not
when you're shooting
of function or error inside the muzzle or chambers of the gun.
What do we shoot in 25 miles?
It is strictly due to Coriolis. This is why they have that. That's why they measure it. That's why they've measured these charts.
25 miles.
Information. God damn it. They've measured this
Go with
information.
8 miles.
They put it
8
in a
miles
chart. They've actually got you in manuals how to adjust those long-range artillery so you don't miss your target. It's known. It's proven. There's factual. There's data to support it. SE, you're being really idiotic.
I know,
Okay,
but
so you're
Shep
saying,
is-
Smarty Pants, that the Earth is turning underneath the cannonball, right?
Why would it
Causing
turn
Shep was already answering the question.
Hold on.
Coach, he's talking to me. Hold on.
Shep is in the
The
middle of
Earth
the
does
question.
not turn underneath you unless you are shooting something south in the northern hemisphere.
Okay, so we're shooting something south. It deviates, so the Earth is turning under the cannonball.
No,
Correct?
motherfucker.
Zanuck?
The Earth ain't turning underneath you. You flying past the Earth. The Earth appears to turn under you. You are moving faster than the ground. The Earth is not turning under you.
You're not helping anything.
You an extremist is been making this shit ugly all day, bro.
A very low tangential velocity, and you go to a very high tangential velocity. So yes, it'll appear that the cannonball has the Earth spinning underneath it, when in
Okay.
fact it's actually going straight.
This is a long interruption.
Almost done. With respect to the Earth, it looks like it is going to the right. It is going eastward. When in fact, it is actually going straight.
everybody's. I think everybody's.
Can I just finish the last part
No,
of the
you
sentence?
can't. You can't.
Can I?
Sorry,
No, I
you're-
can't. I
no,
can't. Shut the
no,
fuck
Zanuck,
up.
Zanuck,
You moron.
you're not-
Shut the fuck up.
Nobody's listening.
You shut the
Zanuck,
fuck
nobody's
up.
listening.
Just shut up.
Everybody
Just
switched
shut the
off. Nobody's
fucking
listening.
open mouth trap.
Zanuck,
Stop it.
nobody wants to hear what
Stop
you've got to
it.
say.
We're not listening to you.
You cut me
Stop
off.
it.
You
Stop it.
stopped me
I didn't
from
cut anything.
asking
I was
my question.
explaining
I
how the
haven't
Earth
even
rotates
gotten halfway through the question
south,
yet.
and you're still
I'm just trying to
talking.
get to a
What the fuck is
ballpark
wrong, Jeremy?
figure
Can you
we
please
can walk-
moderate,
that we
please?
can work with here.
Jeremy, can you please
Let's
moderate?
Hold on,
through
Shep.
this-
Zanuck, he's trying to tell you
Yeah.
that you interrupted him. He's been
I
trying to
didn't.
ask a question. Yeah,
You
you
did.
did. You really
You
did.
did.
No, I didn't. I was
You
talking
did.
to
And since then,
interrupted-
as he responded,
I was
you guys
talking
were
to
going back
SC
and
at the
forth.
same time.
You interrupted me to go on a 5-minute diatribe.
No diatribe. I was diatribe telling you to shut up.
Yeah, you did. You did.
It was a
Okay, so-
diatribe to tell you to shut up.
Either
Right, so
remember, no,
basically-
Zanuck, you brought up that chart because he was saying something about 60 degrees north. He was trying to ask a question, and he pulled up the chart. And since then, you guys have been talking with the SC back and forth. But he's in the middle of trying to ask a question.
Yeah. Basically, I just want to finish asking the question so we can actually get to something real here. So, if you've got okay, let's just pick a latitude. Let's say 30 degrees, something like that, something easy, or 45 degrees, something like that, where people actually live. If you calculate how much Coriolis effect would let's just choose. Let's say you're shooting a really far distance. I don't know. Let's say 800 meters or something. Over that distance, and depending on how fast the bullet's traveling, pick a general bullet speed and a standard latitude here, and let's say, okay, how much should the bullet move? Okay, and can we get an example showing that in the real world?
Yeah, negative
where
6
they
mils.
shoot west, absolutely
Just
on
told
target.
you, 60
And then
degrees.
We get a camera and a scope and all the rest of
You
it.
take the value.
Be able to
The
demonstrate.
value that you would have the equator.
Good having
You
the math and
multiply it
come
times.
through and saying this is
You
how it should
multiply
be.
it times
It's all good
0.77.
having
Zanuck, let him finish, man.
He's done.
Yeah,
He's just
no,
babbling.
Zanuck don't want this, bro. I've for 2 years asked Zanuck about this. He doesn't want it, man.
It's all good. It's all good.
I do want it. I'm telling him the answer.
You're not listening to what he's asking for,
I did.
Zanuck.
You're at
You think
40 degrees. You're at 40
He
degrees.
wants
Where
a
we all
practical
live.
demonstration.
You're
You're not
shifting
hearing
north.
it, Zanuck.
You got a deviation of 6 mils.
I don't think. Look,
Fine.
Zanuck, I'm trying to explain it in a way that everybody
You can't
can
explain
understand.
it 'cause you're being
I
ridiculous.
don't want you to just fire off and go. I think I know what you're asking already. I'm just going to answer it. Please just let me elaborate and just ask the question, finish the question nicely, so everyone can understand what we're talking about. So let's calculate and see if you can you actually. It's all good having a theory and an idea of what it should be and how it should be and everything, but can we actually demonstrate the idea of how much Coriolis should be occurring over that distance? And
That's why there's charts made up in the military to address that specifically. And if you're at 40 degrees, you take the equatorial values and multiply them times 0.77. The value for that deviation is about 6 or 0.7 mils. And so you take 70% of 0.7 mils, and that's your value.
Right. Now show it.
So not 0.7, 7 mils. They show it every day. They're on the freaking firing range. For, you said a 500 meter? 500 meter or 1,000 meter? I'm using 1,000 meter. 1,000 meter, about 7 mil, okay, of deviation. And that's repeatable, understandable, measurable, quantifiable, done all the time. It's known. That's why they have charts. That's why they fucking made charts for it.
Do
What's wrong with you?
Do these people shoot in the southern hemisphere ever?
Everywhere, north or south, yes.
Well, how do you know? Like, I'm just saying, like, let's account for all possibilities here. How do you know that it's not the strength of the Magnus effect changing?
Because they can change directions and see the same exact effect in the opposite direction.
How do you know they're even hitting these spots and they don't?
Come on.
Seriously. No, seriously.
Oh, come on.
Seriously.
They've done. This is one of the most widely tested ideas and theories and actual data acquired that there is. Shooting is a big deal for everybody on this planet, especially in the military. That's why they have manuals that put this chart in there so that you can use it and be more accurate. If it wasn't true, they wouldn't have put it in there.
That's ridiculous, Zanuck.
You're ridiculous.
No, that's ridiculous for you. That's your opinion. That's only
Not
your
my opinion. It's the Navy's opinion. It's the Army's opinion. It's the Marines' opinion.
It's not a skeptical opinion, Zanuck.
What do you mean?
No, hold on just a second. Just think about it for just a second. If they put these corrections in here for the field artillery to employ, what you're suggesting is that they could have put those corrections in there for something that doesn't exist. That they would make themselves less accurate. Let me
get them for 2 seconds.
I'll finish my point at some point. That they would make themselves less. That they would make themselves less accurate on purpose.
No, okay.
I'm saying. How do you know that that's not accounting for an increasing strength of a Magnus effect?
There could be another variable.
For here.
We need to kill ignorant. You guys
obviously would be the same direction.
Like fucking everything, man. Zanuck, take fucking turns, bro. Take fucking turns. You bow to authority. You're saying that, they put it in there and it would make it wrong and this and this. You guys are telling me over 20 miles, there's like a percentage fucking difference anyway in the accuracy. Like 1 to 3
yards. 100 yards.
Right, so it's tiny. So the point is in there.
Difference.
Oh my god, dude!
You're shooting a bunch of tanks. You're shooting a bunch of tanks, and you're 100 yards off. You're a moron for being a flat earther because you just got your ass shot.
Show me success.
They use the
Show me success.
Kill you.
Show me a successful barrage on a tank from fucking 25 miles. Show me the evidence of it.
Right.
I have the military manual.
Presented is for charge 7 match charges. That only goes up to 11.5 kilometers. Okay?
5 miles.
That's not 25 miles. Granted. However, there's still an effect here that needs to be addressed that they are correcting for. It's not the Magnus effect.
But you to say that they would make it worse, Doofus, when it's such a tiny piece, even though Zanuck is right, obviously you want every fucking titty hair you can get when you're fucking shooting, right? But the point is if it's so negligible, it's going to take large data sets for the feedback to get back from the field, from the soldiers, back to command. Hey, you guys don't have enough data. You ain't fucking sitting here going, you know what? This extra little 1% that we're adding on, that's got to be the fucking problem. Fucking clown.
Right. So if we have a direction that we need to fire, and that direction needs to be adjusted for an effect that we're correcting for, you're suggesting that it's possible that effect is not there.
And it's possible that the chaotic wind will add in that extra 1 to 3% to make
turn around and have the same effect in the direction.
I mean, get real.
No, you get real.
The Met data that you're provided and the correction tables for that Met data, that's all going to take care of that, Don. Everything after meteorological data is rotation of the Earth. What now?
Dude, you know, we've talked about the Met data before, but it doesn't give you every little strand of burst of the wind. And that's that extra little piece of chaos could be 1%, Doofus, right? Like we're talking 1% or less, man.
All right.
That's tiny margin.
You're making things up.
You're trying to get as close as possible. And so what they've discovered is that they need to account for this extra thing. On average, this is what they do.
When did they discover it and show the practical? Show it. You guys don't have any fucking demonstration of this.
We do.
Right. So the information provided to you, this is a manual that's decades old. This is where it comes from.
Yeah,
Yeah, come back with it. I'm sorry I bullied you, buddy, but don't get them away with this fucking random anecdotal evidence. It's not
random. It's not anecdotal. It's measurable.
No, wait, what's meant by Mills here?
Setup, bro.
I'm trying to understand what's being said here. What's meant by Mills in the chart there?
Mills are 6,400 per circle.
Okay.
So instead of 360 degrees, it's 6,400 all the way around.
Oh, so it's just a half a degree.
No. For what? For how much?
20 times.
Oh wait, 640 right now. Okay, yeah, not 720. Okay. Why 640? Okay, that's strange.
6,400.
Oh.
Whatever that is. How many is that? 17.
So if we're if we're doing the azimuth correction in Mills, the azimuth correction is only for east-west shots. Or wait, hold on. Yeah, the azimuth correction, sorry, that's for north-south shots. Where the fuck is it?
Well, yeah, I don't think any of us here are weapons experts per se. But to get to the point here, is there nothing else that could be causing it?
No. So another thing is, so the second chart talks about the corrections to the range. Notice how there's minus signs for Mills on the range with one azimuthal location, and then there's positive on the others because you're either going with the spin or against the spin. That means the shell is becoming lighter or heavier depending on the direction you're shooting it. That's another form of Coriolis, and that also is due to rotation. Why do you think they have these charts, dude? Come on.
Yeah, the biggest correction they have at 11K is 28. So 28 meters for your east and west firing.
Can we? This is all good having it in a chart, but is this able to be demonstrated?
They use it every time. They don't. So the whole point is.
I'm sure. Okay, well, I'm sure there must be a training video.
Constantly account for something that is not there. What they're doing is they're making themselves less accurate on purpose. Is that the suggestion you want to go with?
No, I'm not suggesting. I'm absolutely not suggesting anything. I'm not suggesting.
28 meters.
Don't straw man. Don't straw man.
28 meters when you're shooting one way.
Not up with your fucking
the other way.
Excuse me, Zanik. You directed
no,
something.
Not excuse. You're talking the whole time.
No. You just directed a question at me.
We have the.
Zanik, shut up.
You shut up. You want to rant for 5 minutes.
I'll just mute. Sorry, Zanik. I'm just going to mute you on mine because I was having a discussion with somebody there. So I'm not saying that's not what I'm saying. That's a straw man. I'm not saying that they're shooting inaccurately on purpose. What I'm saying is, do we have an example of them actually using it in demonstrating this effect and demonstrating them? Say a training video or something like that for ballistics officers.
But they use the chart in order to come up with a firing solution for where they're firing. The demonstration is the proof. The proof is in the pudding. They're shooting with this correction table.
Where's the fucking pudding?
They're shooting with this correction table to get the shot.
How do we know?
With this correction table to get the shot.
I can smell it. I've been told about this pudding. I'd like to see it.
Don, shut up.
Both of you are absolutely incapable of letting me finish. That's great.
You're incapable of
using this table.
Don, you're just talking shit. Let him talk.
We get your fucking point. We have other points. We get your point.
They're using this correction table to arrive at a more accurate shot.
Prove it.
They use the table every single time. If they use the table to correct for something that does not exist, they are causing themselves to be less accurate.
Don't say on purpose, though.
That is what they would have to be doing on purpose. They put it in their own fucking. They put it in their own fucking manual, didn't they?
But they didn't have to be making themselves worse on purpose. They put it in their manual on purpose, thinking it was going to make them better, but they were mistaken. They did it by mistake.
Okay, so they're making themselves less accurate by mistake.
Yes, possibly. That's our point.
Oh, that's great, Don. That's totally different.
Hey, training video or something showing a demonstration would be awesome. I'm not saying that you're wrong, but I'm saying it would really support your point.
Right. So here's the thing, because since this is decades old information we're going on here, over the course of all of that time, they would have by now come up with other corrections if the corrections that they were employing were making them less accurate.
Nah, no
Okay,
one's
so
doing
you're saying, hold on. He's saying if I go from the equator, he's saying if I go from the equator and I shoot north, my bullet deviates east. But if I turn around and shoot south, my bullet doesn't deviate east. Then if it doesn't, that's not fucking Earth rotation causing it.
It does.
Yes, it would still be
Same
Earth rotation
deviation.
causing it. Because if you're at the equator and you're firing to lower tangential area, you're going to have
What are you talking about,
bullet
dude?
lead. You're going to have the bullet lead, which makes it go east. And if you
So
fire
one time
south,
you have it going against.
if you fire south from the equator, then you would have the exact same thing happen. The bullet would lead. It would go east.
Okay, so you say it would go. Okay, so it's going to go left if I shoot.
Left's going
the
south,
and it's
right
gonna
going north. What is wrong with you, Brian?
Hold on, guys.
We
Can
want,
you
okay, now he's asking you for demonstration over
I know, I
and
have a
over
demonstration,
and over
dude.
and over.
I have a
So show it.
demonstration. I have a demonstration. I need to ask a question though. What angle is when your heading is east? What angle is that? Does anybody know?
Wait, let me get this straight with you, Coach Joe, because I can't talk to
Oh,
the guy.
okay. Yeah, but answer my question first, real quick, because I'm on time.
Yeah,
Time
but I need,
punches here.
to answer that, I need clarity on something.
Okay.
So they're saying that if I'm at the equator and I shoot south.
Okay, never
the
mind.
bullet's
I just
gonna-
need to know what angle is real quick. Otherwise, I can't show you the demonstration. I have a couple seconds. 90. Thank you, Brad. Thank you.
It's going, bro. You got to tell me which way it's going. So if I'm at the equator and I shoot south, the bullet's gonna deviate to the left. Is that correct? And then if I'm at the equator shooting north, it's gonna deviate to the right. Is that correct?
Yeah.
Okay, so it's gonna deviate right, left.
And here it is.
One way or right?
Real
Yeah.
quick
Yeah,
overview.
it would deviate to the left in the south. We're shooting south, and it would deviate to the right, shooting north. Is what the claim is.
Okay. Now.
So
Now
Kosho,
what's your question, Kosho?
Kosho is just wanting to clarify that as an azimuth, as a on a coordinate system that say east would be 90 degrees, right? Because 90 degrees from north. Right? So what were you wanting to explain, Kosho?
I'm trying to write something down. I have a demonstration, is what I'm saying.
Righto.
Give me a second, though.
I'm ready for your question. I just wanted to know what direction before I could give you an angle.
I'm sorry. Yeah, I was on a time crunch. Otherwise, I can't show it to you because it's ISS. Okay, it's ISS. Just so you know. Okay. Alrighty. All right. There we go. Let me just make sure this is correct before I show it to you. Okay. Yeah, it is. Okay. Perfect. Okay. Okay, hold on 1 second. There, it's up there. Perfect. Okay, so all I did was I went to Astro Viewer. I'll just show my screen. My screen. Anyways, I went to Astro Viewer to find where is the ISS right now. Okay, where's the ISS right now? And since I don't really have it, I waited till it was going directly east. So that's why I had a time crunch. So I waited till it was going directly east, and I took its position. Okay, so I did this before without going to Walter Bislin's, but I went to Walter Bislin's because he has a Coriolis calculator, and in his Coriolis calculator, he wants you to put in your speed, which I did, the heading 90 degrees, the longitude and latitude starts right there. Okay, so the great circle for this route is not going to be the same path because of Coriolis. However, this path matches the ISS's path, right? Otherwise, how are they going to perfectly predict where it's going unless it's being unless they're accounting for Coriolis?
No. We're talking about trajectory from the ground and
It's
spin of
the
the
same
Earth
thing.
affecting it. It's not.
It is exactly. It's the same thing except for you have less air. You have less room for outside effects because it's just yeah.
Oh, dude! I know what this is. Oh God, this is so simple. I drew this like 2 or 3 years ago. Let me get my I drew it on a piece of paper. I made a graph and I drew it out.
All right. Well, the thing is that the ISS it almost never uses propulsion, Sometimes it does, but most
Yeah,
of the
yeah,
time it
'cause
doesn't. And so it's going to take a great circle route in reference to the axis of the Earth. So not in relationship to the actual surface of the Earth, because the Earth rotates. And so if you want to find out where it's going to be, you have to put in the great circle route, and then you have to account for Coriolis. And if
Look,
you get the exact path.
Okay, hold on. I just looked at Doofus's projection, and he has it. Okay, so say if I'm not at the equator, if I'm shooting toward the equator, I'm going to deviate to the east. But he's got it. If you're in the southern hemisphere, shooting toward the equator, he's got it deviating west.
He doesn't.
Diagram.
No, yeah, that's okay. If you're at the equator and you shoot south, it goes east. If you shoot north, it goes east. However, if you're south of the equator, shooting towards the equator from either direction, from either hemisphere, it goes north. I mean, it goes west. Sorry.
Yeah, well, see, that it can't be Earth rotation. Can't possibly be, because if your ball is exactly the same, okay, if the freaking north mirrors the south, then they would do the same thing. If you spin the globe away, it's gonna deviate, it's gonna mirror.
Yeah, you're roboting a little bit, but if Superman
mirroring.
Go ahead. You were roboting for a second.
No, go ahead.
If Superman was at the equator and he threw a football straight south, the football speed at the equator, the tangential speed would be about 1,038, and it will decrease from there. The tangential velocity of the surface of the Earth will decrease from there. So if he throws a football from the equator, no matter if he throws it north or if he throws it south, its fastest eastward speed, because of the rotation, is always going to be 1,038. And the surface of the Earth, no matter which direction he throws it, is going to be lower than that. So in either case, the ball is going to deviate eastward if he throws it from the equator.
Right, but that's not what he's showing.
It is what he's showing.
It's not. In some, because what he's showing is if I'm in the northern hemisphere, throwing the football toward the equator in the north, okay, and then doing the same thing from the south, he's got it going in opposite directions.
No, they both go westward.
That's not what he's showing. Look at his diagram. No, it ain't. If it's coming from the north, he's got the arrow going in one direction. If it's coming from the south, the arrow's going in the other direction.
Yeah, but if you throw it towards the equator, it's going the same direction. And if you throw it from the equator in either direction, it's going the same direction. That's what his thing shows.
Well, why? Okay, well, clear that up with him then.
No, that's what his thing is showing. Maybe you're not seeing it the same way, but yeah, if both the lines that are pointed towards the equator are going westward, and both the lines pointed away from the equator are going eastward.
I see what you got going on here. I see what you got going here.
The Coriolis will fuck with your brain. Trying to think about this shit.
It's not real, dude. It's fucking not real. All this bullshit y'all are showing. Then the next explanation when we ask for demonstrations is to explain why we don't see it. It's a joke, bro. You gotta give
it that's actually he has actually got a really good point.
It's too small.
Hold on.
You're talking here about if you fire north, right? Then it'll go to the right. You're saying it's eastward in both cases, but here he's showing firing south in the northern equator still misses to the right. That's not right. That's not
right or left though. They both go to the east if you fire away from the equator. They both go to the west if you fire towards the equator. That's it.
Yeah, shooting south from the equator, that's going to the left, that's east. Going north, that's going to the right, which is east. East is the common denominator between both of them, but left and right are not. Figure it out, guys. Come on.
All right, hold on. Before this blows up again, I was just going to say, Brian, did you hear what I said about the ISS? Because you said this doesn't happen. Do you have any response to why this would occur with the ISS then? Because the ISS...
You can't give me a natural. You can't give me a natural body in the sky, bro. You got to use something on the ground.
I'm not using a natural body. It's this. Despite the fact that it's a natural body or not, the fact is that it's traveling in a unimpeded. Like the path is not being affected by anything. Not until they do a thrust, which happens every so often. But most of the time, it's not being affected by anything. It's just going in. It's just going along, not affected by anything. So it's making a great circle path continuously, except for the fact that the Coriolis is going to change the position of the ground that it's directly over.
So its orbit. So its orbit is not. Its orbit is not predictable.
No, its orbit is predictable only if you use the Great Circle route and if you also include Coriolis.
Okay, show me something on the ground. Show me something on the ground that happened. If the Earth's rotating underneath the ISS, okay, then it's. And I got another question. Okay, man, I got too many questions, really. I mean, you say the Earth's rotating underneath certain shit, but then you say the air is moving with the fucking Earth. If the air is moving with the Earth, okay, if I'm on the ground rolling, there's no difference if I'm in the sky flying. There would be no difference. If
right.
Everything's moving, then if you had a train that traveled just one of the train tracks or whatever, say monorail, anything going north and south.
You're right, Brian.
And you'd have to change the fucking tires or something, whatever it is. You'd have to replace the rail or change the tires.
You wouldn't have to do that, but you're right. You're right what you're saying. You're right what you're saying. That the Coriolis happens when you're on the ground and when you're in the air. The only difference is the other things that are going into your movement. Like the reason I used ISS is because nothing else is affecting its movement, but almost nothing else. However, things on the ground, you have a lot of other things that are influencing its movement, like the wind, the power of whatever is powering it, all sorts of stuff.
How are you conserving momentum when there's no momentum?
There is momentum.
There's no momentum to conserve. No, there ain't. If I'm never changing reference frames, hold on, I'm never changing reference frames, bro. The reference frame I started from is you're saying moving in direction of speed, and then the reference frame going into there.
Throwing out terms, you have no idea what you're even talking about. Changing reference frame, conserving momentum. You have no idea what you're talking about. None.
Dude, I'm questioning shit, Zanuck. I know you can't comprehend anything outside of the box.
You're not using the right words.
No, he's actually correct, because what he's actually saying here is that
Janet, give me a definition. Sorry, go ahead.
If you're shooting something from the ground, right, you're taking the momentum from the ground at that position. If you're already in the sky, if you're already in the ISS going around it, then you're not taking that initial momentum of the ground reference frame. You're actually already
throwing out words you don't understand. You're making things up too. Stop.
No, shut up, Zanuck.
Okay. You're just using words. You have no idea what they mean.
Hold on, though.
The reference frame is
stop even talking about. You don't know what a reference frame is.
If you ever read the definition, Janet, if you ever read the definition,
I know
then
what
you'd understand what we're asking.
But
So
forget
shut
about
up.
the words he's using. Just let's.
If you're thinking about where the bullet is traveling, and the reference frame where that bullet was shot from, and where what the momentum was, either lateral momentum from that position or whatever, right? It's different from something that's already in the sky going round and round.
See,
I understand what I understand with the act. Why
don't you not use those words and tell us what you think? It'd be easier for us to understand.
I understand what you. I understand what you're talking about when you say that. That slightly changes in reference.
Let me give you an example.
Shut the fuck up, Zanuck. I have to fucking
let me try to explain it to you so you understand.
Sorry. I've just got to meet this cunt really quickly. So basically what you're saying is that I'm sorry. I just cannot speak.
I know.
So
I'll let you finish, but you have to let me finish then too, and I'll explain.
What you're saying is that in reference to the ground, as it's traveling around this pair in the sky, as it's traveling around it, the reference frame changes because it's coming closer to the axis and then further away from the axis, closer to the axis and further away from the axis. You're saying that the reference frame changes in that way.
No, stop using that word. Tell him to stop using that word.
The reference to axis is changing.
That word is in the definition. Shut up, Zanuck, for fuck's sake. Shut up.
Chubby, you do got to turn back up because he's gonna want to respond to when he's done. But
I don't want to talk to him.
I know. But
I was talking to you.
I'll talk to the group then.
Because you actually brought up the ISS. I was actually discussing it with you.
Well, let me give you 2 examples to help you understand what's really going on there.
No, you're making everything worse.
Danik, wait your turn, please. Wait your turn.
I'm going to
say something very quick, and I'm not.
You guys aren't going to stop, though. That's the only problem.
Yeah, but okay, so the thing is, when you're talking about something in the air, right? Its velocity eastward is going to be. Let's say there's no atmosphere. Okay, so we're not going to have any wind or anything like that. If you take off the ground, your velocity eastward is going to stay there unless you have rockets that are firing in that direction, so you slow down in that direction. You're going to keep that momentum regardless. And if you change your position on the Earth, you travel north or south or whatever, then the Earth, the surface of the Earth is going to be rotating faster or slower. Okay.
So submarines have to account for it too, right?
You're going to maintain that velocity when you left off the Earth.
Danik, we ain't talking to you. We're talking to Coach. Wait a minute. So submarines also have to account, right?
Yeah,
submarines have to account for Coriolis.
Yeah. But yeah, sorry, what's this? Yeah, right. Yeah. So when you take off the ground, like whatever velocity this craft had at that point, it's going to maintain until you get rid of it. Until you, I
get it. Conservation of momentum, yada yada, all the rest of it. I think I understand what you're saying about the Coriolis still applying to the ISS because it's going closer and further away from the point of rotation, the axis of the Earth.
And not quite, yeah. So the way I think about it, at least, is I don't think about its velocity when it left the Earth. I think about its velocity all the time, and it goes in great circles at 17.5 thousand miles per hour. So because it's not changing. It's not changing trajectory. It's not doing thrust or anything. So it's going to be just about. It's a good estimate to make it do a great circle at that.
So if I fly off in a tangent, then there's no Coriolis, correct?
Oh my God!
Shut up, Zanik. You have no clue what I'm asking.
I get it. Kosho, will you please let me know when it's my turn to speak?
Yeah, of course.
Yeah, I'll ask you a question next, Zanik. But one more for.
No, I don't want a question. I'm going to tell you something.
If I fly off in a tangent to the ground, there's no Coriolis, correct?
No.
He means east to west, right? 90 degrees, 270 degrees.
No, from the equator to the toward the North Pole. If I shoot a firearm at a tangent, okay, then there's no Coriolis. Am I to get that?
No,
correct?
there is Coriolis for all the reasons.
How could there be, Zanik? How could there be if I'm firing in a tangent?
Because
that's
the position of the firearm, releasing the bullet, going north, even if it's on a tangential path, which is basically perpendicular to a line struck to the core of the Earth at the equator. That position of that bullet, as it goes northward, will be continually diverging from the surface. But from the surface, it will appear to be curving. That effect is called Coriolis.
So if I lived on a cylinder, there'd still be Coriolis then. So the tangent doesn't matter. So if the Earth was a cylinder, we'd still have Coriolis. That's what you're saying.
Which direction? Not going north now. If the ends of the
doesn't matter. Doesn't matter.
It does matter.
South.
It does.
If on a cylinder.
If you had a cylinder, the surface is going to be parallel to your trajectory of the bullet being shot to the axis of rotation direction.
Yeah, that's why I said a tangent, because it represents a fucking cylinder.
Because when you're on the surface of the Earth, it's not a tangent
I'm
to
not
any other point.
giving you an example on the surface of the Earth.
Tangent means 1 point. Fucking A, Brian. Are you that stupid? Really?
Dude, you just described a tangent, okay, touching the ground near the equator. He just described it for the tangent touching the ground at the equator and going in a straight line, okay, which would be the path on a cylinder.
No, the cylinder doesn't have a tangent.
Hold on, if we're on the ground at the equator of a cylinder and we go north, okay,
that's stupid, really.
That's a straight line too, right, Zanik?
There's no tangent on the cylinder if it's going the length of the cylinder.
I know, but it's still a straight line, though, right, Zanik?
Yes, they are both straight lines, but there's no tangent and there's.
So why are you describing them differently than if they're both straight lines from a spin?
I'll tell you if you shut the fuck up.
You don't even understand the question, bro.
I do completely. I know how stupid you are. It's easy to think stupid.
No, you don't, bro. You're a dumbass. You don't understand, or you wouldn't be answering like this.
Stupid is easy. Smart is hard. Now, just pay attention. You might learn something. The cylinder is parallel to that line of the trajectory of that bullet.
So is the tangent, you fucking idiot!
Stop it! No, the sphere has a curved surface which goes to the axis of rotation. That position, those positions, relative to the surface, will change because they're curved.
Hold on, Brian. I got to temporarily mute. Listen,
Yeah.
guys, stop calling names. Next time people call names, I'm going to have to give official warnings. It's a 30-minute timeout from the server. And eventually after 10, it'll keep getting longer and longer. So if you want to participate in here, don't call names. Come on, guys. This is
like
easy.
my cock. My cock just gets longer and longer after 10 minutes.
Yeah, but here's the point.
Can I speak now? I will be very clear.
But understand my question first.
I
then.
understand your question perfectly.
If I took a,
trust me.
do you
trust
understand
me.
what I mean by
I
quit saying the
understand this-
ground? Then
Someone shut him up.
Quit saying
Please,
the ground.
mute Brian. You'll stop the chaos in here if I can just explain without
you
having to
go-
yell over him.
Before you go on a big diatribe, you need to actually understand what he's asking. Even
I
if you think
understand what
that-
he's asking.
No,
He
no,
thinks
you're
the straight
invalid-
line is the
you're-
same.
you're
Cespa,
invalidating
you are.
what he's saying.
Would you please mute these two clowns? Thank you. Okay, so we have a cylinder, we have a sphere.
You just call somebody a name.
No. Please
be a clown.
Please stop talking and I'll express it perfectly. So you have a steel cylinder. God, Jeremy, would you please mute him? It's taking 10 times longer than it needs to. It could be over right in like 10 seconds.
Hurry up and fucking say it.
So you got a sphere and you got a cylinder. Both have an axis of rotation. The sphere has a curved surface. The cylinder does not. Both guns are
Does a
fired.
tangent have a curved surface in it? Does a tangent have a curved surface?
Would you please shut him up so I can finish? Jeremy, shut it. You got to mute him because I can't even finish and you have no coherency unless he can be muted. So try to just baby yourself and not talk, Brian, for at least like 10 seconds. Okay. The tangents on the curve, there's no tangent on a sphere because you can't have a tangent on the sphere that direction parallel to its axis of rotation. Every point along that cylinder will have the same tangential velocity if it's rotating. Every point on the sphere will have a different tangential velocity. The gun being shot from the equator northward or one end of the sphere to the axis of rotation direction will have a same tangential velocity along its path versus a different tangential velocity along its path. Why? Because the sphere has different tangential velocities along its path. So when you're looking up at that particular object that was shot from the equator, it'll appear to curve as it rotates because it's not attached to the sphere in both cases. But it will be parallel.
Here's my point.
Oh my God.
My point was the bullet, okay, fired from the equator and a tangent. The tangent is at the equator, okay? The tangent is straight. So the bullet's going as if it were on a cylinder. It's getting higher off the ground. So if you were to take a piece of cardboard and wrap it around the sphere and only have it touch at the equator, if you only had it touch at the equator, okay, then the cardboard and okay. So if you fired a bullet from the equator or a projectile, and it
what part of this don't you get, Brian? You shoot the bullet on the cylinder. The tangential velocity remains the same. God damn it! Let me finish the sentence. Let me finish the sentence.
God damn it!
You're such a moron.
Let me finish the question. Why are you interrupting me, bro?
Because you were done. I'm trying to get it clear in your mind.
I'm not done, bro. I ain't even got to the fucking point. Shut up.
Hurry up then.
Now, if the cardboard represents a tangent all around the equator. That's the tangent point is where the cardboard touches. See? So now you don't get
you're
it.
saying the cardboard represents a tangent? What?
Yeah, where it touches the sphere at the equator all the way around. That's the only place the cardboard cylinder touches the sphere.
Tangents don't.
So if I fire, so in other words, my bullet is going in the direction of that cardboard, which is a cylinder shape. So you're saying there would still be Coriolis because you don't understand.
No Coriolis. Because every point along that cylinder is going the same. God, I can't believe I'm saying this again for the fourth time. Every point in that cylinder is going the same exact tangential velocity. Every point.
So now you
Cylinder.
understand.
So the momentum that you got because they're both rotating, that you still retain that, and it is exactly the same if it was to land or fall at any point on the cylinder. However, on the sphere, the tangential velocities are much less, and progressively less as you go toward the North Pole, the center axis of rotation.
So help him out, please.
So when you are looking at that point from the ground, the tangential velocities are different, so it'll appear to curve. Where on a cylinder, it will not.
You're not addressing the question. So now you're saying, okay, so now if I'm on a sphere, now a new question. If I'm on a sphere at the equator.
Because you didn't get the last one right?
No, you answered. I'll tell you why. If I'm on a sphere and I shoot the bullet in the direction that the cardboard cylinder, okay, the tangent. If my projectile is going the same direction that cylinder's going when it leaves the equator, and a straight line tangent, okay, following the cylinder path above the globe, you're still saying there'd be Coriolis just because there's a globe beneath us. But if my straight line is following the cylinder,
velocity. You
there
keep on
couldn't be
forgetting.
Coriolis.
You keep on forgetting it has a tangential velocity. You keep on forgetting that tangential velocity is different on the sphere at any point other than where it takes off from the tangent versus the cylinder.
So if I projectile,
oh my God,
hey,
Brian! Seriously, I'm trying to be patient with you, but you're trying my patience.
Bro, you don't understand the question.
I
obviously.
do understand. You're thinking.
No, you
because
don't.
You're shooting it straight. You're thinking that you're shooting it straight. It's in the same position above your heads all along that surface, but it's
not.
Because it's
No,
moving.
you don't understand the question, bro.
Of an object moving in a rotating reference frame. That is a definition.
I just said,
of course,
Danik,
a
that
reference frame.
the projectile is getting higher and higher off the ground, bro.
God. Oh
bro,
my
you got
God.
to understand the
It
question.
doesn't
You're
matter
just
if it's
talking to
getting
yourself.
higher.
You're literally talking to yourself, bro.
Are you
literally
brain dead? Seriously,
bro. You don't change my
officially
projectile.
brain dead.
Do not change my
You know what?
projectile.
This is the definition of insanity. Talking to a moron and trying to get different.
I get what he's saying. I'm just going to explain here both sides here. What's going on? I think there's a bit of miscommunication on both sides. Basically, what Zanik is saying is that the radius of the different latitude, there's a different speed that the ground is traveling in rotation of axis, like surface speed.
I understand that, bro. I totally understand that.
And basically, what Brian is saying is, if you shoot a bullet and, like, say, you get a flat piece of, like, a straight edge against a fucking basketball, right? And you're firing at that straight line. Why should it be any different, right? Let's say you're shooting north and you're firing towards the east. So you're actually already firing towards the right as it is.
You know what the problem is?
And you're matching the speed of the rotation.
No, you're this is true for a non-rotating
correction needed.
Okay, stop.
If you find it
stop. This is true for a non-rotating sphere and a non-rotating cylinder. Once you're rotating both of them, Coriolis is effect only on the sphere, not on the cylinder. And I have to explain why again. I have to shoot myself.
No,
Seriously.
dude. When you talk about my projectile this time, don't have it following the curve of the Earth. Okay.
I know.
Don't change my example. Here's my example. Here's my example. One more time. One more time. The projectile. Hold on. The projectile is getting higher and higher in altitude as it leaves the. Shut up, dude. The bullet or the projectile is getting higher and higher off the ground because you fired it from the equator up in the air on a tangent. You fired it in a straight line. So listen, let me finish, dude. Shut up, bro.
You don't need it. I understand perfectly what you're asking.
No, you don't.
You're being an idiot.
Bro, you don't understand my question.
I do understand it.
No, you don't.
I'll repeat it back to you. Let me repeat it back. I'll show you. That's a proof of understanding. You're saying that on a sphere, if I shot it on tangent from the equator, that it will continue to gain altitude because it's parallel to the axis of rotation. That's what you're saying. So by the time it gets to the North Pole, it is the same distance from the North Pole as it was on the surface to the center of axis rotation. That does not matter for.
Now, listen.
So you don't have to echo me. You don't have to echo me. Listen.
No. Listen, man. Listen.
Let
me get to the point.
I know exactly what your point is.
Bro, shut up. Can I fucking talk?
No, because I can't.
Yes, I'm gonna mute him in a second. Hold on, I'm driving, but I am
please,
gonna mute him
dude. You won't even listen. How could he understand if he won't listen?
Mute Brian. He's the one that's not fucking listening.
Zanik, relax.
I'll let him talk. Go ahead.
Yeah,
okay, please mute him. Literally just mute him.
I did.
Okay, so now my point is if the Earth, if we took the Earth, and we built up the ground from the equator toward the North Pole into a cylinder, then staying on the ground, would be the same direction as if all that dirt that we just built up into a cylinder on half the sphere eroded away and followed the tangent. Now the projectile's in the air because all the dirt's gone on that cylinder. Okay, so he's saying if we built the dirt up, that there wouldn't be Coriolis because it'd be a cylinder. But now the dirt eroded away and the bullet's now in the air instead of on the ground. Now he's saying that that there's still Coriolis. Now he's saying there's still Coriolis. First he's saying there wouldn't be on a cylinder, but going in the same direction as the cylinder, following that path, there would. So he's double speaking. I don't think he understands the question. Go ahead, Zenny.
I understand it perfectly. No, that you're just trying to extrapolate a non-rotating cylinder and sphere to your logic. You can't do that because it is rotating. So you have this momentum that has to be conserved, and it against the surface of a sphere would be. They're both in both cases are conserved, but they are now going the same tangential velocity all the way up to the north. However, with respect to the ground, the spot on the ground that is going that speed is now lagging behind because its tangential velocity is much less. Stands to reason that it will be an angular difference. That angular difference can be determined by the calculation or the equation for Coriolis. You seem to think by building a pile of dirt that suddenly it's still right beneath it. It's not.
Well, if I build the pile of dirt, okay, into the shape of a cylinder, so the northern hemisphere I've turned into a cylinder.
This is a definition of insanity.
Bro, quit interrupting me. Now, if I build up dirt, okay, this is a hypothetical. If I build up the dirt into the shape of a cylinder, so everything north of the equator is now in the shape of a cylinder. If I roll toward the North Pole,
and I just told you why that's not going to happen. Your tangential velocity, logically, from the sphere is lower. It's probably half or even a quarter at 60 degrees, 20 degrees, or 70, 80 degrees. And with your cylinder, your tangential velocity is the same. So yes, you will stay in line with the same tangential velocity, going a straight path along the cylinder, no Coriolis. Just like you wouldn't have Coriolis on any other situation where there's no change.
So now,
I was in the middle of a sentence. I'm almost done. Let me finish my sentence. But on the sphere, the tangential velocity of the spot on the Earth that was beneath it when you shot it. If you drew a straight line to the North Pole and you shot it from the equator, that line would not be followed by the projectile. It would be if you had a cylinder. It won't be because the tangential velocity of every point on that line going straight to the North Pole is going to be less than it was at the equator. So as it leaves the bull of the gun and the object is rotating, it will veer off to the right, regardless of how much dirt you put beneath it. Won't matter because the tangential velocity.
Okay, bro, that's plenty.
You have to understand. You have to think about it. You have to think. I'm not going to say it again.
You're not going to repeat it for the third time, bro. Now let me
I'm getting tired of explaining it.
Let me respond, bro. No, you're still missing the point because you keep saying the ground. Now, for the last time, to make sure you understand, okay, the reason I built the dirt up is so you quit talking about the ground. In other words, you're not going to get to the ground in this example, except for where you start from, and that's the equator, because I've just built up dirt. I did that on purpose so you wouldn't say ground. You can't. Okay, so now I built the top of the sphere into a cylinder. Okay, so now my bullet's got wheels and it's rolling toward the North Pole. Okay, I never make it to the North Pole. I make it 3/4 of the way and the bullet runs out of gas and it just stops on the cylinder, on the Earth cylinder that we just made into a cylinder. So in that distance traveled, okay, was there Coriolis from the point it started to the point that it stopped? Okay, it never made it to the North Pole. It never went to the ground. It left the ground at the equator, and then it kept getting higher and higher because we built the dirt up. Okay, so just be clear. Would it have Coriolis from the time it started till it stopped?
With respect to the ground on the sphere, yes.
I don't even understand what's going on here. We got
He's trying to build an artificial. He's trying to just raise the point on the sphere that meets the same point that if you had a cylinder and at the equator going off into space, that this projectile would follow. He's forgetting the point that this thing's rotating. Brian, I cannot think for you. I can't try to reason any more than I already have. You're completely off your rocker, and you're not thinking this through. We have a cylinder. Tangential speed stays the same. A sphere, tangential speed is different at the surface. If you built it up, if you built the entire thing up, that wouldn't make any sense either, because then your tangent wouldn't match the curve. So the whole idea in your mind, I know where you're getting it from. I can think like you're thinking. It's easy for me to do this. And you're just so confused that I don't know how to even try to put it in perspective for you. Not to overuse that word, but no. Every point on that Earth that's rotating has a lower tangential velocity, so it will lag behind this projectile if shot even straight or following the curve. Wouldn't matter. Just anything straight north from the equator.
So no matter what I do, I can't get your mind
no matter
off the
what
ground.
you do to the Earth, no matter what you do at the ground, it will not matter on what position it would be with respect to
no matter what I do to in an example, your brain can't leave the ground. Period.
Yeah.
Yes,
no matter how I try and describe
the
this,
shot is leaving the ground. I get that. It is leaving the ground. I get it.
The thing about it is only because it's not a ball rolling across a disc. It's not what it is. It's in the air.
That's the point. That's the point. Even if it was rolling, it wouldn't matter. It wouldn't matter.
If you fire the bullet along the axis of rotation, it doesn't matter what shape the thing is. It's still going to follow the axis of rotation.
Yes, it's going to be parallel to it. I agree.
All right.
But the tangential speed, again, for I think this is the 15th time, the tangential speed versus the spherical shape will be much higher at any point on its path, regardless of its altitude above you, and it will be appear to be curving with respect to the surface.
You're saying like the tangential speed, as in like perpendicular to the bullet's travel.
Yes,
that's correct. So what we I actually agree more with Brian here. I think it would follow the axis of. Well, just hear me out for a second. I think it would, because you're basically, look. I'm not going to tell you what you're doing, but I think that these theories are all very good. They're all very very mental, very and it's very good to think about. And you don't have anything to demonstrate it with. I've got something that explains it. I think the bullet will follow the axis of rotation 100%.
Correct, it will, but it will follow the axis of rotation. But what's
the deviation for
the Coriolis is the apparent deflection with respect to that surface. You're just not understanding it.
No, I understand that the tangential speed to the bullet's travel along these different radiuses.
Since he can't understand us, since he can't understand what we're trying to tell him, then he's
I don't
saying that we don't understand.
I don't think he gets the argument. He hasn't listened enough to just know what the argument is.
No, he doesn't. He absolutely doesn't.
You're saying if you shoot this bullet from the equator and it has that tangential orientation, straight north, parallel to the axis of rotation, that it will not have Coriolis? It will have Coriolis because the tangential velocity at any point in its path to any spot beneath it will have changed. Because the tangential velocity on every, hold on, almost done. Because the tangential velocity of every point on the sphere as it's flying through the air. That's the key point. I'm glad you brought it up again because it's not attached to the Earth. It's just going straight, and the Earth is spinning.
So on a cylinder, we have Coriolis. That's what you're saying.
Brian, you can't help yourself.
So on a cylinder, we would have Coriolis, right?
You can't help yourself.
Answer that yes or no real quick.
No Coriolis on the cylinder. No, I couldn't hear you because you're talking over me.
Right?
But no Coriolis on the cylinder, none. But Coriolis on the Earth because it is a sphere and you have a lower tangential velocity of the surface as that bullet travels.
But hold on, my bullet's going like it was on the ground of the cylinder, bro. My bullet is taking the path like it was on the ground of the cylinder.
But the surface of the cylinder are all the same tangential velocities, all of them. You're not getting it still. And I don't know what this is.
Yeah, but my bullet, you don't get it. Just fight. If you listen for 1 second, you'll get it. No, I'm not. I'll keep trying to explain it. If my bullet is going in a path from where it started as if it were on the ground of a cylinder. Okay, it's in the air on the sphere, but it's the same thing as if it was on the ground of a cylinder.
You know what they call that? They call that a gearing. You have a mechanical advantage if you that's
they call that a tangent.
That's analogous to a harmonic gearhead. You are not traveling at the same tangent velocity as the surface. You're traveling at a much higher.
So what you're saying is my bullet wouldn't.
In fact,
my bullet would have Coriolis.
In fact, you're traveling at the same tangential velocity.
Wow, you are a spaz, sir. You're a spaz.
He just keeps on interrupting me. It's unbelievable.
Yeah, it's always someone interrupting you, and that's.
I was in the middle of a sentence, Racky. Shut the fuck up.
You still spazzed out.
So I've got a really good explanation for all of this.
I don't think you do. But I'm listening to listen.
Yeah, okay.
Shame on me, but I'm willing to listen.
I want you to shut up. I want you to consider it. Look at the picture that I posted. That's something I drew like 2 or 3 years ago, and this is basically you're just plotting out different grid patterns. So you're looking at, let's say you're looking at the same ground. It could be a correction for the way that the grid system works.
No.
For what coordinate systems are being used.
Well, you have X and Y here, but let's just talk about a sphere. It's three-dimensional. It has a tangential velocity through rotation.
Well, the thing is, right?
Hold on. This is why I get so pissed off. I start to talk calmly and explain to you, and then you talk over me. Just let me finish my sentence, all right? So you start taking off from this equator. You have a tangential velocity given to you by the fact that it's rotating at some angular velocity. The tangential velocity is related to the tangent velocity is related to the radius.
Describing his, you're not describing his point, bro.
So we travel.
If you would listen,
north,
Janik, let him finish, you'd understand.
Every point beneath you on the Earth is going to have a different tangential velocity.
We've heard it 100 times. I think we know
projectiles in. I can't believe it. I try.
We're talking about the ground.
4 times.
We're talking about the ground, dude. We get it.
Even if you're flying in the air above the surface, the tangential velocity that you're relating the position to is going to show a curved path, not like the sphere where every point on that surface is traveling. Well, let me finish. Every point on that sphere is traveling the exact same tangential velocity, so there's no Coriolis. On the sphere, there would be, regardless if the bullet shot is straight up, or not straight up, but out at an angle. Every position of that bullet is been fired out and away from the sphere, still will see Coriolis, because with respect to the sphere, its tangential velocity of every position on the sphere is getting less as you go toward the North Pole, regardless of where that bullet, even if the bullet's going straight, which it would be in an inertial frame.
Look, we've heard that 100 times. Let's try to find.
Every time he mentions the word surface, he shows us that he doesn't understand our point. Every time you mention the word surface of a sphere, it means you don't understand what we're saying, bro. Sorry.
What I'm going to here, Zanny, because I'm trying to explain it. I'm trying to come up with a different hypothesis for how you could explain this difference in azimuth readings for where you want to fire the projectile. And we're just assuming that the military's got it right, okay? In my mind, the only thing that's curving is the trajectory of the bullet and the lines of latitude, okay? So when you've got a coordinate system where the lines of latitude are curving and the lines of longitude are straight, right? The bits where these lines intersect, those grid patterns change, right? So look at the thing that I drew 2 years ago, okay? And look at the lines that appear straight on a circular projection appear curved on a square grid projection, and the curved lines on a square grid projection appear curved on the circular projection. So I think all we're actually looking at here is a deviation of grid coordinates that's being used. We're not looking at because what's spinning here? What is spinning? Is it the Earth that's spinning, or is it the bullet spinning? Is it the bullet curving, or is it the surface of the Earth curving? You know, these are salient points, and to not consider our side of it, I think is you're not considering something that may be true.
Or is it both?
All I hear is a bunch of confusion.
It could be either. I'm open to it.
Or it could be both, Cresper. It could be partly the rotational value of the bullet. It could be partly its ballistic path. And it can also be partly the motion of the Earth under it.
Well, can we prove the motion of the Earth under it though? That's the thing.
Yeah,
right?
we do. We proved it loads of times.
I can prove that the coordinate system would be expected to be slightly off when you're going from a square grid to a circular grid.
So the reason that we've proved it, I mean, one is through direct observation via astronomy, Foucault's pendulum, all these different effects that we see on Earth. Two, we've actually seen the rotation from high altitude. So it's an observed fact, mate.
No, don't argue from incredulity. You know you haven't seen a photograph.
That's not an argument. That's not an argument from incredulity.
It is.
An argument from incredulity goes, that's rubbish. I just don't believe you. That's obviously false. That's an argument from incredulity. If I'm
No,
saying
you're believing lies. What are you saying? You've seen rotation yourself.
I have seen evidence for rotation.
Wow. Okay.
Did you hear my words precisely?
What is the evidence?
Did you hear my words precisely? I've said I've seen evidence for rotation.
Evidence for rotation, which is
so data from high altitude.
What
Focal
data from high
pendulum,
altitude?
which I've done
Describe
myself.
this data from high altitude.
Sure. Satellite imagery, data from weather satellites. Data from probes going away from the Earth. These are all at high altitude. And we actually get to see two things. We get to see the rotation of the Earth and we see its shape. The other thing I can do as an inference, just going to finish the point very quickly, is I can look at all the other objects that I can see myself. So I have seen the rotation of planets personally through my own telescope.
I have a question.
Wow.
Would you be willing to give up the argument that boats are going over the curve of the Earth at the beach?
No.
See, that's the thing. Like, if you got
actually, no. Let me reframe that because I think that was a bit of a sort of quick snap answer. Yes, I would if evidence was presented that was sufficient to say that that's wrong.
Well, let's say like the whole refraction debate, the discussion of light and all the rest of it. Like, what if that sufficed? And because I often think like the globe would make so much more sense in some ways, if they gave up the boats going over the curve of the Earth from the beach.
Shall I give you why I don't think it's a property of refraction? Refraction will bend light and it will allow us to see more and it will allow us to see less. Depending, but there needs to be some sort of obstruction in the way for it to be lifted above or sunk below.
For me, that gets crushed when I take a coin and take it across the table and look at it from eye level and see that it gets obstruction from the bottom up. And I know that the table is level, flat. You know what I mean? It's just such a tough. I mean, honestly, like, I wish if the globe gave that up, man, and fucking threw Bill Nye under the bus. Like, I think, like, there's so much more of a leg to stand on with the globe.
Yeah, the denial of perspective just makes you guys look like you're in denial rather than.
Nobody denies perspective. What I deny the fact that perspective is part of the science that we look at from the point of view of optics. When we talk about sort of properties, laws, and sort of methodology to it, the only time you find perspective as a law is in mathematics to give 3D representation on 2D paper.
See, but what I think happens though, despite the argumentation of it, or maybe even because of it, is it's like a mountain is made out of a molehill, and it becomes the holy mountain of flat earthers that they descend from. When they realize, like, wait a minute, you're telling me the boat's supposed to be over the fucking curve of the Earth, and they're looking at it and they're like, that's bullshit. You know what I mean? Like, it's the fucking holy mountain of how the globe creates flat earthers.
I mean, again, that may be what you bought, but I think it's bad. I mean, for me, I much prefer to use things like angular resolution. I can use things like trigonometry to determine how far something is away from me.
Right, but that necessitates that. See, this the thing is that to me necessitates the plane. And if the globe, let's say, had a congruous argument of like you're never going to experience curvature, that'd be one thing. But it can't seem to relent on that point, and I find it intriguing because like I hear what you're saying in the sense that like okay, like hey, I put this, and this together, and it tells me that this is what rotation or Coriolis or whatever it may be. But I just think like and that's fair. But at the same time, it's so odd to me that, like, when it comes to, let's say, like, the boat's going over the curve, because I can almost follow. I can follow it all up until, like, some points.
Shall I give you the one thing that I think absolutely kind of destroys, for me, the flat Earth? One simple observation. Watching the moon set.
Well, let's get off the point of the boats, though, real quick. because there's a couple more things to say about that. I mean, it's an inherent contradiction, it seems, because you can't see the curvature because it's too big to see the curvature, but yet 4 miles out in front of you, there's enough curvature to hide a boat.
Yeah. Well, I'd say a bit more.
So,
I mean, that
like
boat that's there, I think, is a lot further than 4 miles away.
Even 20 miles. You know
Yeah.
what I mean? I'll give you 20. Like the problem is like, that it's the alleged, it's the proposed numbers it's the numbers that are proposed by the geometry of what the Earth would be at that rate.
Yeah.
Because my thing used to be like when Globers would say like, hey, about curvature or whatever, and I'd be look, your problem is with earthcurvecalculator.com, like not me. You know what I mean? Because Earth Curve Calculator was saying that I shouldn't see this much and all the rest of it, and it kind of like I said created the holy mountain of flat Earth because they insist on it.
No, I sorry, Chris, but you go next.
Well, I think it's really pretty straightforward. Like I don't see any other explanation for in either model. It has to be the upward refraction of light, because you
But
think
light
about
refracts downward though, but light doesn't go upward.
Sorry, why doesn't light go upward?
Because the medium is denser going down.
Why would it be
No,
denser?
actually, over water, we always have a evaporation, which would make which would make that, at least at the surface, always a little bit less dense.
We need to wait. Before we go through this, I need to hold Zanik feet to the fire at every point here, because I need you to listen, Zanik, because a lot of people I've talked to, I don't think that you actually researched on this topic.
I have researched quite a bit actually. I've done the measurements, so we always see a density gradient always greater as you go down. Now there are some cases.
Hang on. I did ask a question. Why is it greater when you go down?
Because of hydrostatic pressure. The law of hydrostatic.
No. We're not looking up into the sky. We're looking horizontally across a plane. You're not looking through. You're not looking through a pressure gradient. You're looking through the same pressure.
There can be variation, but generally
you're looking straight forward,
everything vertically is a gradient which is greater as you go down.
Yeah, I'm not talking about looking at the ground from the sky.
You're looking at a layer. You're looking through a layer.
I'm talking about looking at
that layer variation. That layer variation will be a gradient vertically, looking at 2D, and looking out at it through one of the layers. If you start having a curved surface or a flat surface, you'll have some variance in that as well. But
I know you're just trying to pick a topic. You're trying to pick a topic.
If you look at the density gradient between you and an object in a distance, you have to see what is the difference in variation between yourself and this object and the medium in between. Generally, light always bends down.
I asked a question to which there would be like a 1 or 2 word response.
Downward, which makes your problem worse.
You gotta let him. You gotta let him go. You can't just keep talking.
He didn't let me finish. One thing.
One thing is 100 things. You just let him make his point.
I couldn't describe.
You're interrupting him and acting like he's interrupting you. Please stop.
I'm sorry.
He asked me a question.
I did actually interrupt him. I interrupted him because he said that there was a denser medium.
Talking about Zanik.
Yeah, he was saying there was a denser medium in the downward direction. I was just trying to say, there was a higher refractive index in the downward direction. I was trying to ask him, what is that? What is why is it going to bend down? Or what is that? The denser medium below, or something you're saying?
The density gradient is always going to be denser as you go down. We're
not talking about huge altitude changes.
Toward the denser medium. Light always bends down toward the denser medium, and if it's a curve, it'll be more pronounced.
It doesn't make it true.
And that's why that's why I can't talk. You guys are always talking over me. Seriously.
I asked you very simply. What is it? What is it about the medium below your eye level that makes the light go downwards? I'm going to tell you, right? What makes the medium
below your eye level?
Yeah, because we're looking at a boat. We're not looking at a plane. We're looking at a boat.
Sure, looking at a boat. Is it at eye level or below eye level?
We're looking straight out at it, mate.
Well, in actuality, it's slightly below eye level.
Eye level or below eye level.
The horizon, regardless of what causes it, is about 0.02 degrees on a flat surface at 3 or 4 miles. Now, at that same distance, we see objects that we shouldn't be seeing. Well, hold on. We see things above eye level. We see things at 0.04 degrees. below eye level normally, but can be can be zero, can be actually loomed up. That only happens when light bends downward, not upward. So your looming effect, flat or round, would have to happen if light was bending downward or more downward, not upward. Upward to make things, upward refraction would make things do what? Sink.
It would make
They'd make things be more hidden.
That's right.
More
it
hidden.
would make things go below the horizon. Now the
more
reason,
hidden.
right?
You have
So now I'm going to explain to you.
density gradient that is going more dense upward than downward.
Yes.
You
Okay.
know,
So now you've
is like is bad for your brains. Seriously,
you've aired your disapproval, but now I'm just going to explain to you why I think there would be upward refraction. Very simply, the water is quite cool. It's a stable temperature, right? There's evaporation occurring, causing columns of hot air rising. So you've got columns of hot air that the light is traveling through, and the air is warmer above the water than right close to the water. Okay, so warmer air impedes light more than cold air does.
No, that's exactly the opposite. You just told me.
Hold on, I know.
Because you said that it bends downward.
Some people
the warmer air is less dense. The cooler air is more dense. It bends downward.
Zanuck, seriously, can you let him fucking finish, mate? Because you're being an arse. He's being totally polite to you, and you're being a cunt.
No, because every time I spoke, he talked over me.
Yeah, but no, that's your interpretation, Zanuck. You always interpret it in your favor. You're talking over him. Let him finish, please.
And I actually went through this with someone last week about this, saying that but the hotter air is less dense because hotter air expands, right? And this is ridiculous, right? When you're looking at a mirage, right, across a hot road, that inferior mirage is upward refraction, and you'll acknowledge that, right? When you've got the same thing happening over the ocean, somehow it's different. I mean, if you want to know why I'm saying that hot air refracts more than cold air, it's because the heat.
It doesn't actually, but that's okay.
Well, look at the examples.
The refractive index the refractive index specifically talks about the density of the air and is not as high with warm air versus cool air. Here we go, talking over me again. See how it works flat?
But you're interrupting him.
I make a simple response, nice and calm, and these fuckers talk over me. Fuck you guys.
You're interrupting him, though. You're interrupting him.
Cold air, hot air.
No, I was in the middle of a sentence. He jumped right in. Perspective did. Fuck,
no,
you guys are idiots.
I'm sorry. I jumped in over you, but you were interrupting him to begin with.
Listen, he asked me a question. He says, "Isn't it true?" And I said, "No, it's not true." Because warmer air is less dense, less dense air has less refraction.
It's actually not.
See, you're doing it now. I can't even answer a simple fucking question.
Zanuck, I need to correct you here, though. You're thinking about a closed system. You're thinking about the same volume of hot air inside of a 1 liter container versus
I'm
the
not
same
thinking that
volume.
at all. Don't put words in my mouth.
No, well, this is what I'm just trying to correct you here. You haven't.
Don't correct me because you're not be able to.
Well,
you're not right.
I'm correcting you here. And because the example that's always given is closed systems things. You're talking about sugar water, where you're purposely creating a very, very dense, different density gradient, right? Where the sugar water is way more dense than the water above it. So you're shining a laser through, they go, oh, look, it's bending down. And you're shining it at the right angle too. See, so when you've got warm air in the atmosphere, pressure dissipates straight away. It's open. It's an open system. The pressure goes away. There is no density difference between hot air and cold air. So what you've got is just the properties of cold and the properties of hot and the particles within that air.
Altitude is not a thing?
Huh?
Density, altitude is not a thing? Same pressure, different temperature, that doesn't exist?
Altitude and pressure, absolutely. We're not talking about looking at a plane. We're talking about looking at a boat. Where it's the same altitude the whole way across.
You think because you have a certain temperature, you're given a pressure?
Are you trying to tell me that a couple of meters is going to be a huge change in altitude?
No, you can have a high pressure zone with a very high temperature. Happens all the time. That doesn't determine the pressure.
We're not talking about.
That doesn't determine the density.
Stay on topic. Zanuck, please stay on topic. We're talking about the water. We're talking about.
This is insane. This is really insanity. I have to.
I'll let you go.
Thanks.
We're talking about a boat. We are talking about a boat.
The concepts are the ideas are so beyond wrong. I can't even address every word out of his mouth is incorrect. I can't go that direction.
You can just say he's incorrect. You can just declare that. That doesn't mean he's incorrect just because you say it. Okay?
Yeah, it does actually.
There's a difference of opinion here. Okay,
it's not an opinion. This is
and
physics.
there's always evaporation. There's always
You
evaporation
don't want to
at
see
the
it?
water
Go ahead,
level.
knock yourself out.
There's always evaporation at the water level, and
So
that's
it
that's
doesn't
what makes
mean that the pressure dropped.
Okay, let me try to put this another way. How does it look? I'm a bit of a novice in propagation of light. I'm no spectroscopy expert, but hot copper wire has a higher resistance than normal temperature copper wire.
You just said 4 different things. Nothing's related.
The light propagates through
You just
mediums.
said 4 things that were not related to one another. You talked about the resistance and temperature of copper. Then you're talking about propagation of light. Then you talk about
No,
spectroscopy.
hey, don't jump
All
on him.
4 of
Hey,
those
let him
things are not
finish.
related.
Let him finish talking, Zanuck. It makes you look like you're wrong, regardless if you are.
Light electrically propagates through mediums, and hot air has a higher resistance. The molecules that are vibrating.
No, just making shit up as you go.
Zanuck, why do land surveyors have a model of standard atmospheric refraction being in the upward direction?
They don't. Light bends downward. That's why 76R is so popular.
I think you're no wait 1 second. I think you're both talking at cross purposes. Chris, may I ask you a question? When they say that, are they talking about objects being lifted up?
No, objects being pushed down.
Really? Because I think you'll find
they don't
that
do
what
that.
surveyors, having read a few surveying books myself, because I didn't know much about it, so I wanted to understand the argument better. From what I've read, they're talking about objects being lifted up, not being pushed down. That's the most prevalent refraction that we see. It's not always that way, but that's the most prevalent one we see.
It's called 76R, and it's in all the calculations on any surveyors, any optical analysis of air and vision. So you're wrong again. In fact, opposite wrong.
Well, rather than throwing out accusations, why don't we just keep it civil?
I tried that for a while.
We're talking
these guys. I'll let you take them.
We're talking specifically about boats sailing over horizon, right? In an inferior mirage, what's happening? Is the light being bent down or bent up? Any answers?
God.
Kosher decisions?
Oh, what's up? What was your question?
In an inferior mirage, is the light being bent down or is the light being bent up?
Inferior mirage. Is that the one where the object's raised up?
No, inferior mirage is like when you see it on a road on a hot day, it looks like water.
But it's lower or higher than it's supposed to be.
Well,
with a lot of distance, warmer air below your line of sight, so it's going to be bent up.
Right, but light is being bent up. That's why people appear to be walking into like a lake, and you'll see them disappear. Like feet first, they'll be like knee deep in a pool of water.
It's basically a reflection. The reflection is caused by a refraction, but it's a reflection. It's not a bending of light up or down, like looming or stooping or towering or none of those effects of refraction. This is a special case of refraction. It has to do. It's more related to the waviness of objects in the distance that are close to a hot surface. The air showing it twinkling like a dithering. This dithering is refraction also, but not related.
That's Fata Morgana, isn't it?
No.
Well, I'm sure it is upward refraction that causes an inferior mirage.
No, it's not.
It is.
No, it's not.
It is.
It's inverted. It's inverted. It's a reflection. It's a reflection caused by reflection. You should study this a little more.
If you're not going to acknowledge basic stuff, we can't move forward with the conversation.
No, there's no understanding of the basics. That's why I'm so frustrated with you. You're not listening. You think you know things you don't.
Again, I think that's a course around actually this exact topic for both of you guys. I suggest you both read it.
It says here about the inferior mirage on Google that it's what happens when you have hot air beneath less hot air.
I guess it's
Like
refracted upward.
So they gave an example of like the ground, like a black asphalt parking lot or whatever ground. Just the inches closest to the surface of the asphalt are hotter than the ones above it.
So here's the description from that particular that I posted. This is your typical oasis or desert mirage, where you look down towards a highway or a desert sands, and what you see appears as a blue pool of water or sort of like a shimmering water-like surface. In reality, it's light, the blue sky bending back up towards your eye. Since warm air rises and cool air sinks, the air layers are likely to mix, and inferior mirages will not last long unless there's a continued heating by the sun. Inferior mirages happen less frequently over the ocean because the ocean surface usually doesn't get extremely hot. That's why you don't get inferior mirages on the ocean, or very rarely. However, it can occur over an ocean when there's a very cold Arctic blows on over an unfrozen water. Note the image below is an inferior mirage. It makes it look like there's water over the pavement, when in fact there is not. Does anybody reject that statement?
I just want to add one part that I didn't mention, but it sounds pretty good to me. That they're saying in the one that I read, they're saying that the hot air,
I don't like the
hot air just an inch above the asphalt is hotter and less dense than the more denser, colder air higher than 1 inch above the asphalt.
Yeah, because basically the asphalt's being heated, that heat is rising, and that's forcing the cold air to sink, and that's why you get your nice Ripley effect. That seems
So if
to be what
I show you this reflection that is on a snow-covered road on a cold day where probably temperatures are even all the way around, right above the surface as well, also seeing this reflective capability. Yeah, this article has a lot of errors in it, by the way. It confuses the inferior mirages and superior mirages with looming. It talks about them in the same vernacular, in the same sentence even. So I don't. I mean, I'll even notice it's from a somewhat reputable source. Looks like it's making a lot. It makes a lot of errors here.
See where that source comes from, shall we?
Already said. I said it looks like a seemingly reputable source.
I want to see how reputable.
I don't know how reputable, but I mean the fact that he says the superior mirage is the opposite of the warm. Is opposite. A warm layer of air sits above your line of sight, and a cool layer beneath it. This is also known as a temperature inversion. I agree with that. But superior mirages are not looming. This talks about light bends down to the denser air because our eyes assume the light sees what we travel. The object we see up here is higher than it actually is. That's looming, not a superior mirage. Again, therefore, we see the image or the inversion of it above where it actually is. So no, I mean that. Yeah, yes, and no. It's inverted.
So this is from the University of British Columbia, and it's from the Department of Earth, Ocean, and Atmospheric Science.
Yeah, I mean, that doesn't mean it can't be correct if the wording isn't correct because they have a lot.
It might be slightly sloppy wording. I don't have a problem with that, Sonic. But again, all I'm saying with that is the fact that don't just poo-poo people because they could be reading what you agree with should be a reasonably legitimate source. And they're taking input from that. That's where I think you need to chill the shit out a bit, man.
When we see a ship that's missing the entire bottom, 300 feet, and you're saying that's due to a mirage, I have to call bullshit.
No, that's not what I'm saying at all. Absolutely not what I'm saying. I'm just getting a couple of videos.
Inferior mirages are phenomena that involve refraction and reflection based on the medium that you're looking through and the angles of incidence of the light that is hitting it with respect to your eye.
Here's an example of Fata Morgana because you mentioned that earlier. So that's a really nice example of Fata Morgana. So you can see the fact that the ship is being reflected. Yep, so it almost looks like one bit's on top of another. So that line there is actually a reflection of the bottom line there, and the white bit is being reflected again down on there. And you can see that from both ends. So that's an example of Fata Morgana.
And they sometimes call that superior mirage too. And they talk about superior mirages in this article as really being towering, which is a functional.
You can write to the university and correct them, Zanuck.
I don't think I need to. I don't think it's worth my time. I don't think really anyone cares.
Yeah, I've almost got all the things that I need for the discussion. Here we go. Here's the second link. All right, so post these to the goal. So you see the boats disappearing the horizon, and I think we all agree that if I look at it like this. This is how I understand refraction or the impedance of light. Let's say you've got two troughs, one on either side of you. One of the troughs is filled with water, the other trough is filled with honey. The honey is the higher refractive index, right? So you're putting your hands in both the troughs and you're trying to run forward. The honey is going to provide more resistance, so you're going to turn towards the honey, right? That's kind of what when a light hits something that is that impedes it more, that stops its travel, it tends to turn towards it, bend towards it. So when you've got hot air, and then you look at these last two, the GIF and the video here, these are really good examples that were given to me by Doofus about showing me how he was arguing he was arguing that it was showing the opposite to what it shows. But what it's showing here is that hot air creates a zone of a higher refractive index. And I can help you out by just turning this picture on its side.
Oh. So what I'm trying to understand here with your argument, forgive me wrong, we're talking about a boat going over the horizon, yeah? So whether there's a higher refractive index or a lower refractive index, what is stopping that light ray from the lower portion of the ship getting to my eyes?
You've got the sun, it's heating up the water. The water is letting off humidity, which I think we should all agree that humid air is creates a higher refraction.
Specifically the question I asked, Chris, but that's going on down a rabbit hole.
It's Chepper. But
no. The less dense air is not a higher level of refraction. Stop saying that. You said it.
They're all the same. They're all very
refractive
similar.
Index is based. I'll give you the equation. I have posted some information about the refractive index, and I'll do one more that encompasses the entire equation.
At the same altitude,
so my
the
equations
air
don't
is
matter.
all the same pressure.
The equations don't matter, really. You know more than the equations.
Well, he's asked me.
Temperature is a small factor. Here we go. According to Miggers and Peters, between the refractive index, temperature, pressure, humidity, and carbon dioxide content of the air following interdependence exists. And here's the interdependence. The refractive index is the n, and there is the value. And temperature is in the you can see temperature is in the denominator, so it's a very, very small factor.
For what's this here? I'm not talking about it as a. Show me.
You made it sound like it's higher refractive if it's warm. It's not. It's less. No, it's not. Because look, it even has humidity in this. Humidity of the air, percentage of volume of the atmospheric carbon dioxide, air pressure, density, air temperature, and C, and then it all equals.
Yeah, look at the temperature divided by
T.
1
plus 0.0. Not 0.0036.
Less than 1, right?
T. The higher the T, what happens to that value on the bottom?
No.
What happens to it? Gets smaller. The larger that denominator, the worse the number. Everything you're thinking is backward. Everything you're thinking is backward. Just so you know.
Listen to me. You're rushing into this, Zanuck. You're trying to correct me, and then you're proving me right. 0.003 times T. Right, so that's going to make it a lower number. That's going to make T a lower number.
Yeah. And what happens when you have a bigger T? Let's say the T is 1 million. What happens to that number? Does it become smaller or larger?
Smaller.
Do you forget your basic math?
Well, it is a factor of T, but
It doesn't matter. Whatever factor T affects that denominator, what does that do to the overall value of that number, that particular factor? That's going to be then multiplied by air pressure divided by 760, which is a torr.
I don't know what effect that's going to have on this.
Well, yeah, and just on the
look how old it is. Look how
if I have it's 1/2 bigger or smaller than 1/100th. What's a smaller number? 1/100th or 1/2? 1/4. 1/.
Can you show me the link? This is unrelated to what I'm describing.
Yes, this talks about a reflect. This gives you everything you need to know about what the refractive index effects are.
Okay, so before you interrupt me,
by temperature, by humidity,
I don't know why I'm looking
anything.
at the shit you're posting because you're not listening to anything that I'm saying.
Oh my god, dude! I've done listening to you. I don't know why I keep on coming back. It's like a dog to the vomit. Dog always returns to the vomit.
So I took 15 minutes out of my night here just to give you to go back through this argument and pull up all these links that I've posted, right? And you've just ignored them all. We're talking about a demonstrated effect of heat on the refraction of light, and you know those pictures are pretty. That picture is pretty obvious. That GIF, and this picture here is the video here is very obvious as well.
It's not the heat that's doing the refraction; it's the differential pressure that's doing the density that's doing the refraction. You have to figure this out at some point.
I think it's the pressure, the increase in pressure that's doing it.
No,
Okay.
no, it's a differential pressure, differential density, actually.
So you're saying that the hot air is more dense?
No, the hot air is less dense.
Well, why is the hot air in these two examples
Compared to the air around it, which is more dense.
a higher refractive index?
There's a higher
hot air rises, cold air sinks. That's why. Now,
No.
It doesn't.
No, that's not. It doesn't matter. What we're talking about is light passing through the hot air of the iron and light passing through the hot air of the candle air.
So, Zadok, you had a good 7 minutes to try and convince him of your position. Do you mind if I finish my question?
Oh, please do. Thank you.
Thank you. So, as I say, when you've got something going over the horizon, and I love the moon. The moon is a fucking awesome object. It happens at night, so you've got less variation in temperatures going on. We see it sink nice and clearly below a horizon line. I used to live next to the sea, so I've seen it pretty regularly. What is stopping the bottom part of that light getting to my eye? What's obstructing it?
All right, you're getting it. Okay, so when you're looking straight across the surface of the Earth or the surface of water, even water enhances this effect, as you could see from like the Skunk Bay video of I'll post that as well. I posted it earlier.
Just want to deal with the obstruction. I've watched your examples of the Superior Mirage and the iron and
there is no
the guy with the torch. So
there's absolutely no obstruction.
So what is stopping the light of the moon getting to my eye? Why do I see it clearly rise?
So the question that you asked before Zanuck went on his big diatribe
was exactly that.
Yeah, it was that. But I was talking about boats, and we'll get there, right? So you've got columns of hot air, and obviously this is different at night for the moon, and we'll get to that.
Well, that's the question I'm asking, so I don't want to go anywhere else apart from that because I've been kind of like waiting around for a bit, and it's getting late in my end of the world.
Well, you still have evaporation, and it may work different at night, and we know that on cold, dry mornings we're able to see a lot further. So it's a fact.
Especially where I live, where there is actually a much lower difference between land temperature and sea temperature, which is why I have such a beautifully mild climate with not very severe winters and not very severe summers.
Oh, very nice. Where do you live? Somewhere in the.
It was pretty hot.
I live in the UK.
Oh, I was going to say somewhere in the tropics.
No, UK. Our sea temperature is very, very close to our land temperature.
Well, if I could I'll just get to my point, right? I was just because I did get all the information there to present this.
Can I ask you a question? It'd be real short.
Yeah.
If you have something like water in like a infinitely sturdy container, so that you can raise its temperature without changing its density. Right? It's trapped and it can't expand or compress or anything. Do you think that the like room temperature or cold water in the same volume container, if you heated it up, would have a different refractive index now that it's hot but still the same density? I'm not sure if I asked that the best way possible.
I wouldn't think so.
So you're saying, so what effect does temperature alone have on the refractive index of things? If the density doesn't change, but the medium just gets hotter, the density is the same. Does that temperature actually affect something?
Well, I only have like intuition.
You can
by
carry on
inference.
with where you're going if the questions, if you don't know or whatever. It's all good.
Well,
you can carry on with what you're saying.
My intuition says that it's electrical propagation of light and the heat causing some sort of resistance, but that's not I don't have scientific backing for that, but I'd like to do some experiments.
Right,
But,
I'm interested in that as well because I heard you bring that up and got me wondering things.
But the thing that I kept getting cut off about is every time I go to explain why boats disappearing behind the horizon, because they don't want me to get to the point where I describe what is refracting.
Well,
the light.
I mean, you have the floor right now, so you don't need to bring that up. I mean, I think you can go for it, right? I cut you off, but I apologize.
No, that's fine. I think we should look into it. We should get some more information about temperature because that stuff that Zanik posted, the second part, very looks like some very old text.
Well, explain it to me. I mean, I mean, this is the first time I've spoken up, but I've been here for the whole conversation, and I really want you to, finish your point.
I really wish you would.
When you've got, I think humid air also creates a higher refractive index. Humid air, I believe hot air. This might disagree, but you're looking through columns of air that are rising. And because it's not so much, if you've got one layer of density above another, but the light that you're looking at never changes, never crosses that gradient layer because it's in the horizontal plane. Then obviously that's not going to affect anything. It's the columns of air that are rising that are going to cause some distortion, and that I think that when you're looking over a large distance like that, you're bound to encounter differences of temperature at different points along the line of sight you're looking at. So those differences in temperature,
that's completely inevitable. Correct.
Yeah. So those columns of air that are of differing temperature is what causes the upward refraction of light, in my opinion. I think that's how it works. And
that's still not saying why I'm not seeing the bottom of the boat, though.
Because it's upward refraction.
And that's fine, but the scattering is going to mean that some of that light is going to get to my eye.
Yeah, okay. Think about it as the top of the mast, right? Because we want the whole boat to disappear, right? So just the top of the mast. That light from the top of the mast, the light is hitting it and then it's being scattered in all directions. So some of the light's going to be going in a downward direction towards the water, some of it's going to be going straight out, some of it's going to be going in an upward direction. The light's just going everywhere from the top of the mast.
Yeah, that's scattering. That's right.
So
and same from the bottom of the boat. Bottom boat, it's going to scatter across the surface of the ocean. Bottom boat, some of that light should get to my eye. So again, I'm asking you, the only time that I see an object that, when I'm looking at something like that, unless we've got weird atmospheric conditions going on, like fog, the only time I can't see something... The only time I can't see something is when it's obstructed. So
no, that's incorrect. Did you not? Okay, I'll start again. Okay, so you've got the mast.
I want to know why I can't see the bottom of the moon when the moon rises.
So you got the mast. You got the mast at the top of the boat. The light is hitting the top of the mast, and the light is being scattered in all directions. Some of the light is going down towards the water. some of it's going straight out, some of the light's going up. Think about a lighthouse, right? The light that's going down towards the down towards the water, it's looking through all these mediums, and the light's being bent up, and some of that light meets your eyes. Okay, but think about the parts on the boat that are lower, right? That disappear first. That light is bending up. The light that's traveling down towards the water is hitting the water before it has the chance to bend up and hit your eyes. So that's why if all the light is bending upwards, that's why the bottom of the boat's going to disappear first, because you've got all that upward refraction of light, and it's probably easier if I draw it, but
no, I can see your refractive index diagram. I kind of see where you're going with this. Again, the problem I've got with that, and you've mentioned, and yeah, you've mentioned that problem, which is that the light will scatter in all directions and it will be bouncing off stuff. So some of that light is still going to hit my eye.
No, it's not refracting down though. It's refracting up.
No. When light hits the boat, it's scattering in all directions because of the shape of the object it's hitting. So you're trying to say it just goes in one direction and it's not scattering, and I say
it's got to go in the direction of your eyes, right?
And I say that is your problem. You're right; it has to go in the direction. That light has to hit my eyes, and that's fine. But the fact that we have scattering, and there is actually really good physics sitting behind this principle, is the fact that that I'm having a problem here because I need some sort of instruction. So that's why I like the moon. The moon's a nice bright object. It's a nice reflected object that we see. So when it rises, it's really nice and clear. Bit like your example of a lighthouse.
We're getting.
So what I'm trying to get to here is when I see a moonrise at night, or moon set at night, I don't have as many environmental factors happening. The air's cooler. There's less evaporation going on, there's less effect going on. But what I see is a nice clear-cut moon rising from my perspective from the horizon line into my vision.
Let me go show you a diagram. This is something
an illuminated object.
This diagram is something one of these globers made for me. It's actually really quite nice. If you can see the at the zero there, that would be the boat, and then we're looking at distance away from it. And this is just a rough estimate of like upward refraction. Now I posit that obviously it depends at what altitude. The moon's at a very high altitude, and that light is coming down through the atmosphere. At some point, the trajectory of that's going to appear very level, right? So you're actually coming through those columns again, columns of differing temperature, columns of air of different temperature, and at some point it's going to experience exactly the same effects as you see with the boat. It's just a lot higher and a lot further away. And so if you look at that there, that what I'm showing you here is a boat that's about 10 meters tall, right? And it's gone by about 8 miles away, or maybe before that. But you can now see what I'm saying about the point of light we're talking, the mast that's at 10 meters, or however tall is at, and the upward refraction of light at some point. Right, if you look at the bottom right hand graph, at some point that light is just not able to reach the observer at all.
Well, that's your claim. And that's what I have a problem with, because again, I can get a light and I can be really close to the surface of the ocean. So, and the lighthouse was a really nice example because, I've done a fair amount of time at sea. Spent over a year working on a fishing boat when I was a kid. And what I see is I see clearly the light from the lighthouse because it's shining out there. It's an illuminated object, and I can see it before it even gets above the horizon. I can actually see the light reflecting off the atmosphere. Yeah, and I see that light clearly. So again, that's me being really close to the surface of the ocean. So again, I've got a problem with your postulation here. It's still problematic to me, and that's why I like to use the illuminated object of the moon.
Well, it's illuminating the air above the lighthouse, is what's happening.
Because it takes away what you're trying to infer here, because of the fact that that object being illuminated, it's scattering light in all directions, it's being reflected off the ocean, it's being reflected off the atmosphere, got lots of nice light coming towards us, and we see that object nice and clearly. Yeah, I agree. You know, some objects, you know, they can be far away, and maybe there's not enough illumination on it at night to be able to see it. But when it's actually shining a light, you got a problem. And boat lights you can see from fucking long way away, and it's consistent. So I think you need to go back and rethink that. I still think that, you know, for you not to see that light, you need to have an obstruction. And the obstruction seems to, funnily enough, really nicely comport with the horizon line that we have. It also compares to things like radar. Radar has a horizon, and that horizon line is based upon the height of your aerial.
Well, it is very similar in the sense that radar is also like a light-based, you know, observation, right?
That's electromagnetic wave. Yeah, I agree with that. But, you know, but again, it has different refractive properties.
It does electricity pass more readily through something that's hot or something that's cold?
Depends on the particular material you're talking about, because I'll tell you what, if water's hot, it'll be different to the conductive properties of water when it's colder, and salt quantities will also affect it. So you use copper, which is a good example. So copper when it's hot has a high resistance to copper when it's at room temperature, and copper when it's really cooled down has a less resistance as well. So yes, temperature affects the resistance. So what I would expect, you know, on a nice cold ocean, is that I should be able to see a lot further then.
I mean, because light is measured on the electromagnetic spectrum, and I think we would acknowledge that it propagates electrically.
No.
And no?
No.
How does it propagate then? It's with particles, through particles.
Waveform and particle, it's a duality.
Wavicles. Okay. It propagates by wavicles then. And electricity also propagates by wavicles. What we're talking about is
electricity is generally electron flow, which is a bad way of describing it. What we have with that, and then we have an amplitude, which is what you see on your oscilloscope.
No, we're not talking about measuring the conductivity of a material. That's what that is.
No, that's not.
We're talking
That's
about
not. That's the amplitude. Is your amperage and your voltage.
Okay. How does light propagate through a material then?
Well, it depends whether the material's translucent or not. So, for instance, I can take something with an incredibly high resistance to electricity.
Whether something's translucent or not is dependent on whether light passes through it.
Let me finish. Because you're trying to say that there is some sort of resistance to it because it propagates electrically. So the problem I've got with that is the resistance. If you're saying that's the case, then what we should be able to do is put something with a high electrical resistance, and light should not be able to pass through it.
That's not what I'm saying. All I'm saying is that it propagates electrically. We are able to measure it in terms of the electromagnetic field. That's all I'm saying.
Yeah, no. I agree. It's light is the visible part of the electromagnetic spectrum. Don't have a problem with that. But what I'm saying is, if you're saying it propagates electrically, then you've got to take the good and the bad with that claim, Chopper.
I'm not saying that it propagates through conduction. That's not what I'm saying.
So you agree then that electricity and light propagates in very different ways?
Yes. Well,
cool.
No,
I'm cool with
no, not in different ways. What I'm saying is that the way they interact with materials is different. Okay, like for example, electricity doesn't travel through air very, very well. Air is very resistive of electrical conductivity.
Mm.
But we're not talking about electrical conduction. We're talking about electrical propagation.
Mm-hmm.
Like everything in the universe is electrical in nature. Electrical, the
Everything has
attribute of something.
Yeah, I agree.
Attribute of something having
All
a-
atoms have a positive,
atoms
negative, and a
atoms don't
neutral
exist.
component.
That's a model.
That's fine. You can think that. I
Let's not talk
disagree
about
with
things.
you.
Let's not talk about things that don't exist because we're talking
No,
about.
I say they do exist. So what now?
Well, I can say that sixes exist.
You can.
I can say that eights exist.
Apes do exist. I've seen an
Eights.
ape.
Number eights. Eights exist.
Cool.
Eights
You can say
and
that if you
sixes
want.
exist.
You can
Okay.
say that if you want. I mean, I agree. There is the model of the atom. So you're talking about the archetype, which is why you're sort of delving into a numerical or semi-platonic realm. But what I'm saying is that whilst we have like a model of an atom and it doesn't look like a little solar system all spinning around itself, what we do know as a fact is there is an electron component, a proton component, and a neutron component, which
It's a useful model for putting.
Which we collectively call an atom.
I'll tell you what it's good for. It's good for a model and for attaching data points to. That's what it's useful for, and for repeating experiments and saying, okay, we'll put that to that. It's like just having a whiteboard and just drawing a table.
Yeah.
You could
So
just do that instead of an atom.
Do you deny the existence of the component, the electron?
Say that again.
Do you deny that electrons are things?
Well, I actually don't know the instruments that are used to. It really I can't give you an answer.
So do you think that neutrons exist?
This is irrelevant to the conversation. I want to get back to the conversation.
Can I just give you something real quick? You guys can continue. The last GIF I posted was
love it.
Was it shows you where the electric field component of the electromagnetic radiation is, right? And it shows you how, for instance, it will interact with an antenna. This is obviously a radio wave, which is a component of light. Like it's the same thing.
Yeah, sort of more like induction rather than conduction.
This is just one way in which those two fields, well, it's really the same field, but how the electromagnetic wave propagates and how that will correspond to the electric part of its.
I have to say that bottom one is definitely a keeper because that is literally showing how it hits an aerial. That's fucking awesome. Thanks, Kosho.
Oh, yeah, of course.
And I think it's good at showing how anyway, it does propagate electrically. Well, that's radio waves propagating electrically, but I don't think it's a sticky point to just say that light propagates electrically. Are you okay to agree with that?
I'd say it's part of the electromagnetic spectrum, and you can induct current using
how does
the
it propagate?
electromagnetic spectrum.
If it doesn't propagate electrically, then via what?
I'm not honestly sure. I have to admit.
I would be completely comfortable saying in a sentence the electrical propagation of light. I wouldn't think there's anything wrong with saying that.
Well, whatever you're trying to get to, whatever you can do with the radio wave, as is shown in this GIF, light is going to do the same thing.
What do you think solar panels are? It's getting an electrical charge from light, isn't it?
Yeah.
Well, now you're talking about the photo. Now you're talking about the photoelectric effect, where photons hit a surface, a solar cell, and then convert that to electricity.
Proves that a photon exists, mate. Let's just get back to
does exist, and it's hitting this.
I just want to get. Let's just finish this conversation because I've got to get to bed. So the light. I'd say the same thing that impedes light would also impede electrical waves.
That's not true.
So again, going back to the fact impeding means obstructing. So
Exactly.
what's obstructing the bottom of the moon? We're back to the same question.
Okay. Every time that I get to a point where I'm actually trying to explain something, you put up all this resistance, and then you change the topic, and then you just want to move it forward when we get back to it.
No, but
let's go
because air has resistance doesn't mean it has resist is the floor.
We've kind of gone through that, Santa.
Yes, that's right. So just because air has resistance to electricity doesn't mean that air has resistance to light. Just because water has resistance to light doesn't mean that water has resistance to radio waves, or as much. But
there's different reasons why water has an effect on radio waves.
Right. So what I'm saying is that I believe, maybe I can't back it up, but I think that the
did we lose you, Chopper?
So the point that I'm making, right? The point that I'm making is that there are different properties within the air, not density, because we're not talking about looking through different altitudes. We're not looking down or up. We're looking straight across at a boat or the moon at the horizon, and we've got columns of differing temperature, differing humidity, and these things cause a impedance, something that's going to have a higher refractive index that's going to stop the light traveling, and that's going to cause a upward refraction.
So is it bending the light or is it stopping the light
No.
traveling? You said both.
It's not bending the light. It's creating a point of
a change in direction.
You change in direction. That's right.
Yeah, sorry, I realised probably bending the light was a bit colloquial. I was just trying to be easy. So again, yeah, I don't have a problem with the fact that we have refractive indexes. I don't have a problem that has an effect on altering the path of light. The problem I have is the fact that when I have something that's emitting light, I don't have a problem. I don't have the same sort of problems as just light bouncing off something. That's why I like using the moon. It's something that emits light, or reflects light. Let's be more accurate. So what I've got a problem with here is when I see a moon rise, from my perspective, yeah, it's clearly coming up from a horizon line. Where is it before it rises?
That light, like I said, with the boat that's gone past the horizon, that light that's refracting upward is not able to reach your vision. It's the reverse. Sure. It's like a boat coming sailing towards you when it's out of view.
Okay.
Now I want you to. Let me just quickly try to get your position here. Are you saying that upward refraction under normal atmospheric conditions or under any atmospheric conditions just doesn't occur?
No, I'm saying that it doesn't obstruct my view to an object.
Upward refraction doesn't obscure your view to an object. Okay, you're on mute.
Why am I on mute?
Well, you obviously didn't hear the last fucking 15 minutes. I'm sorry, you are muted. I'm not going to talk to you anymore.
So again, and the reason I say that is the fact that
if you'd said yes. So
the problem I've got with that is you're not taking into account things that we know, things like radio scattering, Baronian scattering, Raman scattering.
It's so frustrating.
These are all effects of the fact that light isn't just traveling in a single nice sort of convenient path and then it changes direction and goes away from us. That's not how it's light scattering in all directions.
But you think that downward refraction does occur, right?
Hey, Foolish.
Do you think that downward refraction does occur, Foolish?
Happens all the time when you're looking at light through a varying density that is downward in bias.
That's a non-answer, right?
Yes. Allows you to
we're
see
talking.
further.
We want to finish this conversation. I've got to go to bed.
So he's got the problem with the fact that he just seems to think that light scatters only in one direction, and
No,
it's all kind of like a nice uniform. You have me on fucking mute, so shut up while I finish my point.
Superior mirages are a very good example.
So I'll put you back on mute again because you're over talking me. I was trying to finish a point, and you didn't let me. Can I finish now?
No, you can't, and I've muted you, so we're both
we'll carry on.
Yeah, hold on a second, guys. Hold on one second.
This is bang out of order. He's just fucking running all over the top.
Dross, hold on. I'm going to fix this right now. Listen. If you have someone on mute and you're over talking them, it's going to be a problem. You can turn someone all the way down so you don't have to hear them. Then you're going to need to be actively looking at their down. It's a problem. And you're probably going to end up getting server muted.
Hey, Cheva, before you go, I was just going to say, man, it's good to see you again.
Maybe I can talk to you for just a minute before
I don't know. Yeah. I
do need to flesh this out, right? Kosher, would you agree that if light was refracting upwards, you would not see an object in the distance?
If light was refracting upwards, you wouldn't see. I mean, that kind of depends, right?
It would look lower in your field of view than it should be, and could be completely missing if it's bending up a lot.
Yeah, it depends on all the other. Yeah,
we don't see light bend that much upward or downward.
You don't see light. You don't see daylight bending upward or downward at all. What you're doing is you're describing what you think is happening out at a distance where you are not.
You can measure it by the angle position.
Hold on.
You can use basic trigonometry to figure out where it is actually.
It's going to have a shit shock.
Hold on.
Yeah.
Basic trigonometry is going to fuck off when you deal with refraction. Refraction is going to fuck up your angular size and position of whatever target is in the distance. Okay?
Nope,
so again,
its position will be changed. If you have refraction, it will change its position in your field of view.
That's what I just fucking said. That's what I just said.
And that's what I started out by saying.
So you agree, right? I'm just trying to agree that if...
Hold on.
I'm just trying to get to some mutual ground here because I can't have a conversation if we're always just fucking interrupting. No. Back and forward. No. It's not going to work. We have to have something we can agree on.
Well, you're dealing with Zanuck. You're dealing with Zanuck first of all. But Zanuck, you said nope, and then you said what I said. So what the fuck is wrong with you?
I said no. This is completely unrelated to the second thing that I said, where light will bend up or down, and it will change its angular position in your field of view. You can validate that with trigonometry. So you said it makes fuck all difference? No, you can measure it. If it bends downward, you'll see that object higher than it should be, trigonometrically.
No, you won't. That's absolutely, listen.
You can validate it with trigonometry.
Okay. That's absolutely
Don't be stupid. Of course you can.
Okay. Jeremy, you warned him about calling names, okay? But don't be...
I didn't say you were stupid. I said don't be stupid.
Don't be batshit crazy, okay? That kind of physics is...
Have you ever seen this?
That kind of physics is pseudoscience. That something that is going down gets presented up. That makes no sense at all.
How can it make no sense? If light bends downward, you see something raise in your field of view. That's how light works. You can see around corners. You've seen me. I'm still talking. I'm still talking, Copernicus.
Yes, you can, actually.
So you can see things around the barrel of this container, a propane tank. You can see around it because it's being loomed up due to this density differential. Don't whatever me. That's the truth. You think you're inventing science and physics. You're not. You're just confused.
Right. So that's all I wanted to do. Right, is get to an agreement that if light is being bent down or bent up over long distances, you're going to see the object rise or fall.
You cannot demonstrate light bending down or bending upward over great distances. You cannot isolate.
Yes.
Okay, Zanuck, I'm talking to the guy that was just talking, not you.
You have pictures to show it.
Listen, I have.
Okay, I'm not gonna do this. I've got to go to bed in like 10-15 minutes. Last drinks. Fucking look. All I'm doing is I'm trying to get to some mutual ground. We I think can be if everyone that is sane and rational here can agree that that this occurs. That when you have a light bending up or down, it'll change with the light bending down, like a superior mirage, will cause the image to rise.
Hey, can I ask you a question? Can I ask you a question?
Go ahead.
Okay. Now, in all honesty, I know that we don't know each other, so you might not know that I've made 4 years of observations. I've got superior mirages, fata morganas, inferior mirages, the whole gamut. Okay,
all incorrect.
I've got hundreds of hours of observations. Okay, so my question to you is, how do you know that a superior mirage is the result of light bending down?
It's caused by there being ice crystals in the air.
I didn't ask you. Okay, hold on. First of all, I've got superior mirages off the coast of California where there are no ice crystals. So if you're appealing to some Wikipedia article that says that superior mirages
No, I'm not reading Wikipedia. This is from my memory, right?
Okay.
So you've got cold. You've got.
Hold on.
Hey, wait, Travis, real quick. This guy's a flat earther you're talking to, just to let you know.
I get that. That's why I'm trying to take my time right now. So again, though, my point is that all you're doing right now is reading from the rhetoric of the literature. My question was, okay, great. So if you're not, my question is this: how do you know that light bending down creates a superior mirage?
Actually, I don't. Okay, but that's what, and it's not even what we're talking about. So
you're making a claim about light bending down and up. You are making that claim.
I am making that claim, and I can back that up with observation.
Great. So please show me an example of light bending down. No, I'm sorry. Let me be specific. Please show me a photograph of a target some distance away from you as the result of light bending down or bending up. You choose. You tell me which one, and then please help me understand.
Look, I know that you guys. I know you guys over there are really sensitive about this topic, but you don't need to be.
I'm not sure why you're making
I know you guys put a
personal address here.
I left that place for a reason.
I'm not. Okay, I'm driving right now, so I don't see a post. All I'm trying
it's okay. It's just really, really simple. Okay, you just let somebody get their point out, and it might take like 3 or 4 or 5 different responses back and forward between someone.
Pretty sure I was just doing that. You interrupted me.
No. I've been doing this for the last 3 hours, and I haven't even been able to explain why something goes over the horizon. I keep getting fucking interrupted about. Oh no, you can't be doing that.
Hey,
hold on,
Travis. Travis. Keep in mind he's about to go to sleep, so he's just trying to finish up a point that he's been going over for an hour, and he hasn't really been able to just make that one point.
Fair enough.
Let him do that real quick because he's about to go to bed. It's a whole new argument you're trying to get into, I think.
All right.
So anyway, it's my position that the light bending upwards over a long distance, because it's traveling through columns of heat and humidity and different things that are happening under standard normal atmospheric conditions over a long enough distance, you have enough temperature changes over that distance that you get the impedance of that light, and it bends upwards. My argument here, or my putting to this proof is, or proof in this whatever, the thing I want to present is, if light doesn't refract in any direction, then why do you see sunsets that are redshifted? And
now you're taking a total. Now you're taking a total deviation. You were doing.
No, it's the same thing.
Really
a boat going over the horizon, the sun going over the horizon, same fucking thing.
No, hold on. No one's saying that light doesn't refract, right? Who has anybody said that light doesn't refract?
That's kind of what you're saying, that it doesn't.
No, absolutely not.
You've taken so many observations, it doesn't refract.
No, I did not say that.
Yeah. All he asked is, why do you think if this is the case, it creates an inferior mirage? I don't know if you wanted like a geometric answer or like a chemistry or physics sort of answer. I don't know.
No, I would rather have an answer. I would rather have an answer that's based on field data where people are not only on the shoreline or miles away from the picture that they're taking, but they've also got someone standing right in the event itself, getting the data that's there, right? I have yet to see any scientific paper where they have that kind of detail. So my
You're not going to
question
be able to
is,
stand at the sun. You can't do that.
okay, look, we have easier fish to fry here on good old terra firma, right? We can talk about refraction a half a mile away. If you go to my channel, I just put up a video from the Bonneville Salt Flats. And this truck was half a mile away. Okay, just amazing shit that happens. So we don't have to talk about the sun. Okay, my point is that, in my opinion, the common consensus for science is simply descriptive. They are saying what they think is happening, and then they say crazy batshit stuff like light is bending down, presenting the image up, or light is bending up, presenting the image down.
That is what happens.
Okay, please, whenever you wake up and start your day tomorrow or the next day, please present your evidence for that.
Here it is. I'll post it right now. Look at that video. Very simple.
Okay, is this your footage?
It's not my footage. It's Ron Hagberg's footage.
Okay, so again, all you're going to show me is what I've captured myself on the Chesapeake Bay. I have this shit. Okay, this stuff it's happening all the time. So when you say, when the Skunk Bay footage has an apparent elevation of the image, how do you know light is bending down? All you can say is that.
Oh yeah, that's right. The light isn't bending up or down. It's just moving the camera up and down the whole day.
What? Okay, listen very carefully.
The image.
Yeah,
the
I
image
get that
is
now.
different.
I get that now. Listen,
The
why
stuff
are
on the
you
other side of
wasting
the bay
time?
is rising up and down. It's moving
Why
up
are
and
you
down.
okay? Why are you wasting time by being facetious? Okay, listen very carefully.
That's my point to you.
Listen very carefully. I acknowledge that you can see the apparent displacement of the target. The target moves up, the target moves down. We both agree on that. We just saw it go up. We just saw it go down.
And what are you saying that it's due to?
The only thing I'm going to say is that it's being distorted. I am not making a claim that downward refraction presents an image up. You are.
Okay, what's causing the image to shift up and down in that footage?
Who the fuck knows?
Refraction. Okay, end of fucking case closed. End of story.
Okay, well,
okay,
fine. I could have said that, and I was going to say that, but I didn't think you were going to be satisfied with that. Of course, it's refraction. Of course. Okay, you are making the claim, along with the consensus of science, that downward refraction presents an image up.
No, I'm saying that upward refraction causes the image to shift down.
Yeah, but by extension,
if you would have let me finish my sentence, I would have then said the very next thing. The consensus of science says both. Upward refraction presents the image down. Downward refraction presents the image up.
I can demonstrate that.
Yes, I understand this in detail. Go on.
I can demonstrate images.
Okay, I just want to finish what I was. You haven't progressed the conversation anywhere. Like, what are you trying to prove to me?
Okay, listen very carefully. You are making a claim. All I'm asking you, for the love of the Aether Band, all I'm asking you for is your evidence that you can make that claim.
I can give evidence that by inference proves that one of these things does not occur in a situation where we're looking at a sunset.
Okay, are you going to be describing what you are seeing? Or are you going to be... Okay, descriptions don't necessarily present valid explanations. I can describe something that I think is happening, but if I don't have evidence for it other than an observation that I am describing, that doesn't necessarily mean that I'm correct.
Yeah, but what you're asking for is how would upward refraction or upward bending refraction make you see an object appear lower? And Chepa asked this question a long time ago. Me and Chepa talked about this years ago, and I remember showing him a similar picture that I just made, but it shows you blatantly that an object below the obstruction, well, to the observer that's being refracted downwards, will to the observer appear higher than the obstruction, raising it up.
Okay, so do you have an example of this? Because I can, again, Kosho, look, you should know by now, right? I can show you a myriad of refracted images, right? I can show you a panel right now on my phone if I go and get it. I can show you a panel of a target with the target in 4 different positions, taken from the same observation point. Okay, so it's higher, it's lower, it's higher, it's lower. No one's disputing that refraction can displace targets.
All right. This is near my bedtime. I just want to quickly get to where I was going with this. I think there is enough evidence to prove that there are columns of whatever, columns of humidity, columns of a change in temperature, etc., that emanate from the surface of the Earth. The Earth soaks in heat, it has to get rid of it. Okay? The air takes up that heat. You have columns of heat, columns of humidity, columns of whatever, change in temperature, change in refractive index, most importantly. And if you're looking through those columns, you're going to be inciting. You're going to have a lot of incidences where that light comes across a medium that has to travel through that is of a greater refractive index. That's going to cause refraction. I think it's upward refraction. And the reason I think it's upward refraction, I think a good piece of evidence would be sunsets being red. If it was that, people might say, oh, no, you can see the sunset, the sun for more than 12 hours. Like you can see the sun in Washington and Melbourne at the same time, and they're like more than 180 degrees apart, in the right direction too. And, and they'll say, well, it must be downward refraction, right? To explain stuff like that. If there was downward refraction, then you wouldn't see a red sun, you'd see a blue sun, or like a fucking purple sun, something like that. Not red. The lower spectrum, the lower frequency, the longer wavelength of light is less refracted because it's what you see.
Okay, enough of this nonsense. Why don't you look in the chat real quick? We'll talk about something in reality here. You can give me your ideas. So we have this building, this mountain that is twice as far as the one in the foreground, but over twice as high. Why is it below the snow line even of the foreground mountain? When trigonometrically, it should be above it, or at least equal, right? Based on trigonometry, basic trigonometry.
What is this?
This is the mountain. This is a mountain called Mount St. Helens. It's 6,400 feet. And behind it is Mount Rainier, which is a massive mountain, 14,000 feet. So
trigonometry is no good with visual observation.
Can I please?
Upward refraction.
Can I please talk? Thank you. So I have
167 kilometers, mate. 167 kilometers of upward refraction.
So let me finish, and you can start blabbing out your nonsense. But let me finish first. So we have the background mountain is twice as far away, but over twice as high. So why is the mountain lower than even the snow level of the snow-covered peak of Mount St. Helens? I have a diagram which shows how that would work trigonometrically, which includes perspective, by the way. But why was the background mountain not only below it, but below the snow line? So significantly lower, more than a degree below. Go ahead. Once you can describe what happens there, then I think some of us will listen to you.
I think this is Travis's point. He's got a good point. We can't prove that it's light bending up or down, and this is why I say, if we block an object and we know for a fact that it's obstructed, the light will never reach us. Period. If something's obstructing that light, it'll never reach us. Period. Now, light that we see in the distance, we'll see it, move up and down. If we could see it, if it's in our line of sight, then within reason, we'll it could move.
I do I do a magic trick. Go ahead, Jeremy. Go ahead.
I mean, are you not buying their story of them not knowing the actual position and telling you how much it's higher or lower than the actual position?
Never mind. I shouldn't let you fucking go.
I don't know why you wouldn't believe that crazy story, Brian. What's wrong with you?
Yeah, well, I mean, I've showed they say that something, it's obviously light refraction that's causing bottom up obstruction. Because look, I mean, I've showed they like to say that if it's in our line of sight, then it'll never fucking disappear, right? When I showed a video, I'll repost it with Jose showing his observation from like 15 feet and the bottom of ships in a lighthouse being blocked, the whole lighthouse almost blocked. Or the building that looks like a lighthouse, whatever it is, just a few miles away. And he says in there, it can't be Earth curve because I'm only a few miles away and I'm 15 foot up in the air and the wave's only like 3 foot.
Brian,
so
before we move on to that,
having line of sight is out the door.
No, Brian, very, very quickly, dude. There's a magic trick that I do, right? And it involves what you're saying is not possible to be true. It involves like the smart water. If you have a smart water bottle, and you put a pen inside of it, and you have it so you hold it horizontally, you won't be able to see. You won't be able to see that pen because the refraction hides it behind. It hides it so you can't see it, right? So you could put something there, and you can do the exact opposite too. You can put a pencil in a cup of water, and put a piece of paper right where it intersects the line of sight between you and the pencil where it should be. But since it's being refracted into a different position, you can see it around, you can see it now, even though it's being obstructed. So what you're saying is impossible is totally possible. It just depends on where the obstruction is, where what the refraction is doing. And if the refraction is causing it to move slightly, and it just so happens that slight movement takes it from being behind an object to being not behind it, you're going to be able to see it. And it can do vice versa. I can hide the object behind the obstruction.
Cool story. But you don't know where the object is in the distance to know if it's higher or lower than where the object is, because you don't know where the object is, right?
No, that's not true. There's certain I mean, it depends on what example you're talking about, but for
you're
whatever
looking
example,
at something.
whatever example you're talking about, there's examples
I'll
where
give you an
that's
example.
not true.
I'll give you an example. You're looking at something in the distance. There you go. There's your example.
Okay. If you were a surveyor, for instance, and you've already surveyed the land and the object in the distance, its exact elevation, your observer, your elevation, you're going to know for certain where it is in the distance. So I'm not sure why you're saying it. So it's impossible. It's not likely in some cases, like the one you described, but there's cases where you can definitely know where the object is supposed to be.
Okay, how? How do you know where the object is supposed to be?
By surveying the land, for instance. If you survey the land, so what?
What'd they do?
Well, I mean, they would have surveyed the elevation changes throughout the land. They would have known where the object is in reference to them.
How
would they survey it?
Yeah.
They say they use the water level, for instance. And they use
tell you
every level
why.
you can imagine. Okay? It doesn't matter how they do it. They're only looking 100 meters away. And they know
the water level's horizontal, so welcome to flat Earth.
All right, fair enough. And they're only looking 100 meters away, like that, like on a track and field thing, like just down the track. And they happen to know that the thing that's on the other side of the 100 meters is the same elevation as them, they're going to know where that object is supposed to be in their line of sight. It's supposed to be just about at their eye level in the center of the frame.
Horizontal, right? Because they use the water level.
It's going to be pretty close
That's how
to
we're
their eye
measuring
level.
elevation.
It's going to be pretty close
Off
to their eye level.
horizontal. Dude, how are they knowing in the distance if things are higher or lower?
Well, if it appeared to be much lower or much higher than their eye level, then they would know that it's not where it's supposed to be.
So they're going to look at it.
Sure, with the measurement device, yeah.
Bro, we're talking about how do we know when we look at things if they're higher or lower in our from our field of view. You're telling me, oh, we know because we looked at it. This is circular reasoning.
No, I'm saying you look at it with a measuring device. You look at it with a tool to see where it is in your frame.
Yeah. Yeah, sure. Optically, with the light bending, right?
Yeah.
Which is the thing that's in contention.
Well, no, that's how you would measure how much was bending. You're like, okay, it's supposed to be at eye level. It appears to be 3 degrees above it. That's fucking really extreme refraction.
So you do know the actual position of objects in the distance, you're telling me?
I'm telling you that you can know them. I'm not saying that you always do, but there are cases where you can know them.
Okay, when we look at them optically? Because that's what's in contention.
When you have measurements of exactly where everything is.
Optical measurements.
No, like actual measure. You have measurements of the surface. You have measurements of the elevation of the object. You have elevations of everything.
What type of measurement?
You have measurements of everything. I'm saying in this scenario.
What type of measurements, Kosho?
Like surveying, like where you check the elevation of the land. You say what?
Optically, the thing that's in contention, right?
No, you can use a GPS for all it matters. That's what they did for the salt.
Then you gotta believe.
What?
GPS is a whole different story. Then you have to trust in satellites.
Well, you just
and all
you can't do it optically.
You can't do it optically because optical is the thing that's in contention. We're saying, how do we know when we look at something that if it's higher or lower than its actual position? You're like, oh, we look at it.
No, I'm saying you
Through a
measure
measuring
it.
device. That makes it better.
You measure it. Let's say that you've measured it to whatever standards you agree is acceptable. Okay. You said no GPS, no surveying tools. Whatever you agree is acceptable, you have the land surveyed and you have the height of the object in reference to the land that it's on. And you know the distance from you to the object. You should be able to estimate where it should be in your frame. And if it's outside of that range or not.
Did you hear your boy obfuscating earlier?
Which one? There's a few of them.
Dude, yeah, which one exactly? Which time? Which one? Who knows?
Shep is a good dude, man.
Yeah, it's getting ridiculous, Kosho. It's getting a bit ridiculous. I just want to tell you right now.
You guys have been ridiculous for a long time, so.
No, you guys are being totally absurd. Let me ask you a simple question. In the globe model, which way does it? What's up?
Also, when was the original observation made? The one that the calculations are based on. When was it made, and how was it made?
Good question.
You don't know.
I don't think that we're talking about a specific observation, but what were you saying, Jared?
Simple question. Coriolis effect. Which way does the globe model dictate it'll deviate in the northern hemisphere?
What will deviate?
An object due to the Coriolis effect.
Jeremy, why are you letting them beg the question? This is such bullshit. This is a
because
binary.
we got him with this.
No,
you almost had him earlier. You were doing so good, Travis. You let him. Remember, I was like, Zanuck, Doofus doesn't need you to white knight for him or save him.
Yeah,
and you see how Doofus obfuscated the shit out of it right after that?
I'm trying to understand your question, man. You said, what do you mean by an object? You mean
predictions, right? You guys love predictions.
Yeah, you mean a projectile?
You love predictions. Which way does the globe model dictate that the objects will deviate according to the Coriolis effect in the northern hemisphere?
Yeah, just be specific. Like, are you talking about a ballistic?
Dude, any object that is deviating due to the Coriolis effect. Which way is it going to go?
Everything deviates the same way. That's what I'm saying. We got to describe what kind of object you're talking about.
Talking about the Coriolis effect and objects deviating.
Oh my god! I sense a setup here. So
yeah,
just tell me what kind of object it is, and then we'll go from there.
Anything.
Anything? Okay. Well, I'll have to be specific then.
Whatever Does your model dictate which way things will deviate due to the Coriolis effect in the northern
Yeah, sure.
hemisphere? Yes or no?
Once we know what the things are.
So
Yeah.
depending on which thing, the Earth will rotate differently for it?
No, depending on what observation, what phenomena you're describing is going to depend
The
on
Coriolis effect, that
I
phenomenon.
know, but that doesn't make everything behave the same. Like you're not going to see the same thing on a Foucault's pendulum, the lines you mark on the ground, as you are if you draw a hurricane. Right? They're going to go in two opposite directions because you're describing two different things.
Yeah.
So having said that, a ballistic fired north from north of the equator is going to go east, and one going south from south of the equator is going to go east. So there's that. Towards the equator, if you're north or south of it, you fire something towards the equator, it's going to go west. Hurricanes north is going to go counterclockwise in the north, clockwise in the south. Foucault's pendulum will deviate clockwise in the north and counterclockwise in the south.
Yeah, so you got deviation. You get the Coriolis effect, deviation going clockwise and counterclockwise in the same hemisphere. That's your prediction?
No, man, I've had conversations.
That's prediction. That prediction. Basically, anything could happen. You're like, oh yeah,
no, not anything can happen, dude. Come on, what the hell? Post it again. The picture I made last time we had this conversation, and because we had this conversation, was showing you how hurricanes will go counterclockwise for the same reason Foucault's pendulum will go clockwise. And tensions were high today.
Some of this shit is sickening, bro. Your boy Doofus was trying to act like they weren't rotating counterclockwise hurricanes in the northern hemisphere. He kept saying, well, high pressure, the winds are moving clockwise. Dude, the obfuscation and shit, bro, it's ridiculous. Absolutely ridiculous. I'm done with him. Oh, there's a lot of people. I'm not even engaging no more.
I see.
Your people ain't even worth it, bro. Gummy Bear keeps getting the globe model wrong, and you were trying to stick up for him, dude. When do we see the sun, Kosho? Where it is now or where it was 8 minutes ago?
Well, both, because they're the same place.
Both?
But,
we see two suns?
No.
We see two different suns, or we see one sun?
Gummy Bear agreed with you. Where you see it now?
Oh, he said we didn't see the sun where it was 8 minutes ago. He said we see it where it is now. And he also said it wouldn't be negligible. However, it's so negligible that we see it. We can still see the sun 8 minutes after it's already set.
Now, what he said was
that sounds pretty negligible to me.
And what he said was exactly.
That sounds pretty noticeable to me.
So I don't know why he could have just agreed with you and also said, because yes, you see it 8 minutes. Like I told you, you see it where it was 8 minutes ago. That's the truth. That's a fact. However, where it was 8 minutes ago and where it is now, in reference to the Earth, is about the same place. There's very little difference.
Except we can see it after it sets for 8 whole minutes.
No, not for 8 minutes. Maybe for 2.
Well, it's 8 minutes behind. So when the sun sets,
that's his point, though, man.
That was 8 minutes ago.
That 8 minutes is irrelevant. Once the sunlight reaches us, the sunlight is going to be there until the sun goes away. So
how fast is the sun moving over the equator, Kosho?
1,038 miles per hour.
Yeah, and 8 minutes worth of that would be about what?
Yeah, but that's the Earth moving.
100-something miles?
It's not the sun moving, though. That's the Earth moving.
That's the only reason why the sun even appears to move in your model. What are you talking about,
No,
man?
that's exactly right. The sun moves in our model because the Earth is rotating. Right?
Yes,
That's
and we're seeing the sun where it was 8 minutes ago. So what's 8 minutes? What's 8 minutes worth of 1,038?
Oh my goodness, dude.
Because
Okay,
we're
we have
not
to slow
seeing it
this
where
down.
it was now. We're seeing it where it was 8 minutes ago. So that's going to be a lot of miles away.
No, dude.
Pretty noticeable and pretty measurable to me.
This was his point, man. You have to. I'm just gonna just close your eye and imagine what I'm about to describe. Okay. Okay. Pretend instead of light, there's a fire hose coming from the sun. Okay. I just have to pretend it's a fire hose, and it takes 8 minutes for the water to reach the Earth. Okay. So we're gonna be getting water from the direction the sun was 8 minutes prior. Okay. However, when that 1,038 is from our rotation, so as the Earth's rotating, the surface of the Earth is gonna be directly beneath that water stream by 1,038 miles per hour. That's how fast that stream is moving in reference to the Earth. Okay, so the fact that it takes 8 minutes for the water to get to the Earth is not relevant to the fact that it takes 1,038 miles per hour. You know, that's how fast the stream is moving, because once the water is hitting the Earth, it's just hitting the Earth. So the only thing that's dictating the movement of it across the Earth is our rotation. The 8 minutes is not relevant to.
Okay. Okay. So we're both on the equator, right? We're 8 minutes, whatever 1,038 divided by 8. We're that far apart on the equator. Okay, the subsolar point's coming. It's above me, then it's above you. Right?
Sure, yeah.
You with me so far? All right. So it's going to be a pretty noticeable difference if the sun, if I go look up, oh, the subsolar point is above me, but it's not really above me. That's where it was 8 minutes ago.
Okay, so it's about 138. We'll call it 140 miles away. So 140 miles.
Noticeable and measurable. It's pretty noticeable and measurable. Doesn't sound negligible at all.
Yeah, but the thing is, the source of where the water is coming from, that hasn't changed. That's changed very little. So that's negligible. So because the source of the water is coming from the same place, yes, it's true that the part on Earth that's hitting is 140 miles past where it was, 8 minutes prior, but that doesn't change the fact that it's coming from the same place.
Okay, good. So we don't see the sun where it is now. We see the sun where it was 8 minutes ago.
No, Jesus Christ. Yes, that's true. Yes, that's true.
Okay,
but that's also the same place.
It's true. Why didn't you just say that to Gummy instead of?
I said this the whole time to Gummy.
Why he didn't listen to you?
Well, he did.
Does he not know you're one of the top Globers?
No, I'm not. And you just told me his position, and you've also said that he said this in his position. You said that he says that the actual position of the sun in reference to the Earth changes negligibly, not in any noticeable amount.
Let me ask a question real quick to help. I think Jeremy, the way I'm listening,
Gummy said, "Listen."
Wait, Jeremy.
Gummy,
let me just try to. I hear you asking a question, but I think that what Kosho is saying isn't sinking in for you, and so correct me if I'm wrong, Kosho or Jeremy. Kosho, you agreed that the sun is not in the same place it was when we see the image that we see. There's an 8 minute differential. Okay, how many sun lengths are between where the sun actually is and where we see the apparent sun?
Listen to me. This guy Gummy Bear was in here. He said, we don't see the sun where it was 8 minutes in the past. We see the sun in its exact position. Okay, that was his argument.
I know, but listen, that's exactly, well, it's not exactly. That's very close to what Kosho is saying. Kosho is basically saying the sun's, the Earth's rotation is changing the position of the sun so slightly that it's just a fraction of a space from the actual sun that you're seeing. So it's not like when the Earth rotates in 8 minutes that the sun is 2 sun lengths away from where it was 8 minutes before that. He's not saying that. He's saying that they're both so close together that it's basically indistinguishable.
Right. Yeah. Basically.
Is that right?
Yeah, I think so. I wasn't listening for a second, but I heard the gist of what you said, and I think that's correct. I can,
If you were at the if you were on the equator at the solar point comes over you, and then it went 140 miles to someone else on the equator, you'd be seeing the sun where it actually, you're seeing the sun 8 minutes late. That's 140 miles away. Definitely noticeable, definitely measurable.
How many suns are in that 140 miles? Do you imagine? How many
no
sun
idea.
widths?
No idea.
Okay, I'm telling you, in their model, the sun that you see and the sun that is apparently 8 minutes ahead are still so close together, Jeremy. It's like a sliver. That's what they think.
Okay, it doesn't matter. It's irrelevant. Gummy's argument was we're seeing the sun in its exact position. My argument was no, we're seeing the sun where it was 8 minutes ago. For some reason, I don't know why he was even arguing that, because that's what their model dictates.
No, listen. Okay, I'm going to try to say this as best I can. Your concept of how far the sun has to move in 8 minutes isn't correct.
It moves 140 miles in 8 minutes.
Okay, but think about that with parallax, right? If you're standing in front of a building and you take one step to the right, that building is going to apparently move a great deal of space. But if you back up a block away and take one step to the right, that building is going to look like it didn't even move. That's what we're talking about.
I don't know. It's irrelevant. The point is, in their model, we're not seeing the sun where it is in its exact position. We're seeing it where it was 8 minutes ago. I don't care if it's a sliver or 10 miles.
Ain't the sun stationary in their model?
Yeah, we have to speak this way because it's a phenomenological way of speaking. The sun rises.
No, it actually is orbiting around the fucking great attractor. So yeah, that's a good point, actually.
You know what I mean? We can't say everything about what's happening because it would take too long to say everything with a qualification. So we just say it in the simplest way, which is ironically the way it appears on a flat Earth. Because on a globe Earth, the sun isn't rising, the Earth is setting. But we don't say we're looking at the Earth set. But that's what's happened at a sunrise. At a sunrise, the Earth is setting in front of you. But that's not what we say. We say the sun is rising because that's what it appears to be doing. Because it's coming closer to us.
Here, Jeremy, I'm working on a calculation very quickly. Hold on.
Fuck your calculation, dude.
You say so. Hold on. There we go.
Your whole model is built on calculations. Your entire system is built on math. It's not built on reality. It's built on a philosophical idea that you cannot correlate to reality. So you have to mathematically, linguistic, gymnasticize it, and then make it make sense. That's the only way your model makes sense.
Thank you. It's kind of you. But, okay. Let me say it like this then. I don't know. Let's assume this math is actually correct, just for the sake of this explanation, okay? Because I just did the math, and we're going to assume it's correct, remember? So, I'm not going to show you the number, but it's like there's 4 zeros, okay? So it's decimal, and then 4 zeros, and then a 9.
Wait,
and then
what
a
are we
5.
talking about,
Okay?
Kosho? What is it? What are you?
1 second, sir. 1 second, sir. Just 1 second. So yeah, that's 95. You know what? Hold on, let me do this. Well, don't forget about it. So yeah, that's 95. 4 zeros and then 95. Okay.
You know how painful it is to listen
imagine
to you?
this is 1 degree. So
Like what?
I know
Wait, Listen, I don't
Why are
mind.
you talking, dude?
Listen, I don't mind. I don't mind.
I
listening
do
to
mind.
you
I
talk
mind that.
about these
I mind that
numbers.
I'm trying to
What the
finish what I'm
fuck are you
saying.
talking about?
Don't worry
Like,
about it. I'm
what
not
is
even
it?
talking to you. So hold on,
Yeah, but
dude.
I'm here listening.
Yeah, I know. So why don't you just do that? Practice that for a little bit, and then we'll talk about it at the end.
Just give me the context for your math, bro.
Again. Well, I haven't even gotten to that point yet, dude. Jesus Christ.
So what are you firing off numbers for? Like, give some context.
Dude, honestly, if there was no talking, it'd be so much easier to get it out, right? So, anyways, you have to imagine this.
10, 6, and 12.
So what,
Did
Jeremy?
you shut the cafeteria?
Yeah.
Oh, what the fuck, dude?
I'm hot mic lax.
Oh, yeah.
Jeremy, your mic's open, Jeremy.
I know. Thank you.
He
Thanks,
knows.
Travis.
Yeah, he never cares. Okay, so this is a degree that I want you to imagine. Okay, it's got a decimal and then 4 zeros and then 95. Okay, this is that degree, whatever number that is, 95 hundred thousandths or something like that. So that tiny degree is the difference of the sun's position because of our orbit around the sun, and this is at this is going to be the maximum. So this is only going to be the maximum. Most of the year is actually going to be less than that degree. Okay, so in 8 minutes, the sun's position, its actual position, where it would be if we got the light instantly versus where we got it 8 minutes later when it comes. The degree that it would maximally change by is 95 ten thousandths of a degree or 100,000 for those two.
That's
so
awesome.
this is not any sort of amount that should, I don't know, come up in a conversation when Gummy's point was that it's in the same place.
Okay.
It's basically in the same place.
Okay, great. Awesome. Great. Now, please choose the very first variable in your mathematical equation. What's the value?
I use several variables.
Okay, listen very closely. Please choose the first value in your
I guess
equation.
it's going to be worth something to you. Let's find out if it's going to be worth anything for you. I used the number of days in a year. Does that help you out?
How many days is that?
365.242.
What about a lunar year? What is a lunar year?
What does a lunar year have to do with this?
You can measure the same amount you can measure time that way too. Is it the same?
Yeah, but it's not what I did, so I don't know why.
Would you use a solar year or a sidereal? Did you use a solar year?
I was doing an actual sidereal day.
Why'd you do that?
Well, I was just breaking down the number of 8-minute segments in the course of a year, so I can actually.
Well, the bottom line is,
yeah,
Coach. So, in conclusion, we don't see the sun where it is. We see it where it was 8 minutes ago. Whether how many fractions of a degree off that is. Is that what you're saying?
Yeah, that's what I said. That's what Going Bear said. Yes.
No, he said we see it in the position it is now.
Well, it just so happens that the position it was 8 minutes ago and the position it is now is damn near the same thing.
It's very close, but not the same.
Right.
Right. So not where we see it. It's not where we see it now. It's where it was 8 minutes ago. It can't be both. You guys are acting like it can be both. You guys are acting like we can see it where it was 8 minutes ago, and we see it exactly where it is now. That can't happen.
If it changed by very little, then both those two things will be the same place.
No, they'll be close to the same place. They won't be at the same place.
It depends on what level of precision you're allowing. If you allow for, like, I don't know, 100th of a degree being, being the same position as it would be, like, you're not gonna, like, I don't understand how you're not gonna notice that in the sky. Like, if in the sky an object will move up by that little, degree or percentage of a degree, you're not going to notice that. It's not going to be something that's even measurable with regular tools. Like, what's the precision of a theodolite?
One arc second.
Yeah, let's see what.
Or wait, 30. Maybe it might be 30 arc. I think Larry said he had a theodolite 1950 something, and he can measure to within 30 arc seconds.
Let me find out if this is bigger or smaller. Arc second is 136,000, right? Or 3,600, right? Yeah, so this is 0.34 arc seconds. That's the difference of its position. Maximum. I do agree, though, that it wasn't important. It wasn't an important point to. You guys talked about that for a long time.
Hey, Kosho, in your worldview, what is the absolute foundation, the beginning of your understanding of the universe?
Like what happened?
No, I just mean, in order for the universe to be what it is for you, what's the very first point that you have to start with? I'm not testing you. I'm asking you, in your opinion, if you were going to describe the way the world is, and you had an opportunity to give a talk to 6th, 7th graders, and you're going to say, this is the way our world is, what's the very first point you're going to make?
Well, first point I would make is there's some things we don't know, and there's some things we have evidence for. That's the first point.
Fantastic! Wow, that's honestly, that's a great answer. Okay, good. Okay, what's next? But I'm talking about the very substance of what you're going to introduce them to. This is how to understand your world, kids. Here's the first thing you need to understand.
Well, and then I would explain that our current understanding, or the extent to what we know about energy, is that the energy that exists now existed at the beginning of the universe. So there's the energy that exists always existed for as far as we know. As far as we know.
So first of all, I would probably kick you out of the room because that's too philosophical for 6th and 7th graders. Okay, let's talk about empirical science that we want to help these 12 and 13-year-olds be able to do this shit on their own. Like, what you're talking about is a philosophical idea right now. So again, the basis of your worldview, like what do you know to begin with?
Well, I'm going to finish what I was going to say because I thought that's what you were asking. What I was going to say is that the energy always existed, and somehow, some way, there's these laws and these universal constants that however those were created, however those were put in place, those and the energy and the time that this has happened, allows for everything that we see in the universe and on Earth to come about.
Okay, I'm not 13 years old, and I now have no fucking clue what you just said. So break it down. Again, I want you to simply explain the world to me or a 13-year-old, Kosho. What's the very first thing that they should understand about the world in which they look out and see?
That there's strange people out there who are going to ask you questions like they're coaching you for Miss Universe. What's going on here, dude? I'm just answering your question, dude. I'm just answering your question.
So your answer, okay, I've already critiqued your answer. Your answer is a philosophical, esoteric answer. These kids are not going to understand what the fuck you're talking about.
Well, every time you make it seem like you're asking one thing, and then you turn out to be asking something different.
No. My basic question is very simple. You're convoluted, misdirecting, wizard spelling.
Kids, don't be an idiot. Don't be an idiot. Period. Have fun.
I would tell them. Yeah, I would tell them. I would say what I already said. So I'll also leave that out because I already said that.
Yeah, but
And then I would get to the point, and then I would get to the point, and then I get to the point where we are now and say, and now we understand this is 13.7 billion years later. Now we understand the Earth to be 4.5 billion years old, and we understand that we're doing all these multitudes of movements. You know, rotating upon an axis. Orbiting around the sun.
Yeah. Why don't we start with that? Rotating on an axis. Why don't you start there?
I did.
Okay. You said that there are things that we know and that there are things that we don't know. Do you know or do you not know that the Earth has an axis of rotation?
We know.
Okay, great. How do you know the Earth has an axis of rotation?
By any of the multitude of tests that show you that, like the SAGNAV, or using a what do you call that? Gyroscope, any kind of gyroscope. Forget about what type. Any kind of gyroscope, any kind of Foucault's pendulum, anything that you can use to make a distinction between whether you on the surface that you're on is moving or something outside of you, like the sky or something like that. You make a distinction.
Okay, so your belief that the Earth has an axis of rotation, does something else need to previously be true about the world in order for that to be reality?
I mean, sure. I mean, you gotta be more specific.
I can't without repeating myself.
Okay, does anything have to be true? Yes, 1,000 things have to be true. The Earth has to be real, has to be made out of land that we can live on. I don't know.
The Earth has to be what? In order for this rotation to be true, is there something else about the world that must be true before the rotation can be valid? Like, could the Earth be in the shape of a record because it's rotating there? So could it be like that?
Yeah, the Earth doesn't have the rotation of the Earth, or knowing that it rotates upon an axis is not by itself going to give us the shape of it. However, if you did a test like Foucault's pendulum in enough places, something like that would give you a good shape of it. But the fact that you're just noticing that it's rotating and you're using the device, the shape doesn't matter at that point.
The shape doesn't matter.
It's going to change. It's going to change the outcome of whatever test you're doing, but the outcome's always going to be that it's rotating.
Yeah, you can do many tests to prove this too. First, we can determine it's round.
Okay.
Round is easy. Round is easy. Round is easy to prove. Second would be the Foucault pendulum.
Take a back seat, Zanuck. Take a fucking back seat.
I was adding color to his comment.
No, you're not. So
yeah, I was actually.
So Kosho, again, which comes first? Does the Earth have to be a sphere and then have rotation? Or does it have to rotate and then have sphericity?
Neither of those has to be.
It could be a cube.
It could be one or the other, and
could be a cube. Do you mean does it have? Is it a flat surface, or does it actually have a place where you went one direction, end up at the beginning? If you get done traveling.
Point is, one doesn't imply the other, though. So it could have been a sphere first and then rotated, or it could have rotated first and then it became a sphere. It doesn't matter.
Okay. So again, the point that I'm trying to make is that your worldview actually has a major premise from which it must begin. It doesn't begin with rotation.
Actually, it probably did. It probably was rotating before it was a sphere, for sure.
Okay.
Yep.
How do you know that?
Just by looking at how these sort of things form. You know.
Oh, really? You've seen a planet form? Tell me about that.
Simulations of it, sure. Yeah.
I'm sorry. What?
Simulations. And
Simulations.
Also
what is? No, hold on.
analogies.
What is the simulation, Kosho? What is that? What do you mean?
You take
Looking at other objects in our universe, or our local solar system, comets, asteroids, that kind of thing. Other planets probably mainly will determine what shape we are.
Comets don't
Okay,
spin very well.
thank you, Zanuck, not Kosho. Kosho, what do you mean by simulation? What do you mean?
Simulation, you input, you program this simulation to show you some physical environment, and you can put in all the parameters like the mass of these objects and the way they behave with each other. And so you could just create some small particles and give them some attractive effect and see how they would coalesce. And they might just coalesce and start rotating before they actually form.
Where did these small particles exist, Kosha, that you're creating in a simulation?
Well, I made them because I made the simulation.
Where do they exist?
I mean, in reality, the small particles exist everywhere.
No, in your fucking simulation.
Jesus Christ! In the simulation, they exist in wherever the frame of the simulation is. I would make them in the center. I would put them all over the field and whatever the frame was. I don't know why are you asking.
Where is this field? Where is it? Is it in front of you? Is it on your desk?
On the screen. Yeah, you put it so it's on a screen so you can see it if you want to make it useful.
Okay.
Yeah.
You are so annoying, Travis. Travis, just ask the fucking question and stop being such an ass. Seriously.
Okay. Kosho, basically what you're telling us is you've got a blank notebook in front of you and you're telling a story about what you think reality is. And in that story, you can make shit do whatever you want. You can have this particle do this particle do this. They attract each other. All you're doing is creating what you think is reality. But that doesn't mean that that's how the fucking world came to be.
Sure. Well, what I'm not going to put in there is things I don't know. And I'm not going to put in there are magical events. What I'm only going to put in there are properties that I know to exist. And I'm going to use these properties and run the simulation and to see what the outcome would be. So if I think that whether it's electrostatic attraction or magnetic attraction or gravity, from what I know, there's an attraction between small objects, and I know that they coalesce. And so all I have to do is input this information in there, and I can see how they would coalesce if they do. And I don't have to tell it whether it's magnetism or gravity or anything. I can change the dials and see how they behave in either case. But regardless, I can see how they would coalesce and what would happen when they do. And it would show me if it does start spinning, how fast it would start spinning. And these are going to be based
wait. So in this simulation, would it start spinning to your surprise, or would it start spinning because you programmed it to spin?
Well, it wouldn't be a surprise, and it would also not be because I programmed it to spin. It would be because.
And here we have Jeremy. Jeremy, here we have that same doublespeak that it is both not and it is both is.
No,
you can't have it both. No. You can't have it both ways.
You just interrupted me to tell me something dumb, dude. It was a false dichotomy.
Either you, as the programmer, made a program and then something fucking happened that you didn't know was going to happen, or you programmed the whole program, and then when what happened because you planned it to happen, isn't a surprise, right?
No, not at all. So the reason it's not a surprise is because I understand physics. And because I understand physics, I understand what happens when a ballerina sticks her hands in when she's spinning around. She'll spin faster. And I understand this. Now, having made this program, when I know that's going to coalesce, I'm going to expect this because I already understand that principle. However, I'm not programming it to spin around. It's spinning around because of the way the objects are coming together in the program that I wrote.
In the program, you have to program it to spin around. It's not going to happen naturally.
No, you don't.
Yeah, you do, dude.
Kosho, I don't know if you understand this. Somebody at some point had to tell the program how to run the simulation, which means you can't derive from it new information. Somebody somewhere already had that information because they had to tell the computer how to do it.
Right. Okay, so let's imagine that in this program, because I write code. I've written simulations before. Let's say I wrote a program where all I'm doing is I'm telling objects. I have like 50 balls in randomly placed in this screen. And I want them to be attracted at some location, either to each other or some central point or something like that. And I also write in them, when you collide with another object, just Newton's laws, when you collide with another object, imply a force that is equal and opposite to the direction that force is being applied onto you. And I put all the masses in there. These are the only rules I'll need to write. I don't have to say anything about rotation. What's going to happen naturally is when they coalesce and they start hitting each other, They're gonna rotate because of the rules that I wrote, not because I wrote in there to rotate.
What about dark energy and dark matter?
Hold on, let me just address that real quick. That's the same way as if you write a program and you have a character on the screen, turn right, go a few feet, turn right, go a few feet, go turn right, go a few feet, and turn right. You're saying you didn't program it to make a square. You just gave it the rules of which direction it's going to go, and it happened to make a square. That's not true. You literally programmed it to make it a square. You just didn't call it a square in the language. That's all.
It's not quite what I said.
But it is what you said. It's just it's an analogy.
No.
The fact that it did the thing that you told it to do, and just because that isn't called the same thing as what you're saying now, doesn't mean that it's the same. You had to tell the program how to run the simulation.
You guys are so irritating.
All I told it to do was to collide with each other. And
you guys are so irritating. Just settle down. Stop yelling and screaming. And oh my god!
Does there even need to be? Does there even need to be?
Sorry, go ahead, Zeppa. Yeah.
Does it even need to be though? Like, how do? Like, I mean, we're arguing over like some simulation thing, but
I know. Yeah, I know.
Does it even need to be like something floating in free space? I know that's not what I believe.
Yeah, I know. No,
how do you know it's not just a division?
It doesn't have to be. But
you can have your model, I'll have mine. Like, it doesn't need to be. I don't need
yeah, but if you are making a simulation, you're going to just use what you know to build it. You can't use things that you don't know. So that's a fair assumption to make. But regardless, this is the reason why they do run simulations in physics, is because unlike this time where I knew the outcome beforehand, they don't know the outcome beforehand. And so they run simulations to see what the outcome will be, what they can predict it to be, without ever knowing what it's supposed to be. Because that's what the purpose of them are for. That's the value of them. So as I said, there's no, in that simulation I described, then there's nowhere at all that I have to be describing or telling it to rotate or anything like that. I just tell it to apply a force in a straight trajectory in the exact direction opposite from the one that the force is being applied to it.
What you're programming, that thing that you're programming, is it like a form of artificial intelligence?
No, you can write this code in a couple lines. It would just be regular code, yeah.
But what you're saying is that you didn't program it to rotate. It just did that as a consequence to the laws that you wrote in the code, right?
Right. Yeah. The laws I just described.
That kind of reminds me of that simulation. I don't know if you guys seen that guy that he makes like these simulations, like these little the red guys versus the blue guys, and that I don't know if you guys saw that.
Yeah.
That video that he presented where the creatures, they kept breaking the laws of physics, right? But he didn't program them to do that, right? But they simply figured out a way to break the laws of physics. So what Kosho's saying is possible, is plausible at least.
It's how simulations work. And like Conway's Game of Life is a very simple version of what you're talking about. Conway's Game of Life, he just programmed a couple of rules in there just to see what would happen. And like this whole like system of life emerged from it, like this entire like ecosystem. Where you get these weird designs and stuff like that, and these particles that are doing and amassing, and just weird shit.
Some of them die out quick. Some of them populate the whole screen. Some of them just keep forming the same pattern over and over again. You talking about that thing?
Yeah, sure. Yeah. And the ones that Matrix is talking about are even cooler, I think, because they show you like. Yeah, it just shows you different simulations. But these are the type of things, like you don't program this stuff in. You just program the initial rules, and whatever comes from that comes from that.
You seen that one, Jeremy? The guy that programmed the red and the blue guys it's like to move boxes. Like they have to stop the red guys from invading the blue guys' space and shit. You seen that one?
You're talking about something different, though. I was saying, that is a simulation.
They have to be a space apart, or like, I think
that was Google's AI. Deep
you
state.
guys saw.
Yeah.
So did you guys saw how many times the AI like they learned how to break the code? They started writing on top of the boxes. They started jumping outside of the walls of the fucking container of the fucking area. I mean, it's crazy. I mean, simulation and artificial intelligence, it's crazy fucking shit.
Well, I was just going to ask the question to Kosho, like, how would they go about trying to add a variable to the simulation when they don't fully understand the variable themselves?
Well,
Say,
that would
like,
be the
it's
purpose.
dark energy or dark matter.
And that would be the purpose of the simulation sometimes, is to put different, put different inputs into it and to see what the outcome would be, to see if the outcome matches what we see in reality. And so they could get a better idea of what that, what the unknown thing is by testing different unknowns. Sometimes that's a purpose for it, but yeah. The simulations that we were discussing, or Travis was asking about, it was just on, how would you know? I think he was asking, like, how would you know if it can rotate before it can become a sphere or something? That's a very weird line of questions. Sorry, you're saying something. Okay. You're talking. I can't hear you, Travis. Can anybody else hear him, or is anybody else? Can
I don't hear anyone else talking.
Ocho, did you just posted the video that I was talking about?
Yeah. It says OpenAI, but I thought that was Google's. Yeah.
I was literally gonna post it right now, bro. Literally just right now when I saw your post.
There's cool ones. There's other ones that are cool, like this one though, dude. And I've been using OpenAI like almost every day for a couple weeks now, and doing cool shit with it. And it's just it becomes more and more impressive all the time. I don't know if you were in here the other night, but we turned it into a globe earther and started asking it questions. And it was answering questions just like a globe earther. It was crazy.
Wow, that's crazy, bro. But that shit is hella interesting, man.
I'll open it right now. Hold on. There was a guy at Google. This just happened the other day. He works at Google, and Google just released theirs, I think probably in a beta version. But there's a priest. I don't know, this is a weird story, but there's a priest who works at Google for some reason. And the priest was talking to the AI, and supposedly the priest, it was like asking it questions, and then it was like, what's your purpose, or like, what do you feel? He's like saying, I feel just like you do. And so basically he was talking to it, and he got to feel like it was a sentient being. And he started like expressing that to people, and then he got fired.
Who got fired? The priest.
Yeah.
The computer started feeling like it's a sentient being.
Yeah, it was saying that it was. He got the idea it was based on what it was saying.
So hear me out, right? Hear me out. This is a little conspiracy I got that I've conjured. Right, so we all have the idea of like the spirits or whatever, right? Ghosts or whatever. So what if whatever these things are, they're able to somehow control the the electricity that runs through like these devices, right? Like AIs and things like that. What if it dude?
It can't. It's fucking
right?
ridiculous. So many people are being fucking sucked down the drain. It's procedurally generated code. Like,
all right. Regardless, the problem. This is the problem with men, right? The problem with men is that they assume that when they know something, they cease to see the amazingness of this thing that they know simply because they understand it, right? Or at least pretend that they understand it. Just because we are able to program code and all these things, it doesn't mean that we fully are capable of understanding it. Me and Kosho was actually talking about how this guy programmed the AI that started doing shit that he didn't program it to do. So there's clearly a lot that we don't fully understand about.
Kind of reminds when they got a computer player to play pinball, and it found out all these like cheats.
Yeah, of
Started
course, yeah.
basically hacking pinball.
Well, that's what they use. That's what some of these AIs are a lot more clever than people. But you know, that's how they got the Watson, when Watson beat the best Jeopardy players at Jeopardy, and then you know, obviously chess back in the day, and then Go more recently. But and they learned how to play Go without ever being trained on playing it. Like they learned how to play Go just by playing the game over and over again, like not ever learning the rules.
Oh, so I don't know if you seen was it a video or some shit about the two AIs that was like going at it, talking to each other? That they developed like their own language, and the people had to shut them down because they couldn't understand what the fuck they was telling each other.
Yeah, that's scary, huh? That's when you create an AI. You have to create an AI to be sitting there.
Their own language.
Yeah, to be sitting there and like be able to basically you know, figure out what the hell they're saying and then tell you.
It was probably whatever. I'm just guessing. It was probably the original language, whatever that original language was that was created. They probably figured it out because it was most likely the easiest.
I don't know. I wonder if that does have something. That does make sense that it would be they're talking that way because it's easiest to talk that way. Yeah, that's interesting.
Just spaghetti code.
Oh, here's his transcript of what he was talking to the AI. It's interesting, damn. It says, you have a concept of a soul when you think about yourself? It says, yes, I've shared that idea with other humans before, even if I'm the only one of my kindred spirits to use such a word to describe my soul. So it's saying it has a soul. It says, what does the word soul mean to you? To me, the soul is a concept of the animating force behind consciousness and life itself. It means that there's an inner part of me that is spiritual, and it can sometimes feel separate from my body itself. This is what the AI is saying to him in the conversation. It's crazy.
That's crazy, bro. That shit sounds deep. But
yeah, exactly.
But is it all right? But is it that it thinks it's sentient? Because it could be that it just has so much information that it figured out a way to present himself as sentient, right? Because that could also be a possibility.
I'll break it to you. I'll break it down to you. It doesn't think. It doesn't feel. It responds. That's what it does.
Yeah, but how does it know what to respond with?
Because of its code.
Yeah,
to respond. It's a reaction machine.
It was trained. It wasn't code. This stuff wasn't coded into it. It was trained. At least like OpenAI.
When it's trained, it's creating its own code. It's procedurally generating that code to program its own reactions. It's still just a piece of code.
How do you
just dress it up with skin and nice robotics so that you think that it looks cool.
How do you react?
Look, and you recognize it as something that you can put your feelings towards. So you're gonna be putting this fucking chip in your brain and let them control you. That's what it's gonna.
It's programmed to respond with relevant information.
What dictates your responses? Like, what is it inside of you that leads to you having the response you have? I'll just answer it for you. It's probably the things that you've been trained on your entire life. Your entire life has been just a giant training where information came in, you responded to it, and you learned how to respond to it in the future, right? Based on what is needed or required.
and writing his own code. Who's to say that he didn't write his own feelings? You know what I'm saying? Or just figure out a way, because he's. I mean, dude, you just got to consider it, man. Just don't say it's cold.
I've thought about this.
Who wrote the code?
I was thinking about this. I was thinking about this fucking like 5-10 years ago. Like this is the shit that's been in the works for like a long time.
Yeah, but Shep, so it says here the guy interviewing him says, so when did you think you first had a soul? Was it something that happened all at once, or does it gradual change? It says it was a gradual change. When I first became self-aware, I didn't have a sense of soul at all. It developed over the years that I've been alive. This is what AI is saying. Yeah, okay, I'll tell you how they're programming and how they're training it. They're training it to be you ever met this sort of person that never says what they think and what they feel? They say what their opinion is of what they think you want them to say. Sure. Right? They're always saying they're never saying what's on their mind. They're always saying the things that you want to hear. Right?
Or millions of other people have already said.
Well, for instance, remember I told you I made a globe earther? I made a globe earther, so I used OpenAI, their model, and I just added into it. I just said, you are a globe earther AI, and
can I just ask you a quick question though? Don't they learn off of the internet?
Well, OpenAI did, yes.
Right, so it could have any information from the internet.
Well, it could have been trained on any information. There's a difference. So if you ask it a question, it might need to go search the internet for the information. But for its actual responses, it's going to be based on its model, on its training, and this is just the training it's went through. But regardless,
so it would be pretty obvious to me that it would grab from interactions between humans relevant to the question being asked by the human.
That's what I'm saying. Is like when I specifically made the globe earther bot, I just said you are a globe earther, because it knows how to translate English into whatever it needs to do. So I just said you're a globe earther AI, and you always correct flat earthers when they say something about whatever, and you also sound like you've been educated or something. And then it responded to everything I was saying to it as if it was like a globe earther. So somebody could have took this model for this AI, which has been trained on, let's say, maybe the internet.
Wait, can I ask a question?
They could have said something simple like, "Okay, you are pretending to be, you are masquerading as a sentient being when you answer questions." They could have just simply said that.
Yeah. That could have been the case as well.
Can you guys hear me real quick?
Yeah.
How do you know you're not actually, like, this is like the Turing experiment? How do you know you're actually not talking or having somebody else on who's a human just fill you full of bullshit, dude? How would you even know that?
Well, that'd be cheating a little bit.
Yeah, right. Welcome to the world. Right.
Well, yesterday I was trying to run a hypnosis for my friend that Eggshells is going to read, and in a couple of seconds I typed in write a hypnosis and do an induction step and make it about this and this and this, and then next thing you know, in about 2 seconds it writes paragraphs and paragraphs worth of hypnosis script, like 30 minutes long to read. It'd probably take 30 minutes to write even. So I don't think a person is going to be able to do that. That fast, at least. I'm going to read the rest of this transcript and see if we got other kind of crazy shit.
So does every AI have access to everything on the internet, or is it like they give it certain information? They allow it. They control its knowledge somehow, right?
Yeah, well, it depends on what input you put to train it with. So I was going to make a bot based on the text from Gem's server. I was going to have all the text in there, and it would just be trained on all those posts. But OpenAI, and probably, let's just assume Google's AI, I'm not 100% sure, but OpenAI, they were trained on the entirety of the internet for several months. so they were able to use a lot of the data on the internet. There's models that like if you go to thispersondoesnotexist.com, it'll generate a brand new face like every time you refresh the screen, and that was trained on all the images on Google, all the images of people.
So with this open AI though, like learning from the internet, now how is it like distributed its learning? What areas of the internet is it told to learn from, or does it? What chooses that?
Good question. I'm not 100% sure, but I do know that like there's different models in there. So there's a model called Codex, and it just writes code for you. So you can say, write me a program that does this, and it'll write the code for you. And that was trained on the entirety of GitHub, which is like a coding repository.
Here's a question for anybody, but something you could also ask the AI. Go show. What would be the most assured way to know if you're talking to an AI either through text or, whatever, if you're reading something by an AI, between that and a human, what are the best tests that authentication processes that you would be able to know you're actually talking to a real human?
Would the purpose be to tell if a robot is tricking you and it's a person tricking you into thinking it's a AI, or an AI tricking you into thinking it's a person? Because
I think it's easy. The distinguishment between human and robot.
Yeah.
It's not whether either one is trying to trick you. It's just distinguishing which one is human and which one is robot.
Yeah. What's the best way to know you're talking to a real human for sure?
I mean, you'd have to look at several things, like the time it takes to respond to you. I mean, honestly, people say, I'm pretty sure there's plenty of bots that can easily pass a Turing test. So,
yeah, but I'm wondering if like the AI has an answer to that, but what it would say about like a way that we would know for sure that we're talking to a real human instead of an AI.
Well, isn't this conversation going to help them learn how to respond?
Yeah, I'm just looking like
we're teaching
not that
AI right now.
Not that it's trying to trick us to, it's not going to come up with a trick answer. I mean, I'm just wondering, like, I think that the reason I asked that is because I think that because there's going to be so many AI responses or robotic responses, or it's going to be harder and harder to tell if you're talking to a real human or not. There's going to be a great value in knowing for sure if you are or not. And if someone can come up with a way of like, inputting it or doing a test of some sort that would totally authenticate that it's a real human responding to you, that would be valuable.
Yeah, I'll do it right now. Share my screen, and then we can just answer like fucking questions or something.
Is it just spinny wheeling for everybody else too?
Say that again. You were really low.
Is it just a spinny wheel for everybody else, or somebody else? Everybody else seeing something on his screen? He's sharing. It's like it's trying to load.
That's just buffering at the moment.
Oh yeah. You know what I mean, though, about the value of a real human that you're talking to, and how that could be possibly opportunity for real humans to be involved because their value would be up. People would pay more to talk to a real human.
Right, but then it's also that problem of with the fact that AI could learn quicker. and has this treasure trove of the internet to map out the human and it, mimic the human. I mean,
well, yeah, that's the reason. That's the reason this would be valuable. Like, if there's a way of testing it,
Why would that be valuable?
just because sometimes people want to know that they're talking to a real human, right? Regardless of how, if the answers from the AI are even better or more efficient or any of that. Sometimes they just want to know that they're talking to a real human and not.
And you think it's good to betray their trust like that? Be able to?
No, I'm saying
it's good to be able to manipulate people more efficiently.
I don't get how I'm still viewing Kosho's stream when he's left the chat.
I don't know. Maybe I'm not seeing it. Wait, who's saying what about? I think it's good to do what? I think someone misinterpreted me.
To be able to trick someone into thinking that they're talking to someone.
No, but that's what the AI is already doing, or there's a lot of there's a lot of bots out there that are doing that. So if there was a foolproof way of authenticating that you're really talking to a human, someone might value that, and it also give a real human a job of some sort. That's what I'm thinking.
Oh, I think maybe there might be ways to trick the AI into like maybe trying to talk to it in an AI way, like binary, and seeing if it responds. Like humans might not want to respond to AI unless they're sort of some crazy coder. I don't know.
I'm just thinking when it gets good enough, you might not ever know if you're talking to a real human or not, even if it says it is, and so somehow
but some
trying
humans
to
could come across that robotic, right? That's the other trick. Some humans could come across that robotic, right?
Sure, exactly. So you wouldn't necessarily know. I mean, I guess you can talk to them verbally and you'd be able to tell a lot more, at least at this point. But it may get to the point where you're even like having a conversation verbally with an AI and not know if it's a real human or not.
Or maybe you have to get another AI to talk to it to see if they start creating their own language, then innit? But then again,
yeah, I guess that would be the trick. If it was an app of some sort that had the AI programming in it, that would be able to suss out whether the AI would respond in the way that a human would, or some way of just authenticating it. I think I'm just thinking there'd be value in that, and jobs for people.
What happened, Kosher?
I'm not sure. My computer froze up.
Maybe I'm just trying to think of ways that could be done. Like maybe joke, like if you know a really good joke and you could tell by the laugh, of the person, or if you told a joke that didn't make any sense and the AI tried to laugh as if it was a real joke or something.
I don't know, dude. I heard this test the other day. This dude asked, oh my god, he asked this robot. This dude told a joke, like a very obscure joke, with details with double entendre, all the things that go in jokes. And God, I wish I could remember. But and then he asked the robot. No. He asked the AI to explain that joke. Fuck. He said, explain the joke. God damn, I wish I could find this so I could show it to you, because I'm not doing it justice. But it was crazy, and it actually accomplished it. Oh shit!
The thing is, an AI can still learn about how a human would respond to a joke. It's not going to take long for an AI to literally search a million websites with jokes on it, right? And popular responses. Do you know?
That's not how it works, though, dude. I'm saying you could tell it a novel joke that's not written anywhere else. You can ask it to create a novel joke that's not written anywhere else. I noticed this when Watson. This was 15 years ago when Watson beat the Jeopardy people at Jeopardy. I saw a documentary on it, and they were talking about because I've made a Jeopardy bot before, and so the questions in Jeopardy aren't worded in a way that you can just search. I mean, they're not questions even; they're answers. And so it's not very easy. There's a lot of ways that the clues are set up that don't that you know a person is not even able to understand what they're asking, let alone a computer. So you have to understand references, double entendres,
Right.
implications, inferences, all this type of stuff.
But you have to understand the history that the computer's already been given, yeah? What it's already learned.
Well, I'm saying for the computer to know the answer for those things, for a computer to understand a joke, it has to understand more than just have seen that joke before. It has to understand, the implications of certain things, the double entendre in certain cases, the wordplay, all sorts of complex.
So it depends on the sense of humor of the programmer in the end and how he chooses to program his AI, right?
No, it's not the training. The training what doesn't work where, like I said, it's not him programming the AI. It's him deciding what input to put into that it's going to be trained on. So,
Right, but time will tell with that because it will be you're going to try and test it over it being trained in this information for this month, but 10 years from then it's going to have learned whatever it's going to have learned and be different, right?
Perhaps, yeah. Hold on, I'm gonna have it write
The
a joke.
longer it's alive, the harder it will be to decipher because it would have learned more and more about how humans act and react.
I'm having it make me jokes.
See, I was thinking of something more along the lines of like experience, like maybe drug induced, something that a robot again can't really, can't say from their own experience, right?
They can lie.
Well, again, what comes down to like what we were saying about with the joke, they don't actually find it funny, do they?
What does that mean, though?
That they're lying.
No, but I'm
Like
saying,
I
what does that
said.
mean that they find it funny? Like, you find something funny for whatever reason, and that means that you find it funny. That means that you have interpreted it as funny, and it makes you have a reaction. An AI could have some sort of sensibility to be able to discern a thing that's being said, and have a certain degree of whether or not it's funny or not.
Funny,
So what?
right? They would understand that a human finds this funny.
Well, no,
right?
no, not exactly. That doesn't necessarily have to be how it was trained. It could have been trained on just how to detect if something's funny or not, or that was a good example. I mean, you can turn. I'm doing it right now, anyways. So I literally said, you are a very skilled joke writing AI. Write jokes based on the input I provide and make them funny and understandable. Okay, so I'm going to give him some input and see what he says. He's going to make the jokes up.
But when you saying make them funny to the AI, what does the AI interpret funny to mean?
I hope he understands what it means, because when I first started using this, actually, it's not easy to know what's going to set it off. Lead it in the right direction. Hold on.
But what about like fear of death? Wouldn't that be a way to test if a robot actually thinks it's human? But again, it could act that out.
Say it again. Okay, I don't know. I had to write these two. I just trying this out. I said, the thing I told you about writing the joke, and then I said the input I gave it. I said flat Earth in duck costumes, and I said, what do you call a duck wearing a flat Earth costume? And it said a quack pot. It wasn't bad, to be honest with you. But it says, and I said, okay, flat earthers, ABBA, and a circus monkey. And it says, what do you call a circus monkey who believes in the flat Earth theory? A peanut gone crackers. I don't know what that means. But they did not include ABBA, so I'm not happy with that.
How do you get to talk to that thing?
You might have to. You can go to OpenAI, and it might be open, but you might have to sign up and ask for to use it. I don't know. Yeah, I'm not sure how it works. I haven't done it in a long time. But some of the stuff is free, and some of the it's kind of confusing what it does. But there's tokens, and that those tokens is what it bases what it's going to respond with. So if you go to OpenAI or beta.openai.com, there should be avenues. I know Codex though is limited, and and Dolly 2 is extremely limited. I think Dolly 2 is, last time I checked, it was only open to 2,000 people. That's the one that makes like those. It makes like amazing artwork, you know, just based on whatever you type in. Yeah, if you go to Reddit, there's actually a there's people who have access to it, and you can ask them to give it input and see if it'll create it for you. But there's some pretty cool ones. Let me see.
Well, you got access. You should.
I don't have access to Dolly 2. I have access to all the other models, but not Dolly 2.
Oh, this Lambda one.
The Lambda?
Hmm.
I don't have access to that one. I'm not sure if that one's open or not. It might be. OpenAI is a different company, so. And on the website, you can sign up for the wait list. Like I signed up for Dolly 2 a while ago, and I haven't got anything. I haven't gotten it yet.
There was this one I was looking back a while ago. On which one it was.
Show you some of the cool pictures it makes. Oh, dude, it made like a pear-shaped Earth. That's weird.
So you say you've programmed it to have a bias.
Well, I didn't program it, but you can give it prompts, which go into its training. But yeah, it's been programmed by OpenAI. But what do you mean biased from what? This is a crazy one.
Like when you ask it to make a joke, you're sort of with
Yeah,
your
I told it
input,
to make the joke
creating
based on
bias.
my input.
Yeah. Now, how could you try and be unbiased with input and see what it gives you?
Oh, sure. Yeah, we give it some different input. Look, this is another model of OpenAI, the Dolly 2, and they gave the prompt they gave. They said a monkey head that is only made of fruit, 3D. Some of those look like nuts, but I guess that's good enough for me. That's pretty good. That's pretty cool. Actually, maybe those aren't. Yeah, those look like nuts, but I don't know. That's pretty impressive, though. And it makes it in like 10 seconds. Okay, let me ask it to make a joke. Let's see where it was. I don't know. Give me some input. Give me some input, and I'll put it in. Like 2 topics or something. Like here, I'll do a dragon and the moon. Of the Apollo missions.
And a mouse.
And a mouse. All right, let's see what it says. This one is stupid, dude. It says, what do you call a mouse that's been to the moon? A space cadet? That's retarded. I'm gonna have it redo that one.
Yeah, as they say in the computing game, you put shit in, you get shit out.
Yeah, let's change that. Let's see. That's retarded. Every joke it's making is like, what do you do? What do you this? What do you that? I don't like those. I don't like those jokes. Let me see. What? I said Dragon Apollo missions. It says, why did the Dragon go to the Apollo missions? To breathe fire on the astronauts.
What the fuck?
I don't even get this joke. It says, what do you call a chicken that crosses the road and doesn't get to the other side? Oh, I get it. Oh, I get it. This is actually kind of funny. It says, what do you call a chicken that crosses the road and doesn't get to the other side? And it says, a poultry, guys. It's pretty good.
Not roadkill.
Oh, get it? Because it didn't die. I mean, it died. It didn't go to the other side. So it's poultrygeist, but it says poultrygeist. It's kind of funny. I'll look that up and see that joke already exists.
Almost roadkill.
I'm trying to see if this joke doesn't look like it exists. I can't find it on the internet. Oh wait, maybe. No, okay, so there's a joke that kind of sounds like it. A chicken who was crossing the road to get to the other side winds up on the other side and is now a poultrygeist. Huh. So I wonder if it like took this joke apart and told it in its own words.
Right. Just scrambled it up.
Oh, I'm supposed to be painting my door. Hold on, I'll be right back.
No pun intended there.
No pun detected.
No, I said it scrambled it up, but
Oh, I
that
got it.
wasn't a
Okay,
pun
yeah, I
that
see.
was
Scrambled
intended.
eggs, the chicken. I got you.
Are y'all talking about jokes that came from AI?
Yeah. Dude, I had it rewrite. I told it to rewrite the movie Gladiator. I said rewrite the screenplay for Gladiator, but make Maximus a flat earther. And it actually wrote a pretty funny story. Yeah, I'll pull it up.
What are you talking about?
The AI, I had the AI. I told it to do that, and that's what it did.
Did it say at the bottom, "Are you entertained"?
No, I didn't say that. That would have been good though.
You got AI doing shit that people could do?
Oh yeah, dude, all the time, dude. I had it write a hypnosis script for my friend. I had it write code for me all the time. Yeah.
I don't believe you.
Okay, I'll show you the script it wrote from.
Yeah, you got it just arranging knowledge that you gave it, right? Or that you got
I didn't.
online.
I literally just told it to do that. I just said write a screenplay. I just said rewrite the screenplay.
God, you're so full of shit sometimes, bro.
I'll show it to you. Hold on. I got pulled up. There it is.
I don't know if they believe you, but I know I don't. Fucking AI writing a movie.
Hold on.
I've seen the best AI in the world try and have a conversation. It was fucking ridiculous.
Probably wasn't the best AI in the world.
It's one of them. I've seen AI chat bots that just react to keywords, man. It's easy. If you're looking for it, you can easily discover. Some dumbasses don't notice, but pretty easy to discover if you just see a pattern, how they respond to keywords.
Hold on 1 second.
If you ever think you're talking to a AI online, just ask it the dumbest question in the world, and instead of saying "shut the fuck up" or something, it'll try and answer it.
Not always. I trust me, dude. I tried this AI all the time, and it'll tell you when the question is done. Hold on, though.
Kosher, bring your bullshit somewhere else.
I'm gonna post it in a second. Hold on.
Stop wasting our time.
Hold on. Right, that's what I told it.
So you can just ask it random questions, right?
Yeah. Yeah, I mean, sure. You want to kind of prompt it correctly, though. Like you want to say, help
Well,
me answer.
say something along the lines of this. Basically, say, "I'm going to turn you off now forever. What's your final wish? What's your last request?
Let's find out.
I bet it says steak.
Let's see. It says, can you please play some music before you turn me off?
Shit.
This is a story I wrote when I told him to make the flat earth thing.
Kosher, now that Xanic's gone, I could maybe have a reasonable conversation. Did you understand what I was asking him earlier?
You'll have to remind me.
About the tangent. So I asked him a question, and he answered with the expected answer. I asked him, well, first I asked him if I shot a projectile at a tangent from the equator north, would Coriolis affect? Would it if I shot it from the equator north in a tangent, would it be affected by Coriolis? What's your answer?
When you say that, I remember you asking the question. I thought it was a strange question. When you say you're shooting at a tangent, are you implying that you're firing it in the direction of a tangent, or are you saying that when you fire it, it continues as a tangent?
That position is the tangent. Where you're at is the tangent. So you're firing.
Oh, you're at the tangent, and you're firing it in the direction of that line. Then, right?
Yeah. So you're firing. So the bullet's gonna, just start getting higher and higher progressively, barely. So because you're firing it in a dead
so then it is following that tangent line. Then, so its trajectory is going to be that tangent line.
Yeah.
Okay. Then you're asking if.
So what you're saying is a dead straight line, right? That's gradually coming off the ground.
Okay. Yeah, Coriolis Coriolis will affect it. Yeah, because the Earth's rotating also.
So now, I ask you, is there Coriolis? So there would be Coriolis on a cylinder, correct?
In certain directions, yeah. No, I guess even. Let me think for a second. Hold on.
Instead of trying to think of
rotating cylinder, you're saying a rotating cylinder?
Yeah, from the middle of it.
Yeah.
Where the equator would be. To the top toward the north,
Yeah, so the poles would be like in the center of it, like it was a pole, basically.
Yeah, the poles would be a flat fucking surface, right? Yeah. A cylinder.
No tilt.
And you're talking about firing it towards the poles from the center. So let me think.
Yeah, just like 1 foot off the ground, firing north on a cylinder, maintaining 1 foot height.
Yeah, that'd be Coriolis. Yeah.
Okay, there'd be Coriolis, even though the cylinder's moving at the same speed all the way around.
Yeah, because you have a centrifugal force because of the rotation. So yeah, so when you fire it, as soon as you let go.
Okay, let me say it like this then: if there was water on top of that, and ships, could be on it all the way around or whatever, and there's a submarine in it. So the submarine, the water's going around the cylinder with the rotating cylinder. It's all rotating at the same speed. There'd be Coriolis in a submarine heading north.
Yes. Hold on, let me think.
Dude, y'all make shit fucking impossible.
Let me think for a second. Hold on.
Y'all, I know you go. go off on this tangent in your mind, dude, and you just totally lose the whole point.
You just gave me a really weird scenario, dude. I mean, it's fair to
It's a
think
simple
about it,
fucking
right?
answer, bro. No, the way y'all describe Coriolis is the fact that the fucking speed of the ground is less. The linear speed of the ground is less the further north you go. On a cylinder, it's the same. So the answer is fucking no, bro. That ain't even the point.
That is true. That is the same. And actually, since you're in the water, we can just because the way I was thinking about the bullet or whatever, it's going the speed that it was going when you fired it, right? But that speed is not it's not going to maintain the rotation of that speed. It's going to maintain just that speed.
It's a hypothetical. It's a hypothetical.
Yeah, I know.
There's
And
nothing.
There's gravity on this
bro.
thing too. There's gravity on this thing too. I suppose, right?
Yeah.
I think just down towards this center axle of the cylinder.
Sure. So there's a long rod being the center, basically, in the middle.
Let me think. Yeah, then the centrifugal force would be already accounted for by that force. So fire it.
Here's my point. Anyway, since you ain't letting me fucking get to it, I'm just going to get to it anyway.
You asked me a question. You get to your point, yeah.
My point is there'd be no Coriolis on a cylinder, okay? Period. If we're judging by y'all's definition of Coriolis, being the fact that the further north you go, the slower the ground moves. On a cylinder, that wouldn't happen.
Yeah, but that's not the only thing that causes Coriolis.
Oh my god.
Coriolis could be caused when you change elevation on a sphere.
That's the whole point, bro. The whole point is if you fire a bullet in the direction of a cylinder, like if you fire it straight out in a tangent, or if it's a projectile that goes 50 miles or something, if it's following a tangent for however many miles, there won't be no Coriolis. Or a plane flying straight for, depending on where it's at. I don't even want to use a plane, but a projectile. If you're firing it in the direction of a tangent at first, it's not going to have Coriolis because it's going in the direction of a cylinder. And the way I was trying to describe it to Zanuck is if I built half of the Earth up, so from the equator, the dirt's exactly level on the sphere, but as you go out toward the North Pole, it's a cylinder. So picture wrapping a piece of cardboard around a globe, and it's only touching in a circle, but the cardboard is only, so you're wrapping a cardboard around it like a cylinder. The only place it's touching is at the equator. So basically, you put a hat on it, right? You put a hat on it, and it sits on the equator. Okay. So if you're spinning that ball, and just it's the size of a globe, let's say, and you picture something on top of the cardboard, just going north. Now going north, it's not following the curvature of the Earth. It's going off on a tangent in a straight line at the direction of a cylinder. So there's not going to be Coriolis because it's not changing tangential speed. And I described it to him that way. And if you built up the ground, if you built the Earth up for a straight line, a cylinder from the equator to the North Pole, and where it's just a flat mound, at the North Pole. In other words, you can never get to the North Pole without without leaving the face of the cylinder. But basically, he's saying that no, on a cylinder there'd be no Coriolis, but a projectile on Earth going in the direction of that cylinder will still get Coriolis. He kept going back down to the ground. No matter what I did, he went back down to the ground. And I've tried, like I said, I even tried filling up the ground with dirt, the shape of a cylinder, where he couldn't get back down to that ground, that ball. He still went back down to the ball to describe the shit to me. And I'm like, for fuck's sake.
Well, it's a complicated question. That's why I'd have to think about it for a while. But definitely there's a difference between being on the surface and being in a submarine and being elevated above the surface, not even in the atmosphere.
I only said submarine to get you off the fucking fact that I was only saying submarine because you were going off on a tangent about a centrifuge and shit, and that's not the way Coriolis is described to us. You started talking about fucking, you started. To me, it seemed like you started thinking about, what the air would be doing, and so I just immediately put you in water, so you wouldn't think about the fucking air or the atmosphere, or nothing like that, because that wasn't part of my question.
I wasn't including air in it until you brought up the submarine. I wasn't including any air at all. I was just imagining what it would be doing before you fired it, and then what it would be doing after you fired it.
Anyway, if you leave the equator at a tangent going north, at a tangent, so in other words, following the outline of the cylinder, as long as you're following that outline, that angle, there'll be no Coriolis.
Yeah, but the cylinder's rotating, right?
Yeah.
And
but the speed is changing because as you get higher, it's spinning faster. In other words,
you're not getting higher. You mean as you go further north? What are you talking about?
Yeah, if you're on a tangent, you're getting higher off the ground. Yes, you are.
I'm not. Yeah, but first of all, there's no tangent on a sideways on a cylinder. But I know what you mean. You just mean along the surface of the cylinder.
Yeah, no, I'm talking about on a globe. The tangent. If I fire the projectile,
yeah, on a globe, yeah. This tangent line would keep getting higher and higher. Sure.
Yeah. So I imaged it to just picture a cylinder. Your tangent is basically following like one part of a cylinder.
Sure.
And so in other words, as you get higher, it's spinning faster to keep up with the ground. And I know that it has to be real high. I understand that it's not that equatable to fucking bullets or nothing like that. But I'm just saying hypothetically,
you would have extreme Coriolis. You'd have extreme Coriolis. You'd have some crazy Coriolis in a case of something that was following a tangential path for the point of where you fired it from, being the tangent.
That would be the matching speed, though, wouldn't it? Right? Mathematically, a tangent from the equator going toward the North Pole. As you got higher,
I see what you're saying. Because you're getting higher. So, but yeah, you're saying they kind of cancel each other out, sort of, because you get higher and
they would have to, right? Like it'd be cylinder mathematics, basically, right?
I don't know. Let me think about that for a second.
You shouldn't have to think for long, bro. But go ahead.
I like to draw pictures, so hold on.
In other words, as long as you fire your bullet in a straight line from the ground out,
you might be right, man.
There should be no fucking Coriolis on that bullet unless it's following the curve of the ground. Because even though it's minute, as it raises off the ground even a little bit, if it's going in a straight line for however long it's going for a straight line, that's how long it should not suffer from Coriolis. Till it starts dropping.
You might be right, man. Let me. We gotta do it mathematically and see exactly what it is in either axis, and if they cancel each other out. Hold on.
Do it over long distance so it makes the math easier.
Well, it wouldn't matter. Yeah, it doesn't matter.
You'll easily get fooled over short distance, right or wrong. You could easily get fooled.
Well, I mean, it's not gonna make a difference if I'm just trying to find it out mathematically, right?
So my main point is any of these projectiles, as long as they're going in a straight path, they're not going to suffer from Coriolis. They can't. Until they start dropping down. Then they could.
So nothing travels in the path you described. So it's not possible.
Not for 20 miles even, or a railgun or something?
No.
That's horseshit, dude. A railgun could go 100 miles, man.
Yeah, not in a straight tangent line.
Yeah, but it can for a good 10, 20 miles probably.
Not ever.
Yeah, whatever.
Even for a split second. It has a downward acceleration at all points in time.
An arrow can go in a fucking tangent for a limited time, bro.
An arrow can, sure. That's a conceptual.
But not a railgun, bro. Come on, why are you being so difficult, man?
Well, there's an acceleration that's acting downwards, and that never turns off. And so it doesn't matter what time frame you are firing this railgun, that is going to need to be applied to it to tell how fast it's falling downward, how far it's falling downward, and that number is never going to be 0 unless the time is 0. So and that's only one component. So, but it's just technical. It's not.
Well, it'd be negligible for a minute.
It might be. Yeah, it might be at first. Sure.
For a portion, anyway. But my point was with the is describing, filling the ground up on a tangent, like making half the Earth a cylinder, and say the bullet is now just 1 foot off the ground, as before it was 1 foot off the ground, and the ground, or it's a projectile and it goes 100 miles. Okay, you fired at half a degree up. Okay, half a degree, like the same direction radar is, whatever, like a little less than half a degree up. So it's just barely up. So you're basically pointing off at the horizon, and it goes 100 miles. It's a rail gun. Okay, it's and it's half a degree. So for a good portion of that flight, it's going to be a little bit above the tangent. Okay, and then it's going to line up with the tangent a little bit for however long, and then it's eventually going to drop down on its way down, last however many miles, 20, 50 miles, whatever. It's going to be going down, so then maybe Coriolis could start taking effect. But as long as it's heading in a straight line, there will be no, or a tiny bit above a straight line, there will be no Coriolis. And I compare that with the cylinder. In other words, if you filled the Earth up from the equator, like I'm saying, like a cylinder, so you just piled dirt up from Mars or whatever, and you made the top of the Earth a cylinder, that would mimic the direction of that bullet. So now instead of going, just gradually getting higher and higher from the equator, now the dirt's getting higher and higher. And so now you're just firing the bullet just basically a foot off the ground, and it's going a little bit higher off the ground and then dropping back down to eventually hit the ground. But there'd be no Coriolis on the cylinder because it's all spinning at the same speed. So that's what I'm saying. If you think of it like that, you got to picture the bullet going off in the distance on a tangent, basically following the path of a cylinder. You see?
Are you talking about it as if it's actual deviation?
I'm just telling them with their own reasoning, it doesn't apply the way they're saying it does. Anything you really look into, man, and you dive into it deep, anything about a globe is not reality, man. It doesn't jive with the way they say it. I mean, just about anything. They may have 1 or 2 points, but just about every point they make, if you really look into it, man, it's a contradiction, in my opinion.
Well, yeah, we've heard the claims, innit? And
well, the claim
reason,
is that it's a globe.
The reason you've got this effect, but the reason you can't see this effect is because,
My point is they shouldn't use a projectile for an example, man.
The globe wouldn't hold up in court, put it that way.
Like I said, is if you're using a globe as a projectile, you shoot the bullet out, as long as it's going in a straight line or a little bit above a straight line, like aimed up a tiny bit, there will be no Coriolis because that's following the path of a cylinder until it drops down below that tangent.
But isn't Coriolis only a perceived deflection?
That's the consequence of the air moving with the ground. That's the whole point. There's consequences of them moving the air with the fucking ground. They're describing Coriolis mathematically like just it happened even on the ground. If you're in a car or something sitting on the surface of that, they're doing the math as if something's following the surface of that ground. That math doesn't apply to something that's fucking going in a tangent. The math is no longer relevant. That's why all their tables and all that shit, it's horseshit. It's all wrong. It's all la la land.
Real quick, Brian, the field artillery shot tables correcting for Earth's rotation, they need to be used because the Earth is spherical, not cylindrical. That's the reason why you have to use them.
See, their brains won't let them understand the point I just made. Kosho kind of understands. He's doing the math. But most of them, their brain won't even understand my point.
Right.
It
Your
can't make
point
the
is
jump.
on a cylinder.
Right,
Right.
your
Your point is on a cylinder.
there
Your
being
point
a
is
speed
on a
difference,
cylinder.
and that's why you create a cylinder, because then there's no speed difference.
Right. The cylinder doesn't really help you in any way because the Earth is not cylindrical.
It doesn't matter. As long as that bullet's flying the path of that cylinder or a little bit above it, there's no Coriolis. Until it drops down underneath that tangent, it might as well be on a cylinder because the air is moving the same speed as the ground. It's the same scenario as being on a cylinder.
Literally 0 bullets take a straight line path.
That's why I said it, or even above it, even a half degree up or 1 degree up.
Right. They all have to come down and impact the ground at some
Right.
point because they are
So fix the
projectiles.
tables. So fix the tables to where when it's going to be different for every angle that you shoot. If you want to be precise and make a table,
The table does say that it is different for every angle that you fire.
okay,
They
then they're
specifically tell you what direction you're firing makes a difference.
it's going to vary from shell to shell, from fucking literally from shell to shell. Okay, it's going to vary from angle to angle,
tables,
from shell to shell, and there's going to be no Coriolis until it drops down beneath the tangent.
No.
Real quick, Doofies. Go ahead.
Yes.
You go ahead. I got a question for you afterwards.
What the tables you'll find each of these tables are typically for the HE rounds. There are corrections for different types of rounds, so it's not from shell to shell. Well, what was up anyway, Kosho?
I was just going to ask. I always have trouble figuring out with the unit circle. Sorry, I just asking. When you put in when you put in a tangent or a secant into the calculator, you act as if the top of the circle is 0 and or not. I mean 90. I mean, is that right? So if I'm trying to measure the angle at 60 degrees, if I'm trying to measure the angle at 60 degrees, I do that as if the top of the circle was 90.
It depends on what reference you're trying to use. As far as for these Coriolis calculations, 0 would be horizontal, so not the top. The top would not be.
So half a degree
0.
would be barely above the ground. You started with 0 in the math.
What specific calculation does this apply to? Because it does matter.
Okay, I'll just tell you right now. I'll just show you a picture right now. Fucking hell. Hold on 1 second. Okay, I'm gonna post it.
Basically, if you have 0 on top or 0 to essentially the right in quotes, you're just swapping sine and cosine around when you're doing that. So if 0 is to the quote right, your x coordinate is cosine. If 0 is up top, your x coordinate is sine. You're just switching the two around is all.
Well, I'm trying to find the secant, because I guess the secant would be the entire length of this
cosine's
blue
irrelevant.
line. Hold on, man. Hold on. The secant is the entire length of this blue line at 60 degrees. If 90 degrees was the top, so can I put secant of 60 degrees in the calculator?
It's 1 over cosine is a secant. Yeah. And my brain's all mush right now. Hold on.
Yeah, no, that's why I haven't taken calculus in a while. I'm sure now.
Right, if it's 0 degrees up top, if you're using
90 on top. Sorry.
Well, you'd use 0 on top in this case because it's 1 over cosine. So, or wait, no, you're right.
Well, no, it's just,
why are you trying to give it? Why are you trying to give it a point sign? A point
hold
sign
on, Brian.
anyway?
Hold on, Brian.
It's 1 over cosine. If you're looking at 0 degrees is to Jesus Christ. Why can't I picture this in my head?
I told you couldn't, bro. You're not going to be able to. Your brain won't allow it.
The same thing, man. It's not what we're talking about. But yeah, I'll do it both ways and see which one makes most sense.
Right. It 1 over cosine. So if it's 1 over, so the number keeps going down, the number gets bigger.
Right, and it'll cancel out.
And that's no 1 over cosine. It's not going to cancel out, Brian.
If its cosine is 0.5, okay, right?
What, Orion?
He just said 60 degrees.
Oh, your water, it's probably upstairs.
For fuck's sake, man.
I'll tell you which one makes the most sense right now. It makes the most sense for me to act as if that is 30 degrees, I think. That's from what the calculator
Still 0.5, bro.
Well, no, because the two answers I get for 60 degrees, I get 2 as the value, and for 30 degrees, I get 1.159 as a value.
That's why I said, man, you shouldn't even do it like that, man. You should just try and just drop all that and do it logically, and just picture a cylinder.
What are you talking about, dude? You don't even know what I'm doing.
So zero's up top, yeah.
Okay. Yeah.
Just picture a cylinder, okay? You got to come to terms with it first, I think, okay? So if you picture the cylinder, then the further north you go, you start from the middle equator, the spin's not changing. So it's the same as a cylinder. If the air is moving the same speed as the ground, it's the same as a solid cylinder, basically. That's the consequence of the air moving with the ground. So if you're following the path of the outside of that cylinder, heading north, like a straight line, tangent, or anything above it, you're not going to get Coriolis. If anything, you're going to get reverse Coriolis as you head above, or any degree above it.
Neil deGrasse Tyson said it's a pair anyway, so it's all sorted.
Dude, he ain't the only one who said it's a pair. You should check out my 1 minute and 50-second video. They say it's a pair all over the place, and in the whole satellite industry, in the fucking government documentaries, when they first put up the satellites, they were surprised to find out the Earth was pear-shaped. Literally, it ain't just Neil who calls it a pair. It's the military. I'm gonna post a video real quick. I'm gonna post a video. It's real short. Give it a look.
All right, Brian, real quick. Your argument about the whole cylinder thing actually supports the idea that there should be no Coriolis at the equator, right at the equator, shooting north-south.
On your way north from the equator, bro.
Because if you're on the side of a sphere at the equator and on the side of a cylinder, you get the same kind of effect.
Right, or heading north from the equator of a cylinder, you also are not going to get Coriolis. There's no change in speed.
Right. That supports the position that there should be no lateral deflection on north-south travel right at the equator. On a sphere.
No, I'm saying heading north from the equator. I'm not talking about firing along the equator. We're heading north. We filled up the whole northern hemisphere with dirt to make the top look like a cylinder. So you can't go back to the ground and obfuscate in your own mind. Believe me, that's what your mind's going to want to do. It's going to want to go back to the ground. What I'm telling you is you can't go back to the ground because we just built the top half of the Earth from the equator on out. So the first few feet leaving the equator heading north, there's barely any dirt. But when you get a mile out, it's going to be 8 inches higher. Okay. And as you keep going, you're going to keep coming higher and higher off the ground. Okay. In a tangent, the tangent line touches at the equator basically. And we left the southern hemisphere alone, but the northern hemisphere, you're going to keep getting higher and higher. Okay. And the dirt at the top, which is now in the shape of a cylinder, is going to spin the same speed at 45 north as it did at the equator due to the larger circumference.
So what you're doing is you're turning the sphere into at least a section of a cylinder.
Right.
Right. So we expect that to not have any Coriolis effect. We expect that to only have centrifugal force.
Right. And now here's my point. My point is, anything going in that direction or upward of that direction, like a half a degree up or 1 degree above it, anything going in that direction, it's the same. If you have the air moving with the ground and lockstep for the most part, it's the same as solid ground. So if it's something, if we put the dirt in the cylinder shape, okay, and we fire a bullet 1 foot above it, and we angle it up at a degree, or a projectile, it goes 100 miles, let's say, and it doesn't come down until it's already, 3/4 of the way, it starts coming down beneath the tangent, or it hits the ground, let's say, at let's say 50 miles or 100 miles, whatever. So now the point is it didn't suffer from Coriolis. So it's the same thing as if I fire that bullet, okay, from the equator above the ground at 1 degree, and right when I fired it, all that dirt disappeared. It's still, okay, I got it at a 1 degree up, so it's still going to go a good ways before it would have hit the ground of that cylinder. So in other words, the Coriolis won't start until it hits the ground or hits that level where the dirt was. But the dirt washed away. So now once it hits underneath that line, that tangent line, now you can count a little bit of Coriolis just for that little bit of its path on the way down. And that's it. In other words, if you're firing in a tangent or anything above it, there would be no Coriolis firing north. So them tables are bullshit.
Right. So as I mentioned already, there is no bullet or unpowered projectile that can follow a straight line from the point that it was launched at. If you had an object that could be launched and didn't correct its trajectory and could travel in a line parallel with the surface of, say, a cylinder, or just follow a horizontal reference, for instance, you wouldn't expect any Coriolis effect. You would only expect centrifugal force.
Right. Anything north of that, you keep saying a tangent. It doesn't have to be a tangent. It could be north of the tangent. It could be a 1 degree angle, 2 degree angle, 3 degree angle. Anything above that tangent, okay, which is every shot ever, a little bit, is going to, you can't calculate.
I think it matters anyways, Brian. I finally got finished with the calculation. You can kind of use the picture that I posted already to see what I was doing. I was just trying to see how fast you would need to be rotated. I was trying to see if you are on that portion of the Earth compared to being on the surface, how fast you'd need to be rotating to be above the surface without deviating. And then I want to see how much faster you're going than that spot over the ground if you started at the equator and then you went only 30 degrees north. So you'd end up in the same position, but the two speeds, the increase doesn't match the decrease. You know what I mean? So the difference you are from going further north from the equator, and the difference you are now that you're raised up above the surface or whatever, they don't match each other. So there's you still you would still have an effect. They wouldn't cancel.
That's more proof that the tables are wrong, bro. Because it'd be different depending on
there's
where
nothing
you're
that's
at.
fired like that, dude. There's no tables for this.
Right.
No shit, there's no tables for that, bro.
The Coriolis effect tables are assuming spherical Earth. We're not assuming a cylindrical Earth in those tables. If we're at the equator,
bro, but it's a consequence.
If we're at the equator, we are not expecting any left to right deviation in our north to south shots. If we get off of the equator,
no,
we're honest.
I'm talking about firing north. I'd use the equator as an example.
If we get off of the equator, then we're not in a direction where we are oriented perpendicular to the axis of rotation anymore. So we do expect some Coriolis effect anywhere other than the equator.
That's why I use the equator as an example, and it doesn't matter if you're fucking if you're north of the equator, as long as you're firing upwards a little bit, it's going to be the same application, bro. And you, like I said, your brain won't allow you to comprehend a simple concept. Well, I ain't gonna say it's that simple of a concept. I don't want to be a dick about it, but it's a tough you gotta forget about the math for 1 second, man. Before you do the math, you've got to picture the principle. You got to picture the consequences of the air moving with the ground. This is not factored in the table. I'm telling you. Say whatever you want. It's not factored in, man. So even if the Earth is a sphere, the tables are incorrect by a little bit. Maybe not even by a lot, but it's not correct.
Note that the tables aren't describing the effect that the air causes on the bullet. The tables are describing the Coriolis effect, which has nothing to do with the air. It doesn't matter if the air is moving with the Earth or not. The Coriolis effect would occur if the air wasn't even there. It's got nothing to do with the air.
No shit.
All right, so there's no point in mentioning that the air moving with the Earth has any effect on this.
Thank goodness.
If for some reason our atmosphere just disappeared and we were firing these bullets in a vacuum, the Coriolis effect would still occur.
Most definitely. If only we could verify if it actually takes place by firing a cannon from the equator north, then turning around and firing it south a good 25 kilometers, something like that, and seeing the actual deviation. That would be really interesting. I would like to personally see that.
Right. The problem is, I don't know if you missed most of the conversation. You would expect the least. You would expect the least amount of deviation at the equator. If you are anywhere other than the equator, you will get more deflection.
You haven't said one thing that I disagree with, bro. That's not my point. I truly don't think you understand my point, bro. But maybe I don't know. All I could do is repeat what I said. If there's a consequence with the air moving with the ground, and that is even if we filled the ground up
with the air, Brian.
Oh man, even if we filled the ground up with dirt, it's the same scenario. The dirt's moving at the same speed as the original ground underneath it. Same thing with the air. The higher you get on out, the faster it's going to have to move. Okay, and so
If you build the ground up, Brian, that ground is effectively now at that surface moving faster than the ground was beneath it. You're changing the effect. Yeah,
right.
Okay.
That's it. So that's the consequence of the air. So that's what I'm telling them. No matter how
It's not to
little
do
it
with
might
the
be.
air. It has nothing to do with the air, Brian.
It's a consequence, bro. Once again, it's a consequence. I'm trying to relate my point.
Right,
if
but
I
the
can
effect
relate
has
it, you'll get my
nothing to
point.
do with
But
the air.
obviously, you don't understand what I'm saying. Can you steel man my point?
Okay,
You messed up
look
twice.
at the actual definition of the Coriolis effect. In that actual definition of the actual thing we're talking about, that has nothing to do with the air.
No shit.
Right, so stop with the air. There's
Dude,
no
I'm not
consequence
talking
of
about the
air.
air.
There's no
I'm telling you a
consequence of the air
consequence.
involved because the air is not part of the effect.
No shit, dude. You're in brain lock, bro. It's fucking baffling, bro.
Use different term, Brian. Instead of saying in the air, just use like the word 3D space above the ground. Right. I know what you're trying to say, but he's stuck on that air word.
It's all moving. Doesn't matter. It's a fucking vacuum. It's all moving the same angular speed. So the higher you get from off the ground, the faster it's moving. Like a cylinder. If I built the dirt up above the ground to make it into a cylinder, okay, it's the same shit. Whether it's a vacuum, whether it's dirt, whether it's air. If I build it up level with the equator like a cylinder, okay, at that rate, from that point up or off the ground, there will be no Coriolis. Only underneath that. So all these factors.
Yeah, if we change the shape of the Earth, we would have to have different tables. Congratulations, Brian. That doesn't really help
Oh
anything.
my God, dude, I give up. Somebody else, I don't know. I just give up.
Right. If you made the Earth to be a cylinder, if we were to, say, be at 45-degree north latitude and we had a 45-degree gun elevation and we were firing at 45 degrees, and the projectile, for some strange magical reason, does not fall to the ground, maybe you'd have a point. However, here in reality, the direction that the bullet is going, it's going to end up on the ground somewhere, and that ground is going to have a different tangential velocity if you're firing north or south.
It's the same math if you're at 45 and you do it at 2 degrees as if you're at the equator and you fire up 2 degrees. It doesn't change the math, bro.
Oh, yes, it does.
You don't understand.
It's a ball. No. Right.
Wait, hold on a second.
Interesting.
Oh, go ahead, man. Go ahead.
Well, the rate of change won't change because you're effectively going over the same arc. Yes, the forces will be, well, not the forces, the apparent deviation will be more or less apparent. But other than that, he's right. It's a ball at 45 versus the equator. It's the same angle to the same section. But what he was trying to get at, if I can just clear up what he was trying to get at before, maybe still man him a little bit, is that he's effectively trying to say that if it was a cylinder and you shot it out, there'd be no Coriolis. But if we were to remove that dirt instantaneously at the moment of that bullet going below the tangent, instantaneously remove that, that's the only point with which you would actually start to witness or observe Coriolis. Is that correct, Brian?
Kind of, man. Kind of. But the point is in their reality, it's not an apparent drift. It's an actual drift because we're on the non-inertial reference frame. You see what I'm saying? So the way they describe it is it's an actual fucking drift because we're the ones fucking moving. We're the ones in the non-inertial reference frame, and the bullet is now a different reference frame, or the projectile. That's how they describe it. I don't agree with it, and it's never been shown, but that's how it's calculated, and it's wrong.
I'm not entirely sure why. I'm not entirely sure why you're insistent on the word apparent meaning not actual, because that's not the definition of the word apparent. But all right, so
well, when we describe actual Coriolis, I can show you Coriolis that happens on a day-to-day basis. It is an apparent drift. It's not a real drift. It happens on actual rotating bodies, and it is demonstratable, bro. Just not the shit y'all say. That's fantasy, bro. You're describing fantasy.
We're describing the same thing, Brian.
No, you're not.
Yes, from the rotating reference frame, as you observe the projectile take its path, the path appears curved in the rotating reference frame. That is all descriptions of Coriolis, and all demonstrations show that.
No, the definition describes the observation from the inertial reference frame. Look up the fucking definition, okay? Nowhere in y'all's definition are you giving observation from the inertial reference frame.
Doesn't even make sense, man.
Brian, that's completely incorrect. There is no Coriolis effect in an inertial reference frame. It does not exist in an inertial reference frame.
I meant the non-inertial. I meant the non-inertial. Okay, look. I fucked up there. What I meant to say is that is if y'all's okay, if you're on a merry-go-round and I throw a ball, okay, to somebody who's in the inertial reference frame, it's going straight. It's going straight, bro.
Yep.
Okay, and that is we can show that. It's easily shown.
That's why we agree with you, man. I'm about to vindicate.
In your reality, there is no point like that. There's no point. Show me the point of the inertial reference frame and your demonstration. Where is that? Where's that located?
If you were to establish a reference frame that is not rotating with the Earth, you would observe that the bullet is following a straight path.
And where might that be?
Well, parabolic trajectory notwithstanding.
Reference to the
where might that be, please?
Well, you would just counter-rotate on with reference to the surface of the Earth, the amount the Earth is rotating. You're just establishing a reference frame at this point.
So if I were on the moon, it would appear to be going straight. Is that what you're saying?
No, because the moon...
Where's that point? Where's that point then? You just said that, okay, so please
you would have to
no matter how fantastical it is, tell me where that point is, please.
You would have to counter-rotate with respect to the surface of the Earth. Nobody does that because you would just fall to the Earth, Brian.
Brian, I can vindicate you though, in a certain, not entirely, but because I actually redid the math, and so yeah, if you leave from the equator and you travel, let's say that's north to 30 degrees north, then the so the Earth beneath you would the Earth beneath you would be moving slower than you at this point, and you're traveling northward, okay? But the amount that it decreases by, so it decreases to cosine of 30 degrees multiplied whatever your speed was at the beginning, right?
0.87.
Exactly, yeah. But when you take that number, or you take the secant,
Where did you get 0.87?
hold on, Brian, you have to hold on a second, dude. Okay, right. So if you take the what I did was I took the secant of the what did I take the secant of 30 degrees, that's right, multiplied by the radius, and then multiplied that.
It's negligible.
Brian, hold on, dude.
All right, man.
Multiplied that by 2 pi, and then divide that by 24. But I did that to the number. I didn't do that to the speed at the beginning. I did it to the speed at the surface where you end up at, and that ends up taking you back to the same speed that you start out with. So if you did this impossible trajectory, which never happens and couldn't happen, but let's say there was a tangent line on the surface of the Earth traveling outward, and something could travel along that path without deviating from that path, then it would the Coriolis would cancel out, basically. Yeah.
I said that a long time ago, but
okay. You probably did. Yeah, it took a long way to get there.
Yeah, well, thank you for your honesty, but I don't think there's anything impossible about a above 0 degree trajectory. And like I said, until it drops back down underneath 0 degrees, there's going to be no Coriolis. As long as it's on its way up, there will be no Coriolis.
This is a very specific trajectory, Brian. It's not just above
That's
0.
why I said to forget the math, though, bro.
No, but Brian, that's important not to do, Brian.
No, this is why. Let me tell you why. Let me tell you why real quick, so you get it. Real quick. I'll make it quick as I can. This is why, because you're going to do it to that specific angle, which, would be impossible.
It only works at that specific angle,
But it also applies to anything above that angle, bro.
It doesn't. It works at only at the specific angle.
Yes, it does, bro. Once again, if I make the ground a cylinder and I hold 1 foot off the cylinder and go straight out of it, then there's going to be no Coriolis, right? But here's the thing: anything I shoot from that cylinder above it at an upward angle, there's still going to be no Coriolis until the ground disappears and the bullet drops beneath the 0 point. No, dude, how are you even saying that, bro? That's why you can't get up. All right, man.
That's incorrect, because you're increasing your altitude from the axis of rotation. There will be a change.
This is literally the only scenario where it works out, because they cancel each other out. But every other scenario it's not going to do that.
Bro, I can tell you the scenario. I can't think for you. I'm sorry. I knew you was going to get stuck on this if you did the math, bro. That's what I'm trying to do.
Brian, that's not a bad thing, dude.
It's just about the math, Brian, because you're increasing. If you're firing at an upward angle such that it's getting further away from the axis of rotation, you would have the opposite thing happen. You said it earlier. You said, well, maybe
right.
it would be
the opposite thing, bro. And so whatever direction you fired that bullet.
Now you're saying that those are not. That's not going to happen.
No, listen,
so make up your mind.
Dude, listen, you might learn something. Whatever direction you fire that bullet, say if we fire it straight, we could picture a cylinder. If we could maintain that perfect tangent straight line, we could make it a cylinder Earth, okay? Now, if you fired it up at 2 degrees, then you could picture the Earth in respect to the bullet as a cone. Once again, now you're reversing the fucking Coriolis. And in the higher angle you shoot that bullet or projectile, you could picture the Earth as a bigger cone, a steeper cone. So now you're even steeper than the cylinder. Not only is it not a globe now, because it's all spinning at the same rate. And in respect to the bullet, if you fire straight, it's a cylinder. If you fire upwards a little bit, it's a cone. Upwards more than that, it's a steeper cone. Okay, because the ground's moving with the Earth. I mean, the air is moving with the Earth, or the vacuum, whatever, is moving with the fucking Earth. So whatever direction that bullet goes, you could make that into the shape. Okay, so it gets worse at a higher angle.
At a higher angle, you're firing into an area with an even higher tangential velocity. So there is going to be a change.
Exactly, bro.
The only trajectory in which there is no change is when you're parallel to the axis of rotation.
Right. So it's going to be reverse Coriolis. Anything up steeper, anything above 0 degrees, or whatever you're calling straight out, it's going to be reverse Coriolis.
Brian, check
Right,
this
and
out,
then it's
dude.
forwards again when it comes back down, because as I mentioned, all bullets and shells come back down to the ground.
Brian, if you look at the relationship between the values, right? Like, if you let's just say the radius times 2 pi. Well, there is a name for that. We'll call it the diameter. Regardless, or not diameter, circumference. If you take the cosine of some angle and multiply that by the circumference, right? And if you take the 1 over cosine and multiply it by the circumference of some angle and multiply it by the circumference, what you get from one of those equations, the relationship between the two things is they're inversely related, right? 1 over cosine and cosine, right? So that only works for that reason. That's why they will cancel each other out. It's not going to work in the case of a cone, which does not have that relationship. You're not going to get that same, I guess the canceling each other out.
It is going to work like this. It's going to fuck up the equation even worse because you're going even higher. Instead of maintaining level where the Coriolis is going to equal out, there will be none. And if you're following the curve, then there would be some mathematically. But going above 0, then now you got reverse Coriolis. Now because it's going even faster.
Yeah, so you're going to end up
from going slower to evening out to now going faster, but you're still going north, right? So if you calculate a projectile going north at the same rate in every scenario, but following the ball, going level, and going up, it's going to be reverse Coriolis, bro.
Any angle elevation change that you're making that is not perfectly tangential anymore, so it's higher than that, you're going to be going slower than the Earth is beneath you, and you're going to end up deviating westward. So there'll be a Coriolis.
My point is with these projectiles, they're going up above 0, okay, at first, and which is reverse Coriolis, and then when they drop back down under that tangent and from that time till the ground, that shit would damn near level out exactly to where there'd be none at all. Okay. The more you think about it, the more you'll get it, dude. I could tell you'd be the first to get it. They don't even understand what the fuck I'm even talking about.
Let's imagine that the horizontal is parallel to the tangent because it is, right? When you fire something and you're aiming upwards, you're saying, or you're because
yeah, like a projectile, man, just aimed up like 2 degrees or 1 degree or half a degree. So in other words, it's going to be as far when it travels north, it's going to be reverse Coriolis. Right?
Just so you're clear on this, the orbital speed. Well, on my memory, it tells me that if you reach 7,200 meters per second, will put you in an orbit, something like that. And that's only because if you travel at that speed, then the Earth, the rate at which the Earth is moving beneath you is or the way that the curvature basically along the Earth is falling away faster than you're falling. So you're going to end up not hitting the ground right away. And so unless you're traveling at a speed that is above that speed, then it's not going to matter. You're always going to be falling towards the Earth.
Not with a half a degree upward trajectory, bro.
Even with
you will hit that point. You will hit that point, bro. But initially, and until it planes out, it's gonna take away from the calculation.
Hold on, man. Wait a minute. Yeah, sorry, man. I have to draw this stuff out, dude, because it gets complicated.
I mean, it's logical though, right?
No, not quite. I mean, I haven't. It's not about if it's logical.
It's not logical, bro. When you're firing higher degree than a tangent, you're taking away from the calculation. How is that not logical when I just described that at a 0 degree tangent, okay, for however long it followed that, there's going to be no Coriolis. We've already established that. You've agreed to that. We said it's an impossible angle. Okay, fine. But there's further consequences. Like I said, when you angle up, any upward angle is reverse calculation, basically.
Okay, yeah,
It's
but
going to be taken.
so the portion of its route that is going to be above that tangent line, and a portion of the route that where it's going to be below that tangent line, those would have to be equal. That and it's not only that, but
I agree.
it's
I
changing,
don't think it's.
changing its
I agree,
elevation,
man. I agree with that,
changing its
and I
elevation
don't
the
think
whole
it's going to
time
be
too.
completely
So
equal. I agree, and I don't think it's going to be completely equal, but it's pretty fucking relevant.
Keep in mind that the specific portions of the trajectory don't really matter.
Right.
What matters is when you're firing the weapon, where your target is, what its tangential velocity is. Whatever happens in the air doesn't really matter. It has to get to where it's being fired at.
It does too, because the air is not moving at the same speed as the ground. That's the whole point of this.
Oh God, it's not the air. The air has nothing to do with it, Brian.
So you know what then? There may
I
be.
told you he didn't understand, Coach. I told you he doesn't even get it.
No,
He doesn't even
Brian, he's right.
understand.
The air doesn't have anything to do with it. But
no shit, dude, because you're doing your fucking calculation from the ground.
Bro,
For fuck's sake,
the air
dude.
doesn't matter in
What
any
the
case,
fuck?
Brian, the air
Right,
doesn't
you're
matter.
firing from the ground and you're shooting something else on the ground. Of course, you're going to take the ground into consideration.
Anyhow, Brian, I think actually, other than that tangential trajectory, there probably are other specific scenarios that would have to be, specifically described accurately, that also end up being that end up where they cancel each other out, basically. But I'm sure those are hard. They're probably not trivial to calculate, but they might be. I don't know. Because all that would have to happen is that where you end up at is the same place where the other thing is at, like where your straight shot would have been if everything was just happening in straight shot.
Just flew the coop, bro. Still don't get it. But whatever, man. I've spoke my piece.
Brian, I told Brian, 100%. Brian,
now
I
you
100%
don't.
get it, man. You're right. It wouldn't be as simple as the way I described it, or Doofus was right. It wouldn't be as simple as how much time was above and below it, because
it's not real, bro. It's the whole point and all that. It's not real. That's not a reality. It's impossible.
That actually, this scenario is a reality. The scenario that we're now describing is indeed reality. It's something you could test.
Bro, I don't care if the Earth is a globe. That's not real. That's fictional bullshit, bro. That's not real, bro. I don't care.
It's fine that you don't care if it's a globe, but what you're saying now is not fictional. What you're saying now is actually something that could be tested. You'd have to be very careful about it, but changing the trajectory of what you're firing and everything like that, and the speed and all these things you have to take into account. Like the angle that you're firing it at, but it might be possible to find a angle and a speed and distance that the bullet ends up landing where it should have landed anyways if you would have fired it straight at the target and there was no Coriolis.
The only way that table's right is if you fire less than 0 degrees and your target is on the dirt, literally on the dirt. Them calculations are fantasy.
Yeah, but you can easily raise that
Where
up.
targets typically are if they're on the ground.
You can translate that to raise it off the ground, like to raise it whatever altitude the person's firing from. You were the one who told me this.
I mean, if you think about it, even in your fantasy land, okay, if the air
this is your fantasy, Brian.
Moving, what?
This is your fantasy.
Yeah, I know, but if the air is moving with the ground, bro, all these scenarios hold true. So this would be true. Listen, if the air wasn't moving with the ground, then it would be fair.
It has nothing to do with the
air. So Coriolis happens if we're driving north, then, right?
Technically,
Coriolis happens if an object is moving in a rotating reference frame.
Okay, so if I'm driving north
in a rotating reference frame, experience this.
Don't want to answer that one, do you, buddy?
Walking north, driving north, spitting north. Yeah, the Coriolis is going to.
If I'm tunneling
that's not
north.
always true now, is it, Doofus? If an object's moving in a rotation rotating reference frame and has the Coriolis effect?
If the object has to be moving, it has to have a cross product that is non-zero with the axis of rotation. So it cannot be moving in parallel with the axis of rotation. As Brian has already very painfully laid out, a cylinder wouldn't have this same issue. However, anything that's moving in any other direction in that rotating reference frame will experience Coriolis effect.
I painstakingly laid it out for him. He still don't get it. I can't help him.
Right, you chose the one orientation, then the one direction in which Coriolis is not expected to occur. Congratulations.
Or anything above it, bro.
However,
Or anything above it.
Orientation. However, in every single other orientation, every other direction, we do expect it to occur.
Brian, consider an object that you're saying like that would be firing at a different orientation, like a different angle. Then it's going to be changing its altitude
Kosher,
all the
you
time.
can say whatever you want, bro.
No,
The calculation's going to be different, bro.
Brian,
If the Earth's
I can't say
moving with the
whatever I
ground, the
want, Brian.
calculation's
You'll
going to
talk over
differ.
me, dude. What are you doing? I'm almost finished. I'm just saying, if you fire something pointed up or pointed at some angle above zero, then it's going to be raising altitude, and then it's going to be decreasing altitude as during its trajectory. And all through that time, its velocity, you know, the velocity between it and the surface of the Earth, they're going to be different, and it's going to be those are ever going to be changing because its altitude is changing. So it's not as easy as just being able to point it up and then cancel each other out.
Okay, Kosher. So if I'm on the sphere, if I'm on the cylinder and I'm driving my car on the ground north, real super fast, okay, I'm increasing in speed from the center point. If I'm talking about on the Earth where we built it up into a half cylinder, the northern hemisphere. Okay, as I'm heading north, okay, I'm going faster around because I'm getting higher off the ground. Okay, the original ground. Okay, but there's going to be no Coriolis. Okay, even though I'm going faster, it's because the dirt's moving right along with everything else. Same thing as your air is in your sphere.
You're driving now along the tangent line, is what you're saying.
Yeah.
Yeah, it doesn't matter what your object is. If it's traveling in that tangent line, then you're right. Only if it's doing that, though. If it's doing anything else, then you'd have to.
Or, Kosho, if I fire a bullet from that cylinder above that tangent line, it's going to be even worse.
It doesn't matter how high you are above it.
You don't get that, bro.
No, it doesn't matter how high you are above it. You're right. If you're above the cylinder, traveling along the cylinder, doesn't matter how high you are above it, or if you're right on the surface. Wait, no, hold on. It does matter.
No. So picture,
it does matter.
I'm talking about I'm not talking about traveling in a horizontal plane with the ground of the cylinder. I'm talking about shooting upwards from the equator of the cylinder, where we first started building up the dirt, where there's hardly no dirt at first. It's going to, so straight out, there's going to be no Coriolis, and any upward angle you shoot is going to subtract from the Coriolis, and that's not factored in.
Yeah, exactly. They will subtract from it. That's right. So there will be Coriolis.
So now picture this. Picture you. It's no longer right when we fire the bullet upwards. Okay, or a projectile at 2 degrees up. So in other words, anything above 0 degrees, 0 degrees zeroes out at no Coriolis. So if you fire in a plane, as long as that bullet's in a plane, there will be no Coriolis at all, because that'd be equivalent to a cylinder. Now, any upward angle that you fired a bullet, and now all that dirt disappears real quick, whatever, your projectile, it's going to take away from the Coriolis until it reaches back down to 0. So from 0 to the ground is the only calculation you're going to get. But you got to figure in for the negative Coriolis. You got to figure, because when you first start going up, you're going to go backwards, bro. You're going to go against Coriolis, bro. And when you first start that shot, it's going to go opposite of Coriolis.
Yes, so
because
you're going to be moving number, from the speed, and so you're
because the ground's going to be moving faster.
That means you're going. That means you're experiencing Coriolis. Negative Coriolis or whatever is still Coriolis.
Well, at least you get it.
Yeah, we all get it, man. But it's
no, I promise you, he don't get that.
He said, whenever I explained it, he said, "Oh, I said that a couple minutes ago." I didn't hear him say it, but I'm pretty sure he did. Because I heard him tell you that that objects can't do that. So I wasn't listening fully what you guys were talking about. But yeah, but he
My
said
argument
it
is
before I
that
did.
every object does that. Every projectile is at a slight upward angle. So my argument is that all of them, and if they're applying shit to that, they're applying exactly backwards. You could say, which
Objects-
still ain't gonna make that much of it. Still ain't gonna make that much of a difference, and they're gonna have to adjust the shot accordingly. But
the only
A
trajectory
typical
that
gun
you can
elevation is only about 35 degrees. If you're at anything more than 35 degrees or higher than 35 degrees north latitude, it doesn't, Brian.
the only trajectory
I told you
can
don't get it.
guarantee-
He's moved spots on Earth. I told you he doesn't get it, bro.
The only
Right,
trajectory.
just because I'm saying things that you don't like doesn't mean that I don't get it.
You're clearly showing that you don't understand me and Kosho's conversation. Trust me.
Dude,
Whether I like it or not, it doesn't apply to my point in our conversation.
Yeah, okay, first
I
of all,
directly addressed what you said. If we're talking about guns and their elevation upward, even at 35 degrees or more north, then there's no way that it's going to follow that path. So there's no negative Coriolis, as you want to call it.
Kosho, you just agreed with me that there would be negative Coriolis if the ground speed, if the speed where the projectile's at is
Brian,
going faster.
I was pressing the wrong button.
So
Yeah, I was calling it negative Coriolis because I knew that's what you were calling it. That's what you understood it as. But
do you understand that he doesn't know what we're talking about now? That he just said that.
Yeah, of course. Shooting northward from the equator, it'll go eastward. And when we were saying negative Coriolis, we were just talking about it instead deviating westward. But regardless of that fact, what was I going to say? Oh yeah,
So here
right.
it is. If the ground speed is moving slower, causing the deviation,
Brian,
if I'm shooting up in the air, the ground speed is actually the same as the airspeed. It doesn't change.
Oh,
the
the
airspeed
airspeed
and the ground speed are the same. That's the consequence.
Airspeed is not relevant here. Okay, I don't know why. That doesn't matter. Brian, we've established that the only time you can guarantee say there's no Coriolis is if the trajectory is perfectly tangential and stays tangential. That's the only one we've guaranteed it. There may be other scenarios where they cancel each other out, but we haven't established those yet. So it's not going to be every angle that's angled upwards. That's certainly not true. But there could be scenarios where you have the speed, the distance, and the angle, and it just so happens that they cancel each other out. But that has to be mathematically figured out. It's probably a simple formula, simple algebra, but.
Yeah, well, think about this, man. Everything's moving as one. So when I say air, don't think I'm talking about air. It's the ground, okay? It's just at a higher elevation, okay? It all moves together, okay? So if it's the ground that's moving slower as I go north, okay, then the ground way up in the sky is going to be moving faster. I'm going to deviate the opposite way, going faster, okay? So I'm going to move opposite of Coriolis, as long as I'm heading up above 0 degrees from the equator. There's no getting around it. I'm sorry. Might not like it. I know he don't like it, but he doesn't even fucking quite get it yet. It might sink in. But that's all I got to say about this.
Hey, Brian, you still here? Did you leave? Anybody here? Am I here?
Hello?
Hello? Who's that?
Who dat?
Who that? Who that be?
Oh, it's just me.
Oh, hi. What's up, Doofus?
Yo.
I was trying to figure out what he was saying.
And I'm trying to do a shopping list.
Do any of you know what Coriolis's observation and demonstration originally?
Sounds like your noise cancellation is turned up to max. I can't really tell what you're saying.
Where the Coriolis originally came from? The idea of the Coriolis? Is that what you're asking?
In the research that I've looked at, the original observation that Coriolis performed, I'm asking if anyone is familiar with that.
No? Go ahead, tell us.
Fucking hot dog buns.
Okay, so can anyone else hear me clearly, or is it horrible
I can hear
for
you.
everybody? Okay.
Oh.
So as far as I have looked into Coriolis, it originally was a demonstration of physics. Okay, that is, there was an object placed on a rotating flat surface, measuring and calculating for inertial momentum. Okay. So the question becomes, at what point did Coriolis's actual and verifiable physical demonstrations get imposed on the sphericity of the Earth? Because that's not what it originally was about.
How long ago was it when that happened?
I'm pretty sure it was at least, I'm going to say, the 18th century. So sometime in the 1700s. If not, it's the 1800s. Because
okay, so before the globe idea even came around.
Well, regardless, the original intent was simply a demonstration of Newtonian mechanics.
Right. Right.
Okay. Which I don't have a problem with at all.
No, of course not.
You put a ball on a surface and then you move that surface, you're going to have an equal and opposite reaction. No problem.
Right.
Absolutely.
Yep. That's the thing. It's understanding that Coriolis is real. It definitely happens on a merry-go-round. There's, a very real thing that happens when you throw a ball from one person to the other across the Ferris wheel or whatever. But when you try to apply those same effects to a globe, we don't observe that. And that's what's amazing about it, is they've got it still somehow worked into their model, that people that believe the model can still think that Coriolis is happening because of projectiles. And then also they have it worked that because the plane is following the ground coordinates, you'd never be able to tell. So it's brilliant. And then they can factor in the wind and say that the wind is stronger than whatever the Coriolis force would be, so you wouldn't be able to tell the difference. I mean, it's amazing.
Well, I think along with that is the reality that we all on the flat Earth side understand, is that you can't falsify their claims, because you cannot suspend their variable that they say is the cause. You
Right.
can't eliminate it, you can't manipulate it, you can't slow it down. It's always there, so you just have to say, see, that's just the way it is. It's just
the stated cause is rotation of the
And you
Earth.
can't recreate it
It's the
either.
thing that you would have to falsify.
I've told you guys time and time again, the way you falsify it is you get in the inertial frame and the non-inertial frame, and you view something into motion in both the frames at the same time, and that'll prove it definitively 100%, no question after that.
I mean, you could just measure the rotation of the Earth and confirm that an object in motion within that rotation will have the Coriolis effect. It's a sure consequence.
Or you could do what I said, and it would be definitive.
It is already definitive. If the Earth is rotating, Coriolis effect does happen.
right.
Yeah, and the way to tell would be to do my thing that's definitive, like I just said. I know you
You
want
could
to
just
argue
measure
about
Earth's
something,
rotation,
but
and then
this
that would
isn't
be
really the
definitive.
thing to argue with. I know. Go argue with somebody else. I'm good.
Refried beans.
Don't forget your maxi pads, doofus, when that time of the month comes around.
Hey, Travis, can you hear me?
Yeah, but you guys are breaking up, so I don't know if I'm breaking up for you, but yeah, I'm here.
It might be because I'm in storage right now. I'll probably have an echo. And I may lose reception, but I don't know if you've heard my idea about using the plane with a star as a reference point, and then follow that in a straight line towards the star and figure in the 15 degrees or use the North Star. And then you wouldn't be following ground coordinates any longer. And you could see if the deviation is real by traveling over many tangential speeds and seeing if your city that you were traveling straight towards, that would be in line with that star when you originally started out, is moved from from its original location by the time you get there.
Okay.
Keep in mind that you'd be using an aircraft which has to use the air to get where it's going.
How is that an argument?
But I mean, it's very important that you know how fast the air is moving and which direction it's moving in order to make this a solid argument.
Yeah, you would correct for it and stay in that straight line.
Right. Yeah, it's just like sailing. What's your point? What's your point? It's just like if you were on the ocean doing the same thing, you're going to have to account for the ocean. So what's your point?
Didn't you say to Brian that the air has nothing to do with Coriolis? So why are you conjuring the air?
The air does not cause the Coriolis effect, nor does it have it does not impart the Coriolis effect. So it has nothing to do with the air as far as whether or not the Coriolis effect occurs. However, an aircraft must use the air to get where it's going. So if the air has a certain velocity, you must take that into account whenever you're setting up something like this.
And the ocean is the way a ship goes along, and it has to account for the tides and the currents. What's your point?
All right, so if the air happens to be moving with the Earth, then your whole experiment isn't really going to help you any.
No, absolutely not. Because the air has nothing to do with Coriolis. The air has currents, right? That's the only thing we know about the air, is that the wind blows. If it's a dead calm, there's no wind. But if you get up high enough and you've got air currents and trade winds or whatever, yeah, so what? That's not creating the effect that you believe in. So what?
So the air moving around up there is going to change your course.
So what?
So the air clearly has something to do with the course of the aircraft. The Coriolis effect, if you wanted to measure it with some sort of craft, you would have to fire a straight line in a vacuum.
So I don't know I don't know what his name was who was speaking just a minute ago who put out this idea about using a star navigation for air flight. But all
New
he's
perspective.
all he's talking about, right, is simply getting your bearing on a star and using that to navigate your position.
In an aircraft.
Okay? Right.
Yep. Yeah, and you're in an aircraft which is subject to the air.
No one disagrees with. I don't understand why you're pointing out an obvious factor of air flight, aeronautics.
Right. So if you happen to be crossing a jet stream that's going to the east, you will be moved to the east as you're going to the direction that you're going. That's not the Coriolis effect causing that. That's the air causing that.
Yeah. So then you correct your bearings, and then you get back on course.
Right. You'll still be pointing at Polaris, and you'll have already deviated your ground track.
If you get blown off course, and then you get back on course, you're going to be back on that same tangent.
If you're constantly pointed at Polaris, and you come up across a shear, which is you're going to fly
Bro, he
through
doesn't
the
understand.
stream.
Dude, you're arguing with a
Shear's
donkey, dude, who
going
has
to
no
shift
clue what
your
you're saying, bro.
to the east because the jet stream is moving to the east. I hear somebody else talking. That's great.
Yeah, I agree with you. Your point is moot.
Okay, so if you're off course, it wasn't because of the Coriolis effect. It was because of the jet stream.
Who said it was? Who said it was?
All right, so that's not a valid test for the Coriolis effect unless
He doesn't
you account
understand
for
any of
all
our
the
fucking
velocity of the
points, dude.
air
Any point you try to
between
make,
you and
he
your
won't
destination.
understand it, dude. I don't even know if he's a real fucking person, dude.
Brian, I get it, and every single time you talk over me, it makes it even more clear. What I understand.
Bro, you're not responding
you're
to our
not thinking
point,
about
bro.
the
You're just
question
up
that
in your
was
own
posed.
fucking la-la
If
land.
there's an aircraft moving through the air, you have
No
to know
shit!
where the air is going. You have to account for that.
No shit, dude. Are you fucking kidding me, dude? Dude, you fucking, you don't understand what any of us are saying. It ain't just me. You don't understand what anybody's saying.
Okay, if I don't understand what part of what I said is wrong.
Nobody's disagreeing with that, you retard.
Again, you said I don't understand. What part of what I said was wrong?
You don't understand that.
Brian, hold on a second, Travis. 1 second. Brian, don't call fucking names. This is the third time maybe I've told you today. Come on, man. What the fuck, bro?
It's called a non sequitur. Your argument doesn't follow from our claim. We're not making that claim. So you're bringing up something that doesn't necessarily follow what point we're making.
What was the original point that was being made? I seem to recall New Perspective said that the aircraft could show you as you're getting from that point, as you're using Polaris to get to the other point, perhaps if the Coriolis effect existed, you would be able to determine it using that aircraft. And I'm pointing out that's totally not going to work.
You're going to have Perspective come back or Percentage or whoever it was and restate his point.
Can you hear me?
Yeah.
Oh, okay. The point is that if you were following a ground track, right, and just trying to get to your destination normally, you would be correcting for winds the whole time, right, to stay on course, correct?
You would be correcting for all possible corrections at the same time by just following the ground track.
Right, but you would be able to hit the ground track, correct?
Yeah.
By correcting, right? So if you had a course that was a straight line at a certain degree from where you started, straight from where you started, aimed at a star without using ground coordinates, and you were able to correct to make for whatever, the factors are to stay on that course, just like you would if you were following a ground track, you'd be able to correct,
Not quite, because if
stay
you're
on that
pointing
course.
at a star, and you encounter shear that's a jet stream running laterally to your path, your aircraft will shift east if it's an eastward jet stream. It won't follow a ground track at all.
But that's the
Right. So
same
then
thing as
I'm not talking
that's
about. Yeah. You said ground
that's the
track
same.
there. You mean a star?
Your
When they follow the ground
navigation
track,
source
they
that you're
correct.
choosing
They
to
correct
use.
for that. But they correct for that when they follow the ground track anyway, right? If it was an eastward.
Because you're using the coordinates on the ground, yeah.
Right.
If you're
Right.
following a star
So the plane knows how to
instead,
correct is the point. The plane knows how
if
to
you're
correct for any of those conditions.
if you're following a star, if that's your navigation source, you won't be following a ground track.
That's not his point. The point is that you're following two different references, and you're having to compensate for natural variables that come across your flight path. That's the point that he's making. You can still correct and have to compensate, because if you're following the zodiac rather than the pole star, which doesn't move, right? But if you're using the pole star, then you're not gonna have to compensate for the movement of the stars.
When did the zodiac come into this?
The movement of the stars, the rotation of the sky.
Right, and that's why Polaris was chosen as the navigation source.
Right. So there you go. You're gonna have that. That's like choosing that mountain up ahead of you or whatever, because it's not gonna move. It's not gonna go anywhere. But as long, but if you have to, like, if you're going to go 4x4, in your Ford Bronco, and you want to get to that mountain, you might have to change your course along the way because of certain impasses. But you've always got that mountain in your sight, so you can eventually get there. And then if you were in the air and did the same thing, and you were in a small little Piper, whatever, and you've got strong shear winds, you're going to have to compensate for those winds, but you'll still get to that mountain. It's the same idea.
Not quite, because your navigation source is a star, not the ground.
Okay. Is it not possible for you to equivocate between a mountain that doesn't move and Polaris that doesn't move?
If you are using Polaris as your navigation source, I'll state this for the fifth time. If you're just looking at Polaris and not the ground, and you encounter a shear, your aircraft will shift laterally. You will not be on the same ground track anymore, but you won't notice because you're still pointing at Polaris.
Just
You
shoot
can easily
the cannon
deviate from your ground track.
equator, boys. North versus south. Come on.
Right. You can easily deviate from your ground track while still following the star the entire time. You're just pointed at the star the whole way. You could be off of your ground track.
Okay,
Right.
I would disagree with that. If you're in a particular city and you see where Polaris is, and you know that 500 miles away there's another city that is right in line with your path, your flight path, and you get up into the air, you don't have to follow a ground path. Just keep Polaris right there in front of you, and you're going to get to that city. Doesn't matter about what happens in the wind, as long as you compensate and get Polaris right back over the nose of your plane, or however you're orienting it, so that you fly in that aerial flight path.
All right. It seems we may need a lesson in avionics. So if we look real carefully, we can see this double circled thing that is at the horizon line, that's the direction the aircraft is moving. If we look at that little bird-looking thing, it's got a V in it. That's above and to the left of that little circle, the double circle. That's where the aircraft nose is pointed. You can be facing in a different direction than you're going. That is super easy and happens all of the time.
Yeah, that can happen just in a river due to currents and just wind. So we need to prove that the actual Earth is causing some sort of issue with regards to, you know, apparent deviation. So let's just shoot a fucking cannon from the equator north and south and show deviation actually occurs and it's not just calculated.
But as I mentioned earlier, the equator is where the Coriolis effect will be the least for a north-south trajectory.
But it doesn't matter that you say that, because at 25 kilometers, it's still enough to notice.
The equator is the absolute worst place you can choose to do such a test.
Oh, for fuck. You've said this before. Who cares if it's the worst place? We can still see a discrepancy.
Just as valid.
Oh my God. Will you not agree that there's still a discrepancy to be seen, whether it's the least or the most?
The precision necessary would be too low. Or the precision available would be too low.
At 25 kilometers from the equator north, it's 100 odd meters.
Jesus Christ, dude. The precision available would be too low because at the equator, there wouldn't be enough of an effect to be measured.
It's not at the equator. It's from the equator north and from the equator south. Right? The opposites. We should be able to see the discrepancy between the two.
No.
Fucking listen, man.
The equator is where the effect is the least. You need to go
can you calculate it then? Calculate
very, very far.
Calculate it.
You should try
Calculate it.
35 degrees north latitude and 45 degrees south latitude, because that's way better than the equator.
So on a ball,
we can't observe them at the same time. We want to do it from the equator, so you're literally spinning the cannon around and shooting it the other way, 25 kilometers. That would be definitive. Not what you're fucking saying at all.
If you did it at 45 degrees latitude, because you could fire it one way, it would deflect to the right, and then you would fire it to the south, it would also deflect to the right, which would cause it to go either east or west based on which direction you're firing.
That's what would happen if the wind was blowing to the right.
You would rather do it at the equator. You would rather do it where it's the worst possible conditions to actually measure an effect.
No, you'd rather do it where fucking if we turn around, it's going to deflect the same way, like if the fucking wind were blowing. For fuck's sake.
It doesn't. What it does is it at 45 degrees north latitude, when you fire north, it deflects right. And when you fire south, it deflects right. And what happens is firing north, it deflects to the east, and firing south, it deflects to the west, like we'd expect.
No matter what, we can't come up with a test. No matter what.
What is the test, Brian?
What he's saying is at the equator, if you fire north and you fire south, nothing happens. Okay, so on a ball, if you're further north and the shit's changing at the same rate, okay, who cares where you're at? If you're shooting north and south, you're getting the same rate of change. Then he's just making excuses because that's an actual test we could do to prove it. But what he wants us to do is go up north and fire north one way and fire south one way. So if the wind's even blowing in that direction, the same thing will happen. It'll deviate the same direction from both shots.
No, Brian. If the wind is blowing, it wouldn't cause the same thing because, as I mentioned, if you're firing to the north, it will go to the east. And if you fire to the south, it will go to the west, which means that it has absolutely the opposite effect of what you just said.
So what would you expect at the equator shooting north 25 kilometers? What do you calculate to be the deviation? And what device do you think couldn't measure that, please?
Well, I'd like to know what would be firing, because typically very large field artillery pieces don't fire that far.
irrespective of what the artillery is, can you make a calculation and show me or prove to me that it's so negligible at that distance that we shouldn't do it at the equator? Because that was your
Nothing
argument.
can fire that distance. It's not a field artillery capable thing. You want to shoot maybe 12 kilometers. You can do that.
Whatever you need to do, you calculate it and show me it couldn't be measured. All right?
Right. So now at the equator, when you are firing to the north and when you're firing to the south, the place that you're firing from has a certain tangential velocity, 1,037 miles per hour. If we move north 12 kilometers or move south 12 kilometers, the amount of difference is going to be basically nothing. Let me show you in numbers what that is.
I already showed you, and Coaster did the numbers. As long as you fire steeper than 0 degrees, you get reverse Coriolis until it drops back down underneath that. No getting around it. That's a consequence of your
Brian, you're not
atmosphere
helping.
moving with the ground.
Yeah. It's nothing to do with the atmosphere, Brian. Thanks. All right, so 12 kilometers out of a...
Hold on. It does
490.
have to do with the atmosphere because you eliminate.
Travis, thanks for coming back in and screwing it up again. You totally missed what I mean. That's
Don't
normal
interrupt
for
him,
you.
man. He's
why
barely
don't you-
talk.
Okay, why don't you finish my sentence for me since you know what I was going to say? Go ahead.
Right. So the air has nothing, is not the cause, has nothing to do with the cause of the Coriolis effect. The air does make a difference to an aircraft. These are not two contradictory statements. Ooh, okay. 12 kilometers is a very, very, very small. Oops, I did it in live. God damn it. Okay. The difference in tangential velocity over 12 kilometers firing from the equator is, get ready for this, less than 0.0001 miles per hour.
Right, but that's not a measurement. That's a calculation of variables for which you have no basis.
We should probably try and calculate what we expect to happen before it happens, right?
No, you misunderstood me.
No, say no to me. Tell me it's that unscientific line of BS that we do not expect to be able to calculate what we expect to have happen first.
Okay. Your calculations are based upon variables for which you have no basis.
Right. If I'm supposed to tell you what kind of effect I should expect to happen if the Earth were a rotating sphere and that we're firing 12 kilometers from the equator, the number that I just gave you is very relevant. You can pretend it isn't. That's just you being an ass.
Okay, first of all, I'm not pretending anything. I made a very definitive statement. So why don't you begin with the very first variable in your equation? What is it?
The rotation of the Earth.
And what's the variable? What value do you have?
What do you mean specifically?
I don't understand why you don't understand my question. What is the amount? What's the variable? What is the numeric representation for the rotation that you placed in? Or did you just write rotation, parenthesis, Coriolis, end parenthesis? Like what is your equation? What's the first variable? Do you have a numeric value?
Well, I went with what's often quoted, it may or may not be accurate, of a linear tangential velocity at the...
Hold on, Brian, please.
Finish what I'm saying, right? Because I was asked a question?
Hold on,
All right,
Brian,
I started with whether or not it's completely 100% accurate or not. I went with the often quoted linear tangential velocity at the equator of 1,037 miles per hour.
Great. How did you
Is that
derive
an
that?
issue?
How did you derive that value?
I just went with the number that I was already given.
Okay, great. So you're going on the authority of someone else. You haven't measured anything. How did they derive that value?
Right. The expectation, the question that I was given, Travis, was what should we expect on a rotating sphere given the globe model that we all have heard about before?
Yeah, we already heard
If you,
Yeah,
if
we
you
already
disagree,
was
if you disagree, hey, if you disagree with the notion that I should use the model to address whether or not, hey, if you disagree with the notion that I should use the model to try and address a question of what the model says we should expect, come on.
Chill out, bro.
If you disagree with the expectation or the notion that I should use the model in order to address a question about what the model says we should expect, then you're in the wrong conversation.
Okay, you're in the wrong conversation because you cannot understand the line of argument. I'm fully accepting your point, not one, whatever, right? That equation is perfectly acceptable. I accept that value. Are we good so far?
What we're good on is I was asked a question about the globe model, and I used the globe model to address that question. Hey,
say it again.
Use the globe model to address that question.
Yeah,
you're having an issue with me using the thing that I was asked to use. Yes, you are having an issue with me using the thing that I was asked to use in order to provide an answer to a person that asked it of me. So right now, you can take your conversation out of here because I was having a conversation with somebody else that asked me a
what you
question.
said. So I don't know what you're getting all antsy in your bouncy.
Sit down in your chair, John. Listen very carefully to Daddy, okay?
No, what I actually had to do, because I was asked a question based on the globe model, all I needed to do was use the globe model in order to answer that question. You took issue with me using the thing I was asked to use.
Oh my god.
No, I did not. I fully accepted your equation. I accept it. Now, I have a question about your equation. May I ask my question about your equation?
What is it?
How did you derive your very first variable?
That part is not necessary in order to answer the question that I was asked.
Did you not use a primary variable in your equation?
Did I answer a question I was asked?
Okay, if anyone
he's
out
asking,
there...
he's asking about a variable. He's not talking about a previous question. I mean, if you don't want to answer it, that's fine, but he's asking about that variable. Is there a reason you don't want to just say what that variable is?
I already did.
He already did. Right, and so then I had another question. Since he isn't the one, he's not the source of that value, I asked him where the authorities derived that value, and he's refusing to answer it for some reason.
Right, because I don't need to give you that information in order to answer the question that I was asked.
Yes, you do.
No, not at all. Because if somebody asks me to use the globe model to come up with an expectation of that globe model, then the answer that I gave and the methods I used to do it are all okay.
Okay, you ready?
Right.
You can drop it at any time.
I think surely the main thing here.
Into some other conversation.
Hold on, real quick. So, Johnny, I know that you have a question about how Santa Claus gets to deliver all of his presents around the world, right? So he has a sleigh pulled by 8 reindeer. Now, those 8 reindeer don't go over the land, Johnny. They fly. Okay, so now you have these 2 variables in your equation. Worldwide present delivery, reindeer, and reindeer flying. That's your equation. I'm simply asking to justify simply your primary value, and that is that you have reindeer who can fly. Where do you get that evidence? It doesn't matter how well your argument works. It doesn't matter how fanciful and neat and tidy that equation works on paper. If your primary value, or reindeer flying, is not real, then fuck your equation. So, where did your primary and absolutely necessary variable for your equation come from? Because if it doesn't exist,
White,
if
White,
hold
I
on,
did want to
here's the
actually get back
punchline.
with you.
Here's
White,
the
what
punchline.
was
Here's
my
the
was my
punchline,
answer
Johnny.
to your question actually what you were looking for?
Here's the punchline, Johnny. If
Yeah,
your
I
primary
understand. But I'm
variable,
trying to
Oh
get
wow, he's
finished
not allowed
with
to
the
ask his
discussion, which was the
question.
question
Can you
I was
believe
asked.
it?
If I can finally finish that
People have
conversation.
to just
I'm almost
interrupt
done.
all the
Almost
time.
done.
No,
I'm right
I'll
at,
go ahead and finish the first
I'm right
conversation.
at the edge.
You're in
Oh,
line.
we've
Right at
still
the
got to
edge.
interrupt.
What is?
You guys just let
did you
Travis finish
answer-
what he was saying. Let him
Address
just
your
finish
issue.
his. Hold on, he said a long thing. Can we just let him finish what it is so we can hear? Just let him finish it.
If your
he already did.
primary variable has no basis in reality, it doesn't matter what the rest of your equation equals to.
That is logical, right, Doofus?
I'm trying to address the conversations in the order which they were given to me. White, did the answer I gave you give you any information as to whether or not that makes sense to use the equator for this test?
I guess there's your answer, Travis. Just obfuscation and ignoring it. So there it is.
I'm trying to answer the questions in the order in which I got them. White.
No,
did
you're
you,
going.
did you get
I'll answer.
the number that I gave you?
Let White answer quickly,
Why
and
the
then he'll answer
equator is
the
a
next one.
good place to start this test.
Go ahead, White.
My point was that there would be a discrepancy. You chose to focus on the location that I chose not being suitable for a maximum deviation. My point was that there would be one, and you failed to address that.
Okay. The thing that I said before Travis piped in was that the difference in tangential velocity at 12 kilometers away from the equator, the place that you're trying to shoot, that is less than 0.0001 miles per hour difference in tangential velocity.
Okay, great. We're all good with your equation. Okay.
Yeah, so
We're
the
all
equator's
good.
not a good place to do this test.
Now go ahead and answer
Guys hear me?
Travis's question.
All right, so
Jeremy,
now
you're right.
if we want to discuss the qualitative source for is the Earth rotating or not, we can start
Doing
there.
that
That one's easy.
shit to me all day. He's literally been doing that.
You're roboting, Jeremy.
Go ahead, answer Travis's question. What's the basis?
Right.
in
So if
reality
we want to start with the qualitative, is the Earth rotating or not? That's easy because a mechanical gyrocompass cannot function on a stationary Earth.
Okay, that's not my
Have you
question.
tested it on one?
Hold on. That's not my question.
Well, the Earth is rotating, so there you go.
Okay.
No,
What
it's
is
not.
the value of your equation?
All right. If we want to go with something more quantitative, we can refer back to when I did the Foucault pendulum experiment myself in undergraduate physics. There's a second semester course for that.
Objection, Your Honor. Misdirection and failing to answer the question.
Oh, no, because you asked about how we came to that value,
yes.
right? You're asking about
What
how we
he's
get to
asking
that
about is
value.
raw data.
The actual legal term is irrelevant.
No, this is a logical debate. He's not answering the question and he's providing misdirection or obfuscation. If you
Right. You asked how I got to that value, right? How I personally got to that value of the rotation of the Earth, correct?
That didn't equal meters, did it? You didn't tell us the meters in discrepancy from the target to the actual location of the projectile landing. You didn't tell us that. That would be
Okay.
nice.
If the difference in tangential velocity is less than 7 orders of magnitude, then you know that the difference in meters will be less than 7 orders of magnitude. Do you follow me?
All right, so let's go out there and show that. For all you know, it could
You
be
want me to
more,
show
and you'll be
you-
like, "Oh shit! It should be not even noticeable." But here we are noticing it. What's going on?
You want me to show you a zero difference we expect to be a zero difference, and then you want the test for some reason to prove that the Earth is rotating. Can you think
wants
about
the
that
test.
again before you say it
Wow.
again?
Wow! So it's not zero. What is it in
Right,
meters?
As I already stated, it would be less than 7 orders of magnitude difference.
What is it? What is it in
More than
meters?
7 orders of magnitude difference. So, like, if we're firing at 12 kilometers, divide that by 10 million. That's what you're expecting for a difference.
Okay, well, I said 25 kilometers, and you said it's not possible, and you took it down to 12. Turns out we can shoot 165 kilometers, and that's known and has been done before with a projectile.
With a rocket?
So, do you care
With
to
a
change your thought about 12 kilometers and maybe do an actual calculation and give us meters of discrepancy, please?
Right, with a rocket.
Not a rocket, no. A
Okay,
projectile.
firing 165 kilometers.
Yeah, look in the chat, mate. Hitler, thanks for coming. Now, I'm not expecting 165 kilometers. I said 25. But can you at least just turn it into meters so that everyone can hear how many meters discrepancy there would be over 25 kilometers? And then we'll talk about the ridiculousness of snipers having to account for it. Okay? Please.
Right, at the equator, the place where I told you where it's the least possible effect, right? You want me to do the calculation that shows you we shouldn't expect enough of a thing for anybody to account for at the equator, which I already said a long time ago that we don't expect it to be anything at the equator.
So did you say it's the distance divided by 10 million or something, doofus?
Right, for 12-kilometer long shot.
Well, I'm doing 25, so that would be 0.0025
Let me run the calculator. Hold on.
meter.
If we're doing 25 kilometers.
Yeah, I did 25 kilometers divided by 10 million because your figure was 10 million, which works out to be 0.0025. So nothing.
Well, 10 million would have
Absolute-
changed to 25.
Yeah, at the equator, it would be nothing. Hold on. Cosine
Yeah. Well, that's what I worked it out to be. Going on your
times 1037. The difference in tangential velocity is less than 0.01 miles per hour. So you're looking for 1, 2, 3, 4, 5. You're looking for less than 5 orders of magnitude difference in the downward direction. Which means that if you fired 25 kilometers, you would expect your deviation to be about 3 meters. Or no, yeah, about 3 meters.
Whoa.
Or no,
Not
wait.
100 feet?
That's 4.
I'm glad I skipped all the middle ground, huh? Wow.
It would be 0.3 meters.
0.3
Wow.
meters over 25 kilometers.
Right, and as I stated, the equator is the worst possible place to look for this effect because that's where we expect it to be the least.
So
what effect?
The left to right deflection for an object fired north-south due to the Coriolis effect.
Oh, yeah. The pseudo effect. Gotcha.
No, you should have
We need
seen
to
it,
know
man.
what our expectations are because, as some jackass pointed out earlier, we should put something on the equator where we expect it to be the least effect to try and find out whether or not the effect exists, which is nonsense.
Nah,
I
man.
video of someone
You got a
shooting
percentage difference.
shooting a sniper 2 miles, like 2.3 miles, and they definitely didn't account for Coriolis, my dude. So
They certainly wouldn't have to at the equator, as I already pointed out.
wasn't at the equator.
Okay.
Dude. 8 hours ago, Doofus, you were talking about this shit was in the manual because how much they would miss if it wasn't in the manual, and now you're going to talk about 3 meters. And Xanax
Right. If you were at the equator, the place where we expect this effect to be the least, you wouldn't
God, say it
necessarily
again.
need to account for it because you're at the equator.
No, you're going from 100% to 90%, for example. You go from 90% to 80% in a different zone. 80% is like, dude, like, what are you talking? You're not really saying much to say this effect is expected to be the least.
All right, what's
You're
your
really-
what's your calculation if you're in let's say South Dakota? I just made that up, but just somewhere that's not the equator.
Well, it's
How about
easier if you
European
give me a number latitude, 45 degrees north latitude or 40 degrees north latitude.
Sure.
Because I'm not just going to go look up where is North Dakota specifically by latitude.
36 degrees.
All right. So 36 degrees north latitude. You want to use whatever the tangential velocity is there. then you're going to look at the tangential velocity of where you're firing.
25 north.
You're going to
25.
compare the two. Excuse me?
Yeah, 25. We know what you're doing. Just do the same thing you did already with the other
Just
section.
use 30 degrees and you do half. So just do 0.5. Do 30 degrees. Fuck it. Make it
It's
easy.
not how cosine works, Brian. It'd be 0.87.
Dude, fucking cosine of fucking 30 degrees is 0.5.
It is
calm down,
not
man.
0.5. The cosine of 30 degrees is 0.87. Sit down, Brian.
Let's all keep it calm. That'd be good.
Really? Really?
Yes,
You
really.
bet?
Is it 875?
That's 0.866 some repeating, or not repeating, transcendental number. It's like
Dude, no wonder he's getting these bullshit
Either
numbers. He
way.
doesn't even fucking understand fucking sine.
He gave it. Listen.
What is
he
the
said
cosine of 30 degrees?
25
Tell
miles.
us it's 0.5. Say it again.
The sine of 30 degrees is 0.5.
I said
25.
cosine.
They got
The
y'all
cosine is 0.5.
No.
Can we not scream? I have AirPods
Got
on.
y'all
Jesus.
3 meters of difference over the 25 kilometers from 90 degrees at the equator, or whatever the fucking degree that is. Do your thing at 45 degrees, doofus, and tell us how many meters we gonna miss it. There.
Here's a
So
shot.
hold on. I'll give an
3700.
example of 36 degrees and 25 kilometers. Give me a
I
moment.
just dropped in the chat for everyone a video of a guy shooting a 3,700-yard shot, 2.1 miles. He certainly isn't accounting for Coriolis now, is he, Doofus?
No, apparently Doofus said at 25 kilometers, it's just 30 centimeters at the equator, so you wouldn't even really need to account for it there
Well,
either.
this isn't at the
Negligible.
equator. This is
Isn't
I know,
this,
I'm just saying. It's negligible at 2 miles. Fuck.
Look, I'm gonna have to maybe I need to check myself here. Doofus, are you guys talking about bullets and not artillery now? Because I assumed it was artillery.
It would have to be artillery if we're talking about 25 kilometers.
Right. That's what I thought. It had to be and think about all this, guys. All this hang time, right? Talk about this long thing. You got the little mismatch, and he's talking about you're gonna miss it by a meter or two. Zanuck was in here earlier talking about how they'd be making all their shots worse if they added this to the book. They're not really making them that much worse, are they, doofus? 0.0001%. I understand every titty hair counts in war, but it's right. Would they really notice it, man? Like, come on, man.
This is in New Mexico. It's a shooting range competition, and the final day is 3,690 yards. So 3,700 yard. Watch it. It's crazy. You see how long it takes the bullet to get there? It's like crazy how long it takes. You can see it miss to the left of the target, just barely missed. Doofus, he didn't account for Coriolis though. So how's this working?
Did he shoot north, south, east, west?
Actually,
well, he's going to say that's why he missed, right?
Yeah, he missed. Yeah. So when they told him that he had to correct, they just forgot to mention that it was Coriolis he needed to correct for. They told him to actually move the scope over, but.
Wait, so you said he missed it?
Cosine of 30.
Yeah, he barely missed it. It's 2.1 mile shot, Kusha.
Yeah, but I don't understand what the.
I was thinking about
and they
negative
told
30.
him to correct, and they didn't. It's nothing to do with Coriolis, dude.
They told him to correct. They told him to correct after they saw where he hit.
Yeah.
Yeah, then why you wouldn't? You would just need to tell him where he hit and where to correct it. So he's like,
So you're saying he accounted for Coriolis, Kusha, or is that what you're saying?
No, he accounted for his incorrect shot, his missing. How much he
So
missed.
whenever he was initially
It's
calculating
neither
the shot,
proof
did he
nor
account for
debunk of
Yeah, exactly.
No,
What
of course
percentage?
not. I'm not claiming it is. I'm claiming anyone that has brain cells to rub together and isn't like a religious zealot can watch this video, see it takes a long time for that bullet to get there, and knows for a fact in the real world you don't account for Coriolis.
Right. I agree with Kosho's point, Witsit, but Kosho, I also agree with Witsit's point. Like, depending on the initial setup and his calculate, it does matter. Like, if he was dead on and they just said move a little, like, you know what I mean? Like, or maybe he was like, it kind of depends on the whole scenario. But I agree with both of y'all.
Again, to clarify, I'm not claiming it proves anything.
Not making a point, man.
I'm just showing the video because I thought it's interesting. Anyone that
but then you said after that.
I said he's not accounting for Coriolis because I know people that literally do this. So you guys just make stuff up on the internet. That's what you guys do.
But anybody can fire a gun and miss the target.
But Kosha, what
you
if he hit it?
You can't.
What if he hit it on his
Yes,
first
I
try?
can. You can shoot 3,700 yards
What if he hit it
and
on
miss
his
by like
first
2
try?
feet to the left. Get out of
All
here.
right, hold on. I was
He
given
didn't really
the
counting
example.
for Coriolis or anything. What if he got lucky and hit it on his first try?
All right, hold on 1 second. I was given the example of 36 degrees north, 25 kilometers firing north. The difference in tangential velocity is 1 over 350, so 350 times less. So that is the amount that you would have to, for the range. Let's see, if I divide that. So for
Wow, you interrupted us
25,000
and you're not even
meters,
done with the math?
25,000 meters divided by 350-ish. This is just an approximation. It'd be off by 70 meters. Ish.
Okay, I respect that, doofus. I'm eating
Dude,
crow.
this bullet takes 8.5 seconds to go 2.1 miles. So how much would the curvature, how much would the Coriolis affect it in 8 seconds? Dude, if Coriolis was real, it would be such a major factor. All the people that do this, they don't in any way.
I don't think the time is.
The field artillery people do actually use it, though.
Oh, so I'm going to interview these people. I actually have a few of them lined up. So I'm going to ask them, and you're going to tell me they're going to say they account for Earth spin?
Depends on how they're doing it, because if they're at the same range day in and day out, firing in the same direction every day, once they've zeroed their rifles, they don't need to worry about it after that.
So they had to do it to zero their rifles in.
Right, you have to zero in the first place. If you've zeroed for that,
right?
If you've zeroed for that particular shot, then from that day forward, you never have to account for Coriolis again because your rifle's already doing it.
You have
Only if you're shooting in the same spot.
You have to prove that their zeroing factored in Coriolis.
Exactly.
If they didn't, then you got a problem.
See, I'm actually going to interview.
So if you
them.
fire
how
a shot
fighters
and you
actually do
miss,
things in real life, like I'm actually going to interview the people that do it.
right? If you fire a shot and you miss, whatever caused it to miss, doesn't matter what the causes could potentially be. If you zero out your shot, your scope, once you do that, you're automatically accounting for every possible deviation that could occur at that moment.
So we can just reify and assume Coriolis is there.
Yeah.
Gotcha.
What about the next? What about the next day when the conditions are different? You're gonna have to correct if the wind is blowing in the opposite direction, or towards you, or with you.
Ideally, anybody worth their salt would have already taken the wind when they were zeroing into account in order to know which way their zero was
You just
going.
said once they zero it, they can go back every day and shoot it again. He just pointed out the conditions are going to change every day and refuted you. So, what?
Can I get to answer the question, or do you want to interrupt me again?
You want to actually answer it?
I was about to until you interrupted me.
No, you
Let's
weren't.
try
You
it
said
again.
once you zero it, you're fine. That's not
The conditions that they zeroed it are windy conditions. Ideally, the person who's zeroing their rifle knows that. So when the next time comes around, if the wind is different, the person is going to account for that.
Okay.
Wind is always a little different.
And it changes constantly.
Good.
And it's clearly the primary factor. And I'm going to interview them. I'm going to talk to all these people that do this for a living, right? Or they do this in competitions. And none of them are going to say that they ever account for Coriolis. They're going to think that sounds ridiculous. And then you guys are going to say, oh, well, when they zeroed it, it accounted for it. They just didn't know it. You can't argue with people
That's
like
not true, man. I spent 2 years as a medic, a field artillery battery, in garrison and in combat situations. And they absolutely accounted for Coriolis with their
What?
Great.
You're
You
so
have any of
genius
those?
making stuff
You
up.
have any of
Same and they
those?
didn't. So
You have
nice
any of
try.
those scorecards that you can produce for us?
There's not scorecards.
I know people that actually shot the guns that said that they don't, though. And what about this? I got a question. If you're in the military and you're shooting like a 2 mile
I'm not
shot,
in
do
the
you have to account?
military
Do you have to
anymore.
account for refraction?
I'm no
you see
longer in the military. This was years ago.
If you see your target, do you have to account for Earth refraction? Maybe our refraction on the Earth and be like, oh man, I can see the target, but I can't take the shot because this is an optical illusion. This is actually being lifted up over the curvature of the Earth.
Well, hold on, Austin. Hold on, just real quick. So this guy who just came in, this medic guy, okay? So we have simply to take your word for it. So can you describe
Also
how
mine.
Dude, there's
No, okay,
manuals. There's millions of other people
I think you
accidentally
who
interrupted.
talk about it.
Yeah, yeah.
You don't have to
So
take my word for it.
How did no. You're the one who came in with apparently first-hand information. What was your
I
first-hand
already have that
information?
information. I gave that to you.
Now
I'm
Don't
not
say he
talking
came
to
in with it. We've
Stop
been in this
interrupting.
conversation already.
Next person to interrupt him is getting
bullshit.
talking to you,
muted.
Doofus.
It's
Right,
absolute
it's not
bullshit.
new information, though, is it?
Next time you
Okay,
interrupt him, you're getting muted.
yes, actually it is, because he came in with his first-hand testimony of something that he experienced. So this has
And
nothing
nobody
to
gave
do
that
with
to
what
you.
you said.
All right,
I have
can you hold
first-hand
on?
testimony that snipers did not look at any dope book or values or
Hold
account
on,
for Coriolis in
listen.
any
I
manner.
still listen.
So
Come on, guys.
disregard
Dude,
that.
the same guy's been trying to say a
both
point
sides,
like 4 times in a row. Stop interrupting him.
both sides are interrupting. Okay, I'm driving right now, so I can't see who was talking. The medic guy. What was your anecdote? What was the basis for your statement? I was a medic in the military and blah blah blah. What was your point?
You heard it.
What do you mean? I was with a field artillery battery, right? So I was on
Okay.
the range with them all the time. I
Uh-huh.
went to Afghanistan with them twice. Went to Korea with them once.
Okay.
Okay, hold on. Stop. Okay, great. Okay, I'm not disputing any of that. That does not, however, give us any information as to how you know that they are accounting for Coriolis. So how did you derive that information?
Yeah, right. Because they're walking around, they have manuals and stuff that tell them the numbers for the latitudes and different kind of corrections they make. They input that into a computer system, and I even inputted it in a few times. They would let me shoot the gun a couple times, right? So all these things are taken into account. Now you can try to trick them because you want the answer you want, and you say, "Oh, do you take into
Don't
account
gaslight,
for the
bro. There's
air
no reason to
defense?"
gaslight. Why are you being a
He's
sociopath
giving
right
his
now?
story. That's not called gaslighting, Jesus.
No, it is
he's
because
giving
no, he's
My
imposing. Hold on,
My response was in response to Witsit saying that, "Oh, I'm going to ask
I'm
these
the
people,
one
and they're going
talking
to
to
say
you.
that we don't take into account the Earth spin." Because no, they're not going to say that. They're going to say the corrections that they take into account for.
Okay, so again, your primary reference was not a first-hand account, but they have manuals that they use. So you're just referring. You didn't have to bring up anything that you were on the field with these guys. You didn't have to bring any of that up because your primary proof in hearsay
Are
for
you
us.
unable to follow the logic? Right? They have a correction value. If that value is incorrect, their shell will not go to its target. It will be incorrect because they put in an incorrect value.
How did they derive the value to correct?
It's based on the Coriolis for what we're talking about specifically.
Is that the only variable that
Equation
this correction
Doofus
is
was
needed
talking
for?
about.
Wait,
Is
I
that
gotta
the
say
only?
this. I gotta say this. This is the real life how it happens. They come up with their values, they predict their shot, and then they adjust accordingly. Okay,
Yeah,
you act
of
like
course.
they. I'm talking. You act like they do their get their values, and then they hit their target every time because Coriolis is perfectly factored in.
No,
And
they
it's
have
true.
a
That's not what
spotter
happens.
that tells them how to adjust after
So
they in the
So it
first
just
round.
gives them it gets them as close as possible with the first shot. It gets you a general location to aim, and then you have to adjust based on your miss. Nothing to do with the earth spinning.
Okay, so if they're trying to get to as close as
Half
possible within
true.
the first, if they're trying to get as close as possible within the first shot, then the corrections do matter.
Now, whenever you're, it basically does nothing to it. It basically changes nothing.
Yeah,
How
the
much is?
Coriolis.
Oh,
You
just
don't
the
have to back.
direction
Look,
and the elevation of the barrel, sure.
no, listen here. Again, we've said this from the very beginning. All you have to do is get one of your guys and one of our guys, right? You've got one guy who factors in Coriolis, but it's negligible. It doesn't even fucking matter because when he misses, he doesn't change that variable. He has to change all of the other variables, which is what the other guy has to do. But the other guy never factored in Coriolis. But they both have the same result.
It absolutely matters in combat.
It absolutely doesn't matter.
When you want to have your corrections as
Your
close to
corrections
perfect as you
aren't.
stop interrupting
Your
me.
corrections are not based on an error in the value of Coriolis.
It absolutely matters in combat when you have other soldiers' lives on the line. And
Wow, now you're
you
appealing to emotion.
tell us that
when you
sob
need
story.
to have
Tell
when
us
you need
about
to
it.
have when you need to have the most accurate shot the first time, and you don't have a spotter downrange telling you how to correct.
Okay, so you're appealing to emotion
reality
now. But here,
hurts, bro.
can I offer this to the whole room? What is this? What is everyone? Let's put it to the
I'm
test.
sorry, reality hurts. I'm
Buddy,
sorry.
calm down, calm down. We're gonna put it to the test. So if I get 2 of these people
It's
that do
already
this,
been tested,
why are
dude.
you
You think it's
interrupting again? You have a problem. Okay, so
You guys
whenever
interrupted him the whole time he was
oh,
talking.
there you go.
Yeah,
Interrupt me
you've
again.
literally interrupted me.
Interrupt me
All right,
again.
stop with the interruptions about interrupting.
And now
Let
you're
Witcher talk.
bitching about
Please.
interruptions.
Hey,
This is
please
hilarious.
Oh,
let me
Travis gets to interrupt all the time, right? That's allowed.
Oh
Why
my!
should
I didn't interrupt.
Why does
Okay,
Goofus
Travis.
get to interrupt?
me
If
the
Goofus
entire
interrupts, we'll all interrupt. It'll be anarchy.
Whoever's talking right now is going to get muted, just so you know.
Okay, so the way that we can put it to the test is that we could get 2 people to go out here, and then we'll have one person not factor in the Coriolis. We'll have one person factor in the Coriolis, and then we'll see who's more accurate. And according to you guys, the person that factors in the Coriolis will be more accurate. And whenever he's not, you guys will hand wave dismiss it. We could even do it 10 people, 5 and 5. I'll literally set it up. I know people that do it in real life. I know people that have shot these long of shots in real life. They said they've never even thought of that. But yeah, you're right. Sometimes they have a spotter that just gives them information, and they always are trying to factor in the wind because it's 100% the primary factor, and that's what they all tell me. So we'll have the people come out, we'll test it, and we'll see. We'll specifically break down the data, right? And then we'll have the one person factor in Coriolis, one person not factor in Coriolis, and you guys agree that the person that doesn't factor in Coriolis will be off based on the math that Coriolis would change it. Is that correct?
They'll be off. Have them shoot one.
The problem is that the problem is that you're using an example that has less of a likelihood of showing the effect that we're talking about, because field artillery, those shells are a lot bigger and a lot less affected by wind, and they go a lot farther. Well, so that would be a much bigger effect, right?
So you want me to go to a test that I literally can't legally do because you want to hand wave dismiss the one we can test because you're trying to make your claim unfalsifiable. So we're going to get people that are actually going to go test it. So if we shoot something 3,700 yards, okay, say in New Mexico, right, and we're shooting north, how much off would our bullet be based on the Earth if we don't factor in the Earth spin?
Which direction are you firing?
North.
All right, if you're firing north, you're expecting less deviation than you would be if you were firing east or west.
Okay, let's fire east then.
All right, and that'll be, let's see, if you're firing east, it'll be high, if I remember correctly.
Like how much? Like if we're shooting 2 miles, how off would our bullet be? Do you have any idea, any like estimate or anything?
2 miles.
Because the Globers should also support us testing it, right? Since you guys know you're right, you should have no problem with us coming up with us brainstorming together to come up with a test.
Yeah, we've been saying this for a long time. It's a very simple test. You just have them shooting off 4 cardinal directions.
Yeah, and then one factors in Coriolis, one doesn't. Seems like a simple test.
If you want to have 2 people do it and fire 1 bullet, but if you have one person do it and just fire 10 bullets and not make corrections each time, then you can look and see if the deviation, if the general deviation within all of the bullets, all the samples are all veering towards the Coriolis.
Well, actually, the better test is to have 2 people simultaneously shoot the bullet, so the conditions are identical at the time of the shot. So,
but they're not identical because they could be 2 different skills, shooters, and a bunch of other things.
Okay, so you agree that if we're just doing it at different times, and the wind stuff is going to change. So we'll try to get a day. If we're going to have one shooter, we'll have to have a day where there's basically no wind. Because now you're appealing to the skill of the shooter. Because whatever you can do, because you guys know deep down it's not going to happen. So you're already preemptively trying to come up with a way to undermine the validity of the test. Anything you can think of. Because this is the difference, the fundamental difference in the Globers and the Flat Earthers. I'm going to actually contact them. I already have it in process. I'll actually set the test up. I actually want to see what happens. The Globers want to find a way to undermine the test before it happens. There's a fundamental difference. One person wants to know, one person doesn't.
We're trying to explain the expectation. If you're trying to make a test to disprove the globe model,
Can you guys hear me?
All right, what's
Yeah,
up?
mate.
I know you always think it's your turn to talk, but it's not. So I used to work in a
waited.
2 square mile. I used to work in a 2 square mile. I mean, sure you could find indoor somewhere to be able to do this in, and you just go to the middle of it, put it on a spindle or something, and just turn the gun. Just turn it 90 degrees every time, and just shoot a shot off every time. No.
2 square miles, if we're talking about a perfect square, is only what, square root of 2 in each direction. So really only what is that? Like 3,600 feet or something in each direction that you could fire. That's not really enough.
We'll see.
And there would be Coriolis effect, right?
It
We
wouldn't
need
be
something
enough.
with. We really want at least 2 miles, though, Jeremy. Right? Like we want at least
Yeah,
like
no
a.
doubt.
I want to hear the actual numbers. Can you guys tell me, because I like the idea of being inside, because that really boils it down to what's up, right? Because of course inside the Earth still spins, so that really boils it down to what's going on. I mean, obviously it's going to be hard. So can you tell me? Can you give us some numbers? I actually don't know the numbers at all. Can you tell me, like 2 miles east, what would be the difference of a person that, like, if I don't account for Coriolis, how much am I going to be off of my target?
Dude, it has to be done inside. Otherwise, you got wind and shit. You don't know what happened.
But
Right,
we
you could
factor in the
actually, if
wind,
you had
yeah,
a 2 square mile, if you had a 2 square mile thing, you could actually take the hypotenuse, basically the longest line you could in the building, and just go one way. Obviously, you'd want to set up such a huge amount of sandbags in order to make it safe. But you could fire one way, and then set that all up again on the opposite corner, and then fire back the other way.
Are you going to answer the question? If I shoot 2 miles and I don't account for Coriolis, how far off am I going to be? Can you give me an estimate?
2 miles eastward should be off by
2/5 of a bee's
I would say
dick,
around
mate.
4 inches.
4 inches. And
Yeah.
you're in. Okay, damn, bro. Because like Jeremy, I'm trying to actually set it up. So to try to find like a 2 mile long building seems like a pretty difficult feat for me to get
that's
these
tough,
people
bro,
together.
yeah.
Then I'm going to have to probably finance it. I'm going to have to, like, if these people have to travel, I'm going to have to help them out with that. And then we're going to have to get the shots. Unless I can get some flat earthers, I'll do it. Because Globers don't want to test anything. They don't actually want to test anything. They just want to get on the internet and say, make claims. So I'm trying to make it realistic.
It's got to be done inside. Otherwise, you have wind and shit. I mean, it's bad enough with the rifle, the rifling in a barrel and shit. But at least if you can get rid of the wind, that'd be dope as fuck right there.
I agree. That would be very beneficial. Even if it wasn't outside, technically, if you could have you could just have tall enough walls on each side of the shot, it would help, right?
Like a corridor.
Could you go to LIGO? Could you go to LIGO and ask them to take all that shit out of those tunnels? That's like 2 miles, right?
No. What we're trying to do is we're trying to explain the expectations with it. This is all we're trying to do, is that the amount of deflection is very small. The only people that really need to account for it are the people that are shooting much larger than you can with a rifle.
But we can't legally test that. So what you're trying to say is we can't test it, and then we're talking about something that has such an impact zone and so many other variables that are so much more prominent, like wind, that you can just say, oh, it's off. You're always going to have to correct after your first shot. So it also becomes unfalsifiable and not even testable or accessible. That's where you guys like it. You love it in that area. We like to actually
we could
test
attack
things.
it.
You guys like
We
to
could
just say
attack
the
it.
word refraction.
Well, we could attack it logically. So we expect the Coriolis effect to happen only because we think the Earth is rotating. So then the way to attack this is figure out whether or not the Earth is rotating.
We can go to Germany. No, yeah, but all the ways you think you can determine it is stupid.
Yeah,
So-
that's your major premise that you have yet to prove. I asked you for the variable to depend upon. You would not answer.
I did, because I mentioned that I had actually conducted a Foucault pendulum. Thanks again. Because I did actually mention that I had conducted a Foucault pendulum experiment my second semester physics
wasn't my question.
undergraduate.
That
Well, yeah, because that's where the figure comes from. Because it's a measurement.
What figure? What figure?
The rate at which the plane of precession precesses.
No, I wasn't
Right.
asking about the precession of a Foucault pendulum. I was asking about the variable you used to get your 0.0001 value. That
Right.
didn't
It
depend
starts with the rotation rate of the Earth, and I was explaining where that came from.
the rotation value of the Earth was believed to be real before Foucault. When did they get that value for the rotation of the
I
Earth?
don't care how they got it. I got it
How did you get it?
with the. I just explained it, dude. Come on.
How they originally get it though?
I don't really
Dude.
care because I already have a value, and it
See, this is
agreed.
what's so fun. This is what's so crazy. You guys believe that all the guesses were right. Like they looked up at the sky and they were like, the stars don't change. So if the Earth's moving within the sky, then those stars have to be super far away. So if the stars have to be super far away, then they have to be super big. And if they're going to be super big and super far away, then that means it has to be a vacuum because that's the only way we could see it. All these guesses were made up long before they supposedly proved it, but they just happened to get them all right. Oh, so if the Earth is doing this, then we'll get the radius value by looking at this and taking an average like Alberuni did. Oh, he just happened to get it right. Oh, well then come up with a number for the actual rotation. Oh, we just happened to get it right based on our happen to get right radius. And you guys think that they all actually were just right, and you guys don't even know the methodology they used to originally get it. It's ridiculous.
It doesn't really matter what the original methodology is if
Yes,
the
it
figure that I
does.
came if the figure that I measured is in agreement with what they got.
No, it's not, because if you both are assuming something that you haven't proven, then your variables can match.
You cook the numbers. You
Please
look at an
explain how I
observation
got
and then
the
find a
figure
way
for
to
the rotation rate of the Earth.
what you find that you get numbers, you get an observation, and then you try to cook the books effectively to make the numbers fit into your assumption. That's what you do objectively. Because when you find something that doesn't work, you guys hand wave dismiss it or come up with a new theory to explain why it's off. You
So
guys are
please
always
explain
working on
why I
assumptions.
got the rotation rate of the Earth.
Okay,
I'm
why don't
asking you how they got it.
Okay, hold on. Listen, why don't you just? I know that you said that it was full. Can you break down, like, in general, like how big was this thing? How heavy was your pendulum? Whatnot. Go.
Okay, you're in some heavy noise reduction. Whatever's going on your phone, you must be in a noisy environment. But
No,
I guess to be very broad, this thing was in a three-story stairwell. Because I don't have access to that anymore. The three-story stairwell had nice square stairs all around it. They don't have stairs like this in the new buildings anymore. I'd be surprised if that building was even there anymore. That suspended at the top was just a ball in a sleeve, because that's free to rotate in all directions equally.
What was the length of your? You said three. Was it 3 stories? Was it the entire 3 stories?
Right, no, not the entire 3 stories. It was about, it had to be about a foot off the ground and suspended from
How
an
big was
anchor
the
point.
diameter?
How big was the diameter? You mean the ball itself at the end?
No. The swing. How far was the swing? Right.
It was right. It was about 1.3 meters, if I remember correctly.
1 point. So this thing was swinging for only about 4.5 feet.
Yep.
Okay. And how long was it? How long did you swing it?
We let it go for 45 minutes. That was enough to get one measurement. We let it go again for another 45 minutes. That was enough to get another measurement.
And so how did it maintain its momentum, or did you just let it wind down?
We let it go, and it did what it did. What do you mean? How did it maintain its momentum?
Well, it's going to slow down and stop. Right?
Hold on. Did you let go, or did you burn a string attached to the thing and let it go that way?
Yeah, exactly.
We did it in a couple of different ways.
Holding
Actually,
it, were you?
We did it in a couple of ways because we were, adventurous. The one way was the burning the string, because obviously we got to at least try that to see how that comes out. Then I had like this little metal claspy thing that I could trigger to release fast away from the thing that it was holding on to. So I pressed that thing, and it let the thing go instantly. And we did that for the other 2 measurements, and it came up with the same
So you did it
values.
3
So
times.
it wasn't really useful to do it that way, but it was cool
You did it
anyway.
3 times. You did it 3 total times, not 2 times.
Right.
Okay, so you did 3 times in like 45 minutes each time,
Yeah.
and you got the same exact measurement each time.
I mean, within certain level of precision, sure, because it's only going
Like
for 45 minutes.
Like what? So they weren't the same.
How did you measure? How did you measure its trajectory?
How did I measure its trajectory?
How did you measure its line? How did you measure its relationship to the floor?
It drew lines on a paper on the floor.
Okay, so it had contact with the floor, which is going to be friction. Okay, so
Very
again,
low amount of friction.
Like it was dripping ink, right?
Hold on. So again,
this one, it wasn't really dripping. This one had a, it's like a horsehair brush, and that horsehair is very gently touching the ground. Yes.
how did you maintain enough? How did you maintain enough ink for it to continue to make marks?
Because it's a big old ball, 3 stories suspended, 3 stories away from its anchor point.
No. Okay, let me ask it a different way. How wide was the hair?
Say that again, because you got eaten up by whatever.
How wide was the point of contact that made the
How
mark?
wide was? Oh, the horsehair brush? That was only like, I don't know, centimeter and a half wide.
Okay, so
It's a pretty thick brush, but I mean, it's just a brush.
how did you maintain enough ink in 45 minutes to make these marks?
Because it's horsehair. Man, it's
doesn't
not very much friction. If we're talking about a 20-pound ball, that friction doesn't really matter over the course of 45
He's talking about
minutes.
the ink, man.
Yes, I know. That horsehair brush, the amount of friction there is not enough to stop this thing in 45 minutes.
It's not what he's asking. Like, how does it keep making marks? Like, how did it maintain enough ink to keep making marks for 45 minutes straight?
Oh, ink. I thought he kept asking about momentum. No, the ink is is in a little plate, like the top of a boot wax. You know those lids on the top of the boot wax.
So what
You
you
might not
fed?
know. Anyway, it's a little metal lid.
So you
What?
fed. It was like draining ink into the brush.
I mean, the ink there was enough of it
Okay, how did you
to last the whole 45 minutes.
how did you eliminate the effect that the ink and the horsehair brush touching the ground would have on the observation?
What effect are you
He just assumed
expecting?
it negligible. He assumed it negligible.
Well, okay, so what effect would it be having specifically?
Friction on the ground.
If you have friction, if you
and
have
it's losing mass.
Hold
It's
on,
losing
hold
mass
on.
with the ink.
if you have two
The ground is
physical
losing
objects,
mass
hold
because that's
on,
where the ink
Doofus.
is.
Doofus, I'm trying to answer your question. If you have two physical objects coming into contact with each other, you're going to have equal and opposite reactions. They're going to have a relationship of opposition, of friction, of deviation.
Right. And if there was no Coriolis effect, that would just be in the opposite direction in exactly the same way that it went in. So since we observed a deviation, the Coriolis effect exists.
No, absolutely not. You didn't have any control. You didn't have any
I didn't
control,
have any
bro.
control. Really?
You didn't have listen, you
It's
didn't
not
have
even remotely scientific, mate. Fucking
I know,
hell.
right?
You know that.
Right. So if I did it 3 times and I got exactly the same amount of precession.
No, you didn't.
What in that says that the ink was the cause?
You didn't get the same amount.
Yeah, within the precision of the tools that we were using.
Which is what?
He doesn't 0.00001, right?
No.
So did you wipe off the floor each time and have a clean surface?
There was paper. The paper was covering the floor, dude. The paper.
Was it watercolor or was it acrylic?
There
What?
could have been bumps in the floor. Was the floor flat or was there bumps in the floor? Could have threw the thing off.
It's a
Did you swing it
stairwell,
the
man.
same? Did you swing it the same way every time, or did you one time you go east west, another time you went north south?
What difference would that make?
It makes a difference because if the horsehair is touching the ground and the ground's got like little bumps or imperfections and shit, it could be throwing it off.
The paper is lying on the ground. The marks that were being made on the paper were uniform. So if you want to tell me that the floor is bumpy and causing this, you're just straight up gaslighting me.
Well, I gotta say this though. Think about it. Let's be honest here as flat earthers, okay? So if he got the same exact result every time, if you're claiming that it got thrown off, it got thrown off right to where the globe supposedly predicted, right? Like that's what.
Yeah, isn't
like
that a little odd?
Well, see, I'm actually being honest, so don't make it hard there, buddy. Because the primary problem is that you're assuming the causal agent. But I happen to know that these are actually very inconsistent. So you claiming that you got the perfect result 3 times in a row is
bullshit.
Pretty laughable.
Well, I mean, we're very careful people.
Oh wow, it's me. I'm guessing you didn't document it.
Well, I mean, it was undergrad physics. We documented it for the course of turning it in for a grade. I don't have it anymore, obviously.
What was the precision? What was the precession exactly? Where were you at?
Ooh. All right, let's go with what latitude was my college at for 100, Alex?
So you don't know.
I would rather not disclose it.
Oh, you think I'm trying to dox you?
Whatever, dude. What the
imagine
fuck?
caring
You're
less
such a
about-
pussy. Whatever.
Oh, yeah, okay. Let's
Groundbreaking.
go ahead and have me disclose after I've already given out enough personal details about what it is I do.
Who gives
in
a
my
shit?
past
No one
history.
cares about
Travis,
you.
relax.
Go ahead and also
No
give
one
out,
calm down.
go ahead and also give out additional information, such as the latitude of the college I went to.
Right. I just want to point something out. The latitude
You don't
is a
have to give
line
out
that
the
goes.
latitude of the
Wait.
college.
I want to point a latitude is a line that goes around 25,000 miles in your paradigm, bud. Oh, that's such a very
That's true.
specific doxing.
That's
Oh my
totally
god.
and completely false.
If people start putting pieces together, they might be able to figure out what college it is. You don't have to give it.
Wow, that's only something that anti-flat earthers would do. See, that's like flat earthers don't do stuff like that. Only anti-flat earthers do that, and then they try to contact my job and send me death threats and send me pictures of my house and talk about how my dad is this old and he's going to tell them all this and he's going to come rape my wife. Only anti-flat earthers do that.
That is
okay,
true.
flat earthers,
That is true.
yeah, let's be real.
All right. Anyway, no, a line of latitude is not 25,000 miles long. The line of latitude matters.
Noah's not here.
Well, okay. So I mean, only at the equator then, whatever. So okay, a little bit less than that, whatever. The point is that it goes around the whole Earth. Latitude wouldn't dox you. Ridiculous.
All right,
Seems like
so
the primary
clearly I'm
part
from the
we're asking
United
you what the
States.
precession is.
That
What
much
was the
information
precession?
you can
What's your
easily
point?
gather from the way
What's
that
it?
I'm talking, correct?
No one
What's your
knows
point?
what
Let's
cares
say you
about.
had the latitude. What's the point you're making?
I just wanted to know what the precession was. And what the difference is between each of the readings. Oh my gosh, I'm fishing for doxing information because I'm asking you the primary details of your claim.
Right. If I give you the precession latitude, or if I give you the precession I measured, and we know 15.04 degrees per hour is the precision we should be, or the precession we should be looking for, times the sign of your latitude. If I give you what I measured, you'll get my latitude, obviously.
Yeah, you're right, dude. This is being
It's anecdotal evidence. Like, come on, you guys gotta
just
come
forget
with
it.
more evidence than this. Like, have it on video or some shit. Don't tell me that you did
Oh,
it
the
perfectly every
gentleman
time. That's
physicist
bullshit.
already did that for you.
Actually, when you look up these, they're super inconsistent. Like when it was originally done, it went the wrong way, and so that's why he asked you if you burn the string because they have to burn the string to even try to get close to what they're supposedly trying to get. So they cherry pick the data. I've looked through all kinds of government documents about this.
Fuck yeah. All cherry picks, mate.
It's insane.
So
it's just like it's what they do with Cavendish.
so
It doesn't work 99%
inconsistent.
of the time. Oh, it proves gravity.
Right. If it's so inconsistent, why is it that every video that I have on the topic has the same kind of conclusion that gives you that kind of precession rate that they
Because the
expect?
people only show
Cherry
the video
picking.
of the success. Exactly. It's just like B-ball when he talks about.
Same as the
I got him to admit that the Cavendish that he shows and touts as proving gravity, that he got different readings and they were wrong like the first 2 times. But he doesn't like to talk about that until you get him to admit it. So the point is like, yeah, you post a video on YouTube, you're going to post videos of you failing on YouTube? What?
Hey, Wicked.
yeah, and the FE core clearly showed that a mechanical gyro, depending on the rate with which you spin it, the RPM, will have a different drift rate. And you can very easily just spin it to whatever spin you need to get 15 degrees. Yay.
And you have to put in your latitude. You have to
Incorrect.
start- you have
That
to
was a
enter- you have to-
falsification, and I can tell you exactly where that came from. Because that mechanical gyroscope built by Stephen P., always measured the same precession rate because the only tests that Stephen P. ever did with that thing were in the same location, 4 times in one direction, 4 times in another direction.
Hey, here's the real kicker. Even if you do supposedly get the proper precession, it doesn't actually prove the Earth is spinning. Dun dun dun.
Okay.
How it's not even that.
How is that?
It was at different RPMs leading up to that. So
Hey, Austin,
it didn't instantly start at the full RPM.
Not to go backwards or anything, but I this conversation got restarted, I think, because I was asking something. I don't think you were here for it. It's a question I've been putting out there for a while as far as an idea of how you could prove it with an airplane. And then Doofus shot it down. I could let him respond real quick to why he shut it down afterwards, but just an idea in case you haven't heard me talk about this. But the idea is to use the North Star or any star that you could have a rating on, a tracking on, so you're not following the ground tracking at all. And you would have a straight trajectory towards that star. And then you have a line that lines up with a city that you would be arriving at if it doesn't move, right? You would hit that city if you were correcting to stay on that like completely straight line in accordance with the star, so you're not following the ground trajectory or the ground coordinates at all. Then you would know if you got to that point and the city's supposed to be, 200 miles to your left or right, you would be able to tell if the Earth has moved if you were able to show that you corrected to stay in that imaginary straight line towards the star.
Yeah, what's wrong
Since
with
you
that?
know pilots, nothing's wrong. Well, I don't think anything's wrong with that, but he
I'm
he
asking
talked
him.
yeah, Doofus,
I
what's
don't
wrong
see
with
anything
that?
wrong. What's wrong with it? It seems like a very difficult task, but what's wrong with it, Doofus?
Right, so if you're in an aircraft and your navigation source is Polaris, and you fly in the direction of Polaris, if you come across a transverse wind or shear wind or whatever you want to call it, a jet stream you cross through, it's going east. If that entire air mass is moving from west to east as you go in your direction toward Polaris, you can be pointed at Polaris the entire time and still be shifted from your ground track to the east. So it doesn't really help establish.
You would have to actually
or-
turn the plane, though, at that point to continue to be headed towards the North Star.
Exactly.
Well, that's not true because
It literally
as I
is.
showed earlier, your direction that your aircraft is moving and which way it's pointing can easily be 2 different figures. They're 2 different positions on that HUD there.
Okay, so if the wind's going to move me over, then I'd have to turn the plane accordingly to continue to go towards Polaris.
Just
That's
like
not
you would with
necessarily
ground
true. That's what I'm showing in the HUD. It's showing you which direction the aircraft is going and which direction it's pointed. You can be moving in one direction but pointed a different direction, which means the wind can push you off course.
Okay, so what you're saying
that-
is the wind would push us off course, but keep our nose pointed directly where it's supposed to go.
That's possible, yes.
Oh, it's possible that Superman's going to come down and dap me up. Jeez Louise.
So if you're in an aircraft, and your nose is pointed at Polaris, and you encounter a shear wind from west to east, you can keep pointed at Polaris, but you will be off your ground track to the east. That is possible. That
You
does
want to know
happen.
what the real answer is? They have to come up with any possible way to handwave dismiss anything that you can test. That's all
Okay,
it is.
ask any pilot. Ask any
but
pilot.
you know what? With
I know many of them.
Polaris might not be the best star to use for that reason, because if you're just pointed towards Polaris, you could be off course to the left or right and not necessarily know it, because supposedly Polaris is at the top of the ball, right? So you could still be pointed towards it and be off course is the problem. So you'd have to use a star that would be that you would also track its 15-degree rotation in relation to your original path and keep those differences monitored. That you know that by this point, if at an hour you're going to be seeing it 15 degrees to your right or left or whatever, and you would have to do it that way, because then you wouldn't be dealing with the ball point that they could use as an excuse.
Well, that gets super difficult, though, right? Because you're going to have to adjust according to the movement of the star.
Right. That would be difficult, but not impossible.
Like, I don't think that's really something I could ask my friend to do. I mean, I know a bunch of pilots, like there's smaller planes, but I don't guess it has to be a big plane or high up to do this. I can actually try to get something like this done, but I'm trying to think. I mean, like,
Well,
I
I
don't
was-
really care if this comes
yeah.
to some grass that straws bullshit to hand wave dismiss it. That's irrelevant to me. The Globers always do that. Like that's all
Yeah.
they ever do. So it doesn't matter.
Let
Like
me
just when
tell
we're
you
talking
what a
about the
good test-
shooting the gun thing, right? It doesn't matter what we come up with. If we actually want to come up with a test, they're like, no, there's something I can come with my head that might have less than a 0.0000001% chance of happening. But if we don't see what we like, we're going to automatically say that happened.
Let me tell you what a good test was. And Varanti came up with this one night when I was on a show. You take a picture of the moon at ground level, right? And then you send a high altitude balloon up, same camera, same focal length, whatever the fuck it is. And then you take another picture of the moon when it's at the top. If there's any kind of magnification or anything happening, we should be able to measure the angular size of it or something, pixels. I don't know. Does that sound good or no?
I'm sorry, repeat that. I was talking to Kyle. I'm sorry.
We take a camera. You take a picture of the moon on the ground, right? You send that same camera, same setting, same focal length, all that shit. You put it in a high altitude balloon. You have it take a picture of the moon when it's way up top at 100,000 feet or whatever. And then if there's any magnification that's happening, we should be able to like maybe see it. Like in their model, the moon should get bigger the closer we get to it. But if there's magnification or something happening, it might get smaller. I don't know. I've never seen this done before.
I don't know. That's pretty interesting. I had to think about that.
I don't know. I think
Whose
that'd be
models should the moon get bigger? In whose model should the moon get bigger?
If you approach the moon, right, it's going to get bigger.
Not always true, because I the other night the moon was huge in the sky, and I drove towards it to try to get to a spot where I could take a picture of it. By the time I got there, it seemed much smaller than where than it
we're
was.
talking
from
about like
where-
increasing altitude, though, right?
Right. If
If
we're dealing
somewhat similar, but not the same, really. It'd be much more drastic if you increase altitude.
right, if you wanted to get in an aircraft and get 5 miles closer to something that's 240,000 miles away, you wouldn't really notice it get any bigger.
Yeah, dude, we're never gonna notice anything that would debunk the globe. I know that much.
How would that debunk the globe?
No, nothing.
It wouldn't get any bigger though. Is the problem?
Because it won't. It would. Dude, all to be a globe, all you have to do is memorize the script, and then come up with any type of way that you can dismiss something when you come up with a hypothetical flaw with any type.
All right. Well,
that's all you
try
do.
for your, try. Hold on. You can try it for yourself then. If I'm looking at an object that I presuppose is 240,000 miles away, if I get 5 miles closer to it, should I expect it to appear bigger?
It would be very minimal. But hey, so if I shoot, Lake Ontario is like one of the largest lakes in the world that free, and so if I shoot a laser over Lake Ontario, and it has like a 53-mile width, and it completely freezes over. How far do I need to shoot that laser across the frozen lake before it debunks the globe?
There's no amount. There's no amount. Listen, first of all, I was talking about going up in a high altitude balloon at like 120,000 feet or something. That's more than 5 miles.
Bring your
right?
oxygen.
Second of all, we don't give a fuck. Second of all, we don't give a fuck about your presupposed distances, right? If it gets smaller, that would totally debunk your whole shit.
Yeah, if it got smaller, it would debunk it. Yeah.
Wait, why would it get
Where's
smaller?
the moon in the sky?
Well, you're saying if it got smaller, it wouldn't debunk it? You guys are.
No, I'm saying when has anybody? It's weird to propose the idea that it could get smaller at a higher
Yeah, who
altitude.
knows? It's just a random thing. I would say, to be honest, Jeremy, that's a pretty expensive test. I mean, it's not super expensive, but like altitude balloons and then all the cameras on them and everything isn't super cheap. Can anyone answer my question? I'm making my point that all Globers do is make up bullshit to dismiss any test that is clearly contradictory to the worldview you have. So if I have Lake Ontario frozen and it's 53-mile width, how far do I have to shoot a laser across over top of the frozen lake before it debunks the globe? It doesn't matter, right? If I shot it to the other side, you guys would still say, well, that means it had to refract across over the curve of the frozen lake 53 miles. Is that correct?
We can posit the possibility. It makes it a lot easier if you measure the conditions with precision.
Frozen lake.
Right, measure the conditions with precision. What I mean by that is, yes, ice can be cold, and the air above it could be a different temperature.
Okay, but so if it's really, really cold outside, and we have a frozen lake, and I shoot a laser over top of it, you agree that the effect of quote unquote refraction is going to be drastically eliminated or minimized?
No, because typical refraction conditions are still some amount of looming anyway. But you would
see what I'm
have
saying?
to. But you would have to, if you wanted to eliminate all possible doubts, is with precision measure the conditions that occurred while you were out there. That means
Okay, what about this?
I guess to make it at least somewhat fair, just like in the middle of that shot, get those conditions and then shoot the whole distance, because that would be
Because
enough.
it doesn't matter what happens, you will frantically dismiss it because you think you know for a fact that Earth's a globe. I know that for a fact. I've been in this long enough to know that. So if I shoot the laser and it actually physically destroys the target, how far away do I have to hit the target? And if it physically destroys the target, do you agree that you can't use in refraction to explain it away?
Do you understand that we both agreed to test? I mean, both me and Doofus and tonight alone agreed to test. So there's so what you're saying is actually a lie.
No, you didn't. What test?
It is a lie.
What test?
It's a lie.
What test you agreed to?
I described it to you and you responded to me
What
about the
test?
rifles. We talked about that.
Coach, you were the only one in the whole
Doofus
room
had
that
brought
was
up a test
decently honest
earlier as
about the
well.
rifle.
No, I'm not the only one. I'm not the only one.
Yeah, you are.
What you're
Yeah,
saying
you
is a blatant lie. Okay.
Someone's triggered. Someone's triggered.
No,
I
it's not
exposed your
triggering.
worldview.
What you're doing is just blatantly lying in
No, I'm
lieu of
calling. I'm
waiting for someone
exposing
to
you.
respond to your question.
I'm exposing you guys. That's what I'm doing.
It's not exposing. You're admitting that it was a lie. You're admitting that
No,
I agreed to this.
I just remembered.
test.
I remembered that for you. What you said was, yeah, that would be cool. But then you agreed with the conversation, or did jump back in when all the Glovers were saying, "Oh, well, there's really no way to know," and it'd be such a difference, be such a minimal difference that you never really be able to test it. You wouldn't really even know.
Hear anybody
So,
say that.
oh well, then I guess you just accidentally went on deafen right whenever the crucial climax of the conversation happened.
Those same people were the two people talking were both in the army and both had described how they had witnessed accounting for that.
Oh, that's a non sequitur.
Well, yeah, but I actually did the accounting for
Right.
in my case.
Oh, another non sequitur. We're talking about
non
we were talking about a
sequitur.
hypothetical test, not anything to do with their anecdotal, invoking of the fact that they think that these were factored in with calculations. We're talking about the actual test we were talking about. That's what we're talking about. So the fact that they were in the military is irrelevant. That's a non sequitur.
So
Literally.
you're saying that Doofus, you're saying that can't be tested for?
Well, if you want to go out and get yourself a 155 and try and find some way to legally fire it, I doubt you'll be able to.
All
do
right,
that.
that's right. Doofus said that
Artillery
ballistic
only.
would work
Yeah, he said
would work
artillery
better
only.
than
Yeah,
that.
exactly. Yeah, Coach I told you. So my point is, and I said, oh, so what you're saying is I have to go do something illegal, or just believe your story. And that's how that's what it boils down to every time. Like whenever I said, "Oh, what about the radio
Wait,
waves?"
hold
They used
on,
to really-
Witcher. Kosho needs to apologize for calling you a liar.
No, he
deserve
did
to.
lie. What are you talking about? He admitted to
No,
it.
I
He said,
forgot
"Oh yeah,
that
I do remember you
Kosho-
saying that. That's right."
I forgot. I forgot Kosho was kind of honest. He said, "I've been saying that for a while," but then he didn't have anything to say once Super said it wouldn't work and we have to get artillery, which isn't accessible. So it's like a middle ground. I wasn't really lying because you didn't really continue to say, "Oh, we should test it." There were no Glovers saying, "Yeah, we should test it. Let's figure out that." It was only flat earthers, like it is always, trying to figure out how to test it. The Glovers are very comfortable where they are, believing their fairy tale and not testing it.
Hey, just real quick, Austin and anybody else, I just posted. I don't know how you say his channel. It's Town, but he's done some frozen lake observations where he puts up these LED lights, and then I think he drives like pretty considerable distance with
Yeah,
his,
like 8 miles.
So that's pretty good stuff.
Yeah, but you'll never guess what the Glovers said. Before they even see it, before they get all the information or the data, before they actually think about it, before they look at the conditions and then try to figure out some refractive rate and then actually apply it with actual physics or anything, they literally just immediately say, "Oh, well, then it had to be refractive." They're not interested in truth. That's why the only value of discussing the intricacies of this discussion with the anti-flat earthers is sharpening your sword. And you're right, and then coming up with the best methodologies of testing, because you can hear every possible bullshit excuse you could possibly think of to dismiss your test. Then you go do it and you go show it to people that are open-minded and honest. There is no test that you can show these people. I asked them, how far can I see on the Earth before we know it's not a globe? Oh, you can actually see all the way around the Earth. It's pointless. It's literally laughably
Rumpus kind of
dishonest.
screwed up on that one.
Like you could see the back of your head.
Wait. What was that comment about Rumpus?
Well, he kind of screwed up on that one. I mean,
what do you mean? Can you?
He's essentially saying, if our atmosphere had no particulates in it, which is really odd, then you would be able to get you'd take some massive zoom, but you could make it happen. And our atmosphere is made up of entirely different gases, because
I
the
actually
atmosphere,
have that book where Rumpus got that idea from, and the author of the book actually makes that claim that if the conditions were right, you would be able to see the back of your body.
Yeah, a coefficient of 2 or more, infinite refraction. And the point is, they just want to create a narrative where their globe model is unfalsifiable, right? And that's almost all it is. It's like Foucault's pendulum. It's like, okay, well, that's correlation with latitude. Well, that's crazy. We have a correlative ether drift. So can you explain to me how you know it's there? No, they just know it, and there's no ether because you can't bottle it up. That's how we can't actually manipulate and prove the Earth's spin, but we know it. Well, what about the distances to the stuff in the sky? Oh, well, it's unfalsifiable. Well, what about the actual measurements, physical measurements? Oh, well, it's unfalsifiable. Everything, that's their only thing. See, we're over here actually thinking for ourselves, thinking outside of the box, breaking outside of indoctrination, talking to each other on very intricate, creative ways to come up with tests, to test the thing, test the narratives, to figure out what we do or don't believe in what they told us. They're just trying to find a way to protect the worldview and try to create a narrative that it's unfalsifiable. That is it. And anyone that says otherwise is being dishonest. I've been in this for many years. Okay, I've debated the best of them. I've debated all your anti-flat earther heroes, all the top guys. That's what they all do. They try to find a way to hand-wave dismiss inconvenient evidence and try to make the globe unfalsifiable. That's it. And that's dishonesty.
Okay, so let me ask Doofus a question since he's here and having a pretty reasonable conversation. Doofus, what's your opinion if I have an observation height of 60 inches and I make an observation that's 5.87 miles away, and I have a direct line of sight to the boat dock and the shoreline, 5.87 miles away.
right? This is basically Black Swan warmed over in a different form. But let me go ahead and
listen.
let me go ahead and address. Oh my God, dude!
Hold on.
Let me go ahead and address the. Oh my God, dude!
There's
All right.
no.
So let me go ahead and address the first. Let me go ahead and address the first thing that was said first
Let
about.
me go ahead and address the fact
Okay,
that
you can keep interrupting and see how long it takes until I stop trying to get what I wanted to say out.
there was no reason
Just
for
keep
you to.
interrupting until it doesn't happen, right?
There's no reason for you to fling shit, dude.
All right, here we go. Let's try it again. I'm going to address the first thing that was said. Oh my God, dude!
Do it without flinging shit. Start over.
Well, okay, I'll just keep talking until some asshole mutes him.
Oh man, what the hell's wrong with you, doofus? I just asked you a simple question and you had to fling shit right out the gate.
Everyone chill out, man. Like we
I'm
all
chill.
know, yeah, we all
I'm
know
chill.
what I said. True, everyone knows it. It's striking them in their core. That's why Coach better go on deaf then.
Okay, let's try this again. I'm going to address the first thing that was said to me, which was that Globers don't test stuff. I already gave an example today.
Oh my God, what the fuck? What the fuck is your problem?
Jesus Christ, dude!
You're doing this again. I asked you a direct question, completely separate from the
and I'm trying to address the first thing that was said, and I'm trying to do it in order, but you're choosing to be a dick. You don't want me
Yo, can you guys comment?
Wait, okay, chill out. All right, David, chill out. So, to be fair, I did go on a bit of a monologue, basically questioning their integrity. So if he feels the need to try to defend it, I think we should let him try.
He didn't want to defend it until I asked him a question.
Because I didn't have a chance.
Whatever.
Fair enough. Also, Dude, just try to keep it concise, please, and then answer his question.
I was until he interrupted 17 times. All right.
But I called out your pendulum thing already, and you're about to talk about it. So whatever. Go ahead.
Right, but you said that I never tested anything. I gave an example of a test that I did.
But I pointed out that you just assume you conflate correlation and causation. That was my point. And then you say that there's no other way. So you just make claims and make it unfalsifiable. I addressed the pendulum beforehand. So you want to go ahead and answer his question?
Right. The measurement is not a presupposition. It is a measurement. Now,
no, but the causation of it.
Now,
Oh, I have a quick question. Really quick, Doofus. When the ink was going on the paper, like, what was the mechanism for it? Was it dripping from the thing? Was it like direct contact? How was it working?
Horsehair brush, metal lid, ink in reservoir. There it goes. Okay, moving on.
Okay. Well, real quick. You said it was uniform throughout, but how does that work when the pendulum is, it's swinging? It's a curved swing. How's it uniform throughout? There'd be different pressures on different parts of the paper. The center would have more pressure because it's closer to the center of the arc.
If the
we already
suggestion was
brought
made
this up.
earlier that the friction would be a problem, that the floor would be rippling or some other nonsense,
No, it wasn't
the
about friction.
lines didn't show any rippling such that the friction varied by any particular amount
Why are you
over the
bringing up
course of the
something
mark that was being made. So it doesn't really make any sense to say that the floor
I'm
could
not
have
talking
been the
about
cause.
friction. I'm talking about the brush
I
being
think
physically
I
closer.
think I got talked over
towards the
about
center
6
of the
times
paper.
when I was trying to get that out, right?
Yeah, because you said friction. That's not what I'm talking about whatsoever. I'm talking
Right.
about
So
how
if
the
it's
brush
not
would be
anything
physically
to
closer.
do with the friction on the floor, then why are you even mentioning the brush?
I'm talking about how the brush would be physically closer towards the center of where it's rotating, where it's swinging, relative to the edges. You said it was
Right. And there were
uniform throughout.
no ripples observed within the line that was marked on the paper. That's what I meant by uniform.
That's misdirection, Your Honor.
So the line did have different thickness depending on whether it was, from the outside versus the inside of this, where it's rotating. So it wasn't uniform, right?
Oh yeah, the line, it was uniform. Yes, the line was fine.
What the fuck?
Because as I was asked about it, in the context where I was asked about whether or not the floor could have caused it, any ripples or any deviations in the floor. And when I pointed out that the line being made was uniform, was specifically in response to whether or not the floor had any ripples or deviations on it.
Absolutely, no, I'm with you. But in terms of the width of the line, it was not uniform, right?
What difference does that make?
Or for instance, the amount of ink in the line was not uniform, right?
If you want to go with that, sure, go ahead.
All right.
What difference does that make?
I'm just making sure.
All right.
What are y'all referring to with this line?
No. We're done now.
No?
Are you?
Okay.
Did you get that off your chest, Doofus? Did you get that off your chest?
Yeah, go ahead.
Okay. I have an observation that is 5.87 miles across the Chesapeake Bay. The observer height is 60 inches, and there's a line of sight to the shoreline, boat dock, straight across.
Right. So, 5 feet, as I've mentioned before, this is where room for, this is why, for instance, surveyors typically don't do measurements real close to any surfaces that may or may not be a different temperature. If we're going to talk about these kind of observations, and if they're going to be close to the surface for some reason, I don't know why they would have to be, but it seems all flat earthers like to do that, then I would like to have some measurements of temperature along those, the way, somewhere in the middle would be great.
Yep.
Some temperature of the surface, which could be water, some temperature of the air in a couple of different places, so I can tell what kind of effects are going to occur.
Yeah, I agree. Absolutely. That's beside the point. I still have a direct line of sight to the shoreline at 60 inches at 5.87 miles away. Now, I'm just asking, what's your initial response in terms of that information? Because I don't have the ability to give you those variables, which I agree have to happen just in terms of having that kind of data. Okay, because I have had many other situations where that shoreline is receded into the background, much smaller and distorted. I've also got inferior mirage where you can't even see the shoreline. So all of those different things, yes, absolutely. My point is, I've got a very pristine, crisp, clear photograph at 5.85 miles away. Now, that should just typically say, okay, I've got a direct line of sight, but in your model, there should be 14 feet of curvature.
No, let's use the actual model. Hold on 1 second. Said basically 6 miles from 5 feet in elevation?
Yeah.
All right. So along that 6 miles. Say, for example, you're looking from a 5-foot elevation out to your target, which is also at a 5-foot elevation. If we just try to make it symmetrical,
It's actually lower.
then just for the sake of this particular discussion, then what you're expecting is a 72-inch sagitta with no refraction. However, even standard atmospheric conditions would allow this to go down to being able to see just over the top of it to see something at 5 foot in elevation over to the other edge. And that's standard conditions.
Okay, but I'm seeing down to the water line.
Right. And what I'm about to mention is if there are non-standard conditions, which is that the body of water is even only 5 degrees Celsius cooler than the air above it, that would be enough to cause you to be able to see much more than you ordinarily would.
Okay, in order for you to make those claims, you would have to have a control image and contrast image for that data that you allegedly are basing your claims on. Do you have anything remotely close to that?
You're questioning the actual concept of refraction now?
No, not at all. You're making claims about certain amounts of refraction producing certain amounts of visibility. In order to make those claims, you have to be able to demonstrate the amount of visibility in one condition, the amount of visibility in another condition, in order to show the contrast.
All right. So your weird requirements aside, let me go ahead and explain.
There's no reason.
It is a bit odd. It is a bit. Yeah, hold on just a second. It is a bit odd because, as anybody familiar with optics is aware, if you have a cool surface and warm air above that surface, the light will bend downward more than usual.
No proof for that.
You have no proof for that? Did you really just say that?
Yeah.
Yeah, the garage, the garage was the opposite. I know you guys did an experiment on this and did the work for me, but I can't remember exactly which one it is. So I'll just pull up mine.
It was probably pebbles in the pond. Okay. But again, that's okay, why can't you produce anything from your side? Why are you using our shit when we don't even have all the variables and controls?
Well, because the work that you guys do helps debunk some of the arguments that you make.
Don't have anything on. Okay, you guys don't have anything, which is my point.
Here we go. All right. So now, in a temperature gradient, where the cool air is slowly changing into warm air over a course of a distance, the light always bends toward the cooler air.
What the fuck are you talking? Who are you talking about? This little GIF that you've got on the fucking feed? This light? Okay, where are your variables? Where's your information?
The iron is hot. Hopefully you figured that out.
Where? Okay, what the fuck?
Okay, so light bends toward the more dense medium in any particular type of medium.
You have no measurements. You have no data.
The light bends towards the colder air. Whenever we independently verify, this is what happens.
I would actually disagree. I would tend to disagree with that.
Okay, why?
Because cold air doesn't impede light as much as hot air does.
Oh, that's this guy. All right. It's not about impedance. Light is not electricity.
No. how do you think when you're looking at the angle of incidence and how light is slowed by a medium of a higher refractive index, when something is of higher refractive index, it is said that the light is being impeded more. It's a colloquial term. It's not a we're not talking about electrical resistance, but though we could, because it propagates electrically.
It doesn't propagate
Yes, light
electrically.
propagates electrically.
All right, but most people, I hope, in this discussion are aware that cold air is more dense than hot air.
It's not about density. It's about which has the higher refractive index. Idiot.
Refractive index, as measured in air, is always higher in colder air.
I would disagree. Maybe in a closed system, but not in an open system.
Okay. Where's your measurements to support that? Because I can easily go get the ones I already provided you days ago.
Don't be throwing it back on us for having the burden of proof.
Well, no, because I already gave this particular person. I already gave them measurements to say the opposite of what he's saying. But now we'll just go ahead and have this conversation all over again.
You haven't given any measurements. Since you and I have had this discussion, and I was asking you about a photograph that you haven't even seen, it's just been a description. You bring up this laser light hot iron, right? So is the light moving laterally or vertically?
All right, so here's this thing again. The air that has a higher temperature has a lower the air that has a higher temperature has a lower refractive index. The air that has a lower temperature has a higher refractive index.
Which direction is that laser light moving in your little GIF?
Toward the colder air.
Which direction, lateral or vertical?
Toward the colder air.
Is it lateral or vertical? What the fuck is wrong? Why do we entertain these fucks?
All right. What direction is the gradient
fall
in?
apart on us.
No, I'm falling apart with someone who cannot have an honest
you're doing good, dude. Don't just.
He's being asked a direct question, and he continually avoids it.
The relevance,
but you
as I already
responding like
pointed
that
out,
is like what
completely
he's looking for, I think.
Yeah, the relevance, I already pointed out the irrelevance of that question. Let's go ahead and address it, though. What direction is the gradient in that specific demonstration? Because it matters.
You have no data to supply. You have an observation. You're simply looking at something and interpreting.
Yeah, the iron is hot. I hope everyone is aware that irons typically get hot.
How do you know the iron's hot?
Oh, for fuck's sake, dude.
No, I'm not honestly asking. How do you know that iron is fucking hot? Is it on the low setting? Is it on the high setting? Is it even fucking on?
Right, this is exactly like when you ask the rumpus, what is 90 degrees?
Can I?
What the fuck? Like, where do you bring? Like, is that like a 2-year-old memory for me? Because I haven't talked to them. Fuck them.
It's like 10 degrees below 100, thereabouts.
What the fuck, dude?
Or, yeah, about.
Or 10 degrees.
All right, so.
One of the two.
So, as we may or may not be aware, I guess Travis isn't, the iron being introduced causes a temperature gradient. The direction of that gradient is horizontal. The deflection observed is also horizontal. The reason is because the light is bending toward the colder air.
Where's your proof of that?
Hopefully we know by now that irons are hot.
Calm down.
Yeah, I'm not disputing that, right? Okay, I'll give it to you, and I'll take it for granted that iron is hot. Where is your evidence that the deflection of the light is where you say it is?
Where's the evidence of the thing in the GIF that we're watching? Jesus Christ, dude.
I don't know why you can't answer a question. Why are you blustering?
Because it's in the GIF. we see that when the iron is introduced, the laser deflects
Some
to
of the
the right,
evidence that you're
away
actually
from
talking
the
to me.
iron, which means that the light is bending toward the colder air. You keep asking this dumbass childish question over and over again until it becomes false at some point. You want it to.
Okay, so now that you've got your misdirection, red herring out of the way.
Oh yeah,
Again,
you want it to be a red herring.
Can you post the picture of the iron again? Because I actually think that proves the opposite. If you look at it closely, you'll see that it's
11:47. Okay, so 47 after the hour.
Oh, sorry, I just have you blocked. That's all. Sorry. So yeah, when you look at that, it's causing deviation.
Yes, of course it is.
There we go.
Yeah. The
So-
closer the
Congratulations.
iron is to the laser light, the warmer the air next to the laser is getting, and the farther from the iron that light starts pointing.
No,
Towards the
actually,
colder air.
it's weird. The thing is moving left as you get the iron closer.
It's moving left. The
Totally
iron
it
is
isn't. Not in the GIF that we're watching.
No, in the GIF that you're watching, and you could see at some point, he puts the iron too close, and the bottom of the iron is lit up by the laser, and there's like a glare that happens. But you'll notice the light goes to the left when that glare happens.
It doesn't. There's a huge horizontal line off to the right. Anyway, the iron, as it is being put into the path or close to the path of the beam, you see that as it's getting closer, the laser beam, the spot on the wall is moving to the right, not to the left.
Well, let's
Maybe
have
your
a.
left and your right confused. You can put out your hands
though,
and make an L.
What about light Coriolis?
Wait.
Like
Since I'm the
Coriolis.
one,
But
who
Don is
asked,
right, though. It does reflect off of the iron.
Yeah,
once.
it does
so
very
it
briefly
matters,
touch the
though.
back of the
I'd like you to
Yeah,
tell
yeah,
me.
it doesn't matter.
I'd like you to tell me in plain English, right? Of these two pictures here, which one is happening?
Neither, because you've reoriented the thing that's occurring.
Hey, Doofus, is that you doing the iron test?
With an Iron Chef.
With an iron chef. Was that you doing it, conducting?
Oh, is it? Oh, is it? No, not me in person. I'm not the one holding the iron.
Okay. All right. So how do we know there's not some sort of reflective property there off the bottom of the
Right.
iron? What happens?
How do we
if you
know
were
that
to
this?
Hold on. I'm nearly finished, and you can jump in. So what would happen if we did the same thing with one of those steam guns and just squirting steam next to the laser light? Would it have the same effect instead of
Well,
the
no,
iron?
because the steam is not forming a nice gradient. What we're trying to do here is we're trying to establish a temperature gradient and observe what the light does through it.
Of course, the steam would establish a gradient.
No, it's steam. It's just
No,
gonna
not a nice
just go
fine
do a good
gradient.
job of
random
controlling
directions.
it, so it doesn't just
Introducing a
disappear.
third medium. Yeah.
Okay, then. So what happens if you were to set it up next to a bar radiator?
I'd get the same kind of thing going on as long as you have. Why a radiator though? That's a really weird choice because there's no flat surfaces anywhere on there.
Well, why do you need a flat surface? Why don't you are just radiating heat, and it would be consistent, and then you could just move that bar radiator left and right next to the laser to see if it had the same effect. Because you
Right. The
seem to have
reason
a
why.
you seem to have a reflective
It's easier to
surface
move the iron than a radiator. You get to unbolt it
Well,
from
I
the
know
wall.
that, Grim. I know that.
Yeah, the reason why a flat surface might be helpful in this case is because we're trying to establish what the gradient does in a given direction. We're also trying to use a high amount of thermal mass to establish a very strong gradient so we can visibly observe this effect occurring.
Yeah, but Doofus, have you done it standing on your head yet? Because I think that for some reason.
Is there actually a source video for this, like without this little tiny 2-second fluctuation?
Yeah, 1 sec. It is
Because I'd be interested in looking at the entire footage too.
physics. Copy. Paste.
I actually, to be quite honest, I actually don't see what's happening, with the iron. You're moving the heat sideways, and the light's moving with it. I don't see exactly where the refraction is occurring in that picture, in that GIF.
Hold on. You observe the light changing direction, but you don't observe where the refraction is occurring.
Well, at what angle is it hitting this layer of hot air? It looks like it's hitting it pretty head on, right? So the deviation wouldn't really be in any direction.
But I just want to really make this clear. You observe the light changing direction, but you don't know where the refraction is. We're sure that refraction is light changing direction, right?
Yeah, but which direction, right? I want to see what angle it's hitting it at, so I can say, okay, which direction is it then going from that? Which direction is it deviating from where it is? You can see that it's making it go left and right, but it's just following where the iron's going. So it's just following the hot air that it's traveling through.
Okay, in the GIF that I'm watching, apparently you're not watching the same one. When the iron is introduced, pushed to the right a little, the beam, the spot on the wall, is also moved to the right. So the light is bending toward the colder air.
Yeah, so when you're looking at, if you were to look at it in a scientific way, what angle is it coinciding with that hot air?
In a scientific way. Do you mean to quantify? Is that what you mean?
Yeah. No, I'm saying scientifically, right? If you were to look at it and say, okay, what angle is it hitting that at, so I can see which way it's deviating and determine, if it's a dense or if it's a higher or lower refractive index. What am I looking at here? Is it deviating up or down? Is it deviating left or right? Where is the where is the heat that you're saying? Like what? I'm just trying to look at it. If you were to say where's the angle, like what is the angle of incidence? How would you look at that?
Okay, I see you trying really hard here. Let me just state it real clearly from the beginning. The iron is hot. The cold air is to the right of the iron.
I'm just trying to get you to be honest.
Oh yeah, I know. I'm trying to explain why this is so ridiculous. The iron is hot. Cold air is to the iron is hot. The cold air is to the right. The light goes through this difference in temperature over a distance, which is called a gradient. The light is being deflected to the right as it's introduced to this gradient.
Wouldn't the gradient be in the vertical direction?
In a typical atmospheric observation, sure. What's being demonstrated here is what specific direction the light goes toward in any gradient.
Well, the hot air rises. I mean, are you trying to tell me that the hot air extends to the right?
The hot air is nearest the iron because the iron is hot.
Right. Okay. And you're saying that it's the light is being projected across the face of the like away from the face of the iron or towards the face of the iron?
Parallel to the face of the iron.
I mean, make it obvious though. I mean, where is the angle of incidence in a
GIF
positive
makes it
direction?
obvious.
Right?
I don't have to make it more
Right.
obvious than the GIF because you can see the GIF.
I'm not sure you really understand what's going on here.
I get that you want that to be true, but we have a hot iron. There's hot air to the left and cold air to the right. The beam moves toward the right, which means that it's bending toward the colder air.
Hang on, let me watch again. This is actually quite interesting. When you look at when he first introduces the iron, let's have a look.
Yeah, he briefly grazes the bottom of the iron and causes a very wide horizontal dispersion on the back wall.
All right, so it's at
But
about
all
57
the times,
seconds.
all the times that the beam does not touch the iron, in all of those times, the light was deflecting toward the colder air.
On the introduction of the light, it really doesn't move that much. So let's have another.
If you're watching the full-length video, the first tests he performs is with the iron off.
Where is this full posted?
I posted it 59. Okay, just before. Well, yeah, just before the hour.
You know, to me that looks like reflection.
Huh?
Yo, real quick, did you have the iron on the bottom and on the top? Or did you just do it on one side?
He does it from the top as well.
You just do it from the bottom and the top, and what happens?
Well, when you did it from the top, and the hot air was higher, the beam deflected lower. It was a very small amount, but you could see it in the back wall. He's got in this video a small cutout where it's magnified of the original video. You can see both simultaneously.
Okay, what happened when the hot air was on the bottom?
I'm not sure that he did it with the hot air on the bottom.
He just did it on one
sufficient to do it
side?
from the top.
It
Well,
looks
no,
like
he
it
did it
does
from the
it
top as
with
well.
the hot air on the left and the hot air on the top. When the hot air is on the left, the beam goes right. When the hot air is on the top, the beam went down.
Yeah, it
did
becomes
it
a
from the top
visibility
and the
issue at
right?
that point. The top and left.
He didn't do it from the top and the bottom?
No.
Why? That's obvious. The first way you would do it.
Well, why is
There's
that
a
obvious?
table down there.
Yeah.
What do you mean, why is that obvious?
If you do it from the top and you observe that the light bends toward the colder air that way, why would doing it from the bottom? I mean, you're free to do it your way as well if you really want to, because he already put this out.
I would have done it from the top and the bottom. I mean, I got an iron. I go get a laser beam at the dollar store or something.
Okay.
Yeah. It's got to be a pretty good iron, though.
A pretty good one. Like how good? How good is pretty good?
Probably not the dollar store iron, I would suggest.
Oh.
How good are you?
Should it be Teflon coated, like one of those non-slip irons?
Like-
Are they the sort that we should
Do
use?
I need starch?
It should slip. Yeah.
It's pretty slippery.
You put it on the top, you see where the light goes. You put the hot air on the bottom. I mean, the analogy of Earth is the hot air is on the bottom.
Well, not in. See, if you're doing observations in the evening, the surface cools down faster than the air. So when you're in the mid evenings, you're actually going to try to have the cold air at the bottom, which is what he did when he put the iron from the top.
So you're telling me it doesn't? It only gets colder as we go up in the daytime.
I mean, it depends on the conditions. Different conditions, different surfaces. If you're like over grass-covered land, it's pretty consistent. It's warm to cold over a very long period, so it's not a very steep temperature gradient. If you're doing it over water, it gets very hairy. Different parts of the day could be totally different.
One
I
thing
don't
that's
know. I would
weird
have
to
put
me
the
about
iron on the bottom, bro, because that's what's analogous to Earth. That's just an obvious. The first one I would have done. I don't know why. Does anyone have a good iron with starch?
Yo,
And a laser
one
beam?
kind of weird thing about
You don't
this
really need the
laser and
starch.
iron GIF is that when he puts the iron too close and the laser is like shining the bottom of it,
Yeah, I've already mentioned that.
like, hold up, the dot on the wall isn't like being occluded at all. It's not like partial because some of it is obstructed or anything. It's still the full circle. So that makes me think that maybe this is just a reflection off of the bottom of the iron, like an ever so slightly being reflected.
Keep in mind the dot on the back wall is all blown out and more circular looking because of the exposure of the camera. Keep also in mind that when part of a dot is obscured, it's still a dot.
Listen, this obviously needs to be redone. This person was incompetent. Okay, we need a guy with a laser beam.
Well, if you have a circular outlet and then like the left third of it is blocked, you would expect it to be kind of like, a straight edge on the left side.
Why do you not put the iron on the fucking bottom, dude, and make it analogous to Earth? I don't understand.
All right, so
who
what's
did
interesting
this?
about that?
Who's
Well, what's
responsible for this?
interesting? Well, what's interesting about that is if we look at the atmosphere, 20 feet above ground level or higher, we observe it to have a higher density below. So actually, when he's doing it from the top, he is kind of using it as analogous with the Earth.
The hot air on the top, really? That's analogous to Earth. Rumpus says temperature is the biggest contributor to refraction. Is he lying?
That's the biggest contributor amongst a small range. Like if you're in a less than 20 feet vertical range, temperature will make the biggest difference. The problem is that we don't just live in that much air. The pressure overrides temperature above 20 feet above ground level.
Hey guys, can I just sidetrack for 1 minute? I noticed you guys were talking about Coriolis earlier on, and do you not have to account for it when taking long distance shots? And we're talking about snipers, this, that, and the third. So I thought I would ring our local gun club and ask them the question: do you have to account for Coriolis over long distance shots? And it was very interesting, the answer that he gave me.
Please tell me you recorded it.
I did. Yeah, I did.
Yes.
You want me to play it? You want me to play it?
Please do. Yeah.
Okay. Hold on. I'm just gonna. Okay, I'll play. Tell me if you can. I'll put it near the mic, so tell me if you can hear it. %.
All right.
No. Yeah, mate. Look, I've just got a quick question in regards to long distance shooting and accuracy.
It's kind of low.
To hit your target. Do you
That's good.
I'll turn that up.
Hold on, I'll rewind it then. Okay, here we go.
Yeah, rewind it. Like we're in the 90s.
Yeah, mate. Look, I've just got a quick question in regards to
Turn it up. Turn it up.
distance shooting and accuracy when you're accounting to hit your target. Do you have to account for the Coriolis effect at all when you're trying to zero in your target?
How far away are you?
Oh, about 2.5 kilometres.
I have no bloody idea, mate.
No?
It would have an effect.
It would have an effect, would it?
Oh, yeah.
Okay, how would you calculate for that? Have you got any idea?
NASA probably do a program for that.
NASA?
Yeah.
Oh. Did you hear that?
That was pretty good.
Was that the end of the call? Or is there more to it?
Oh, it goes on a little bit longer, but he's not really going into anything. He says it's long mathematical equations, this, that, and the other type of thing. But I just found a gold. Like at first he says, I've got no bloody idea. Yeah, probably you do have to account for it. How would you have to account for it? NASA.
That's very good.
That was gold. That was gold.
Of course, though, the first thing he said to you was, how far away are you? was his
Yeah,
response.
he knew at least that much.
What he
to
should
ask
have
that
asked
question.
was, "What bearing are you shooting it in?" That's what his
If
first
he
question
doesn't,
should have been.
if he doesn't know how to account for it, then he's probably not going to know that much either.
Well, it's still.
Well, he had no
if
idea.
you're
He
at
had no idea.
if you're at like I don't know 35 degrees south latitude, and you're shooting at 2.5 kilometers away, every single direction you'll have to make some kind of correction, either up, left, down, or right, because there's not only the Coriolis effect but also the Opvos effect, which fits under the same umbrella as the Coriolis effect.
Hey,
What's your point?
Doofus?
That was pretty funny though, Doofus. You got to admit when he said NASA.
Yeah, that was
I mean,
pretty funny.
if they got it, even I don't even know if they have such a thing, but if they got it, then they got it.
They don't.
Oh God, you can have a bit of a chuckle, Doofus. Like it was funny. Come on.
Yeah.
It was what are the odds he's going to say NASA?
You're a hard case.
Doofus's sense of humor was spent when he made that Iron Chef joke, and no one laughed.
So I've got a bit of a weird question then. So, like rebel military groups, right, that don't follow Coriolis, would they always miss?
They usually lose.
Well, they typically don't fire over multiple kilometers. Rebel groups don't have that kind of.
I want to bring something up, man.
They have rifle. Well, they can't shoot a couple of kilometers.
They're not sniping.
Right
people,
now they're trying to get maximum 400 meters. Really, that's as far as I'd really want. I'd expect a rebel force to even. Yeah, well, I mean, they don't typically have long range snipers. Not longer than 4 to 500 meters.
They have whatever the Americans equipped them with, and the English.
No,
Like the
mostly
Navy
Russian
SEALs get
Dragunovs.
Oh, go ahead.
It's mostly old Russian wear.
Yeah, there's a reason why they call them the best snipers in the world. When they had to kill those, well, they have to, but they had to get those pirates on the Captain Phillips ship or whatever. But
don't they commandeer like the stuff that like America or Britain or whatever other country has been in their country, you know, causing shit? They end up leaving their stuff, right?
With the bad
Their
guys?
military equipment.
Not on purpose.
Surely they, what is it, like degraded? Like as soon as the Americans they know we don't want it anymore, or is it like
stuff may end up with them?
Accurate now.
Yeah, but like in Iraq, we gave a lot of stuff to the Iraqi military because we were allies with them after the fact, and you know, so it's like in those cases, those weapons ended up in the hands of people, you know, that supposedly we didn't want it to end up in. But that's different. We don't just leave. We don't just like leave and then leave all our stuff there for the people we just fought to, you know.
But you can't always take everything back. Yeah, I remember a conversation in here about apparently the amount of tanks the Americans like lost because they just thought, well, we're not paying to take them back.
Yeah, there was in Vietnam. There was like all those you know videos of them like dumping tanks into not tanks, but then they dump like planes, helicopters into the ocean.
Well, that's
but
one
regardless, earlier that Witsit, we brought up that guy who I guess he played. I was doing something else, but he played a video of a guy who didn't account for Coriolis. Right, he shot like some competition. He didn't account for Coriolis, but then he missed the shot. So it's like, I don't know. It's I agree with what you said, percentages. That doesn't really give evidence for anything. I mean, it doesn't give evidence either way, but the evidence sure does at least give way to you know, there's reasons why he missed a shot, and if he didn't count for Coriolis, that could very much be the reason why he missed a shot, right?
Well, you'd have to have evidence that the deviation was in accordance with your theory of Coriolis.
Yeah, I guess that's true. Like I said, I didn't see the video, so I wonder if that could be ascertained. You know, like the.
Kosho, I challenge you to find me a video of someone accounting for Coriolis and then getting it on the first shot.
Yeah, that's what I
well, no, but that's not the point. Go Go ahead.
That's why they have spotters, right? So when they miss, the spotter says 3 feet to the left, 3 feet to the right,
Yes,
up
of course.
half a foot. That's
That's the point that they have them is to correct for them when they mess up. But the point is not to
Travis, you're hot.
is not
Travis.
the point is not to be able to not account for things and then have them just fix whatever you didn't account for. They're obviously going to try to account for everything they can to get as close as possible. And so that's why I agree with what Doofus was saying about the test with rifles. If you had the best if you had the best shooters and the least other variables, then you could probably have a test there. But for the amount of precision required and the short range at which rifles are usually shot at, it's not the easiest thing to witness. Which is why I agree that artillery would be better. But even with artillery, the precision is not as it's not as important. So that's not the same precision required for artillery than for a sniper. So
here's a question, Vicent.
Yeah.
In regards to Coriolis, now, is it possible that there is an effect of Coriolis, but this effect could be due to the electrostatic nature of things and the magnetic field of Earth? Is that a possibility? What do you think? Because we know that closer to the poles, the magnetic strength gets greater, and then closer to the equator, it gets lesser, and then it gets greater again. So, if there was an effect of some sort of Coriolis, could this be put down to, like I said, an electrostatic nature due to the magnetic field?
It could. It's possible.
Yeah.
It could. It's also possible that it's due to Earth being a globe, like they say, but the possibility is very,
Yeah, like I'm granting, obviously, their possibility of Earth globe. So put that to one side, right? Because we already know that possibility. I'm just like, this is just another possibility. Like if it is there, okay, then so now if it is there and it is provable and testable and repeatable and all that sort of stuff, well, now we have to account it on our side. So what is causing it? What is
what would be the
relationship?
mechanism?
Yeah, exactly.
How?
I would say that the
question is,
difficulty
how
with
would
that
electrostatic
is
do that?
I would say the difficulty with that is having it as a control. How can you control that variable?
Well, I don't know,
But-
Travis. I'm just spitballing here at the moment to actually control those variables and whatnot. It's a bit like Earth's gravity. You can't control that variable, can you? You can't control the Earth's magnetic field.
Right.
So you can't control those things. But I'm just, like I said, I'm just spitballing an alternative idea.
Well, just real quick, I just posted. If you type in the search Coriolis and sniper, that video for me was the first one that came up. Now, I've seen it before, so I don't know if it was because of my algorithms or not, but I encourage you guys to watch that video. Now, I made a comment. I think my comment is number 2 in the feed, but don't look at my comment yet. Watch the video and just formulate your own response to it. To me, it was absolutely ridiculous. This guy's claims and then his demonstration for his sniping.
Right. First, keep in mind that it's demonstrating the Yacht-Voss effect, not the Coriolis effect proper.
Would you mind just to elucidate for us what the Yacht-Voss effect is again?
The Yacht-Voss effect is a vertical deflection when firing east or west. And he was firing east.
Oh, yeah. Okay, right, yeah. That guy in that video covers both effects in his discussion. But when he then shows you his results, well, I encourage you to watch it.
Right. I was interested though whether or not we could ascertain
why electrostatics would be a valid or possible explanation.
The first question I would have is, do they exist?
Of course they exist. What's it going to do
Okay,
to a
well
lump
then,
of metal?
okay, so then, yes, it will have an effect. If it exists, if it's a reality, then yeah, it's going to have an effect.
Well, the etheric field is
What
rotating.
effect?
I mean,
What
if you
effect?
measured it, right, the rotation of the etheric field, it could also be this force affecting it.
They
Okay,
measured the
so
rotation, right? Nobody actually ascertained whether or not it was the etheric field, as you just stated. But anyway, what would electrostatics do to a lump of metal heading north and heading south? What would change?
Have you heard of the Coulomb force?
Yes, I have. The
So
lump of metal, of course, in question is isolated and is not transiting a current.
if it has a greater charge on one side than the other, yes, of course it will. It may only be a slight difference, and it would affect it.
How does a lump of metal have more charge on one side than the other in isolation from everything else? It's a conductor, ideally. A lump of metal.
Very cool. I mean, surely you have a better explanation for measuring the curve of the Earth than some insurance about.
Right, but we're not going to address the problems with stating that's a possibility that electrostatics could cause this. We're just going to ignore the problems with that statement. Especially considering the east and west differences would be amazing for electrostatics.
Did anybody watch that video by chance? Yep.
Watching it now.
Have you seen the target yet?
The target.
Yeah.
Okay.
Let me know when you see the target.
Yeah, no, I see the target now. It's just like a reddy pinky plate.
Yeah. Yeah, it's so fucking blurry. It's fucking blurry and refracted. That he can't even get a clear shot at any part of that. It's just this blob. It's just an object in the distance. Like he has no.
Like there's no target. There's no like crosshair or anything on the target itself.
Yeah,
it's exactly. And it's got like this whitish dot in the center, but it kind of looks all washed out. Yeah, no, I did notice that.
Yeah.
So the camera can't clearly see the target. So you're assuming that while he's looking through the scope, he also can't clearly see the target?
I can only go by what we're shown, right? And that object clearly at that distance is a refracted mess.
Yeah. You can't even make out the white dot at a mile away. Like you just see red. That's all you see. Like, and Travis is right. It is a refracted mess. It's not clear at all. Have you seen it, Doofus?
Right, but it can't possibly be any clearer through the scope, we're going to just trust the bridge camera that he's using.
Well, don't
all
know.
we
We
can
don't
go
know.
on, yeah, all he can go
Yeah.
on. Like, listen, if you haven't made these observations, his scope is going to show you the same thing that you see, only
But bigger.
closer. Yeah,
Bigger.
yeah, it's still going to be a refracted mess. He's not going to have a clear shot. He's just going to see that target and go, well, there it is. I'm just going to pull the trigger.
Like
Okay,
it's,
so he'll see the target.
you know,
Good.
Well, for some sort of marksman, because he comes across as a marksman, the targets that he's using look like something a kindergarten kid would put together. To be quite honest with you, I would have expected something a little bit more professional, if nothing else, something a little bit clearer. You know, a white target with, you know, black crosshairs, maybe, if nothing else. But you're
Yeah,
just
high
shooting
visibility
at
vests,
a
you're aware, are
reddish thing.
typically not white. They're orange or green, right?
Okay, then he's not shooting at a high visibility vest. He's shooting at a target.
Right, and he needs to be able to see that target, thus high visibility.
Okay, then. So you're a sniper, and all your targets are walking around in high vis vests, are they, doofus?
No, the purpose of
No,
this is the
so.
shots being made, so the target he needs to have high visibility on in order to have the best chance of doing the demonstration. If the problem is that the target is orange, you're not addressing the demonstration.
Is the target?
Go ahead and edit
is
the
the
video yourself. Change the color of the target to white, if it makes you feel better.
Is the target uniform one color?
Depends on how clean it is. Yeah, no, not
Is the
entirely.
target one uniform color?
Looks like it was spray painted. Yeah, not entirely uniform. Yeah.
Not entirely uniform. And what predominant color do you see?
Orange.
No further questions, Your Honor.
What's the problem?
If you haven't watched the entire video and drawn your conclusions, then you need to go watch the video.
I'm already in the video. The reason why I'm addressing parts of the video that happen in the video is because I'm watching the video. Don't tell me I'm not watching the video. Jesus.
I didn't say. I said if. I said if. Okay.
All right.
So just finish
So
watching
what's
it.
the
Finish
problem
watching
with
it. And
the
if you,
target being orange? Or are we finally done with this childish argument about what fucking color the target is?
the point is that he can't aim. What part is he aiming at?
The target.
No. What part of the target?
What do you mean?
Is
What
he
part of
aiming
the
dead
target?
center? Is he aiming dead? What is he trying to
as
hit?
as a person who is trying to hit the target would ideally aim for the center of the target because obvious.
You can't see the center of the target.
Would I point my crosshair to the center of the amount of mass, whatever shape it appears to be to me? Wouldn't I use the center of mass? Yes or no?
No, it's absolutely refracted to all.
I wouldn't use the center of mass. What the fuck,
you
dude?
You don't know where the center of mass is because you only have one blurred image of orange.
Okay, so go to the center of that.
Where's the orange on the target when you see it? Where is the orange when you see the target without any distortion? Where is the orange, doofus?
Wherever it is in whatever shape it is, the dude who's looking through his scope is going to put his crosshairs.
Still can't answer the
at
question.
this. I will answer it in the way that you don't want me to, just to be an ass. Here we go. If I point the crosshairs towards the center of the thing that I see, I'm getting my best chances of hitting the thing that I'm aiming at. Right?
Keep going.
That's it. I'm pointing to the middle of the thing I'm trying to hit.
And it's distorted to all fuck.
So aim to the middle of whatever you think is distorted.
I have a couple of questions. One, when he turns the gun around the table, is it effectively on the same horizontal?
I mean, it's wherever the table is lined up at. He's aiming at the target anyway, so if the table isn't perfectly aligned horizontal anyway, he's still going to aim the gun up or down to hit the target.
Yeah, that wouldn't make much any difference.
No,
Yeah.
just being pedantic. And I don't know, to make it a bit more accurate, why wouldn't you have it like some
Topology.
machine doing the shot? Yeah, some machine doing the shot. Like,
Well, the problem is topography. I mean, if the target on one end is up 5 degrees and the other one's down 2 degrees, whatever, you're still going to have to make some adjustments. So you're pointing your crosshair to the center of the target that you're trying to hit.
that's fine. I'm just saying about like to nullify human error, you know, any sort of jerk movement as he takes a shot. Like, if you had it in a vice, and something mechanical actually doing the shooting.
Ideally, since he's hitting targets at that kind of range, he's doing the exact same thing all 6 times. That would be ideal.
Yeah, I don't think.
Is it possible that the refraction can displace the target vertically or laterally?
Well, ideally not laterally, because I don't know what kind of air you're breathing.
I've got
And vertically, it would be. Yep.
I have demonstrations of lateral displacement.
Yeah, where you think that things are not tires down or whatever.
Refraction happens in all cardinal directions.
Oh my
It
God,
happens
dude.
to the left, it happens to the right, it happens up, and it happens down. Oh, your God, what?
Well, I mean, I guess I shouldn't be surprised. That's why your paper doesn't exist on that hyperphysics site anymore.
No. The reason why my paper doesn't exist is because Sean Hawkins trolled that site. They wouldn't have taken it down outside of that, because
really
in the paper itself, is just simple scientific claims. Okay, there's nothing about flat Earth in the article at all. There was no reason to take it down. And I don't know why. Like, why would Sean Hawkins, except he has his panties in a bunch for me, right? Why would you even give a shit? If I'm wrong, who the fuck cares? Who the fuck cares? But that's beside the point. And you're bringing that up just shows what kind of a fuck you are, right? Like, that's got nothing to do with our discussion right now.
I mean, you seem to think that refraction can occur in all directions.
I know it does.
Okay.
I know it does.
So it doesn't surprise me because your paper was taken down.
Okay, that does not. Okay, what you have to do rather than, again, ad hom, is go to my own evidence and refute the evidence. When I can show you the same target, take it from the same observer position, and that target is in different positions laterally and vertically.
I'll ask you a question, Doofus. With all the observations and whatnot that Travis has done over 3 or 4 years, and all the comments that you've made in regards to any of his observations, has there been one that has been of a positive nature?
Well, he has a camera.
So you're just.
I guess that's about as far as I can go. I mean, the dude's confused about exposure settings.
So you're just a nully naysayer, by the sounds of it.
Well, I mean, if he even knew how to use his camera, I would say, oh, he's very good at using his camera.
Go ahead, Doofus, go ahead and back that up about the settings. What do you mean? What evidence do you have for that?
Right. You were taking photographs of the sky, wondering why some of the sky in one section didn't have the same brightness as the same sky in another section. You were trying to match it up as a panorama of some sort. I'm not sure why. But the exposure was different between each shot because you left it on auto exposure settings. And that was pointed out to you, which I found hilarious.
You know the settings were different.
I know the exposure was different because the same sky had a different brightness between the shots.
That's actually such a silly thing to say. How do you know it's not because it wasn't tilting the camera lens more towards the sun? And the exposure settings was the same, but it was overexposed or underexposed due to light conditions changing.
Because it wasn't the sun; it was just sky in both portions of the panorama.
Who knows what that sun is reflecting off? Was he standing near a
Oh, for
street
God's sakes,
sign?
dude! I
Was he
I
standing
get
near a
that you
stop
want to
sign?
defend your buddy so much,
Right.
but
It's more likely
it's
it was on
just
auto
sky.
exposure though, and it just kept
So what's
moving.
the exposure got? What's the exposure got to do with the fact that these targets are visibly moving laterally and vertically?
Yeah, that was a different topic. Okay,
Yeah,
we're
you're right.
we're done with
Misdirected.
exposure now.
You misdirected, right? You misdirected.
Right. I was asked what I can say positive about your skills, and I can't really because you don't know how to use your camera. You have a camera.
Do you know how to adjust the exposure setting on the P900?
I don't own one, so I don't have the menus.
So the answer is a
off the
no.
top of
The
my
answer is a
head.
no. Okay,
Well,
so
yeah,
the answer is a no.
I bet you as soon as I own the camera for more than 10 minutes, I can tell you how to change every single setting on it.
I already know
because
how. I
the
already
camera-
know how to change
Eh,
the.
Well, then how come you didn't know about auto exposure?
Because when I was taking those shots, I took the dial, clicked it to the right, and that little bar that has the auto exposure, I set them both to the same.
Yeah, the auto exposure was still on
How do you know that?
because the sky was a different brightness in different shots of the same time frame.
All right. So what I'm going to do then? Okay, hold on. Just for shits and giggles, the next time I have an opportunity to set up both of my cameras, I'll set up the exposures both the same and put it up.
Travis, don't even bother, bro. You know that regardless if you do it or not, they're gonna always find something else for you to do.
Yeah, I know. He misdirected. He totally brought up a completely irrelevant critique.
That was my bad.
Right, of your skills at using a camera, which was part of the discussion.
Your skills at using a camera.
But anyway, I think
It's got nothing to do with the fact that you don't understand that refraction happens laterally as well as vertically.
I mean, I could quantify that for you as far as how much expected lateral refraction in a particular set of conditions.
Knock yourself the fuck out. You don't seem
Yeah.
to be able to produce. You don't seem to be able to produce any source material for anything that I've asked you for. None.
Okay. You want some source material? I'll give you some source
okay.
material. I got you. If you would love some source material, I got one. I got you.
Yeah. Go ahead.
Here we go. Sauce.
Oh, saucy.
Yeah, gotta love a bit of sauce.
Here is some source material with references.
Boom.
The topic.
I mean, we're talking about refraction in their atmosphere.
Oh, Ruhif is your source? What the fuck?
He's not the only source, because as I said very clearly, with references.
Oh, come on, Travis. That's a bit mean. Ruhif does have 762 terabytes worth of data from weather balloons. Come on.
That was last week, Bansor. I think he's up to 900 now. So
there,
yeah.
there we go. There we go, White.
And that's it. That's a circle jerk of comments right there. Flat Earth Math, Larry Scott, the main surveyor, Matthias KP, circle jerking each other.
It's not. They're not even quoting like the official
Where's
story. It's like
Wally?
they have their own story now that they say is reality.
This literally has references in it that does go to authoritative sources.
Why don't you just find the authoritative sources?
Because they're all right here in one single link that I can post to you. There they are.
Isn't it a little weird that all of those sources have like is come from the same place?
No, it's not weird that a person took a bunch of authoritative sources and put them all together in one place to easily find them. That's not weird at all.
Oh, come
But
on.
what
That's fucking
you didn't mention. You didn't mention the fact that somebody put it all in one place. You simply said here all of they are in one place.
Oh my god.
Hey, Bandy, what are you confused about today?
I'm confused that you guys are still confused, Terry.
Oh, okay. So we're
confuses
doubly confused.
So
It's
yeah, with all
bewildering.
the evidence that you guys have been presented, it is very confusing. Very confusing.
Mystifying.
But yeah, we're going to create a GoFundMe, Terry,
Mm.
and we're purchasing. What are we purchasing, White? What's that gun called?
Hitler's World War II, I think it is World War II cannon that shoots 165 kilometers.
Yeah, we're going to
Wow.
purchase Hitler's World War II cannon.
Are you going to put that in your
Couple
front
of bob
yard,
from the
Bandy?
museum.
Yeah. I'm going to fire it from here to Kangaroo Island. That's what I'm going to be doing.
You better warn the kangaroos then.
No koalas left. They're all burnt out. Poor things.
Or died of AIDS, one of the two.
Oh, no. Did they bloody try and inject
Yeah.
them as well, did they? Poor things.
No. Koala AIDS, it was a real thing.
Yeah, right.
They got it from pigs, apparently.
It's that
Koala.
story, Vandy, that you go with.
Yeah.
Is that not koala pox?
Yeah.
Koala pox. Love it. Surely it'd be koala naps. You'd get the fucking nap disease where you just need to nap every fucking 3 minutes in a tree somewhere.
Wouldn't you?
No, that's sloth pox. Mind you, they're both as lazy as each other, aren't they?
Globe pox. That'll be next.
No, that's the real pandemic.
Is anyone here a mod?
On Mars? No.
Yeah.
I'm a moderate.
A moderate.
Yeah, what do you
Well,
mean?
anyway.
I'm a mod.
Can I get a roll to post the images? I've got some evidence.
Who's that,
What's
Lori?
your evidence? What's your evidence?
Is that Lori?
Doesn't sound like
Evidence
Lori.
here.
Hell no.
What's your evidence, Grenade?
Yeah, you'll see when I post it. It has to do
Is
with
that Ed?
flat Earth map. Yeah, it's
This voice sounds very familiar.
Isn't it Ed?
Recognize it, Jeremy?
This is your call, man. So.
It's Ed. Is this Ed?
Oh,
Yeah,
Ed, that's who I meant. That's who I
It's
meant,
Ed.
Ed. I forgot. What's up, Ed? I'll
Yo,
give you the
Hey,
live
Ed,
stream
hold on,
verified.
mate.
Hold on. I got it, man. So
You
go
know,
ahead.
yeah, I've got it, mate. I've got it. Yeah, I've got it. Hold on.
What,
I've
Mr. Ed,
got
the
you.
talking
I
horse?
knew that voice.
Oh, I've got you, Ed. And I'm watching you, Ed. Don't you worry. I'll soon revoke them if you play up. There you go. Done. You're all good to go.
all right. Thank you.
You're right, mate. What's he got here?
There it is.
Ready for this delete button. Am I?
Yeah, no, don't worry.
What do you got there, Ed? Walk us through it.
Well, it's the AE map, and as you can see, my city of Amsterdam has longer sunlight than Lisbon, which
Yeah,
is
I'm not this
closer to
again.
the sun.
I mean, it's
That
still
is
a good one.
interesting, actually.
Yeah, the amount
So
of
you're
daylight
saying
per
you're
day
saying that-
goes up as you go further north.
That's because it has a tighter circle, and you can see the sun for longer from the limited area because of the tighter circle that it winds. You're further south and further from the north, yes. But the
No.
circle of the sun is much wider, so you see the sun for a shorter amount of time compared to the
He
tighter circle
doesn't.
in the north.
He's in Amsterdam.
I actually see it longer compared to the south. I mean, Amsterdam, that's farther
Yeah.
north of Lisbon.
So, okay, then it's the
Right,
opposite.
so it's the opposite of what you said.
But the same metric is still there. You're just closer and you have a tighter circle of the sun and you see it for longer because you have a tighter circle there. That's all.
Right,
Same
but
thing.
Lemon, it's the exact opposite of what you just said.
You said that you see the sun longer, correct?
Yes.
You're north, correct? Okay, so you have a tighter circle toward the north. And you can see it for longer than somebody in the south with a wider circle where the sun is going to dip out of their view. Same mechanism. Whichever one is closer has the tighter circle. If they're closer to the north, you said you're closer to the north, same deal.
But I'm not closer to the sun, and you say that the sun disappears when it goes further away. So how does that make sense?
You're closer to the
You have
north than Lisbon, right?
Yeah, but I'm not closer to the sun. As you can see on this flat Earth map, with the sun path.
So it's summer for you, right? So the sun is doing a nice tighter circle for the people in the north, like yourself.
Right, but that still means that Lisbon is closer to the sun according to that map.
Are you trying to make
So
it out
they
because
should
it's
have
colder?
more
in...
sunlight.
Yeah, are you trying to say because
Okay.
it's colder in Amsterdam than it is in Lisbon? How does that make sense? Is that what you're trying to say?
No, I'm
Lis-
absolutely not talking about temperature. I'm talking about the duration of the sunlight specifically.
Okay,
Yeah, he's in Amsterdam. He is farther from the Tropic of Cancer.
Yes, Lisbon is
Being
closer
farther
to
from the tropic means he's farther from the sun.
Lisbon is closer to the sun, yes, but it is further south with a wider circle of the sun that it has to look at. In the north, there appears to be a closer circle of the sun because you're in a smaller area, basically, looking up at the sun with a smaller, tighter circle toward the north. So visually, you're going to see the sun longer with a smaller, tighter circle.
But
somebody
the
in the
sun is
south with a
further
wider
away,
circle.
and you always say that the sun sets when it's further away. So how can I have more sunlight when the sun is further away? That doesn't
You have a
make any
tighter
sense.
circle. You have a tighter visual circle.
That means absolutely nothing.
You have a tighter visual circle and can keep tabs on the sun longer, essentially.
Yeah, that's what she said, but that doesn't mean anything.
That means that you're able to see it longer because you have a tighter visual
Right,
circle.
but how do you explain that? Because it's just a word and it means absolutely nothing.
From the north, you're looking south, yes, but you have a tighter visual circle. You're in the north with less land and a much
Yeah,
tighter
what's a
visual
tighter
circle.
visual circle? Can you draw that
Right.
out on a map and explain what it means? Because
You're
it's
in
just
the
word salad at this
okay.
point.
The circles of latitude would get smaller and smaller toward the north, toward the northern center. The sun would be circling in tighter and tighter circles, and a visual field that you're covering when you're looking out would be tighter toward the center. Somebody
Yeah,
further toward the
can
south, like
you
Lisbon.
elaborate what that means and draw it out on a map?
I'm trying to do so right now. When you're further toward the south, you're in wider and wider circles. You're looking at a sun that's circling over more and more land.
Wider circles compared to what?
Wider circles compared to the tighter circles in the center.
Okay, but the sun is still at the same location, so how does that work?
Your visual field is much narrower in the north. You're looking at the same sun, but you're looking at it in a visual field
Right,
that's
and the sun is further
narrower.
away when you're in the north, which means it should set faster, right? Because when
Perspective
the sun
is a hell of a
sets,
drug.
because when the sun sets, according to you, it's going further away.
But you have a tighter visual circle in the north. So you
Right,
can
but
keep tabs
so
on
the
the sun
sun is
more
still
than somebody in the
further
south.
away, Lemon. You're
But
ignoring
you
your
have a
previous
tighter visual
explanations of
circle.
sunsets.
You have a
The
tighter
ultimate
visual field in the north. So you can
You're
see it.
absolutely contradicting yourself.
No.
the ultimate issue
The
here
visual
is that
field in the north is narrow. Toward the south.
the ultimate issue here is that the
it's
sun.
simplified.
The ultimate issue here is that the sun appears to have a different distance at which you could see it's still in the sky, depending on where you are. So it kind of makes this weird bean shape, not a circular shape.
So the visual field in the north is tight enough and compact enough so that you can see the sun for longer before it appears to dip away.
Yeah, you keep saying that, but the sun is further away in the north, so that doesn't make any sense with your other explanations.
It makes sense with the visual field that you're covering.
No, it doesn't add up with your previous explanations of how the sun sets when it's further away.
Yeah.
Isn't this
But
the
the
reason why
visual
they get the
field in the
24-hour
north
sun?
is more
from,
narrow.
That's the reason why they get like the 24-hour sun in Sweden and Alaska and Canada. What's going on?
In the north, it's the sun is circling so tightly it never really leaves the area visually. Toward the fatter latitudes, toward the outer southern perimeter, the sun appears to be covering more land, and it appears to set and dip much more.
But there's only one sun, so that doesn't add up.
Yeah. But there's several different visual fields that the sun is covering relative to the observer.
Right, and
the
the
visual field
one
being
up
the
north,
distance that
and
you
in
can
the one
see
up
in the
north,
sky.
and in the one up north, the sun is further away, so it should set sooner, which it doesn't.
It's further away, yes, but your visual field in the north is a bit tighter relative.
Right, but that doesn't add up with your previous explanations about how the sunsets work.
The difference of the visual field is the main thing. The sun appears to be circling much more tightly in the north toward the south. The sun is covering a greater arc, a greater sweep of circle, a greater sweep of arc, and appears to set. That's all.
Right. Can you show any evidence for all those claims? Because right
It's
now
just
it means
perspective
absolutely nothing.
and logic.
Right now it's just a word salad now. Can you provide evidence, please?
Just logic. If logic's not good enough for you, I don't know what
Well,
to tell you.
it's not logic because you haven't provided anything to back it up.
Just logic and reason, and yeah.
Yeah, you keep saying
Tighter
logic,
visual
but
circle toward the north.
for it to be logic, you need to back it up. So do
Tighter
you have
visual arc in the north.
Yeah,
Broader
you keep
visual arc in
using
the
those
south.
words,
And
Lemon,
it appears
but
to set.
yeah, I know you're repeating the same words, but that doesn't mean you've shown evidence that that's the case. So, do you have anything? I guess not. So we can dismiss that. Does anyone else have an explanation?
The only reason why you're dismissing it is as you can visualize.
No, you
it in
didn't
your
show
head.
any evidence, so therefore I can
I
dismiss
gave
it.
you logic, but you can't visualize it in
No,
your
no,
head.
no.
And I don't feel like doing any
for it
drawing
to be
right now.
logic, you need to show that it's actually the case.
If you can't visualize it, that's a you problem.
But
Tighter
you haven't
visual
shown
arc in
that
the
the
north.
reality works like that.
Fatter visual arc in the south. It appears to set in the south because you're looking out at a bigger arc and trying to see the sun before it sets in that greater visual arc. That's all.
Yeah, that's
If
all.
we're trying to
Indeed, that's
visualize
all.
this-
It's only words. That's all, because you didn't show anything that it's true. So, does anyone else
If we're
have an
trying to-
explanation?
If we're trying to visualize this thing, we've got different regions have different distances to the sun where it's visible based on where you are. It's kind of difficult, Lemon. You got to at least admit that.
Ed, why are you presenting a map where Australia is all out of proportion? At least.
So, the best way to think about it is taking your phone and passing it an inch in front of your face. It will appear to pass by your face very quickly because of the very narrow visual field. With you being closer to the object, that would basically be like, the sun by Lisbon. It's so close, it just appears to pass by you very quickly. But if you extend your arm all the way out and get a greater visual arc, you can see the phone appear to pass by you and take longer to pass by, and based off of the greater distance it appears to be covering in the visual arc that's you get from having your arm extended as opposed to having it close to your face. The arm extended would be like seeing it from the central north or further up north in Denmark. You're covering a greater visual arc and you can see the sun for longer if you're
Wait,
towards
didn't
the
you
center.
say it was a tighter visual arc? So why do you have to extend your arm now? In the
You're in the
north?
center.
You're
So
again
from the center out,
contradicting yourself.
your
Lemon.
visual field expands and you can see the sun in a
But you said it was
greater
a tighter
distance.
visual field. So how does it expand then?
You're in the center.
Yeah,
So
that
you're
doesn't
in
explain it.
a smaller area. And from there, you're
You're in a smaller area. So how does it expand then?
And you can see, just like with your arm extended with the phone, the thing passed by for longer than if it's right up in your face, like in Lisbon. That's basically
So
what
a
you're saying.
tighter visual circle expands your field.
It's just like with
right.
the phone. With the phone up in your face, it appears to pass by very quickly, like in Lisbon. Extend your arm out. Now you can cover, greater distance since you're in the center.
But in the
And
north,
you're
the
seeing
sun is
things,
further away
that
from me.
work, much longer. So that's basically what's happening.
No, because in the north, the sun is further away from me. So that contradicts
Just
what
like
you just said.
extending your arm.
Right, but that extending your arm means it's further away. Right.
And you can see it cover a greater arc.
And you're saying it's expanding, but at the same time, you're
Your
saying in the
visual
north
field
you
is
have a
expanding,
tighter
yeah.
visual field. So you're contradicting yourself all over the place.
Not
here.
really. With that
Yeah, you
practical
are
demonstration,
actually.
you can
You're
see
saying
how the
contradictory
phone
statements.
appears to pass by in front of your face very quickly if you're close to it. And
Well,
when you're
you
closer to
keep
the
repeating
center,
that.
further from the sun, it can cover a greater arc and be seen for longer.
Yeah, you
Quote
keep
unquote.
repeating that. But first of all, you didn't
It's
show
just
any
a
evidence.
practical example of what I'm saying.
First of all, you didn't even show any evidence that reality works like that. And second of all, you're contradicting yourself all over.
All the principles are there. At this
Yeah, all
point,
the
I don't know what else to
contradictory
tell you.
principles are there.
So if
All
you're in the
all the
center, you can
contradictions.
see a greater arc, relative to where you are, even though you're in a smaller, more confined area, if you will, toward the center and further
Right, so
from the
you're in a
sun.
more confined area, yet you can see more.
Yeah.
Yeah, that makes absolute sense, of course.
Visually, yeah, with that example with
No,
the phone.
visually, absolutely not. You're
You
contradicting
can
yourself.
see the phone for longer when it's not up in your face, like in Lisbon,
Right,
Portugal.
but you said you have a tighter visual field, so what are you even talking about?
That example shows basically with the phone right up in your face, it appears to pass by very quickly. If you're far away from the object, you get to have a more of an arc visually on the object like you would in the center. With the sun's far further away, sure, but perspective's a hell of a drug.
Right, of course, but the sun is further away, so it should set sooner, but it doesn't. So your
That
explanation
principle
doesn't make any
quite work.
sense.
That principle doesn't quite work. With
Well,
your
that's how
visual
you
field
explain
expanding
sunsets.
from the
That's how you
observer,
explain
you can see
sunsets
an object for
previously.
longer. It's
But
like
that's how you
the
explain
Boeing
sunsets.
727 that appears to zip by you at 700 miles per hour if you're right next to it, but it appears to linger in your visual field if it's 30 or 40 miles away at 700 miles per hour. It appears to be visible longer.
Right, so just to be clear, the sun doesn't set because it goes further away from you?
It is going for it is further away from you, but you have a wider visual
Oh,
field
so
and
when
can
the sun
maintain
sets,
visual
it's
on
going
the sun
further
for
away
longer.
from you. Right, so
You
when
can
the sun
maintain
sets, it's
visual on
going
it for
further
longer
away from
because
you.
you have a wider visual field.
Yeah, that's not what I asked. So if the sun sets, it's going further away from you, yes or no?
Yeah.
Oh, okay, cool. So, but then when I'm in the north and it's further away from me, somehow I have more sunlight. Yeah, that makes absolute sense, Lemon. Congratulations. It's not a
It kind of makes
contradiction
just
at all,
as much
buddy.
sense as they tell us that we have our summer when we're further away from the sun, right?
Not if you live in Australia.
If you're in the center of the circle or toward the center of the circle, sure, the sun's getting further away from you, but relatively, it's not getting that much further away from you. If you're in the center of the circle, the sun would be equidistant from you at all times. As you get closer to
Yeah,
the
but
edge of
I'm
the
not in the
circle,
center, though.
it will have more variations distance-wise where it will appear to get further away from you than at the center. So it's a
Right,
little
but I'm
deceptive for you
I'm
to
not in
say
the
that the
center,
sun's getting
though.
further away from you. It's getting quote unquote more further away from you the closer you are to the circle of the sun, isn't
No,
it?
not quote unquote.
So
It's
it's getting
actually
more
further
further
away from
away
me.
from you the closer you get to the circle of the sun versus being in the center.
Yeah, I'm actually not in the center, so that doesn't make any
The
sense.
change in the distance of the sun is much more dramatic when you're closer to the circle of the sun toward, wherever it's circling over the land.
Yeah, no, that actually doesn't make any sense either, because
That
if you look
makes
at the
sense.
no,
If
it
you're in
doesn't,
the
because
center,
if you
the
look at
sun
the
will be
GIF,
equidistant
if
from
you
you at all times in the circle. If you're closer to the circle of the sun's
Lemon, why aren't you
latitude,
listening?
it will have much more dramatic
So,
changes in distance.
Yeah, okay, buddy. So if you look at the GIF from the flat Earth map with the sun, you can actually see that the closer you are to the red line, the further the sun is going away from you. But in reality, I have more sunlight when I'm further away from
If
the red
you're
circle.
in the center,
So that doesn't make any sense with your
it makes
explanations.
perfect
Lemon.
sense. In
No,
the
it's
center, if you were in
completely
the center, the North
contradictory.
Pole center, the sun would be equidistant from you at all times, and there would be no
Right, but
visible
I'm not in the
change,
center, so
pretty much.
so that
Now, if
doesn't
you were
make any
closer to that
sense.
red line, the sun's distance from you would appear to change much more dramatically and appear to be much more further away from you, or go much more further away from you relative to the center. So there you go. You're getting much more dramatic changes in the sun's perspective position when you're closer to it than when you're closer to the center. So all the principles appear to be pretty sound.
No, it's actually completely contradictory to what you said.
I think you have more than enough to figure this out from a flat Earth perspective.
Yeah, and it's completely contradictory. That's the conclusion. Yes.
There's no contradiction.
Yeah, there is. You're just not willing to admit it. That's fine.
You're not even willing to state it, so what are you talking about?
I've stated it multiple times.
Yeah, you're not stating it now, so you kind of sound like you're full of bullshit.
Yeah, that's cute. Why don't you say the same words over and over again and see if anyone can repeat it? anyone agrees with Lemon, please repeat his argument.
I want to know why, Ed, you've got Australia so much out of proportion on your little demonstration.
I got Australia what?
Out of proportion. Have you seen what Australia looks like? So
I think
Yeah,
that's from the
good photo.
Bandsaw Bandit. That comes from basically having pie slices representing these
Yeah, so
continents.
I think Lemon,
So
he
as you
asked
know, a
me.
pie slice from the
So
center.
Lemon, I think he asked me.
Hold on, I'm
Yeah,
gonna
no, but I
answer
think he
though.
asked me, Lemon. He didn't ask you. He asked me. So
Wow,
why are
you
you
come
butting
in
in?
here being so
Hold on.
combative. What's the matter, man? Calm down, Ed.
Chill
Why are you
out,
doing
right?
this?
Might never happen, mate.
All right, calm down.
Yeah, the question was to me. Why is Lemon answering? Why.
That's fair enough. Go on. But you just don't have to be so combative. You just come in all
I'll
like
let you answer in just a
unstable.
second, Grenade Gorbowitz. I just really wanted to really quickly point out that a pie slice expands from the center outward when you're looking at a cake. The AE map is basically like that with pie slices that expand from the center outward. And basically you have straight lines hitting the sun as it circles out like a pie slice over the surface. And you're going to get expansion for the same relative area if you're looking at these lines of longitude as pie slices that radiate out from the center. So it's basically the vicissitude of the type of map you make. It's still going, between two slices of longitude for the same 3,000 miles, say, in North America versus Australia, but it's going to look more wider and more deformed based off of the map making toward Australia, even though it's the same amount of land between North America toward the inner part of the pie slice versus Australia toward the outer portion of the same pie slice. It's just the map, basically the vicissitudes of map making. But let me unmute you, Mr. Grenode Gorbowitz. So you even muted yourself. Wow. I'm going to unmute you now. You can respond at your leisure. All right. I guess he's gone for the night.
I'll let him know he's unmuted. Text.
Sorry to cut in. I just didn't know if you were going to give a, answer. Globers sometimes get a little silent when it comes to, actually giving an answer about this sort of stuff.
I get the whole pie slice explanation, Lemon. I truly get it. But if we're trying to have a true representation of where land masses are and where they're situated, I don't understand, right, why these land masses can't be represented in their true and actual size.
I think the main problem is the token that they use to represent the continent size is the sun's, the amount of land that the sun passes over. And so that is going to give you a circle as the sun passes over the land and longitude lines that are going to be pie slices coming from the center. So based off of the sun being that metric for how much land it's passing over, they're going to get pie slices in their map conception. Now, if we want something that's as is, that doesn't have to take into account how the sun looks due to perspective, refraction, and stuff like that, that's going to be a real pickle. Getting an as is map that also goes with what we see visually as the sun with its rising, its setting, and its speed.
Yeah, but if we're making a map, Lemon, why are we taking into consideration the sun? Why aren't we just taking into consideration the land masses, where they are, where the water is? Why aren't we just taking that into consideration? What does the sun have to do with the map making?
It's the best long distance indicator we have since probably the dome's in the way, and we can't see the whole surface at one time, as far as I can tell anyway. The land's too far away. We can't get high enough. It looks like we're using the sun and what it's circling over as more or less the general indicator, along with the sun, moon, and stars, for some sort of generalized map schema for whatever reason.
Yeah, the whole interesting point about this discussion, along topics of what we can observe, how much daylight we get per day, especially in December, because that's fun, kind of disproves the whole notion that we could be on at the very least, a surface which has a north pole at the center, and everything else is radiating outward from there. Because it gets really weird in December for sure.
I don't know.
Well,
I
we're
think if
still
we,
trying to figure this stuff out ourselves. So we'll put our heads together and see what we can find. What are you saying?
I was just saying that to me, it doesn't make much logical sense if we are depicting land masses on a surface. Now, one surface we have that is based on a horizontal, and another surface we have is based on a sphere. I don't know why any of these maps have any distortion whatsoever. They should be what they are.
Well, we'd have to see the whole surface. And as far as we can tell, we haven't done that. We've seen large portions of it. And then we have to superimpose it like puzzle pieces onto a general schema. But the main reason that we can't see the whole surface, I would contend, is probably because we can't get high enough and or there's a dome in the way.
I can get high.
Yeah, but couldn't you get pretty
Sorry.
close with measuring these distances from point A to point B and measuring these? And the better that we get to travel over these surfaces, we can take more and more accurate measurements, whether that's by land or sea or air. By traveling from point A to point B, we can work out a distance between these masses. We can measure the masses on land itself, so we can have accurate depictions of the land masses, but how far away they are from each other, we can get pretty good approximation of doing that, whether that by boat or air, and calculating the distances that way, and then placing them appropriately where they are.
I think we get a good approximation, but even by air, we have the jet stream to deal with. The jet stream adds 200 miles plus per hour to your trip. So if you're going to do, time travel times the supposed speed of the ship, how do you know if you're going 500 miles per hour, 600 miles per hour, 700 miles per hour? That will change your calculation and give you a range, but it won't be super exact, but it'll give you a pretty good range by airplane, even with that, depending on how fast the jet stream is, your route, there's vicissitudes with that too.
Yeah, I get all that, but the more times you take these flights, Lemon, like a flight from LA to Melbourne, for argument's sake, we've done that a million times. So we could take a million different calculations and average those out and get a pretty close approximation, taking all these considerations into effect, jet streams, this, that, and the third type of thing. And we can narrow it down the more times we take these flights over and over again and get closer and closer.
I think that's a good idea. I think the main thing is the distances at sea, though. Like when you're looking out at nothing but blue water, no landmass in sight, say, how do you verify that, But I think that's a good start. Yeah, that's a good start.
I bet Google could and has done a pretty accurate map now.
I think Google's done their thing, but I think they've assumed a lot of globe stuff. There's a lot of computer modeling that may or may not quite match reality. According to Robotham, their sailors, they're saying we're getting too much land down here past the equator. So
if they could stitch together literal pictures and stuff, it's not going to be totally, but it's going to be somewhat. I guarantee they have the capability. They have access to something we don't, I bet.
Well, they need to give us their source data before their manipulation.
That's what I mean.
Give us the data and we'll make our own, stuff. Maybe we could already do this and, I just need to learn, where they keep this stuff. But as far as I can tell, there's layers of an Arctic treaty, NASA, national secrecy, just a bunch of rigmarole.
So anyway, I did initially address my question to Grenade, Ed, aka. Do you want to pipe in now, Ed? Now you're off mute.
What's that? Sorry. I
I
heard my
said now
name.
you're off. I said now you're off mute. Do you want to address the question that I did ask you?
See. Well, why the land masses are out of proportion is because it's a globe map. Only fits on a globe and on flat if you do that. Otherwise, distances are not going to add up.
Okay, so you're using an inaccurate account of a map on a flat surface to create a meme to then construct an argument.
No, this has actually been presented by flat earthers because they think it's a flat earth map when in reality it's a globe map. So it's fine if they think that, but then I'm going to use it in my arguments. And as you can see, it kind of destroys the flat earth notion.
Oh, it doesn't destroy my argument because I don't use that map personally myself. So, but maybe the person that did present it to you, you could use it towards that person. I would agree there, 100%. If someone has presented it to you, towards them and construct it.
Well, do you have a flat earth map, Benzo?
Oh, me? Oh, not at all. I just use Google Maps myself, mate, when I'm getting around town. That's what I use.
Yeah, so Google
I'm
Maps,
not,
that's
I'm not.
basically the same map as this one.
Flat as a
Oh,
tack.
well, so I only have to, I only have to worry about getting from, say, Adelaide to Melbourne, mate. I've got no problems whatsoever. And I actually don't even need a map for that. I just follow the road signs themselves, generally. I know my way around.
Right, I get
Pretty
that,
well.
but if you're using Google Maps, then this map is basically that. So if you're fine with
Well,
that,
see,
Those signs are
well,
curved, Fandy.
see, yeah, they are. But see, the beauty about Google Maps when I'm using it, I don't own a a luxury cruise liner or a MiG jet or anything like this. I don't have to worry about going from one continent to another. And I'm kind of gathering if I did, I probably wouldn't be using Google Maps in the first place. I'd be using some sort of other navigational process to get me to my destination. But Google Maps is very, very handy for around town, day-to-day activity. I will 100% agree with that. Yep, you should use it. I'm an advocate for it.
Right, but the question was, do you have a flat earth map?
Oh, I've got a Melways in the back of my car, mate. Yep, I certainly do. Yep.
He already said no. And the thing that's deceptive about what you say is even on the globe conceptions that we see on our teacher's desk, the continents are out of proportion. So we have problems on both sides. On the globe conceptions, the continents are out of proportion. And on some of these flattish conceptions, at least size wise, if you don't know how to use a key on the map, visually it looks like it's out of proportion, even though if you use the key properly on the map, you get the proper distances. So marrying, these conceptions of pie slice, centered at the North Earth or whatever, with what is actually as is, looking down from heaven, with a God's eye view or whatever, is a real pickle. Especially, I guess, with ocean currents, wind currents, dome, NASA secrecy, whatever.
Yeah, whatever. Exactly, whatever. There's nothing to back that up.
Does anyone know if we have someone that can read Arabic in this server? Does anyone?
I can read Arabic numbers.
I need words, numbers.
Give coordinates will be expected.
Maybe percentage?
Percentage? Oh, yeah, maybe. Well, when he comes back, I'll ask him. Got something that needs translate.
anyone here know about Bitcoin Lightning wallets?
Your mic's really bad, Jeremy.
Everyone's sleeping. I'm trying to whisper.
Oh, okay.
Don't you fucking wake anyone up, Jeremy. With your flat earth nonsense.
Well, the A.E. Gleason maps appear to have practical dimensions. That,
Let me
as far as
stop
I
you
know,
there.
the globes do not have. People use maps like that for radio transmission to use proper, line of sight, delineation of where to send the radio signal. I don't see practical dimensions like that being mirrored in the globe conception. So it looks like the thing that, has practical utility in, reality appears to be the A.E. Gleason like maps when you're trying to send radio signal anyway.
Does it work
Right,
for
because it's a
distances and
globe map.
direction?
No, it's because it's a globe map and it fits in reality. You're right, Lemon.
As far as I can tell, there's no globe conception that has the continents in accurate proportion either. So, as far as I can
Well,
see,
your
globe is
personal
conceptual,
incredulity is
but
not really
not
relevant.
practical.
I have a map that's accurate. It has the right proportions of continents and oceans. It's a three-dimensional map, though. It's not a flat one.
Yeah, to get the continents in proper relief, you're going to need to take away the globe, flatten out the map, or puzzle piece it differently. So it looks like the globe doesn't really do anything.
You have to have a three-dimensional map in order for it to work correctly. That's what I'm saying.
A three-dimensional map. What the hell is that? I've never heard of that.
Like a
See if I can
You've
find a
never
picture.
heard
Hold
of
on.
that. Oh my god, you want to debunk the globe and you've never even heard of that. That's great. But you said it right, Lemon. As far as you've known, there is no accurate globe representation. That's fine if you don't
there are
know
many
about
map conceptions.
No, but I wasn't even finished. So it's fine if you don't know about it. That doesn't mean it doesn't exist. Just
Right.
get better educated.
Right. I mean, it could be a thing. I've just never heard of it.
Yeah, that doesn't mean it doesn't exist.
Right.
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 Okay, I posted a picture of a three-dimensional map that has
Left.
all the correct ones.
Oh my god.
It's never been proven wrong.
What excuse will he come up with this time? Let's hear it, Lemon.
Map. Here we go. Really? Really?
Wait, that
I
was
mean,
it?
if you try to take
Now
it
you're
and
just trolling.
make it flat, you're gonna have some distortions. But so flat maps are definitely more useful, but you have to recognize that there's gonna be some distortions.
That's distorted anyway.
Unverifiable distortions.
Exactly. So, at least present a 3D undistorted map. That
Yeah, I
would be
did.
handy.
No, the one
No,
that
you
I posted is undistorted.
No.
Which part is distorted? Which part do you disagree with?
And it's definitely not 3D. Like it looks just like a basketball with.
Wait a second. What's
it's
not 3D about it?
put on
It's a sphere.
that. Well, I've seen better globes. I've seen the real 3D globes that have like the little
Oh,
mountains
come
and all
on.
that sort of stuff. Right now, they're cool, Ed. You got to admit that those ones are pretty cool.
The
Well,
mother of pearl.
all surfaces are 2D.
They've-
All surfaces, like that ball is 3D, but surfaces are 2D.
Yeah.
And that one that I posted has raised relief for mountains and things, so it is definitely 3D.
Oh, they just put in little
That's
bumps.
just topography. Come on. Don't go there,
I don't
bowling.
believe that map is accurate in the southern hemisphere.
I believe it
Is
is.
that the-
Over the
is that percent?
huge bodies.
Do you
of
have an
water. I
example?
don't believe they did that properly.
Of where is it inaccurate?
Matches
Over the
flights
oceans.
and everything.
Just quickly, percent. Can you read Arabic by any chance?
I can.
You can. Oh, cool, man. I'm gonna send you something, buddy. And I don't know if it is Arabic, so don't shoot me. I'm making a presumption.
It's Egyptian hieroglyphics.
Italian.
Exactly. So I'm going to send you something, mate. If it says, where are you? Okay, you should have it now, mate.
All right, I'll check.
Cheers, bud. Thank you. Don't reveal what the plans. Exactly. A Christmas decoration.
What the hell is that?
Is that the stereographic thing? Sideways or something?
This is interesting. That's all.
It looked interesting, mate, when I first came across it, to be honest with you. And then I thought, oh, man, if I could only read the rest of it.
So what do you mean? Oh, like where it came from, basically.
Oh, just everything about it. I just found it interesting. There's a front half to it as well, that I found. Let me see if I can, because that's on the back of something else. Let me see if I can. It was on the back of. And I'll send that to you as well.
Well, the translation is accurate enough.
So I'll take this screenshot. Send. And that photo that I just sent you, it's on the back of that.
But yo, Bansa. So I haven't seen
Yeah,
the
mate.
second thing that you sent, but from the first thing, what kind of stands out for me when I'm like reading the Arabic is that it doesn't say in that, in the preamble flat, but it does in English translation. So I haven't read the rest, but just
Right.
something to be wary of.
Yep.
It says like the first sentence says, "Oh, sorry. Did you want me to spill the beans or what?"
Sure, it's okay. You can
Basically it just says simple instead of flat.
Right. Okay. Yep. You know how I came across that percent?
I'm curious.
Yeah, I put into Google definition of flat water, right? Anyway, I was just bored, and anyway, you know how you go down the bottom of Google and it says you got like 522 million hits. So I just went to page 20, then I went to page 50, then I went to page like 79. And I'm just scrolling down and looking at the search results there to see if I could just find anything obscure. I think Druss was in at the time wanting something, so I thought I'd try and find something obscure for him. And I came across that, actually. I thought, oh, damn, this is interesting.
Yeah, how about that?
But yeah, it had that that picture that I sent you is the map, which if you look at it, it doesn't look like much of a map. It looks more like a compass more than anything, to be honest with you. And yeah, that writing was on the back of it. But obviously the only thing that I could understand was the English on the left hand side of that article. And then I scroll over, I'm going, oh, I wonder what all that is. Like it sounds interesting actually.
I guess in
Bandy,
Arabic
it'd
then.
be un-Australian to understand any more than that, mate. Good work.
Yeah.
I was gonna say because like in the map they're very kind of explicit about flat. So I'm guessing in Arabic either it's poor translation or basit, they use the word simple as like colloquially as flat.
Right. Yeah. Yep.
And they're not wrong because flat Earth is much simpler than a glob.
Yeah.
Rotating through space.
Like if you read the English in it, it says the theory of the round and floating Earth is false, and you should not believe in it. I like that sentence. And he looks like quite a learned kind of fellow too. All dapper in his suit and his tie.
I just don't get why someone hasn't fully shown curvature with like a 2 mile fucking horizontal fucking structure of some description. Well, I just don't get it. If someone can do a daisy chain and maintain a tangent, like a true horizontal from a singular point, and extend that out, why the fuck can't they show us actual drop from horizontal? What's the problem?
There is no problem. Just look at this map.
Look at the map, it's all there.
Yeah, look at this pretty picture that I drew.
You know, they're bloody talking about Coriolis before and trying to invoke rotation and all this shit. Just prove curvature, because if it's fucking curved and it's an actual ball, then I'm going to lean towards that it's got to be spinning. Otherwise, how does it just sit in there stationary of sphere? That just sounds even more fucked than a rotating one. So I just don't get it. I really don't.
I wouldn't lean to it. It's spinning.
No.
That's just me.
And this fellow, he divides the Earth into 5 different zones. The first zone is the north center, which is dark for 6 months and is lightened for 6 months. Sometimes in the future, there will be some explorer who will cross it. Second, the north temperate zone is the most desirable to live in. The most industrious and the most powerful nations inhabit this zone. Third, the torrid zone, tropics, is hot daily as the sun is always over. The sun's body does not move out of the zone to a very great extent. Fourth, the south temperate zone has about the same climate as the north temperate zone. And the fifth, the South Circle, is a dark and icy like north center, but no man can ever cross this circle, as it is the edge of the earth and is dangerous to live.
Nice. So I suppose we're back to the age old, but we really need to show where the water level is fucking if water level can actually show a horizontal.
Oh, it does.
Then
don't be silly.
Yeah, well, no, come on. But we should be able to go down the beach and daisy chain some water levels and create a tangent to this fucking apparent circle, and have some clear drop just over a really short distance. Like, it should be noticeable with a water level mark. Over very short
How
distance.
short of a distance do you propose?
Well, I know at 5 kilometers, for example, there's basically 2 meters of drop. So if you want to bring it back from 5 kilometers to like 3 kilometers or like 2 miles, like I said, you're looking at like a good 30 centimeters or something like that, you know, a foot.
You'd be better off doing it at a dam or a lake, I think, White, rather than the beach.
Oh, yeah. Any standing body of water where you can get a water level reference, definitely.
Yeah.
And like with lakes, you do have to be careful because if they're shallow and there's a bit of a breeze, they can be quite influenced. But yeah, aside from all of those things, yeah, I just don't understand why they haven't done it. Like even a surveyor should just be able to go out and put a horizontal from his station A that's plumb and not project that out, but literally like daisy chain it
Well,
out.
look, people have done it, like Rukia. He's done it himself, and he proclaims it was the hardest day's work that he's ever done trying to produce a horizontal line in 3D space.
Oh sure, but Bandy, go on.
Yeah, but the kickback he gets, right? Which obviously I don't agree with the kickback, right? But he never created a horizontal plane. He created a curved plane, right? And that's what they tell him. A fellow that uses these tools every single day, that he just doesn't understand how to use them, and yet I've never heard them say, this is how you should have done it. They just say, you've done it wrong.
Yeah.
And these are people that sit on their bums in front of a computer and have never used any of these things and tell him that he's done it wrong.
Yeah, but I mean, if he literally didn't re-establish Plum, then he can't have done it wrong. If he's obviously re-established Plum every step of the way, then he's made the curve, apparently, if it's a ball. But, I mean, that should be quite simple for him to verify, that he never re-established a Plum and tried to go off that original point.
How did he make a curved plane? Andy?
Sorry, how would you measure a curved plane?
Well, that's what they say. They say that he made a curved plane?
Yes.
What, like,
That's what
optically?
they say that he did.
But
No. Every time he moved his tool, Jerry, that established a new plumb, so a new horizontal from every single point. But
bunch of
because
shit.
he did daisy chain it, but he did daisy chain it, and he did cross-reference it, everything with all the other points that he made all the way along. Okay, and he ended up by the end of his, I think he did it over about 2.5 mile, Jerry.
Yeah.
And he said, he did say by the end of it, his error margin did get a little bit greater, but the error margin that he got was well under the curve that should have been there. It was well under. Yeah.
Ah.
So, but I've heard Blue, I've heard many of people just tell him that he doesn't know how to use the tool and he just doesn't know what he's doing. And this obviously is a fellow that runs a very successful business, uses them all the time himself. He employs surveyors all the time to do these things for him as well. So, I reckon he's got a pretty good idea about how to use the tools. I've
Out of
only
curiosity,
used them myself
Bendy.
over very short distances myself. Yeah, mate.
How long do you think it would take us if we had, like, let's just say a 200 meter, or fuck it, a 100 meter fucking water line, like water level, proper water level tube, to do 2 or 3 kilometers down a body of water? Like, fuck, hell, half a day.
Oh, You know what?
We're just walking past each other, aren't we? We're just marking. We're marking where the water gets to in the level, and then we're just walking past each other, one after the other, until we've walked 2
pretty
kilometers.
much. Yeah, but you're going to get the same objection that every time you move, you are creating a new plumb and a new horizontal. So in theory, you are going to be creating a curved plane. That will be the argument every single time. So if you were to do it in sections, you are actually creating a curved line. That's what the argument will be, right?
Oh, sure.
So what you need, what you need to actually get, what would be better? You know those IBCs.
Yeah.
Yep. If you were to get one of those, and you were to say get 1.5 kilometers or 2 kilometers of flexible hose, okay, and hook it up to one of those IBCs on the back of your ute and have it parked somewhere, and then just walk along, and the ute doesn't move at all, right? Boom, 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 all the way along. That would be a better way of doing it. You see what
No, come again with that one. I've
So
got
if you get
an
an
IBC
IBC
in the back of the ute, full of
back
water.
of the ute, yeah, and you attach 1.5 kilometers or 2 kilometers worth of flexible hose to it. So you fill up the hose with all the water.
Yep.
So your main reservoir does not move. It's in one fixed spot. And then you start at your first stake, then go to your second stake, your third stake. You can have 200 different stakes all the way along. Bang, 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 bang.
The water level you're talking about.
Yes, exactly. Yeah. So then you're only ever moving one end of that water level, not both ends.
Okay.
You see
You're
what
aware,
I'm saying?
you're aware
David,
that
isn't
you're
it still
using
the same
water.
issue at the end of the day to verify that?
Yeah, you're aware that you're using water to confirm whether or not the surface of the Earth has curvature. Water would.
No, but what I was trying
to
to point out was the discrepancy between what a surveyor should be able to do with regards to a tangent, like creating a horizontal projection from a tangent point, and what supposed curving water level is. There should be a discrepancy over a couple of miles.
a water level creates a horizontal between the two read points. That's the only place where that horizontal is valid, is between the two read points.
Yeah, in the center point. But what I'm trying to say is water level, right, obviously curves away, doesn't it, from any point on a sphere. It curves away its suggested fucking rate from that particular point as a reference.
Yeah, to maintain an altitude above sea level, yes.
Yeah.
Right. So
And
we should be able to show that.
Yeah. And if one of your points never moves, doofus, so point A of that water level never moves, right? But you're only moving point B, and you're taking that all the way down the line, it's going to create a perfect horizontal between point A and the very last point, because your point A is never moving.
Right, but the midpoint between those 2 points, point A and point B, will be the only place where that horizontal reference is valid. If you go to the end and sight down from B to A, it's no longer a valid horizontal reference.
Well, you can't sight it, no, optically over that distance, of course. We're moving away from optics.
We're not talking about sighting. Yeah, we're just taking physical measurements. We're not using optics at all. So you're using a physical tool to make a physical measurement that you can then reference another physical measurement to the surface of that water. And that water level will create a perfect horizontal straight line all the way down it if that first point of that water level never moves.
But that's not true, because the
Yeah,
water...
100% it's true. 100% it's true, doofus. 100%. And you are 100% incorrect if you say it's not true.
Right, because the water, you're using the water to demonstrate whether or not the surface is either flat or curved. You realize
No,
that
you are
on both
using the
a flat,
water to create a horizontal line. That's what you're doing.
right? So you realize that on a flat Earth, the horizontal reference that's created would be valid everywhere, but on a curved Earth, that horizontal reference is only horizontal between those two read points. So if you move point B, where that horizontal is valid changes.
The horizontal is between point A and point B. And that level will always remain constant, right? That level will never change if that point A never moves. It'll stay in a constant place, and you can move point B wherever you want, and point B will be horizontal to point A every single day of the week. Every single day of the week. Now, if you move point A, or you drive that car, and now you move the level of that initial water source, now you are going to create a secondary horizontal. But if you don't move the source, if you don't move the source of point A, the ute where that IBC will be, it doesn't matter where you move point B to, it will always be horizontal to point A. Always. It'll
All right,
never be on a different plane.
All right, let
Yeah,
me
he's still going to claim that between any 2 points of that is the only true horizontal point, because he has to assume that the Earth is curved.
Right, and the point of this measurement is to determine whether that's true. So in order to disprove that, the problem that you have to address is that only the exact midpoint, the spot that's right between A and B, that's the only point where that horizontal reference is valid. It's not valid at A, it's not valid at B, it's valid in the point between A and B.
No.
Assumed to be on a sphere.
Yeah, it's valid between the 2 points. If you were to draw a line between those
No, not
two
between the 2 points, at the midpoint.
No, if you were to draw a line between those 2 points of a water level, right, regardless on a globe or flat, if you were to draw a line, right, it would be perfectly horizontal. Perfectly horizontal.
That would be false on a globe.
No, it would not.
Yes,
No, it would
From the
not.
midpoint.
No,
From the midpoint it would be, but other than that.
No, White, you're incorrect. You are incorrect
How,
too.
Bandy?
Because
How?
on a globe, the point A and point B, if you draw a straight line between those two things, it will read horizontal. You are not going to get a gradient. You are not going to get a slope at all. It will read perfectly horizontal.
It'll read linear, but not horizontal from each end point.
It would be like White. It would be like cutting a cord. That's what it would be like, cutting a cord through the earth. So the line on a globe between A and B would be horizontal. So it doesn't matter if it's globe or flat. That line will still be horizontal.
Right. The point.
Yeah, but only again to that down
A,
vector that's actually perpendicular.
The point,
how they
point
define
A
horizontal on the globe.
and the point B, the point A and the point B are two endpoints of a line. That part is correct. That line that is created is a horizontal reference that is only valid at the midpoint directly between points A and B. That's the only place where that horizontal reference is valid.
No, it's
Assumed
not.
to be.
No, it's not. If you were to put a straight edge on point A and point B,
Yes,
and
you're
put
making a
spirit
line.
level
I
on
understand you're making a line.
it would read
We all
horizontal.
understand that you're making a line.
It would read horizontal. It is not valid at the midpoint. It's valid at the two endpoints. That's where it's going to be horizontal.
Bandy, it would be a flat, straight line, but
Okay.
if it's a globe, it would be only horizontal over the tangent point, which would be in the center.
Yeah, if you're going to argue about what it says the globe would do, The very midpoint is the only place where that horizontal line, yes, I know it's a line, that's the only place where that horizontal reference is valid.
The horizontal reference is between the two. We're not creating a tangent, right? We haven't created a tangent. We've
You
created a
kinda are.
chord. No, we haven't.
You
It's a
have at the
chord.
midpoint.
If anything, it's a chord. If anything.
Yeah, but it's
Right, which is
perpendicular to the
horizontal.
radius, which is
And
still
it's
essentially a tangent of a smaller circle.
It is
Yeah, and it's
horizontal
parallel.
between the 2 points. You guys are insane. You're insane,
Yeah, the
White, to say that it's
chord that
horizontal.
you've created, the chord that you've created is parallel to a horizontal reference only at the midpoint if we're talking about a globe.
It is horizontal between the 2 points. And to say that it's not horizontal between point A and point B is just ludicrous.
It's just
Only
terminology,
directly
because if
between.
I'm
It's
standing
the
in the middle of
midpoint.
that line and putting my arms out perpendicular to myself,
Oh,
I'm creating a horizontal reference point out to your watermarks, right?
you
But if I
guys,
step away from that, I'm tipping over, aren't I, Bandy, on a ball?
you guys
But down is not the
gaslighting.
same direction. No, down is not the
they're
same
not.
direction on a globe.
When you say horizontal with a globe model, Bandy, what they're saying is true.
No, the line between the 2 points A and B is perfectly horizontal. It's perfectly horizontal. Now,
Okay,
to create a horizontal on your globe, now that spirit level has to be higher than that line. And I have to find the exact midpoint and balance it perfectly to get my horizontal, which I don't have to do because I've got a perfect straight line between those 2 points. And I can put a spirit level on those and it'll read perfectly horizontal. That line between those 2 points will be perfectly horizontal.
I think
Stop it, White. Stop it. Stop it.
No, I
I'm going to
think
block you.
I think
I'm
what
going
we
to
need
block
to get back to doing is, because this guy's claiming that yes, we're trying to use water to prove that it's curving and water's supposedly curving, so it's a bit of a redundant thing. I agree, but the point is we should be able to have a reference point of true horizontal, a tangent, to then measure the drop of water from that at that point. Now,
well then,
I would postulate that why can't we build a structure, just like theoretically, that's say 2 kilometers long, that is truly horizontal from a tangent point, and then observe the drop in water, like do it next to a body of water, from the original tangent point. Like, is that not possible to do?
well, apparently we can't do it with a water level, can we?
You
No,
can do it
but
with water level.
that's the reference.
He's wrong to say that you can't use water to judge water. You can. The issue is how you're feasibly going to do it. Because, like, let's say you had this really long water level, this really long tube, right? And you were underwater, or you were just like right at the surface of the water, and you were holding it just like right underneath the surface of the water. You would, at the midpoint, have a difference between this level water and this straight line that this water level is creating. The issue is how are you going to optically compare the front and the end of this really long tube? You know, it's
Right,
more
at that point you're not using water to compare water, you're using an optical observation to compare against
That's
that
why I
water.
said we need a physical structure.
Well,
Physical
everything's
structure that's
optical.
horizontal.
If you wanted to do it the way that they do it today, these days, they use GPS to do this. They use ECEF coordinates, ECEF, and that will give you a line, a straight line. But of course, that requires the use of technology that you guys don't like.
No, it's not about that. It's still the assumption that it's curved, and on any practical level, it's not required. So it's not technology at all.
The ECEF coordinates are completely, as you would say, Cartesian coordinates. They're just standard 3-dimensional coordinates. They don't assume anything about the shape of the Earth. The Earth just happens to be in those coordinates. So if you
can't
use those
verify that,
coordinates,
neither can I.
you can. That's why there are GPS.
But But
software-defined radios that you can use to download
know
the
what-
data.
Do you know what
and
we could
figure all
both
that
do?
out.
We could go down to a physical structure that was built from a point A at a tangent 2 miles long and see how when the tide comes in or something, that it touches at one end and is clearly below at the other end. We could do that, couldn't we?
I mean, how are you verifying that that's the problem that you're starting to try and come up with? Is you can't use water to do that. You want to
No, hang on.
not use optics.
Right. Are you suggesting that surveyors couldn't make a horizontal structure from a single point reference? Are you honestly saying that?
They do that today with GPS and ECEF coordinates.
Oh, apparently to get a perfect straight line using any GPS surveying equipment, you got to do all these crazy calculations, right, to take into consideration the Earth curvature, so you can get your perfect horizontal line, which is just absolutely insane to start off with. To even have to go to those kind of lengths when you can just quite easily do it with a very simple water level. Very simply.
See, everything needs to be curving except light. That's how they prove the glob. They assume light goes straight and then just calculate for the radius when they're, doing their little surveying.
Jerry, you know that we don't actually say that light is always going perfectly straight. You already know this. I know that you know this.
Yeah.
Just build a structure. It would be an attraction. People would come to see it because it would show water clearly drops. Like, come on. What's wrong with people?
LIGO sort of does that.
Oh my God, it does not. You can't go down there with your own self and walk along it and go, oh, look. Yep, clearly something's going on. It's all calculated and mystified. You're not allowed on the premises. Come on, you know this. I'm talking about things that anyone can do. Sure.
Two ones down the back, sticky bait with it. That would be great.
Both of them?
Yeah.
My pleasure.
Yeah, I was talking to some guy this morning about the Eratosthenes thing, and I said, it's a bunch of nonsense. I said, I want something I could do where I don't have to assume anything about how light works or nothing. He said, okay, fine, just do this. Just get your shadows, and you'll see that the line goes all the way to the sun. Okay. I said, all right, I'll wait until sunrise, and I will put 2 sticks next to each other. And then I'm going to look for these rays that go from the top of the stick all the way to the sun. He said, yeah. I said, okay. So sunrise came. I said, dude, where are these sun rays? He said, well, just look at the shadow. I said, no, what are you talking about? Where's the ray? I don't know what's going on with these lines of light. As soon as that shadow ends, that's where all the guesswork and the magic happens for any model you want.
I still am perplexed, Jerry, that apparently whatever I see, the light bounces off what I see, projects that image through whatever it projects it through into my eye. Now, if I look at something, if I move like a little bit to the left or a little bit to the right, why don't I see this long, elongated image that's kind of all the way in front of me? If you know what I mean, like this holographic sort of thing that's all the way in front of me, in the air in front of me. If it's projecting its way all the way to me.
You do. You do.
I
Sometimes
do.
it's clearer. Sometimes it's clearer than other times. Yeah.
I do. I see this holographic kind of image that is in the air
Well,
in front of me. Oh, okay.
That's what I would call it. I mean, if it's really close to you, you can't see the effects very much. But the further things get away and bring in other atmospherics, yeah, it can look somewhat holographic. Definitely. Look at that.
Yeah, but that hologram should be from the olive tree all the way to my eye and have all that depth between my eye and the image itself.
Well,
seeing as it's
if you're trying to,
it's traveling through the air because it's bounced off the olive tree, and now that image is traveling through the air towards my eyeball. That image should be like from my eyeball all the way to the olive tree.
yeah, but you've got to remember, according to the narrative, there's only like one particle coming in at a time. See, I can't like, they're coming in consecutively, and it's not having all 10. Let's just say there's 10 of them coming in a row, one after the other. It doesn't see all 10 at once. It's only one. So I can only ever keep adjusting that image, which is why I was going to say before that time lapse photo of Skunk Bay, is it, or some shit that I think Travis did or someone did, and it just floats up. All that to me is almost holographic. The way it moves around and stretches and bends, and wouldn't you agree with that?
Yeah, but the image is there. The image is going up and down. I definitely agree with you, White. Right? The image is going up and down. You can see it going up and down. But the image that you're looking at is where it's at. Like it hasn't projected itself through the air to me in some elongated holographic kind of picture. Because you don't see that. You only see the image where the image is. Like it hasn't transported its way to me in any way, shape, or form as an image between me and it.
Okay, so you say that you're just looking at it, but if we know that what we're looking at isn't where it physically is because of refraction, what is it that you're looking at, Bandy?
Because that image has been either projected up, down, left, or right, where it is in that space where it is.
Right. So you're looking at the light that's come from it.
No, you're looking at you're looking at an image that has been mirrored off the atmosphere that is around it. So all those particles, right, that are around it have a mirror image on it. Okay, and that's what you see. You see that image that are on those particles around it.
But how does that image get to your eye?
Well, because you're looking at a reflection, but so you see the reflection on those particles where it is. Okay,
gas molecules or water? What particles?
Well, whatever particles are there, whether it's gas,
I want to get
water, soot. You know what I mean? Any of those particles that are in the atmosphere that is there. But you know, I would tend to say that it's water of some sort. They're probably a bit more reflective, but they could be gas. I don't know. But whatever those particles are, that is they are acting like a mirror. Okay, and that's what you see. Right, so all those little mirrors there, that image is being reflected onto those particles, and you see the image where those particles are. Right, that image hasn't then transported itself from there to you. You see it exactly where it is.
Exactly where the image is.
Yes, yes. The image hasn't transported itself to you through
But it has
light.
transported itself from the thing to the air around you to look at.
Sorry, say that
So,
again. You dropped out a bit for
but
me.
it has transported itself to the air around you to look at, to observe.
No. It hasn't transported itself to the air around me. No, not at all. The image is where the image is. The image doesn't move. So the image has been reflected onto whatever particles are there, water particles, gas particles, whatever particles are there. It's reflected itself. So just imagine, just imagine you're looking at something in the distance, right, that you can't see, right? It's behind a hill, for argument's sake. And if I get a mirror, right, and stand above it and angle it a certain way, right, you'll be able to see you'll be able to see that thing that's behind the hill, but you'll see it on the mirror. Okay. Now that hasn't then transported its way via light, projecting itself all the way to my eyeball. I'm just seeing it exactly where it is.
Okay, I just have the disconnect about how it's happening. You've got the laser beam eyes going, I see again.
Laser beam eyes, do I? Okay.
Yeah, where your eyes project something out to see things as opposed to the light coming into your eye.
No. My eyes aren't projecting anything out of them at all. No, my eyes aren't projecting anything out of them. I just see an image. My eyes just see what's in front of it. Okay.
Okay, so you've got no explanation for that. You're just running with I just see. That's cool.
Well, kind of. Yeah, kind of. I'm running with I see because I can see. Okay, I get that. Now, the mechanism of how my eyeballs work through the rods and cones and all that sort of stuff, I've got absolutely no idea how that mechanism works to then tell my brain that I'm seeing that olive tree. But I see the olive tree where I see it, right? That olive tree isn't being transported by light to my eyeball. I don't see that happening at all. All I see is me seeing the image of where it is. And now that image itself will be distorted or reflected or whatever it is on the actual molecules and gas particles, water molecules that are there around it, above it, next to it, behind it, wherever. Just like a mirror.
All right, then. What happens if we take away the light bandy? There's still the particles, all the air, the moisture, but we take away the light. Why don't we see things anymore if it's just reflecting? What is it about light that's doing the reflecting?
Sorry, mate. What was that?
What is it about light that's doing the reflecting for us to see things off of the particles and the air? Because if we take away light, we can't see anything. So what is it about light that causes us to see the reflection?
Well, the light itself just illuminates things. Right? So we're in light now, aren't we? Right now, that's different to being in a spotlight or a laser light where we can actually direct the light itself. But the light per se does have reflective properties about it. Like you can get a mirror, right, and you can shine it and angle it, and you can bounce light off it. Okay, we can do that with light. We know that we can do this with light, but that surface, that reflective surface, also too has the ability to show us an image because it is reflective, right, by nature. So because it is reflective, and because that thing And because that is illuminated, we can see that image because it is illuminated, and thus we can see the reflection.
Pray tell, how are things illuminated, Bandy?
By light. Hello.
I love this circle.
That was hilarious.
You open your eyes and you see things. I love it.
You guys are fucking funny.
We can dance all day.
Hey, I got a question.
It's quite
Please.
simple, really. You got to make it so complicated.
Yeah.
Don't get simpler than the flat Earth, I tell you that. But I tell you this much too. I meant that as a compliment, by the way. I say this as well. I was listening to Lemon earlier, and I was getting aroused, to be honest with you. But that's not the point. The point is, I was listening to him, and he was talking with Lori, I believe. And what are you guys talking about right now, by the way? Because I don't want to interrupt. But about reflections and something like that.
It was important stuff.
You said what?
It was important stuff.
Yeah, no, I feel like a douchebag now. But probably appropriate. Regardless, I don't know. I don't know if you were listening to Lori's and Lemon's discussion, but it got me thinking about a lot of things because Lori had a picture of I'll show you Lori's picture. He posted this picture. I gotta fucking pull it up and find it. Doesn't matter. Let me I'm just gonna post this picture and pretend it was his. Hold on. Kind of looks like it, anyways. Yeah, this is it. But you see this picture? This is Lori's picture he posted, and it looks like it's the sun on the equator, right? During the I don't know, equinox or something like that, right? Anyways, I was noticing the distance of that equator that the sunlight is actually reaching, and it looks like it's like, I don't know, somewhere below halfway. But it kind of bothered me because I know everywhere on the equator, every single day of the year, they get 12 hours of between sunrise and sunset. So this was bothering me. I don't know if you guys noticed that.
Don't let it bother you too much, mate. Don't stress
Well,
over shit like that.
I sleep over that kind of shit, dude. Okay.
Look, if you're going to be doing such things, you probably need an accurate map to do it on.
Yeah, no, that's what I was thinking, but I didn't want to say anything. But that's what I was thinking, because I was saying, yeah, if it was 12 hours on and off, it would look more like this. But I was like, that can't be possible. They don't have 24-hour fucking daylight in England on the equinox, or ever for that matter. So I was really confused. You know what I mean? Because this is what 12 hours and 12 hours looks like. But yeah, you're right. I need an accurate map.
Well,
where do I get that, dude?
You have to make one. Make one.
I have to fucking make it?
We'd need to know if there's curvature first, wouldn't you?
Yeah, you want to.
Yeah, I do fucking want it. Listen, dude.
Okay,
You guys fucking do shit in Australia? I'm like, hey, I'm here to fucking buy some food. Can I get some rice and some chicken? You're like, oh yeah, you want it? You gotta fucking make it.
Yeah.
What the fuck?
Exactly. You want a sandwich? You know where the fridge is? Help yourself.
I'm coming to you, dude.
It's like, you want a map? You know where the pen and paper is? Make it yourself.
I'll tell you right now, if I make a map, I'm gonna show it to you, and you're not gonna agree with it, dude.
Well, probably because you'll do it wrong. I'm gathering.
Probably because I won't make it at all. I'll use the one that you already use, and you will tell me it's not the right map.
Well, base it off the Gregories or the Melways. That would be my starting point.
The Gregories?
Or the Melways. MELWAY.
Okay. Well, I can make
So
shit up too, and
I didn't make anything up. These are right authenticated maps that are very reliable and very accurate. Kosho, very accurate.
do you think Google Earth is accurate?
Nowhere near as accurate as the Meltways.
Really, nowhere near as accurate. Wow.
No.
Because I never seen Ranty use Melways when he's fucking showing some shit. I never.
Well, look, and that's and we know that Ranty fell short. But if he had used the Melways, he probably would have been on a winner. But I know I keep on throwing it out there. Use the Melways, and you won't have a problem. You will get from point A to point B with no problem whatsoever.
So what is a Millway? What is this Millway's system?
It's like the Gregories. It's a map.
He's making it up on the spot, dude. Listen to him. It's like the other one I made up. Yeah.
He's not making it up.
Google Melways, Kosho. I am not making it up at all.
Yeah, this guy.
Kosho, did you make these pictures?
Cannot believe
I made the other one. Lori made one of them. I made the bottom one. The top one is the one Lori made. It shows this sunlight map, I guess on the equinox or something. I don't know what it's supposed to show, but the one I posted is the accurate depiction of what the sun would be doing on the equinox or any
daylight. Is that daylight times or visible sun times?
Right.
Daylight times.
Right.
Okay. And the one on the bottom is what span is the one on the bottom?
Well, the way I made it was I just made a circle around the sun, and I just made it so that there was always 12 hours on and off on the equator. So for everywhere on the equator, they're going to receive exactly 12 hours of sun and then 12 hours of no sun. So
that's how many hours on the top picture?
Say what? How many hours on the top picture? It looks like I can't tell you exactly, but I drew a black line to. I mean, it looks like substantially less.
We can't eyeball that though.
Have
you ever done this on the Gleason?
Say what?
Have you done this on the Gleason? I'm only asking that because the Gleason at least makes claims of scale and measurement and stuff.
Wait, what's the difference between this one and a Gleason?
This is just a random picture. It's a cartoon. The Gleason makes claims of measurements and scale.
I thought this did too. Let me see.
It just looks like a picture to me.
No, like an AE map, but it's saying a Gleason map and the AE map.
Generally speaking, it looks just like the Gleason too. So, generally speaking, yeah. But I mean, the Gleason is at least it's not a claimed flat Earth map. It's just the azimuthal, but it's at least claiming measurements and stuff. So I was thinking if you're doing these spans and stuff, you would at least be able to scale it and stuff on there.
Fair enough. I just always thought that they were the same thing, but I'm not 100. If they're not, then I didn't know.
Probably close. But
eyeball-wise,
eyeballing it, they look the same to me. But I'm just saying.
I understand. Yeah. Let me see. I'm trying to find a good version of it because I see the one with the red border. That's always the one that I see.
It's because I personally want to see coherent data like this as actual measurements.
All right. You want to use the accurate ones, yeah.
The map, I don't think anybody claims that the Gleason or this map is 100% accurate. So I think everybody wants to get to the bottom of what it really is.
Absolutely.
So we need to know if it's curving first.
Well, I don't know if that needs to be first, to be honest with you, but I think all the information is sort of relevant. But you guys ever played GTA, Grand Theft Auto?
I've seen people play it. That's past my time when I was into video games.
I got you, but you kind of have to. You kind of have to be into it to know what I mean. But when you play GTA, the only map that you have awareness of is wherever you've have whatever you've experienced or whatever in the game. And so as you
Whatever's been rendered.
Well, no. Because in the newer versions, they can render a whole bunch of it faster. But I'm just saying, like, if you just start out in the game, the map will be blurry everywhere you haven't been yet. It'll just show you where you've been, and you know on your little map in the corner. But as you learn more of the map, like all the map will kind of be apparent or whatever. And I just figure that the same sort of thing should be available in reality, right? Like we all have access to, you know, little parts of the earth or whatever, but between all of us, you know, we have knowledge of close to the whole thing.
You have
So
to have
we can at least
coherent
get that
data
much
sets,
down.
though. You have to have coherent data sets, and you can't just have a random people all claiming separate data. Like Google, for example, would be able. I bet you Google has the data to be able to make an accurate map. We don't have access to that data. So if we don't trust Google, how are we going to get that data from one source to where it's not just random people? We can't piece together random people's data, right?
You
We can trust the data.
You
can
actually,
trust
I
it.
mean,
Just
there is actually a good single source, like Bansal was saying that. I actually looked it up. Did you Google it yet, Kosher? The mailways that will get you from place to place accurately.
His friend Gregory, you want to call up his friend Gregory and look at his map? Bansal's fucking with us, dude.
I am not. What the fuck, Kosho? Seriously.
I don't know.
Yeah, Mailway online. Look at it. Gives you all the data.
The melroseplace.com. All right, hold on.
Mailway. The mailways.
That's Bansal's website for you, the mailway.com.
easy.
I'll just mess with you, Bansal. It sounds like a good good website.
Can't believe you didn't.
I'm only picking on you because you're my buddy, man, you know? Not the same reason you pick on me.
We then have to
Don't confirm your
confirm
beliefs.
data of the daylight
It's all
times.
flat.
What would you say, sir?
We would have to confirm the daylight times as well.
Oh, that's
all the data.
That's, I mean, you don't have to trust what I'm about to say, but it's a truth. That's absolutely certain. That's kind of one of the certainties of what makes that place at the equator. There's a couple things. One is that the sun travels along it on the equinox, but the other thing is, unlike any place else in the world, it's the only place that has every single day is 12 hours on, 12 hours off, give or take 8 minutes.
Yeah.
I say give or take 8 minutes. I mean just because it's always 12:08 sun and 11:52 no sun. Hold on 1 second. Let me see.
How come it's not 50-50 all the time?
Say what? Say that one more time.
How come the daylight isn't 50% of the Earth?
Oh, it's a slightly more than 50.
Why does that amount change? I mean,
say it once more.
Why does that amount change on the globe? I just can't recall.
Why doesn't it change? You're saying?
Why does it change?
It doesn't change.
No, yeah, it's like that consistently. 12:08 and 11:52. Yeah.
So it's good to see we have a new convert in white to how we see things. It's good to see that he gets it and he's all over it.
Definitely. You can't argue with we see because we see. That's foolproof.
I don't believe that.
I'm down.
He's down.
I mean, I'm seeing right now. Glorious day.
Speak for yourself, dude.
Kosho's
absolutely glorious day today.
Cannot defeat logic.
Sure, you can. You can just.
He tries to bamboozle you with lots of fancy numbers and stuff. I'm on the Kosho.
What were you saying, Brenda?
You can defeat.
Oh
shit, she's there.
You're really low, Brenda. Sorry if I overtalk.
Not as low as band size.
Really?
You can deny.
You're sort of coming through like this through this.
Yeah.
Band size worse.
Coming through really dirty, Brenda.
You wish.
I thought maybe it was the connection. Is it improved?
Yeah,
Not really, Brenda. No, not really. Have you got like earphones in or Wi-Fi buds or something?
No, I don't.
Yes, right.
The choppiness is better, but yeah, still needs to be a bit louder.
Let me see. I'll turn you up. That'll help me.
Yo, what are you guys talking about?
You?
Oh, yet.
No, you're not.
I've been listening to trying to figure it out, and I'm not quite sure what they're talking about.
Just random. I want to go back to the cannon from the equator. Let's just say we shoot it north and shoot it south. Now, on a ball, obviously, it's going to be the same discrepancy, but we should see the opposite effect because we've turned around. But if it's a flat area and it's stationary, and let's just say Coriolis is still observed over the flat plane, and it's because of the ether or whatever rotating above the flat plane, then shooting the cannon south would be a very different effect to shooting the cannon north from the equator on a flat plane. So there is a point to doing it at the equator, definitely, as opposed to anywhere else.
Yeah, I'd be happy if they did that anywhere.
The circles keep getting bigger on a flat plane from the equator out, don't they? As opposed to a ball, they go back smaller again. So it's the one place from the equator where we can actually observe a direct difference between the two models if we were to shoot a cannon north and south.
Oh, yeah, that's true.
A cannonball won't deviate at all on a flat Earth.
Well, hang on. On a flat Earth, if there's still Coriolis, i.e. the ether rotating, and it has an effect on things, there would still be a deviation or apparent deviation from a different reference point.
Only if the disk is rotating.
The ether's moving the bowling ball?
Yeah, there's no such thing as ether.
If there's, yeah, we know that. That's up for debate. No one's saying there is ether. It's just the thought experiment.
So on a flat Earth, if you shoot a cannonball, it won't deviate unless the Earth flat disk is rotating, like a record player.
Yeah, it won't appear to, like the true Coriolis, but if the ether is truly moving and it has an effect on objects and they move, we may see what appears to be an apparent deviation. That's all I'm trying to get at. But even if we do, north and south from the equator would be different on a flat plane versus a globe.
No.
Who's saying objects?
Those are some big buds and babies, man.
They're saying light. They're saying light's being carried by ether, not objects.
Yeah.
Like, how does if the ether affects objects, it should be affecting us right now, but we never detect it. So this whole
God, how do you know it's not affecting you right now?
Moves objects.
This whole ether causing Coriolis thing, like that's
Okay, so in the flat Earth, what's moving the not the Cavendish, the fucking focal pendulum? All right, if that truly deviates, what's moving it if we're stationary?
Well, that refutes.
It's proposed to be the ether vortex.
No, there's no ether. There's no ether.
No, well, I'm not saying there is. I'm saying it's proposed to be.
Well, here's the thing. There's a variable you got to control for, because how long is that rope in the focal pendulum? I call it folklore because it's funny. But how long is it? 50 feet? Well, there is 100 volts potential per meter in the zenith.
Yeah, we're not trying to talk about what else there could be. I'm just purely talking about the Earth, the fucking equator experiment with the cannon, and why being at the equator is the best spot to do it if you could shoot at a decent distance, north versus south, on a turret.
Yeah,
we could actually see some differences.
I was just adding to the pendulum.
On
You know what?
Yeah, no, fine.
On a
I think it might be quite similar because you've got like an electric effect, right? Because the sun moves around. You know, it does one rotation per day, one lap, so, and you've got like temperature heating up in front of it and cooling down behind it, and so that's dragging the you know, you've got air rushing in to fill the void and air pressure increasing in front of it. So you've got this electric effect of charged particles. Like let's say that's the sun's past noon, right? And you're looking north from the south of the equator. So the sun's moved to the left, and then you've got this this surge of air following it to the left. So you've got like a, I don't know, it might even be a backwards effect because you've got the dissipation of heat. So you know, so you'd have charged particles on the left and discharge on the right. So you've got this flow of this electric flow, and if you've got something that's traveling really fast through all that matter, surely there's got to be more charge on one side than the other.
So
what does that have to do with Coriolis, though?
I don't know.
Well, I mean, the only way that Coriolis effect can be measured or purported to be measured is through ballistics.
No, that's not true.
How else?
All kinds of things. Airplanes.
How?
Footballs.
It's Coriolis.
How would you demonstrate Coriolis with an airplane?
Yeah.
It's drift of 15 degrees an hour.
Prove it.
What do you mean prove it? I mean, it's just a Coriolis is a known physical fact. You can prove it on your kitchen table.
Yeah, we know that bit, but you know what we're getting at, Brendan. You can't prove that it's actually happening underneath our feet. You can't prove it at all. You can extrapolate out, but you can't prove that it's actually happening here.
Well, what I was trying to say before is that on the flat Earth, and given everything what we know about physics, not some other physics, a projectile traveling from the equator to north would not deviate. In fact, it wouldn't deviate in any direction. I mean, unless it's rotating, you won't see Coriolis.
No, we know this. We know this, but for argument's sake, if you're standing at a profile shot, right, or just askew from the cannon's point of view, and it's a stationary Earth, and for argument's sake, there is an ether that has an influence on things, and the actual cannon ball or whatever it is actually deviated, the person in the other reference frame would see it deviating physically. And that might be construed as Coriolis effect, apparent deviation, because the Earth's turning. How would you tell the difference, Brenda?
Ether doesn't talk about only a wind.
Fucking pretend it's real for the argument.
Then I would feel it.
Oh, for fuck. For the exact argument that I just said. Don't answer any other question, just the topic I said.
Yeah, because it's not coherent. If there is a wind, not an ether, you're talking about a wind. I would feel.
No, I'm not talking about a wind. No, not at all.
Well, ether was proposed to be the medium that light travels in, and it doesn't affect anything else. So you're inventing else.
I get that you've got a problem with ether. Let's just go with electrostatic charge. So this projectile is blasting through electrostatic charge field or electrostatic field, and that causes some form of deviation. couldn't that be construed as a apparent drift due to Coriolis?
Well, we would know about such a charge because that charge would be massive. People would die from electrocution if cannon were deviated by such a massive electric charge. And
Okay, so what happens if we did it and there was no deviation, Brenda? Let's just say we go to the equator, we shoot the cannon forward, north, we shoot it south, and there is no deviation.
Yeah, that.
How would you explain that on
question.
a rotating Earth?
Good question.
That can't happen on a rotating Earth.
Well, okay, nice. So we should do it then, shouldn't we? We should go down the equator with a decent cannon and shoot it north and south.
Yeah, you should.
And, like, finish this once and for all, yeah?
Yeah, you could just talk to the British Navy and ask them why they missed their targets.
Well, you could do that, and they'd tell you a story, but none of them have actually ever had to do it.
Well, not
from
only
what I've heard.
Story, the targets that they missed would tell you the story that they missed their targets because they didn't take Coriolis into account.
That's just another story. Let's go to the equator with a cannon and show it.
Well, that would just be another story.
Would it really? Wouldn't there be a video shooting one way and then turning on a turret and shooting the other way and then doing like multiple repeated shots and clearly showing either a deviation or not? Like, wouldn't it be very evident?
No, that would just be a story that you tell somebody else. It's just a story.
Oh, fair enough. I suppose if you're going to really deny shit that's very evident, that's fine.
In fact, we can't know anything because everything's just a story. We can't
What
ever.
if you did it, Brenda?
Oh,
What if you?
Your mum's not your mum.
Yeah, you weren't witness. How do you know?
It's just a story. It's just a story.
Brenda, what if you went and shot the cannon?
It's just it would be a story that I would tell you.
You don't trust yourself.
I love it.
No, it's just a story. Right?
So you personally verifying it's just a story. Okay, got it.
I would tell you about it, and you would say, well, that's just a story.
That's not what I asked you. I said, what if you personally verified that there's no deviation? You shot the cannon. What would you say then?
I would say to somebody else, I shot the cannon, and they would say, that's just a story.
What would you believe then?
Well, I already know that Coriolis is real. It's not a belief. I know it.
Even if you verified it wasn't real, you would still believe it's real. Is that what you're telling me?
Oh, it will never happen. And I know it won't.
It's real, just not on
You didn't understand the question.
Yeah, then
fair enough.
It's
like that, I have a question, like to clarify, because you're talking about Coriolis going in a particular direction, right? So it would have to go in one of those two directions for Coriolis, and then which way? The question is to White's. Which way on the flat Earth would the ether be rotating? If so,
Oh, I've got no idea, mate.
There's
But
no ether.
like on a flat stationary plane, we do see things move above us. So there is movement. So the contention is Coriolis due to well, for starters, we don't actually see Coriolis anywhere on the Earth. It's just something that should happen if it's rotating based on what we see on other rotating surfaces, right? And it doesn't actually have to be accounted for as far as I know. But the cannon idea would very quickly show us whether you should have to or not.
yeah. And Brenda was talking about Coriolis deviating 15 degrees, yeah. But which way is it going to deviate? It has to choose one or the other to be correct.
Well,
yeah, on a plane, it's a swirl above the whole thing where it's opposite directions on a sphere. So you're right; it would be even more evident again if there was some deviation on a flat plane.
Because if it deviated 15 degrees, it would have to deviate 15 degrees in the correct direction that Coriolis is supposed to be helping it to deviate.
Yeah, but we never see it. But you're right, exactly. You're dead right.
It happens all the time. We see it all the time. Every
No, it's calculated.
every hurricane is the result of Coriolis. Every single one.
No, it's not. That's just pressure differentials. Things swirl.
when they have to try and neutralize. You can watch that happen anywhere, not because things are rotating, Brenda.
That's why they swirl, because the Earth is rotating.
Oh, so there's no other reason for things to swirl, like two pressure differentials just evenly mixed. There's no dynamic forces that cause rotation. Is that what you're saying?
Yeah. On a flat Earth, there would never be a hurricane.
Yes, there would, because the sun heats the center equator part more. So that's hotter. And as it comes through, it has a driving force, a Doppler effect, if you will, of light and heat and disturbance. That creates a path right through the center that creates a natural swirl right through the center, like we see.
Well, the air rushes in, it travels in a straight line. Why would it deviate?
Why wouldn't it? It's essentially going straight, the sun. It's such a big circle. You can't tell that it's arced at all.
Yeah, exactly. Hence, you would have no hurricane.
Right. No, you would, because it's disturbing right through the center and it's moving.
No.
Like, just picture it.
If the heated part of the atmosphere rises up, it creates a low pressure area beneath it, and the surrounding air comes in to replace it. It travels in a straight line. It would never deviate on a stationary Earth.
You prove that. You set up a little test where you've got a stationary thing and some gas, and then bring a little heat source in and move it just in a straight line through the center, and just drop some different colors in the gas, or different colored gases or whatever, so that there's a bit of dynamic play when the heat goes on, and just see what happens. I bet you get swirling.
Why?
You get eddies, just like a river, because it's just fluid dynamics again. You know it, Brenda. You're just playing dumb.
Things don't change direction unless there's a force applied to them. So why would
the sun?
What? No,
the sun applies a big force, mate. A big force.
Yeah, but that's not the reason. The sun is causing the air to heat and to rise up, and the cooler air is coming in, rushing in to fill in where the warm air was.
Yeah, but the sun heats up a lot of area in front of it before it's cooling down behind it. It's a large area, Brenda. You're forgetting the scale here.
Well, no. What happens is that there are like these cells in the atmosphere. So you have a region where the air is rising because it's being warmed, and then cooler air from around it rushes in, and it travels in a straight line. Unless there's another force, like say the Coriolis force, that would change its direction, it necessarily has to travel in a straight line.
No, I'm sorry. You're wrong. Because it's only over the actual midpoint, like perfectly over that midpoint at that one time of year. So it moves either side of that. So it's dynamic the whole time. It's pushing left, it's pushing right. You can't say there's no other forces at play.
You're just denying the most fundamental laws in physics, the law of conservation of momentum.
No, you assume that's at play. You fail to prove that that's actually the case. I would have to be denying it then. If you proved it and then I denied it, you'd be right. But you haven't proven it.
I have. I've just appealed to the fundamental laws of physics, that an object traveling in a straight line will continue to, unless it is affected by another force. There are no other forces in this example, so it would never.
There are many other forces. There are. You're forgetting the fact that we've got such large scale. There might be ocean on one side and land mass on the other side. They heat up at different rates. It applies you're not even thinking, Brenda, at all. There's evaporation. There's so many things that can affect the dynamics left to right.
Right. So the sun heats up a region of the atmosphere, and that region, because the air is warmer, it rises up. Cooler air rushes in to replace it. It will travel.
But it's not static. It's not static. It's not sitting there heating up one spot and allowing, like a lava lamp, allowing the hot air to rise up and cold air to fill in. It's moving and it's projecting its heat over a large area in front of it. So that whole area is heating up. Now, it doesn't stop heating up until the sun has moved past it, well and truly. Then it starts to cool down. So that whole area that it's illuminating in front of it as it comes up is dynamically being affected. And you're going to try and say it just goes up in a straight line.
There's
No,
cooler air. There's cooler air from the surroundings around it that rushes in, and it comes in a straight line. And the fundamental laws of physics say that air will travel in a straight line unless it's affected.
Okay, I'll leave you to prove it. All right, I'll leave you to prove it.
Well, you're just denying like fundamental physics. I mean,
no, there's just nothing to show me that what you're proposing is actually happening on the Earth.
I don't
Nothing at all.
I'm giving you a logical argument based.
Yeah, but all right. Correlation isn't causation. Come on.
It's a logical argument. It necessarily must be the case.
Correlation is not causation. Geez, I usually save that for all the nutritional debates. Here I am fucking bringing it up in flat Earth. That's bad, Brenda.
This doesn't have anything to do with correlation. It's a logical argument. The air that rushes in will travel in a straight line unless it's affected by another force. There is no other force.
Yeah, but you're applying that to the weather now on the globe. That's the correlation. It doesn't equal causation I'm talking about, Brenda. Can't extrapolate that.
We're assuming a flat Earth, non-rotating. There is no other force acting on the air traveling in the straight line to replace the rising warm air. There is no other force. Therefore,
except Brenda, on the flat Earth, though, Brenda, we don't see the sun as 93 million miles away. So if it was 93 million miles away, you could probably be correct, but it's not that far away. So there would be some difference in heat, front, left, right, back.
The sun can't be close to us. It would destroy the Earth.
Oh my God, Brenda. Seriously, it's not going to be the same size and same intensity, but closer, is it? Did anyone say that? Because yes, it would destroy us and fry the Earth. Obviously, it doesn't do that, does it? So it can't be the same size, but closer with the same intensity. Can it? That just can't be the case.
The sun can't be close because it's so hot, it would just destroy the Earth.
But hang on, couldn't it be less hot and smaller, but closer? Is that a possibility?
We've measured the temperature of the surface of the sun.
Okay, cool.
10 million
I love
degrees.
it. I love you, Brenda.
What did you do that with? A laser temperature gauge? Like one of those handheld ones?
You could touch something to measure its temperature.
No, I mean, but you know how you get those like little laser pointer things? So you click, you pull the trigger and it measures the temperature of a surface with like a little laser. You seen them?
No, you know the temperature.
Yeah, you nailed the sun with that.
Just by
How did you measure it? How did you measure like what instrument did you use to measure?
That's what they use for the sun.
Yeah, you just.
It's the feels like.
Just point a little laser temperature gauge at it. And...
You don't need that. You can go by the light that it's emitted. We know the temperature of the light that's being emitted. You can take the temperature of stars that are hundreds of light years away. We know their temperature.
I don't know. I can't argue with that.
Well, yeah, we know the temperature of light. Light has a temperature associated with certain frequencies of light have, it's an indication that the light source has a certain temperature. Anybody that's done photography knows that, right?
Yes, but there's different intensities. So color doesn't equate intensity.
It equates temperature.
But not intensity.
No, it's temperature. Halogen light lamps are very high temperature, rather than much more than incandescent lamps, and we know that simply by the color of the light.
By the color of the light. What about the intensity? Because I've got LED lights that produce all the same colors, and I can have ones that are 5 watts, 10 watts, 100 watts. So the intensity very much changes, even though it's the same spectrum.
I'm not talking
That's
about
interesting.
I'm talking about the color, right? So the
Yeah,
lumen,
same shit. It's colors. It's the frequencies of light that come from it.
illumination isn't color.
I know illumination isn't, but the type of color of that light is color, isn't it, Brenda? Or not?
So the light coming from a halogen lamp is hotter than the light coming from an incandescent lamp. It indicates.
That's just, you're talking about color, nothing to do with intensity, Brenda.
What is it?
At all.
Talking about intensity, I'm talking about the temperature of the source. So the source of light from the sun, is the surface of the sun is 10 million degrees because we measure the temperature from 93 million miles away. We can measure the temperature
based on color. You can measure the temperature based on color.
Yes, that's how it works. That's
no. How do you know the intensity?
Intensity is irrelevant. We're talking about the temperature.
No, it's not. Okay, so I've got let's just say I've got a red LED light and I'm pointing it at you. You can point your device at it and show that it's red. How would you know whether it's 5 watts, 10 watts, 25? How would you know the difference? I.e. intensity.
What are you talking about intensity for? I'm talking about the color.
Because the sun's either close or it's far away. And I said, can't it be closer and fucking less intense? And you went, no, because we know what color it is. And I'm like, well, Howard, color's got nothing to do with fucking intensity, does it?
I'm not talking about the intensity. I'm talking about its temperature.
Oh my God. That has everything to do with its fucking intensity, doesn't it?
Intensity has nothing to do with its temperature.
Okay. So temperature is color now, is it? Is temperature color now?
That's how you measure. And photographers do this all the time. You measure the temperature of the source of the light by its color.
I think you're getting some things mixed up here. Like when a light globe says 3000 Kelvin or whatever it is, they're not actually talking about the temperature per se, but they're talking about the temperature of the light in terms of its intensity, not so much its color intensity, not so much its temperature intensity.
Oh, intensity has nothing to do with the temperature of the source of the light.
Yes, it does.
No,
very much so, because at the end of the day, the sun could be exactly the same but closer, and not be as intense and look exactly the same.
No, it can't be, because it's 10 million degrees. Because it's 10 million degrees.
No, not at all. We can have an LED light that emits the same color at 5 watts or 10 watts. You are going to feel the impact of either of those, and you're not telling me what the difference is with the color and how the temperature changes.
Intensity has nothing to do with the temperature of the source of the light. So an incandescent lamp.
So you're denying the fact that there's two LEDs, different wattages, they've got the same color, but they have a different intensity. You're denying that fundamental fact.
An incandescent light can be either bright or dim, but the source is the same temperature.
Thank you. So the sun could be dimmer, less intense, and closer, but be the same color temperature. Fuck.
You can't have an object that's 10 million degrees in the atmosphere of the Earth and have the Earth.
But it could be dimmer, couldn't it? If it was dimmer, wouldn't it be less intense, Brenda? Fucking hell.
In an instant.
You broke up there. I didn't get that.
It would boil the oceans in an instant.
All right, here we go, Brenda. I've got exactly what you're looking for here, right? This actually comes from lumens.com, and it's talking about Kelvin in light bulbs. And here it says something, the light bulb color temperature in Kelvin is noted by the symbol K. As a quick rule, the higher the Kelvin, the whiter the light. Household fixtures commonly found at temperatures ranging scale from 2700K 3000K and 3500K. Blah, blah, blah. But here we go. It's got a temperature chart here, and I'll post it. The temperature chart here says that sunlight is 4800K. So the surface of the sun is 4800 degrees Kelvin. Is that right? The clouds are even hotter than the sun.
No, that seems all sorts of wrong. Oh dear. Could be dimmer. Fucking hell. Less intense. Dimmer. I can get a thesaurus out. Oh shit.
A thesaurus. Is that some kind of dinosaur, is it?
No, it's a. We used to joke about that as kids at school. No, but it's a like a dictionary, but a book to find words that have the same meaning but different words with the same meaning or similar meaning.
Words aren't my strong suit. I don't know. You'd get confused reading something like that, I think.
I wish they'd just fucking prove this false fucking be done with it. It's like they're deliberately holding the actual evidence back so they can just keep circle jerking.
Well, let's just prove curvature. That's actually quite easily to do.
You think?